productively using CSS.
Designing web pages with CSS. You can influence the appearance of web pages by using the cascading style sheets CSS style language. As mentioned earlier, CSS is a style language for controlling how certain hypertext markup language HTML elements of a web page are visualized in the front end. For example, you can use CSS to specify the font in which a text should be displayed in its color. You can influence the appearance of lists, form elements, and tables, for example, setting the bullets in a list or determining the background color of individual table cells. So, you have many options to make HTML, which looks rather dull by default, as shown in figures in Chapter 2, more attractive and appealing. Figure 3.1 CSS, one of three important languages for the web, defines the appearance of a web page. Introduction. In this section, I'll show you how CSS style sheets are structured and how you can handle CSS in HTML code. I'll also provide an overview of the most important terms and concepts of the language. The principle of CSS. You can define how the content of certain HTML elements should be displayed using CSS rules. These rules basically consist of two parts, as shown in figure 3.2. The CSS selector enables you to specify which HTML elements should be subjected to the respective CSS rule. You can use the CSS declaration written in curly brackets to specify how exactly these HTML elements should be displayed. Declarations, in turn, consist of CSS property and a CSS value, both separated by a colon and ending together with a semicolon. For example, properties can affect the color, font, dimensions, or border color of an element. Using the value of the property, you can then specify, for example, which color, which font, which width or height, or which frame color should be selected. Each property has certain predefined values that are valid. Figure 3.2, the structure of CSS rules. In the course of this chapter, I'll show you what types of selectors and what properties are available. First of all, for illustration purposes, let's consider a simple CSS rule. Listing 3.1, a simple CSS rule. This CSS rule states that all first level headings defined by the H1 selector should use the Arial font defined by the font family property and be displayed in dark blue defined by the color property. Including CSS in HTML, in total, three different ways exist for defining CSS rules and including them in an HTML document. External style sheets, external CSS. In this case, you save the CSS instructions as a separate CSS file with file extension .css and include this file in the HTML document. Internal style sheets, internal CSS. In this case, you define the CSS instructions in the header of the HTML document within the style element. Inline styles, inline CSS. In this case, you specify the CSS instructions directly in an HTML element. Including external CSS files, external CSS. Let's start with the variant that makes the most sense in most cases. The inclusion of separate CSS files, external CSS. The reason why this variant is often the most useful is you can cleanly separate the CSS code from the HTML code and thus easily include it in multiple HTML documents. Thus, web projects can have one central CSS file or a few files that can be included in all HTML documents in the project. This approach ensures that each HTML document uses the same CSS instructions and that the presentation of each web page is consistent. This structure also has considerable advantage with regard to modifications. When you make style changes, you only need to make them once centrally in the shared CSS files, which will affect all HTML documents as shown in figure 3.3. Figure 3.3, reusing external CSS files in different HTML files. CSS files are ordinary text documents that you can create and edit in any text editor with the .css file extension, for example, styles.css. Listing 3.2 shows an example of the contents of a simple CSS file that contains a total of 3 CSS rules. Listing 3.2, a simple CSS file. In Listing 3.3, we show you how to include this external CSS file in an HTML document using the link element. You can specify the URL or the path to the CSS file via href attribute. Since the link element can basically also be used for including other file types, you can also define the meme types of CSS via the type attribute. See also chapter 6. In addition, with the rel attribute, you can define whether the browser should use the respective CSS file as the primary stylesheet value or ignore it until the user or an application explicitly activates the stylesheet alternate stylesheet value. Listing 3.3, including an external CSS file in an HTML document. When you now load the HTML file, the browser finds the specified CSS file and applies the CSS rules to the corresponding HTML elements. So, the web page should look similar to the one shown in Figure 3.4. Figure 3.4, HTML and CSS rules applied. Defining CSS instructions in the HTML document, internal CSS. You can also define CSS rules directly within an HTML document, internal CSS. However, this option should be an exception. When you mix CSS code and HTML code, you cannot reuse the CSS code elsewhere, i.e. in other HTML documents, unless you copy it over manually, which is even less advisable because then keeping changes in sync becomes quite difficult. To define CSS rules directly in an HTML document, you can simply write them out as text in the style element, which is usually located in the head element of the web page. The sample code shown in Listing 3.4 illustrates how you can define CSS rules in this way. Listing 3.4, directly defining CSS code internally in HTML code. Note, for most examples in this chapter, I define the CSS code directly within the HTML code for didactic reasons. In this way, you can see both the CSS code and the HTML code clearly arranged in a single listing. Defining CSS rules as an attribute, inline CSS. Finally, you can also define CSS directly in a single HTML element, inline CSS. For this task, simply define the appropriate CSS declarations within the style attribute of the HTML element. However, you should consider this option only in exceptional cases, since even the reusability of CSS rules within an HTML document is lost. In the next example, you can see this limitation with the CSS declaration for the H2 elements. You must design the CSS declaration, text-transform, uppercase, separately for each element, which is not at all ideal for reasons of reusability. Listing 3.5, defining CSS code in HTML elements. Note, in addition to these ways for including CSS, a fourth option exists but is only available within CSS files or within CSS defined via the style element. To import additional CSS files, you can use the @import rule, @import URL /styles.css, @import URL /styles-more-styles.css. CSS rules can be made even more reusable via imports. For example, you can store the rules for table layouts in a table.css file, the rules for forms in a forms.css file, and rules for basic layout in a structure.css file. You could then access this construction kit of CSS rules relatively flexibly and include different files depending on the project or website. Selectors. To define which HTML elements are affected by a CSS rule, you can use different types of selectors. For example, you can select elements by their tag name, by the ID attribute, by CSS classes, by attributes, and by the hierarchy in which an element resides. Table 3.1 contains an overview of how to use selectors. Selector. Type selector, description, selects all elements that match the specified type or element name. Code example, input, color, green, h1, h2, color, green. The input description of the code example, the input selector selects all input elements. The h1, h2 selector selects all h1 and all h2 elements. Class selector selects element based on CSS classes. That is, elements whose value of the class attribute corresponds to the value after the dot in the selector. Code example, dot valid, color green, a dot valid, color green. The dot valid selector selects all elements whose class attribute has the value valid. The a dot valid selector selects all a elements whose class attribute has the value valid. ID selector selects elements whose value of the ID attribute corresponds to the value behind the hash symbol in the selector. Hashtag start, color green. The hashtag start selector selects all elements whose ID attribute has the value start.id. Attributes should be unique within a web page and related to the example. Only one element should have the start ID. The P hashtag start selector selects all P elements whose ID attribute has the value start. Universal selector, description, select all elements. Code example, asterisk, color green. The asterisk selector selects all elements on a web page. Combining selectors. Selectors can, of course, also be combined with each other, making quite complex selection rules possible. For example, you can craft a selector that selects all input elements whose class attribute has the value important, dot important selector, whose type attribute has the value text, type equal text selector, and which are immediate child elements of a form element, greater than selector, with the ID order details, hashtag order dash details selector. Listing 3.7, combining multiple selector types. Cascading and specificity. You can use selectors to specify to which elements a CSS rule should be applied. However, you must understand how CSS rules affect the child elements of elements selected in this way because styles are applied in a cascading manner. In general, the word cascade refers to a waterfall that falls over several steps. In terms of CSS, the principle of cascading helps in defining CSS rules. Thus, more general rules can be defined that apply to many elements, which are thus arranged on a higher level in the waterfall and reach several elements, as well as more specific rules that apply to a few or even only a single element, and which are arranged on a lower level in the waterfall analogy. Due to this cascading of CSS rules, sometimes of course intentionally or unintentionally, several CSS rules may apply to one element. The CSS standard defines exactly which CSS rules takes precedence in such cases. For two selectors that are the same and apply to the same element, the second selector takes precedence. In our example shown in listing 3.8, level 1 headings h1 elements are displayed in the green color because the corresponding CSS rule in the CSS code was defined after the CSS rule that colors the text blue. However, note that yellow is used as a background color because this CSS declaration is not overridden in the second CSS rule. Listing 3.8, if the selectors are the same, the CSS rule of the last defined selector is used. For two different selectors, the selector with higher specificity takes precedence. For example, a concrete selector like input is more specific than a general asterisk selector, so the former has higher specificity. In the example shown in listing 3.9, level 1 headings h1 elements are also rendered in green color, although the CSS rule that colors the text in blue was defined according to the other CSS rule. The reason for this result is the higher specificity of the selector of the first CSS rule. The h1 selector is more specific than the general asterisk selector. Listing 3.9, if the selectors are different, the CSS rule of the more specific selector is used. The calculation of the specificity of a selector is based on three counters, A, B, and C, each of which has the initial value 0. Counter A is incremented by 1 for each ID selector. Counter B is incremented by 1 for each occurrence of an attribute or class selector or pseudo-class CBox, and finally counter C is incremented by 1 for each occurrence of a type selector or pseudo-element CBox. Selectors other than those mentioned, such as the universal selector, are not considered when calculating specificity. Let's look at some examples where the selectors become more specific from top to bottom. Listing 3.10 examples of calculating the specificity for better readability with empty CSS rules. Furthermore, CSS rules defined via the style attribute, even if they don't have a selector in that sense, are considered more specific. Pseudo-classes and pseudo-elements. Pseudo-classes select regular elements but only under certain conditions. For example, if their position is relative to siblings or if they are in certain state. Some examples of pseudo-classes include the following. See also section 3.2. Link denotes links in the HTML code. Visited denotes already visited links. Hover denotes links that are currently touched by the mouse. Active denotes links that are currently active. Focus denote links that currently have the focus. Pseudo-elements, on the other hand, address specific parts of selected element and sometimes even create new elements that are not specified in the HTML code of the document and can then be edited in a similar way to a regular element. Example of pseudo-elements include the following. : before creates an element before the element selected by the selector. : after creates an element after the element selected by the selector. : first dash letter refers to the first letter of the text in the selected element. : first dash line refers to the first line of text in the selected element. : selection refers to the part of the text in the selected element that is currently selected by the user. Implementing CSS spacing. It sounds like the issue is related to how the content is being parsed and rendered by React HTML parser and how spacing, like line breaks and paragraph spacing, is handled in the blog app. HTML parsers by default may ignore certain formatting like multiple spaces or line breaks unless the HTML structure is properly formatted. Here are a few steps you can take to fix the spacing issue. First, replace multiple spaces with pre-tags or white space. Pre-wrap, HTML collapses multiple spaces into a single one by default. To preserve the spacing as it is, you can use the white space CSS property. Update the .post_content CSS class to apply white space. Pre-wrap so that the text maintains all spaces, new lines and paragraphs like this CSS code. Content styling, .post_content, font size 1 rem, color #555, line height 1.6, white space, pre-wrap, preserve white spaces and line breaks. This will ensure that the formatting with multiple spaces and line breaks is preserved when the content is displayed. Second, ensure proper HTML structure in the content. If the content contains multiple line breaks or excessive spaces, they may not render correctly in the HTML if the parser doesn't translate them into proper HTML tags. You can manually ensure that line breaks, BR, or paragraphs are inserted. You can modify the content by pre-processing it before parsing it with React HTML parser, JSX code. Function, pre-process contents, replace multiple spaces and line breaks with HTML safe versions. Let formatted contents equal contents that replace line breaks with BR dot replace, etc. Explanation: BR add line breaks wherever a new line character /n is found. And NBSP adds multiple non-breaking spaces where multiple spaces are found. This pre-processing ensures that your content preserve both spacing and line breaks when displayed. Third, ensure proper handling of p tags. If the content in your post includes paragraphs, it's also a good idea to check that paragraphs are correctly rendered with proper margins and line spacing. For paragraphs, P, update the CSS as follows to ensure they have consistent spacing. That post content P, margin dash bottom, colon 15px, semicolon. These ensure there's space between paragraphs. Fourth, debugging React HTML parser. Output. If these changes don't resolve the issue, you can debug what the parser is returning by logging the output before rendering it, like this JXX code. Const formatted contents equal preprocessed contents console.log formatted contents formatted formatted contents. Return article class name equal post h2 title h2 div class name equal post content React HTML parser formatted contents div closing div closing article. This will help you understand if the formatting is being processed correctly before it is passed to the parser. Fifth, use dangerously set inner HTML as a last resort. If React HTML parser still doesn't behave as expected, you can use dangerously set inner HTML as a fallback for handling raw HTML content. However, be careful with this method as it can open up your app to cross-site scripting, XSS vulnerabilities if not sanitized properly. Example using dangerous set inner HTML, etc. Warning, always sanitize content when using dangerously set inner HTML to avoid security risk. Recap of steps: CSS, whitespace, pre-wrap. Ensure line breaks and multiple spaces are preserved in the .post content. Pre-process content, add BR for new lines and end NBSP for multiple spaces before passing content to React HTML parser. Handle paragraphs, P. Make sure paragraphs have spacing via SSS. Debug output, log the pre-processed content to see if the formatting is being handled correctly. Use dangerously set inner HTML as a fallback, only if necessary and with proper sanitation. These steps should help ensure the correct spacing and line breaks are applied in your blog up. Let me know if you need further clarification. To ensure that your blog up handles the formatting correctly and visually differentiate sections like subheadings properly, you can improve the CSS for more structured styling and spacing. Here's a breakdown of how you can adjust your CSS to fix the issues. First, ensure proper heading styling. Since the issue is with headings like web data format, CSV, XML, etc., make sure the headings are clearly distinguished in your CSS by setting styles for H1, H2, H3, etc. You can update your post list.css to ensure subheadings are clearly styled, like this CSS code. Body, font-family, Arial, sans serif, background-color, hashtag F4, 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 color, hashtag 333, margin, 0, padding, 0, line height, line-height, 1.6. Container for blog post, post-list container, max width, max-width, 1200px, margin, 0, space auto, semicolon. Individual postcard, post, background-color, white, padding, 20px, margin bottom, 20px. Post hover, transform, translate y, negative 5px. Title styling, post h2, font dash size, 2 rem, color, hashtag 333, margin bottom, 10px. Content styling, post content, font size, 1 rem, color, hashtag 555, line height, 1.6, etc. Second, Update the post.jsx component since the content is being parsed from HTML. You need to ensure that the parsed HTML content retains the structure of headings and paragraphs. You're already using a React HTML parser, which will help with this, but you need to ensure the content is properly wrapped in div or section elements for styling purposes. In your post.jsx, ensure the parsed HTML has appropriate class names for styling, like this JSX code. Import prop types from prop types. Import delete post button from /delete post button. Import delete post button component. Import format from date-fns. Import date-fns for date formatting. Import React HTML parser from html-react-parser, like this code, etc. etc. Here, I wrap the parsed content with the class post-content, which will help you style it better, especially for sections like headings, paragraphs, etc. Third, fixing paragraph spacing and subheadings. Make sure that paragraphs and subheadings have adequate spacing, especially when the content is parsed into HTML. You can do this by adjusting margins, padding, and line height for headings and paragraphs. In the post.this.css example above, I added a rule for H3 and H4 headings. You can further adjust this to fit your needs. Fourth, ensuring line breaks in paragraphs. Since you're copying and pasting content from other sources like Google Docs, it's important to ensure that the line breaks and paragraphs are preserved in the app. When HTML is parsed, it might lose line breaks or paragraph tags. To address this, you can ensure that paragraphs have spacing between them by styling them in CSS. For example, CSS code.post-content-p margin-bottom colon 15px semicolon. Fifth, test it. After applying the above changes, you should test the blog up to ensure that content from copied sources, including headings, subheadings, and paragraphs, appears correctly and is styled as expected. Try copying text with multiple headings and check if it properly differentiates sections. By combining these steps, you can improve the visual structure and readability of posts with multiple subheadings and ensure better formatting for content copied from Google Docs or other sources. It seems like the blog app you're using does not handle the spacing and formatting correctly when you copy from Google Docs or other rich text sources. The issue might be that the app is treating the copied content as plain text, which strips away the formatting such as headings, paragraphs, and line breaks. Here are a few ways you could work around this issue. First, ensure proper HTML formatting in the blog app. Since the app seems to strip out rich text formatting, you can try directly adding HTML tags, headings, paragraphs, etc. in the content when you paste into the blog app. For example, instead of just pasting web data format, etc., try this integrating this HTML code with H2P, etc. Second, use a code/HTML block in the blog app if available. Check if the blog app has any feature for pasting raw HTML or a special HTML editor where you can directly input HTML code. Many content management systems, CMS, or blog platforms allow you to add custom HTML in specific blocks. If that option exists, you can paste your formatted HTML content directly, which will maintain the structure when displayed on your blog. Third, review the blog app's formatting options. Some blog apps provide a toolbar or formatting option where you can manually style your content, like setting headings, bold, italic, etc. If the app has such a feature, you can try using that to format your text rather than copying and pasting directly. This can help avoid issues where spacing and formatting are lost in translation. Fourth, consider switching to a blog app with better rich text support. If none of the above options work, you might want to consider using a different blog platform that better handles rich text formatting and spacing. Many modern blog apps support rich text with minimal issues when copying and pasting from word processors like Google Docs. Fifth, custom CSS workaround. If the app allows for custom CSS, cascading style sheets, you can apply some CSS rules to ensure headings, paragraphs, and other elements are styled correctly, even if the text formatting isn't coming through properly. Here's an example of CSS rule that could be added if supported by the blog platform. H2 font dash size colon 24px, margin dash top 20 colon 20px, P margin dash bottom 15px, H3 font dash size colon 20px semicolon, margin dash top colon 15px semicolon. This will ensure that headings and paragraphs have appropriate spacing and font size. Since the issue is likely with the blog app itself not recognizing the rich text format, these steps should help either by improving the way the content is pasted into the app or by providing workarounds to ensure your formatting is maintained. Let me know how it goes or if you need more specific assistance based on the blog app you're using. I see. Since you're using a virtualized environment like BlueStacks with ColorNote, the content you're copying and pasting might come in as plain text without retaining its original HTML structure, headings, paragraphs, etc. ColorNote or BlueStacks may not preserve HTML formatting when copying text from an app. In this case, there are a couple of things you can try. First, manual HTML markup in ColorNote. If possible, you can try adding the necessary HTML tags manually while editing in ColorNote. Once you have the HTML tags in your content, it will be interpreted properly in the React component when passed to the dangerously set inner HTML attribute. Use a rich text editor. Consider using a rich text editor to copy the content. If you are preparing this content in ColorNote and copying it into your web application, the text will be treated as plain text without formatting. You could try using an editor that supports rich text formatting like Google Docs or even an online HTML editor to copy and paste content. Third, handling content in post.jsx. If the HTML content is still not being rendered correctly, you can attempt to process the text before passing it to the post.jsx component. This involves using a library or function that can parse plain text into HTML tags. You can try using the HTML-React parser library for this. Here's how you could implement it. Install HTML-React parser. Run this command to install the HTML-React parser library. npm install HTML-React-parser. Modify post.jsx to use the parser. Update your post.jsx to use this library to safely parse and render the HTML. Why this works? The HTML-React-parser will take care of parsing the plain text with HTML tags into valid React components. This should help with properly displaying headings and other HTML elements that may have been lost during the copy-pasting process. Fourth, handling rich text copying in BlueStacks. If you're still experiencing issues with how BlueStacks and ColorNote handle copied text, you might consider exploring other ways to copy and paste, like using a different app or directly from a browser-based text editor. To make the site visually appealing, you can focus on several key areas of design. First, typography. Choose a clean, modern font for readability. Ensure appropriate font sizes and line spacing to make content easy to read. Use different font weights to create a hierarchy, making headings stand out. Second, spacing and layout. Add padding and margins to elements to prevent them from looking cramped. Use a grid or flexbox layout for alignment. Create clear sections for blog posts, author details, and other content. Third, color scheme. Pick a color palette that is not too harsh on the eyes, like soft backgrounds with contrasting text. Use primary and secondary colors to differentiate between sections or calls to actions. Images. Fourth, images and media. If you're using images for blog posts, ensure they are high quality and appropriately sized. Add thumbnails or cover image for each post to make the content more engaging. Fifth, buttons and links. Style buttons with hover effects to improve interaction. Ensure links are clearly identifiable like underline or style buttons. 6. Card design for post. Use card-based layouts to group contents like post titles, authors, dates, and previews together. Add hover effects to cards to make them interactive. 7. Consistent UI elements. Use consistent spacing, colors, and font choices across the site. Ensure navigation is simple and easy to use. Here is an example of what you can implement in CSS to improve the visual appeal of the blog page. Like this code: body, font-family, Arial, sans-serif, semicolon, background-color, #F4F4, color, #333, container for blog post, post-list container, max-width, 1200 px, individual postcard, post, hover, post h2, post-content, post-footer, post-footer span, post-author, post-date, delete-button, delete-button, hover, etc. A soft background color, #F4F4F4 is used for the body with dark text, #333 for good contrast and readability. Line height, 1.6, improve text readability by increasing the space between lines. Post layout, posts are styled with a clean white background and soft shadows for a card-like effect. The hover effect on the post adds interactivity, slightly lifting the card when the user hovers over it. Typography, titles are large and bold for emphasis, with a margin to separate them from the content. The content is set to a slightly lighter color, #555, and a comfortable font size. Footer, the footer uses flex to align with the author and date properly, with spacing for separation. Delete button, a red button, #F44336, is styled to stand out with a hover effect that darkens the color. Responsive design, the layout adapts for a mobile screen, like padding font sizes to ensure the blog looks good on smaller devices. Further enhancements, add a navigation bar. Make sure your site has a clean header with easy to access navigation links for other sections like home, categories, etc. Add icons. Consider adding social media share icons or a read more button. Improve visual hierarchy. Adjust spacing between elements like posts, titles, and contents for a better flow of information. Feel free to tweak the colors, fonts, and layout to suit your brand or aesthetic preferences. It looks like you're using the post.js component to render individual posts, and you're also using post.list.jsx to display multiple posts. Since your title appears as an h3 element in the post.jsx component, but you want the title to appear more prominently at the top in the post.list.jsx layout, the solution would be to adjust how the post.jsx component handles the title. To align everything properly, you can make the following changes. First, make the title more prominent in post.jsx. In your post.jsx file, you can change the title's HTML tag from h3 to h2 if you want it to appear more prominent, or you can adjust the CSS styles to make it stand out. Like this code, post.jsx, etc., etc. Second, ensure correct placement of title in post.list.jsx. Since you're rendering the post component inside post.list.jsx, you can keep the structure as it is, but make sure you're passing the right props, including title, contents, author, post ID, and created at each post component, like this code. Third, styling the title in postlist.css. In the postlist.css file, ensure that the title appears with the desired spacing and prominence, like this code. Post border, 1px solid space, #DDD semicolon. Post h2, font size, 24px. Post content, font size, 16px. Key points: post.jsx, changing the title from h3 to h2 makes it more prominent. You can also add more custom styles to make it stand out more. PostList.jsx, you're already passing the correct props from PostList to post. Make sure post.jsx is structured as you want. CSS, adjust styling for better formatting of the title, content, and footer elements. It looks like your PostList.jsx component is already structured to display each post with the title at the top. Based on your description, if the issue is with how the title is formatted or how the title appears in relation to other content, there are a couple of potential issues. First, ensure title is at the top of the post. Your current layout seems correct, where the title h2 class name equal post-title is already at the top of each post. If the issue is about making the title more prominent or adjusting the overall structure, you can focus on adjusting CSS to ensure the formatting matches your expectations. CSS adjustment for title formatting. You can modify the postlist.css file to ensure the title has a proper spacing, styling, and alignment. Like this, code.post-list-container, display : flex semicolon, flex-direction : column semicolon, styling for individual post, post, border : 1px space solid space #DDD semicolon, padding : 15px, post-title, post-content, post-footer, post-author, post-date, margin : 0 semicolon. Third, ensure post.jsx is not overriding title placement. Since your post.list.jsx is handling the title and content directly, you shouldn't need to modify post.jsx unless you want to separate these concerns further. However, ensure that post.jsx isn't conflicting with your structure. If you're still using post.jsx to encapsulate individual posts, it should look like this code, etc. Fourth, check for additional styling or markup. If the title is still not appearing as you want, inspect if there are other global CSS rules or parent container styles that might affect the display. You can use the browser developer tools to check for any inherited styles that may be affecting the layout. To achieve the desired format where the title appears at the top of your post in the postlist.jsx file, you can adjust the structure and styling in either postlist.jsx or post.jsx depending on how your components are structured. Here's how you can approach it. First, in postlist.jsx, if you're rendering multiple posts, if you're rendering post inside the post list component, you can modify how the title is rendered for each post, like this code. In post.jsx, where individual post content is rendered, in the post.jsx component, you can ensure the title is properly rendered at the top by making sure your JSX structure is correct, like this code. Third, CSS styling for title placement. To ensure the title appears where you want it, you can adjust the CSS. You might need to add styles to the .post-title class, like this code. This will ensure that the .post margin-bottom : 20px, .post-title font-size : 24px, font-weight : bold semicolon. This will ensure that the title is styled correctly and appears at the top, followed by the content. Fourth, if you're working with dynamic data, if your title data is coming from a dynamic source, like from an API or state, ensure that you're correctly passing the title data as a prop to the post component. To improve the readability of the blog post displayed on the left side, you can format the content in your postlist.jsx file by adding proper spacing, line breaks, and structure. Here's how you can adjust your postlist.jsx. Add BR tags for line breaks. To insert line breaks, you can include BR tags in the return JSX or wrap sections in paragraphs P. Second, format blog post with semantic HTML. Use semantic HTML elements such as article, header, section, and P to organize the content. Updated postlist.jsx example. Here's a revised version of your postlist.jsx to make the blog content more readable. Export function postlist post return div class name equal post dash list etc. etc. Explanation of changes. First, added semantic tags. Wrap each post in an article element to group content. Use header for the title, author, and date. Added section for the content. Second, formatted the date. Created into a human readable format using two local string. Added readability enhancement. Use HR for separating posts. Wrap text content in p tags for proper paragraph spacing. CSS optional to make it visually appealing. You can add CSS styles that post-style, max-width, 800px, etc. Result, after these changes, each post will have a structured layout with headers, paragraphs, and line breaks. The post will be more readable and visually appealing. Here's the modified version of your postlist.jsx with improved HTML structure and added CSS classes for readability. I'll structure the post using semantic HTML and add styling suggestion to enhance the presentation, like this code, etc. Suggested CSS, you can add the following CSS to style your blog and improve readability. Save this as .css files like postlist.css and import it to your component. Result, after these changes, each blog post will have a clear structure, header, title, author and publish date, content, blog post, contents, footer, additional functionality like post component for actions like delete or edit. Post will be separated with padding, borders, and subtle background color for readability. Let me know if you need modifications to post.jsx file to complement these changes. You should place the postlist.css file in a location that makes sense for organizing your project. Here are two common approaches. In the same folder as postlist.jsx. This is the most common approach if the CSS file is specific to the postlist component. Directory structure example, src / components / postlist.jsx postlist.css in a centralized styles or CSS folder. If you prefer to keep all CSS files in one place, create a folder for styles /src / styles / postlist.css. Best practice: if the CSS is specific to postlist.jsx only, it's better to keep it in the same folder as the component. This follows the component-based styling principle, making it easier to manage. Let me know if you need more clarification. It looks like the issue is caused by a combination of duplicate elements and CSS styling inconsistencies. To address the concerns, remove the redundant author and publish date at the top left. Fix the layout to properly indent the blog post content. Ensure there is no duplication blog content. Use the modified postlist.jsx. Return div class name. React.fragment key id. Div classmate name post. h2 classmate name post title, etc. Changes. Remove redundant elements. Remove any unnecessary display of author or publish date at the top left. Move the written by and publish sections to the bottom right of the post inside that post-footer. Updated CSS. Update the postlist.css file to include proper styling for indentation and alignment. That post-list-container padding : 20px semicolon. That post padding : 20px semicolon. That post-title font-size : 1.5 em. That post-content margin : 10px space 0 semicolon, etc. Explanation of fixes. Indentation for content. Added text-indent : 30px in that post-content to ensure the content starts indented. Fix duplication. Check that the post.map function only maps each post once. Remove top author/date. Consolidated these details into the .post-footer. This setup should now display in one copy of each blog post. Remove the top-left author/date. Ensure the content looks properly styled and indented. To achieve the layout where the title web data format is prominently displayed at the top as shown on the left of the image you provided, the best approach would be to handle this in the post.jsx file, since the post component is responsible for rendering each individual post. Here's how you can modify both post.jsx and post.list.jsx to achieve the desired result. Updated post.jsx. Modify post.jsx to structure the post data properly. What are props in React in the context of control components? In React, props, short for properties, are a way to pass data from a parent component to a child component. They are immutable, read-only from the perspective of the child component. When working with controlled components in forms, props are used to manage the flow of data and ensure that the parent component maintains full control over the form state. For instance, the parent component holds the state of the form field values. The child form component receives the current value via props, and an event handler also passes a prop to update the state when the user interacts with the field. This approach ensures unidirectional data flow where the source of truth resides in the parent component. Metaphor: props in a controlled component as a house plumbing system. Imagine your React applications as a modern smart home, and props in a controlled component are like the plumbing system that ensures water flows precisely to each faucet. Child component in the house. Parent component as the main water tank. The parent component is the central water tank that stores and manages the water. It knows how much water data is available and can adjust the supply state management. Props as pipes. Props are the pipes connecting the main water tank to various faucets in the house. These pipes ensure the water flows smoothly and consistently to each sink, shower, or tap. Controlled components as faucets. Each faucet controlled component doesn't store water itself. It merely opens or closes to let the water flow. It relies entirely on the central tank, parent state, and the pipes, props, for its operation. On-change event as a feedback loop. When you turn the faucet, user interacts with the form. A sensor sends a signal back to the central tank event handler in the parent component to adjust the water supply, update the state. This ensures the water flow remains controlled and accurate. Complex details in the metaphor. Bidirectional dependency without overlap. While the pipes, props, provides the water flow, the faucets themselves can directly decide the water pressure or amount. They merely relay back their needs. Similarly, controlled components rely entirely on props to render values and send changes back to the parent. Multiple outlets, one source. The parent component can manage multiple faucets, form fields simultaneously, ensuring each one gets the appropriate data and updates individually through separate pipes. Props. Immutable nature of props. Just as water flowing through pipes can reverse direction back to the tank without explicit feedback mechanisms, props in React are unidirectional. They flow from parent to child and cannot be altered by the child. Leak-proof design for consistency. The system is designed to prevent leaks, inconsistencies, ensuring the form always reflects the parent's data accurately. If there is a leak, it's likely due to improper piping, bugs in data flow. Conclusion: in controlled components, props act as the lifeline for managing form inputs. Just as a house plumbing system ensures precise and controlled water distribution, props ensure smooth, predictable, and centralized data flow between components. This metaphor highlights the importance of keeping the plumbing well maintained to prevent data leaks or inconsistencies in your app. What are props in Context API with uncontrolled components? In React, props and Context API both facilitate communication between components, but their roles differ. Props directly pass data from parent to child in a top-down, unidirectional manner. Context API creates a shared global context, avoiding prop drilling by allowing any component in the tree to access data without passing props explicitly. Uncontrolled components, on the other hand, rely on the DOM to manage the state of form elements instead of React managing it. For example, retrieving the value of an input field requires accessing the DOM directly using reps. When combining props, Context API, and uncontrolled components, props might still be used to pass functions or reps for uncontrolled elements. Context API can provide global configuration, form validation rules, or state management that child components consume directly. Metaphor, props and Context API in uncontrolled components as a smart irrigation system. Imagine your application is a modern smart house with an automated garden irrigation system where roles in the house, uncontrolled components, individual sprinklers. These are the sprinklers scattered across your garden. They store their own state, like water pressure or coverage area, and function autonomously, like props, local connections. These are like the local switches and valves near each sprinkler. Each switch is wired props to trigger specific behaviors of its corresponding sprinkler. Context API, Central Hub, and Weather Sensors. The Context API acts as a smart hub or control panel in your house. It provides global configurations like watering schedules or weather forecasts that any sprinkler can access and adapt to without requiring individual instructions. How this works: local autonomy, uncontrolled components. Each sprinkler works independently using its own sensors to detect soil moisture, similar to reps accessing input values. It doesn't rely on the central system to know the exact state of the garden. Localized control via props. Props are like the local on or off valves controlling specific sprinklers. They allow some manual adjustments like turning a particular sprinkler on or off. However, this method becomes cumbersome when managing a large number of sprinklers. Global context for efficiency. The Context API acts as the overarching system that automatically updates watering times based on weather. Ensure all sprinklers follow consistent rules like no watering during rain. Allow sprinklers to request additional data like when to pause or resume. Complex details in the metaphor. Interplay between props and Context API. Imagine a scenario where some sprinklers need specialized configurations like more water for vegetable patches. Props handle this fine-grained customization. Simultaneously, the Context API ensures all sprinklers follow the global rain detection logic. Uncontrolled component as independent devices. Each sprinkler manages its own state and function much like controlled components rely on their internal DOM state, decoupling for scalability. Without the Context API, you'd need to wire individual switches for every sprinkler to the central hub. This prop drilling becomes inefficient. The Context API eliminates this by broadcasting the watering schedule globally. Ref-based access for real-time data. If a sprinkler needs to report its current moisture levels, it uses direct sensors, refs, instead of querying the central system for every update. Greatest metaphor summary: sprinklers equal uncontrolled components, manage their own state but need occasional external influence. Switches or valves equal props, provide targeted adjustments but are inefficient for large systems. Smart Hub equal Context API, ensures global consistency, avoiding repetitive manual connections. By combining props, context API, and uncontrolled components, your irrigation system becomes both autonomous and harmonized, much like an efficient React application. Yes, exactly. In this metaphor, a prop drilling represents the tedious process of manually connecting every sprinkler, child component to the central hub, parent component via direct wires or hoses, props. It involves physically drilling through the land to lay down the pipes or wires, similar to how you would pass props through multiple layers of components in React. How Context API eliminates this? Instead of requiring physical wires or hoses, props to connect each sprinkler, the Context API acts like a wireless system using sensors or signals to broadcast information like watering schedules to all the sprinklers simultaneously. Key differences: prop drilling, wired hose system. Every connection must be explicitly laid out and maintained. If you add a new sprinkler or need to change the configuration, you might have to dig up the ground, modify all intermediate layers of components to adjust the wiring. This becomes cumbersome as your garden component tree grows. Context API, wireless signal system. The central hub broadcasts watering schedules to all sprinklers through signals. Any sprinkler can tune into the broadcast, consume the context without needing a direct wire. This approach avoids digging up the land, modifying intermediate components when adding or changing sprinklers. Why Context API is superior for global state? It simplifies and streamlines communication by eliminating the need for direct physical connections, prop drilling, making it easier to manage large gardens, applications with many sprinklers, components. What is routing in a single page application in React? In a single page application like React, routing is the process of navigating between different views or pages without fully reloading the page from the server. Instead of requesting and loading a new HTML document, React dynamically updates the DOM to render the appropriate component based on the URL. How it works: React Router or similar libraries handles routing by listening to changes in the browser's address bar, matching the URL to a specific route defined in your application, rendering the corresponding component or view. This allows SPAs to feel faster and more seamless as the browser doesn't need to reload the entire page. Relation between routing, props, context API, and uncontrolled components. Routing in React and props. React Router can pass props to the component it renders. These props include useful data like match, information about the route parameters, location, details about the current URL, history, methods to navigate programmatically. These allow components to behave dynamically based on the current route. Routing and Context API. The Context API can be used to share routing-related data like user authentication, app settings, or global state across components without drilling props down the component tree. Routing and uncontrolled components. In forms with uncontrolled components, refs can manage the input values. Routing comes into play when form submission trigger navigation to a new route or when different routes load specific uncontrolled components. Function versus class components. Function components use hooks like useHistory or useLocation from React Router to access routing information. Class components receive routing props via with router, HOC, or directly from React Router. Metaphor: routing, props, context API, and uncontrolled components as a smart home navigation system. Imagine your React app as a smart home, and routing is the system that helps you navigate different rooms, views in the house without stepping outside. No full page reload. Let's break it down. Roles in the smart home: routing as hallways and doors. Routing is like the hallways and doors that connect various rooms in your house. Instead of stepping outside every time you want to move to a different room, like a multi-page app, you just walk through the hallways, navigate routes within SPA. Props as local maps. Props are like maps or directions provided by the hallway system. When you open a door, you receive a note, props telling you what the room is, its purpose, and what you can do there, like route parameters. Context API is the house intercom system. The context API is like the intercom system in the house. It broadcasts information like user preferences, temperature settings, or announcement to every room. So no matter where you are, you can access it without carrying a map. Uncontrolled components as furniture. The furniture in each room, uncontrolled components, is self-contained, managing its own state. For example, a chair input field doesn't rely on external systems to adjust its position or value, but can still respond to global settings or context like rearrange furniture for cleaning. Function and class components as room types. Some rooms are modern and minimalist function components, while others are more traditional and intricate like class components. Both can coexist and serve their purpose. Complex details in the metaphor. Dynamic routing as automated doors. Dynamic routing like /rooms/:ID is like having smart doors that change labels based on the person entering. For example, the same door might lead to different bedrooms, dynamic content based on the props, route parameters passed to it. Global context for house rules. If the entire house has a rule like no lights in unused rooms, this global logic is managed by the intercom system, context API, rather than wiring each hallway props to enforce the rule. Uncontrolled components and routing interaction. If a guest user fills out a form in one room and then moves to another, the furniture form state must remain untouched. This is where uncontrolled components and reps helps maintain the state without relying on routing or context. Class components and props passing. Class components are like old-fashioned rooms where every new feature, like new furniture arrangement, needs to be physically added. Props must be explicitly passed, making it harder to scale without the intercom system or context API. Function components with hooks for efficiency. Function components like smart rooms use hooks, sensors to pull in routing data and context dynamically, reducing dependency on hardwired systems. Greatest metaphor summary. Routing as hallways and doors, connects rooms and allows navigation without leaving the house. Props as maps, provides detailed room-specific instructions. Context API is the intercom, broadcasts global rules and information. Uncontrolled components as furniture, self-contained elements managing their state independently. Function and class components as room types, represent different architectural styles within the same house. This metaphor shows how routing, props, context API, and uncontrolled components combine to create seamless navigation and management system for React application, much like a smart home. Yes, you are correct. When I mentioned the furniture form state must remain untouched, I was referring to a scenario where the user fills out a form in one room, like view or route, but does not submit it, and then navigates to another room, route, without losing the data they entered. In this case, uncontrolled components with wraps allows the form's internal state, the furniture arrangement, to persist independently without relying on routing or context API. Since uncontrolled components store their state internally, not managed by React state system, the entered data remain as is unless explicitly reset or modified by the user. How this works in metaphor: imagine a guest starts rearranging furniture in a room, filling out the form. They decide to explore another room, navigate to another route without locking in their changes, submitting the form. When they return to the first room, the furniture is still exactly as they left it. The form retains the field values because the furniture manages itself internal state in uncontrolled components. Key contrast: controlled components, the state of the form is managed by React and often tied to the application state. If the guest leaves the room, the furniture arrangement might reset unless explicitly stored elsewhere, like context API or routing props. Uncontrolled components. The form data is stored in the DOM itself, so even if the guest leaves the room, the furniture form state is untouched and remains exactly as it was. This behavior ensures that the form data is preserved until the user explicitly submits or clears it regardless of navigation. No, when I say that form data is stored in the DOM itself in the context of uncontrolled components, it does not mean the data is stored in browser cache or cookies. Instead, it means that the values the user enters into form fields like input or text area are stored directly in the DOM elements themselves, not in React state or any external storage. How it works: when using uncontrolled components like form fields manage their own state internally and React does not track their values, the DOM element like an input field maintains its current value in its internal state, which is accessible via RF. Example like this code, function, uncontrolled form, etc. etc. The value of the user types into the input field is stored inside the DOM element, accessible via input ref.current.value, not in React state. Does it use browser cache or cookies? No, uncontrolled components do not rely on browser cache, cookies, or any external storage unless you explicitly save the values there. The data exists only in the DOM until you programmatically extract it, such as via ref or form submission. Metaphor explanation. In the context of the house, the form data furniture has been rearranged by the guest user, but it hasn't been stored permanently like submitting to a React state or a backend server. The rearrangement remains visible, stored locally in the room's DOM, and as long as no one resets or removes the furniture, clears the input, it stays in place. If you were to store the data in cookies or browser cache, that would be akin to saving the rearrangement of furniture in a blueprint outside the house for reference later. But that's not the default behavior of uncontrolled components. Metaphor. The furniture in the house. Imagine furniture rearrangement during a party. Guest, users, rearrange the furniture form inputs during party, a current page session. This rearrangement exists in real time while the party is ongoing, but it's not saved anywhere outside the house. It's just there because the guest physically moved the furniture. No permanent blueprint. If the house gets reset, page reload, it goes back to the default arrangement because there is no permanent blueprint like browser cache or backend storage capturing the changes. If you want the arrangement saved, to preserve the arrangement, you'd need to take a photo, store the state in local storage, write it in a logbook, save it to a database, communicate it to the intercom system, context API or props in React. Why doesn't it stay after reset? The house browser only holds the changes temporarily while the guests are there. When the house is cleaned or reset, page reload, the temporary changes vanish because they were never saved externally. Why doesn't DOM cache the data? The DOM is designed to handle the current state of the page, not to persist data across sessions. Persisting data would require explicit developer action using tools like local storage, session storage, cookies, or backend server. Security and privacy. Automatically saving user input without their consent could lead to privacy violations. Where is the form state stored in the DOM? In technical terms, the value of an input field is stored as a property of the DOM element in memory. Example, like this code. Input ID equal my input, value equal hello world. The browser internally keeps track of this value property in its in-memory representation of the DOM. However, this memory is volatile and cleared when the page is reloaded or closed. Summary: the DOM stores form data temporarily in memory, like real-time changes to furniture in a house during a party. If you reload the page, it resets because there's no permanent record.
To make changes last, you need to save them explicitly using tools like local storage, cookies, or state management. To explain the metaphorical relationship between how browsers calculate and rebuild the DOM tree and how React calculates the new version of the application via the reconciler, let's delve into the process and compare it to managing a dynamic house with multiple rooms and guests. First, browser DOM tree calculation and rebuild. How it works: when the browser receives the HTML, it parses it to build a DOM tree and combines it with CSS to create the render tree. Changes to the DOM, like via JavaScript or user interaction, triggers a process where the browser recalculates the affected parts, determines what has changed, and repaints or redraws only the necessary elements. Second, React reconciliation process. How it works: React maintains two versions of the UI. The current version, the DOM as it is now. The next version, the virtual representation of what the DOM should look like after updates. React's reconciler compares these two versions via a diffing algorithm and determines the minimal set of changes required to update the actual DOM efficiently. Metaphor: a dynamic house with guests and furniture. Imagine a house where guest users frequently rearrange furniture, add decorations, or move things between rooms. You have two approaches to manage this dynamic situation: browser DOM tree calculation. The traditional host, the house, is run by a traditional host who rebuilds each room from scratch every time something changes. If a guest moves a chair, the host doesn't just move the chair, they rebuild the whole room based on a blueprint, HTML plus CSS. This process can be slow and inefficient, especially for large houses with lots of rooms, complex applications. Example: a guest moves a chair, user updates a form field, the host redraws the entire room, browser recalculates and repaints the DOM. React reconciliation, the smart butler. The house is run by a smart butler who keeps an internal map, virtual DOM of the house. Whenever a guest makes a change, the butler compares the current state of the room with the desired state. Instead of rebuilding the entire room, the butler makes only the necessary adjustments, like moves just the chair instead of repainting the entire room. This process is fast and efficient because it minimizes unnecessary work. Example: a guest moves a chair. The butler checks the map and notices only the chair needs to be moved. The butler updates the room with minimal effort. React updates the DOM efficiently. Saving state in the DOM versus React reconciliation. Browser DOM, furniture in the room. The browser saves the state of the furniture directly in the room, like DOM. When the house is reset, page reload, all the furniture returns to its default position unless explicitly saved elsewhere, like local storage. React reconciliation, virtual map of the house. React keeps an updated virtual map of the house, virtual DOM, to track changes. Even if the guest changes multiple rooms, the butler, reconciler, intelligently updates only the necessary pieces based on the map. This map is not stored directly in the room but exists as an abstract representation for efficiency. Greatest metaphor summary: the house. The DOM is the physical house, actual UI. The virtual DOM is the house blueprint or map, virtual representation of the UI. Furniture. DOM stores the furniture directly in the room's current state. React's reconciler tracks the furniture state in its map and updates only what's needed, the host versus the butler. The browser acts like a traditional host who rebuilds room entirely when changes occur, less efficient. React acts like a smart butler who compares the current map to the desired map and makes only the necessary updates, more efficient. Resetting the house. If the house is reset, page reload, the browser loses all furniture arrangements unless saved externally, like cookies. React ensures updates are managed efficiently as long as the butler is running, but it also requires persistent mechanisms like states or props for longer term storage. Why React's approach is better? React's reconciliation process minimize the effort required to manage changes, just like a butler who works smarter, not harder. By keeping a map and focusing only on differences, it ensures efficient and seamless updates compared to the traditional approach of rebuilding everything from scratch. You've got it. Let's break this down and address your question one by one while refining the greatest metaphor for understanding how the browser and React handle user interactions, especially on save input. First, browser rebuilding entire rooms versus React map updates. Browser DOM, traditional browser. The browser typically rebuilds the entire room, reparsing HTML, CSS, JavaScript whenever the page is reloaded. User input, like typing into a form, is temporary. It lives in memory as part of the DOM tree, but it is cleared during a reload unless explicitly saved elsewhere, like cookies or local storage. React reconciler. React doesn't rely on rebuilding the entire room every time a change happens. Instead, it compares the current map, virtual DOM, with the desired map and updates only the differences like moving a chair or adding a decoration. React can keep track of the type input in state, React's memory, or by relying on the DOM directly for uncontrolled components. Second, what happens when a user types without submitting? In both the browser and React, when a user types into a form field, the browser updates the DOM's value property of that input element in memory. This is not stored permanently anywhere like cookies or local storage. It exists only in the current session, tied to the active DOM tree. React adds extra control. If React is managing the form via control components, the input is synced with the state variable. React state ensures that even if the input element itself is cleared due to re-rendering, the type value persists in React's memory. For uncontrolled components, React relies on the DOM itself to maintain the current value, like how the browser does it. Why isn't the type data lost immediately? The browser in React for uncontrolled components temporarily stores the type data in the input element's value property as part of the DOM tree. This happens automatically without permanent storage because the browser treats input like living object with properties like input value equal hello. The value remains accessible until the page is reloaded or closed. The input field is explicitly reset. React enhances this by syncing the input value to its state for better control and reliability. The greatest metaphor, the dynamic house with temporary nodes. Let's revisit the house metaphor to explain this magic. The house furniture and notepad. Think of the furniture as the DOM elements like input fields, form data, etc. Each room in the house has a small notepad pinned to the wall, input fields value property. When a guest user writes on the notepad types into an input, the note is temporarily visible to everyone in the room as long as the party lasts current page session. What happens when the guest moves furniture from submission? If a guest moves furniture from submission, the change is recorded permanently in house blueprint, backend server, local storage, etc. If they don't move furniture and just leave notes, the type without submitting, the notes are temporary and will disappear when the party ends. Page reload. How does React help? React has a smart assistant in each room. For controlled components, the assistant copies every note input value to a central ledger, React state in real time. Even if the room resets, the ledger can restore all notes. For uncontrolled components, the assistant trusts the notepad in the room input field and only checks it when needed. What if the house is reset, page reload, without saving notes to an external ledger, local storage, cookies, all notes and their context disappear. Summary of the metaphor. Browser DOM. Each room, DOM element has a temporary notepad value property. Notes exist only during the current party.
page session. A reset, reload erases everything unless saved externally. React Reconciler. A smart assistant tracks changes and updates only what's needed. For controlled components, the assistant uses a ledger state to record notes, ensuring persistence even if the room temporarily resets. For uncontrolled components, it trusts the notepad until the session ends. Great question. Let's clarify what is meant by React keeping track via the virtual DOM and how it relates to the initial HTML or DOM tree sent to the browser. React and virtual DOM, what it tracks, initial HTML or DOM tree sent to the browser. When a React application loads, the browser receives an initial HTML file. This file is usually minimal, containing just a div id equal root, div or similar placeholder. React then takes over and dynamically renders the UI using JavaScript. This process creates a full DOM tree in the browser based on React components. Virtual DOM. React maintains a virtual DOM, which is an in-memory representation of the current UI. Think of it as a blueprint or map of the house, your application state and structure. The virtual DOM is not the same as the initial HTML sent to the browser. Instead, it is continuously updated as the user interacts with the app. Used by React to calculate what needs to change in the real DOM without re-rendering everything. What does React do with the blueprint virtual DOM? Initial state. React builds an initial virtual DOM that matches the component's default state or props. This blueprint is then used to create the real DOM furniture arrangement in the house. Tracking changes. When the user interacts, like types into a form, clicks a button, React doesn't directly modify the real DOM. Instead, it updates the virtual DOM first, reflecting what the UI should look like after the change. Reconciliation, detecting differences. React compares the previous virtual DOM before the change with the updated virtual DOM after the interaction. It calculates the difference called a diff and updates only the affected part of the real DOM. The blueprint and house metaphor. Initial construction. When the app starts, the initial HTML, just the div id equal root, is like an empty lot. React uses its initial blueprint, virtual DOM, to construct the first version of the house, real DOM. Updating the house. Every time the user interacts, moves furniture, or writes on a notepad, React doesn't immediately rebuild the house. Instead, React updates the blueprint, virtual DOM, to reflect the desired changes. It compares the old blueprint with the new blueprint to see what's different. Only the affected furniture or decorations are updated in the real house. Efficiency. Traditional methods, like reloading a page, would rebuild the house from scratch for every change. React uses its blueprint to minimize work, ensuring only the necessary updates are made. What about the browser's role? The browser itself doesn't know about React's virtual DOM. It only works with the real DOM. React uses the virtual DOM as a middle layer to decide how and when to update the real DOM efficiently. So, is the virtual DOM the same as the initial HTML? No, the virtual DOM is not the same as the initial HTML or DOM tree. Here's why. Initial HTML. This is the minimal file sent to the browser when the React app loads. It usually contains little more than a placeholder like div id equal root. Virtual DOM. This React's dynamic blueprint of the app, built entirely in memory. It evolves with user interactions and guides how the real DOM should be updated. Key difference. The initial HTML is like the empty lot sent to the construction crew browser. The virtual DOM is the dynamic blueprint React uses to keep the house UI up to date as users interact with it. When the browser receives the initial HTML file, React takes over by hydrating the app and taking control of the DOM from there. React does not need to be in the same directory as the initial HTML file, but the JavaScript bundle containing React's logic needs to be loaded and executed after the initial HTML file. Let's break this down step by step, including the algorithm, data structure, and the greatest metaphor to understand this better. First, how does React take over after the initial HTML is loaded? Here's how the process works. Initial HTML is served. When a React-based web application is accessed, the server serves the initial HTML file. This HTML is minimal, typically containing a div, like div id equal root, as a placeholder for the React app. JavaScript bundle. Along with the HTML, the JavaScript bundle, which contains React and your app's code, is loaded by the browser. This bundle is typically created by tools like Webpack or Vite, and it contains the necessary React code that drives the app. React takes over. Hydration. Hydration is the process where React attaches itself to the existing DOM. It looks at the initial HTML, the static markup, and takes control of the relevant parts of the page. React renders the app dynamically from the JavaScript using the React DOM.render or React DOM.hydrate for the server-side rendering function. The placeholder div id equal root becomes the root of the React app, and React uses the virtual DOM to update and manage the DOM. Does React need to be in the same directory? No, React doesn't need to be in the same directory as the initial HTML file, as long as the JavaScript bundle is correctly referenced in the HTML file. Typically, the initial HTML will link to the JavaScript file via script tags that contains all the React logic. These JavaScript files are usually in dist/or build/folder. Second, the algorithm and data structure for React to take over. Algorithm for React to take over. Initial load. The browser loads the static HTML content, a minimal shell, often with just the div id equal root. JavaScript file loads. The JavaScript file is loaded via script src equal path/2/bundle.js script. This JavaScript file contains the React code and any other app-specific JavaScript. React DOM renders. React DOM.render or React DOM.hydrate in SSR is called in the JavaScript file. React looks for the DOM element with id equal root and start hydrating it, attaching React to control to it. React updates the real DOM. React constructs the virtual DOM, a JavaScript object representation of the UI. React compares the virtual DOM with the real DOM, the HTML the browser initially rendered. React applies only the differences between the virtual DOM and the real DOM, updating the UI efficiently. Data structures involved. Virtual DOM. The virtual DOM is an in-memory JavaScript object that mirrors the structure of the actual DOM. Each component in the React app has a virtual DOM node which corresponds to an element on the real DOM. React Fiber. The React Fiber architecture is a data structure and algorithm that enables asynchronous rendering in React. React Fiber works by breaking the updates into chunks, allowing React to prioritize and process the updates without blocking the main thread. This data structure is a tree-like structure that mirrors the real DOM's node tree, but with extra information to manage rendering cycles and scheduling. The greatest metaphor. React taking over the house. Imagine you're walking into a house that just been built, but it's only partially furnished. Here's how the metaphor works. Initial HTML, the house frame. The server gives you the blueprint HTML of the house, which is basically an empty house with no furniture. This is like a skeleton. The walls are up, but there are no rooms, no doors or windows, just placeholders. React, the furnishing crew. React, acting like the furnishing crew, enters the house and begins filling the empty rooms. The furnishing crew looks at the blueprint, virtual DOM, and calculates what furniture should go where. Instead of going room by room and rebuilding everything, The crew looks at the existing furniture, the real DOM, and decides what needs to be added, moved, or updated based on the blueprint, virtual DOM. Efficient updates. The crew doesn't have to refurnish the entire house every time you move a chair, like change the UI. They focus on just the pieces that need rearranging or new items that need to be added. If you make a small change like moving a chair or changing a painting, only that part of the room is updated rather than rebuilding the entire house. Hydration. When React takes over, it's like the crew starting to manage the house, even though the house was empty, just a placeholder with no furniture. React now brings everything to life and manages the house details, UI efficiently. The initial furniture, the HTML markup, is like the empty house, and React adds or updates the furniture, DOM, based on the blueprint, virtual DOM. Conclusion. React takes over by hydrating the initial HTML with its dynamic content, utilizing the virtual DOM as its blueprint. The JavaScript bundle allows React to take over and start managing the app state and UI dynamically. The Fiverr architecture and virtual DOM helps React efficiently calculates and apply chains only where necessary. This process ensures that React doesn't rebuild everything from scratch, but rather optimizes updates, ensuring the house UI stays functional and responsive with minimal effort. Great question. Let's break this down and clarify things for you. First, what is hydration? Hydration is a concept used in server-side rendering and does not imply that React switches to a full server-side rendered application. Instead, it refers to React taking over the static HTML generated by the server and attaching interactively to it on the client side. Server-side rendering. In SSR, the server generates the HTML content on the server side and sends it to the browser as a fully rendered page. This is useful for faster initial page loads and SEO. After initial HTML is loaded, React hydrates it by attaching event listeners and state management like rendering components dynamically without rebuilding the entire page. Single page application (SPA). In a traditional React SPA, the browser loads an empty HTML file with minimal content, often just a div with an ID equal root, and then React takes over by rendering components to that div. React does not involve SSR here, and all rendering and updates happen in client side. So hydration is only relevant in SSR scenarios. React can still be used in a simple single page application where the content is rendered entirely on the client side without any SSR involved. Second, does React use the diffing algorithm in single page applications? Yes, React always uses the diffing algorithm regardless of whether the application is a single page app or a server-side rendered app. Here's how it works. Virtual DOM. When you update a React component, React doesn't directly change the real DOM immediately. Instead, it updates the virtual DOM, an in-memory representation of the UI first. Diffing algorithm. React compares the old virtual DOM with the new virtual DOM. This is called the diffing process to determine what has changed. It then calculates the minimal set of changes that need to be made to the real DOM and only applies those changes, ensuring performance is optimized. SPA and diffing. In the context of a single page applications, SPA, when a user interacts with the app, like clicks a button, types in a form, React updates the virtual DOM. React then diffs the virtual DOM with real DOM to identify differences. Only the differences between the virtual DOM and the real DOM are then applied, which is an efficient update process. React does not re-render the entire page or DOM on every change. It just updates parts of the page that needs to be updated. Third, SPA versus SSR and hydration. Let's use a metaphor to clarify the difference between SPA and SSR, especially regarding hydration. SPA. Imagine a play that takes place on a stage. At first, the stage might be empty, but as the play begins, actors, components enter the stage and perform. When the actors, components move around or interact, stage changes. Only the parts of the stage relevant to the performance are changed. The stage itself remains intact, no reloading or re-rendering of the entire page. SSR with hydration. Now, imagine you get a pre-drawn stage design, server-generated HTML, which you already know how it's going to look. When the audience browser arrives, the play starts and the stage HTML is already set up. But when the browser begins, React App starts, the actors, React components take over and make the stage interactive, hydrating it. Even though the stage was pre-built, the actors can still interact with it dynamically and make small changes on the fly without redoing everything. Conclusion: SPA, React uses its diffing algorithm to efficiently update only the parts of the UI that change based on the user interaction. It doesn't re-render the entire page every time. SSR with hydration, React takes over a statically generated HTML page from the server and hydrates it, making it interactive. This is more useful for SEO and faster initial page loads, but once hydrated, it behaves like a regular SPA. React diffing algorithm. React always uses the diffing algorithm in both SPAs and SSR apps. It compares the virtual DOM to the real DOM and applies only the necessary changes to minimize performance overhead. Let's break it down and create some great metaphors to understand how bundling works and what tools like Webpack and Vite do. First, what is bundling? Bundling is the process of combining multiple files such as JavaScript, CSS, images, etc. into a smaller number of files, typically one or a few, to improve performance in web applications. It reduces the number of requests a browser has to make to load all the resources, which improves page load times. Think of building like packing. Imagine you're organizing a shipment of goods that need to be delivered to different rooms of a house. Instead of sending each item separately, which would take a lot of time and effort, you decide to pack everything into a few large bundles. These boxes contains all the necessary items and will be shipped in a way that reduces time and cost for delivery, performance optimization for the web. Second, how does bundling work with Webpack? Webpack is one of the most powerful building tools for JavaScript applications. Here's how it works. Webpack process. Entry point. Webpack starts with a single entry file, usually index.js or app.js, and begins tracing all the dependencies that the application needs. This is like identifying all the rooms in-house that need to be furnished with different kinds of furniture. Dependency graph. As Webpack traces dependencies, it creates a dependency graph of all files that are needed: JavaScript, CSS, images, etc. This graph is like a blueprint of your house, showing how all the rooms components are connected to each other. Transformation. Once Webpack knows about all the files, it transforms these files using loaders or plugins into a format that's optimized for browsers. This could involve minification, shrinking the size, compiling, like TypeScript to JavaScript, and other tasks. This step is like assembling the furniture and ensuring each piece fits perfectly into the right room. Bundling. Finally, Webpack combines all the files into a few bundled files, often bundle.js. It's like packing all your transformed and optimized furniture into boxes, bundles, and sending them to the browser for delivery. Metaphor for Webpack. Webpack is like a highly organized moving company that, upon arriving at your house, gathers all the pieces of furniture from various rooms, assembles them to ensure they fit perfectly, and then packs them into boxes so they can be easily delivered to your home. Third, how does Vite work? Vite is a newer and faster bundling tool compared to Webpack, and it introduces several optimizations that make it much faster, especially during development. How Vite works. Development mode. Vite uses native ES modules, ESM in the browser. When you start your project, Vite doesn't bundle everything up front. Instead, it only sends the specific modules that are needed for the page to load. This is like unpacking the first few boxes you need to get the house ready, and then only unpacking additional boxes as you need them on demand. Hot Module Replacement, HMR. Vite has fast HMR, meaning when you change a file, like JavaScript, only that file is updated in the browser without refreshing the entire page. This is like replacing a single piece of furniture in your room without having to move the whole house around. Bundling for production. When you're ready to deploy your app, Vite uses Rollup, another bundler, to bundle the files for production. This process involves tree shaking, removing unused code, and minification, shrinking the code. This is like optimizing the furniture so it fits perfectly and efficiently in the rooms before shipping everything. Metaphor for Vite. Vite is like a super efficient home designer who doesn't need to bring in all the furniture at once. It starts by unpacking only the essential needed to set up the house on demand, and as you work development, it quickly replaces or updates the furniture when needed. When the house is ready, production, it ensures all the furniture is optimized and neatly arranged before final delivery. Production build. Fourth, summary of Webpack and Vite in metaphors. Webpack, imagine a moving company that organizes, assembles, and packs all the furniture from every room into a few large boxes, bundles, ensuring everything is ready to be delivered efficiently to your home browser. Vite is like a home designer who unpacks only the essential at the beginning, during development, and optimizes everything for final delivery, production with minimal wait time. The key differences: Webpack focuses on bundling everything up front, especially useful for large, complex applications. Vite focuses on fast development by loading only what's needed at the start and updating files quickly with hot module replacement. Yes, React Fiber's method of breaking updates into chunks and processing them in a non-blocking way is similar to how Node.js handles asynchronous operations, but there are key differences. Let's dive into that analogy and break it down. React Fiber and Node.js async behavior. React Fiber. React Fiber is the reconciliation algorithm introduced in React 16 that allows React to efficiently update the user interface. It works by breaking the updates like re-rendering components into smaller chunks of work and processing them incrementally. This approach avoids blocking the main thread so the app remains responsive while updates happen in the background. Breaking work into chunks. Imagine you're trying to clean a huge room, but instead of trying to clean it all at once, which would take a long time and potentially block you from doing anything else, you decide to clean a small sections at a time. This way you can clean quickly and still have time to take breaks or even do other tasks. Prioritization. React Fiber gives different priority to updates, ensuring the most important updates like user interactions are processed first, while less critical updates like background processes are done later. Non-blocking, just like cleaning small sections without stopping completely, React Fiber allows other tasks like handling user input to keep running while it's processing the updates. Node.js and asynchronous handling. Node.js is an asynchronous event-driven JavaScript runtime that handles I/O-bound operations, reading files, making HTTP requests, querying databases, without blocking the execution of other code. It achieves this through a single-threaded event loop and callbacks, or more modern async/await, which allows it to process operations in a non-blocking way. Event loop. The event loop is like a task manager that goes through the list of tasks, operations like I/O, execute them one by one, and doesn't stop for any task. If a task is I/O heavy, it simply delegates that task to the system outside the main thread and continues running the next task.
Non-blocking I/O. Imagine a person trying to process a series of tasks like reading a book, cooking a dinner, and checking emails. Instead of sitting idle while the dinner is cooking, they move on to the next task, checking emails while the cooking is happening in the background asynchronous. The similarities between React, Fiber and Node.js asynchronous handling, non-blocking. Both React Fiber and Node.js work in a way that ensures the main thread is not blocked. React Fiber does this by breaking updates into chunks, and Node.js does this by offloading I/O tasks and moving to other tasks in the meantime. Efficiency. React Fiber and Node.js ensures that tasks or updates that are less time sensitive are not blocking more important operations. For instance, React prioritizes user interactions and Node.js handles I/O operations asynchronously to prevent bottlenecks. Incremental work. Both systems process tasks incrementally to improve efficiency. React does this by breaking updates into chunks, while Node.js handles multiple asynchronous tasks without waiting for each one to finish before moving on. The key difference: React Fiber focuses on the UI rendering process, breaking down the UI update work to ensure the browser's main thread remains responsive to user interactions, even for large, complex updates. Node.js, on the other hand, handles asynchronous tasks like I/O, files, databases, APIs, ensuring that operations like fetching data or reading files don't block the main execution flow. Metaphor for both. Imagine you're hosting a big party, the main thread, React Fiber. You need to decorate a big room, the UI. Instead of doing it all at once, which will block your time, you decorate a small sections at a time. You can stop to chat with guests, user interactions, or handle emergencies, higher priority tasks. Node.js, you're also cooking food, handling I/O in the background. Instead of waiting for the food to cook before doing anything else, you put the pot on the stove, like I/O operation, then go talk to guests or do other tasks while the food is cooking. Both approaches allow the main event, the party of the application, to continue smoothly without blocking or stalling. In summary, React Fiber's chunk processing of UI updates is similar to how Node.js handles asynchronous data, in that both focus on non-blocking operations, allowing other important tasks to proceed without delay. Yes, React automatically converts its JSX syntax to JavaScript, and the resulting JavaScript uses the JavaScript DOM API to interact with the browser's DOM. Let's break this down further. React JSX to JavaScript conversion. React uses JSX JavaScript XML, a syntax extension for JavaScript that allows you to write HTML-like code in your JavaScript files. However, browsers do not understand JSX directly, as it's not valid JavaScript syntax. So React relies on transpilers like Babel to convert JSX into pure JavaScript. JSX conversion. JSX elements like div, h1, etc. are converted into JavaScript objects, React elements that describe the DOM structure but not the DOM itself. The JSX syntax gets transformed into React.createElement calls, which return React elements. These elements are later used to render the UI. For example, this JSX, like this code. Building the dist folder, bundle. When you run a build process, typically using bundlers like Webpack or Vite, React's JSX code gets compiled into JavaScript that browser can understand. The final output, called the bundle, is stored in the dist folder or another configured folder. This bundle contains all the JavaScript code, including React code and app-specific logic, the compiled and optimized version of any dependencies, the React library code itself, since React is a dependency, virtual DOM, and the browser's DOM. Once the JavaScript is executed in the browser, React uses its virtual DOM, an in-memory representation of the real DOM, to manage the UI updates. The virtual DOM is like a blueprint of the DOM that React uses to figure out what needs to change. Here's how it works. Initial render. React creates a virtual DOM from the JSX components. It compares this virtual DOM with the actual DOM in the browser, the real DOM. Diffing algorithm. React's reconciliation algorithm, often referred to as the diffing algorithm, calculates the differences or diff between the current virtual DOM and the previous virtual DOM. Updates. React then calculates the minimal set of changes necessary to update the real DOM. It doesn't update the entire DOM, just the parts that have changed. JavaScript DOM API. React uses the JavaScript DOM API, like document.createElement, append child, set attribute, etc., to make those updates. These are the sample browser APIs you'd use to manually manipulate the DOM with the JavaScript. The crew and the blueprint metaphor. To understand this in terms of metaphor, crew, browser. The browser's job is to follow the plan, the DOM, and execute it to display the content. The crew, browser, can follow the plan but needs specific instructions on how to arrange the furniture, UI elements. Blueprint, virtual DOM. The virtual DOM is the blueprint or a plan of the house UI. It's just a map of what's the room UI should look like, but it's not the actual room. Plan change. React updates. When a change happens, like user input, a button click, React calculates the difference between the previous blueprint and the new blueprint, the virtual DOM. It's like updating a house plan where some rooms need to be changed or added. Crew implements the change. JavaScript DOM API. The real crew, the browser, follows the updated blueprint and makes the necessary changes to the real house DOM using the DOM API. The crew will only adjust the areas where the plan has changed because React calculates the minimal updates required. In summary, JSX to JavaScript. React automatically converts JSX to JavaScript, which uses React's internal methods. React.createElement to create React elements. Build process. Bundlers like Webpack or Vite compile your React code and dependencies into JavaScript, and this is placed in the dist folder for deployment. Virtual DOM diffing. React compares the virtual DOM, the blueprint, with the real DOM, the actual house, calculating the minimum changes needed. JavaScript DOM API. React then uses the browser's JavaScript DOM API to update the real DOM based on these changes. So React's role is to manage and optimize the updates to the DOM by using a virtual DOM to efficiently calculate changes, ensuring that only necessary updates are made without full page reloads, thus improving performance and providing a smoother user experience. No, this app.js file is actually the main component file in Create React App template, not the Webpack configuration. What you're looking at is the root component that React renders into the DOM. In this file, you can see it imports the app.css styles. It imports a list component from /list. It defines a simple app function component that returns the list component. It exports the app component as the default export. The Webpack configuration in Create React App is actually hidden by default and handled behind the scenes by React scripts. If you needed to customize the Webpack config, you would either need to eject the Create React App using npm run eject, which would expose all the configuration files including Webpack. Use tools like React App Rewired or Krakow to override Webpack configs without ejecting. The actual Webpack config handles things like bundling all your JavaScript files together, processing CSS and other assets, setting up development server, optimizing the build for production, managing the dependency graph. I understand the confusion. Let me explain your house delivery analogy. Think of Webpack and entry points like index.js or app.js this way. Index.js is like the main door of your house, the entry point.
Even though the delivery company Webpack is hidden, they still need to know which door to start from. When someone visits your React app, the process goes like this. Index.js is the first file that runs. It's like opening the main door. Index.js typically renders app.js. Think of app.js as the main hallway that connects to all other rooms. From app.js, you can access other components like going from the hallway into different rooms, even though Webpack is hidden in Create React App. It follows this pattern, etc. The hidden Webpack still starts at index.js, follows all the imports like finding all connected rooms, bundles everything together like packing all rooms, contents into one efficient delivery, deliver this optimized bundle to the browser. So even though you don't see Webpack's config files, it's still working behind the scenes, using these entry points to efficiently package your app. This is why these files remain important even when Webpack is hidden by Create React App. Great question. The browser receives bundle.js instead of index.js because Webpack performs several crucial transformations. Code transformation. Your modern JavaScript won't run directly in all browsers. Webpack plus Babel transform it into browser-compatible JavaScript. It handles things like converting import or export statement that browser don't natively support. Bundling process, like this code. What Webpack bundle.js convert to. Function modules, Webpack's runtime code, transform version of your files, all dependencies bundled together. 0. Index.js content. 1. React library. 2nd. App.js content. 3rd. Styles.css content. Then all other dependencies. Single file delivery. Without bundling, browser would need to make separate HTTP requests for each import. With bundling, one HTTP request for bundle.js that contains everything. This is much more efficient for performance. Think of it like this. Index.js is your shopping list. Bundle.js is the packed grocery bag that contains everything from that list, prepared and organized for use. This is why you'll see bundle.js or something similar like main12345.js in your browser's network tab instead of your original source files. Advantage and disadvantages of functional programming. Functional programming emphasizes immutability and pure functions, meaning no changes are made to data passed into a function. Let's break this down. Advantages, predictability. Since functions do not modify external data or their arguments, the same inputs will always produce the same outputs. This makes debugging easier. House metaphor. Imagine you cannot modify your house structure after it's built. Everything is fixed in place, so you always know where every room is, no surprises. Easier to test and maintain. Immutability, avoid side effects, making it easier to write unit tests and maintain the code base. House metaphor, if you know your house design will never change, any future work like painting or redecorating is simplified. Concurrency, FP is inherently thread-safe because immutability eliminates race conditions. House metaphor, multiple people can live in the house without worrying about someone randomly tearing down walls. Reusability and modularity, pure functions can be reused in different parts of the program without unintended consequences. House metaphor, reusable modular furniture that can be moved between rooms without altering the house itself. Disadvantages, performance overhead. Copying data to ensure immutability can result in performance issues for large datasets. House metaphor, if you want to rearrange furniture, you must create new furniture instead of moving the old ones, wasteful and time-consuming. Less intuitive for beginners. For those used to object-oriented programming, the idea of immutability and avoiding state changes can feel restrictive. House metaphor, you might feel frustrated that you can't remodel or extend the house as needed.
Limited by immutability, you cannot add properties like name or age to an immutable object at runtime. House metaphor. Once the house is built, you cannot add new room. Any new requirement means building a new house. Declarative programming versus object-oriented programming versus functional programming. Declarative programming focuses on what you want to achieve rather than how to do it. House metaphor. Imagine describing to a builder, I need a house with 2 bedrooms and a garden. You don't worry about the construction process. Interconnection with FP. Both are high level and abstract, emphasizing the desired outcomes. Object-oriented programming, OOP, focuses on objects, encapsulating state and behavior together. House metaphor. A house where each room is self-contained object with its own purpose and properties, such as a bedroom with a bed and closet. Interconnection with FP. OOP encouraged mutable states unlike FP. However, both aim for modularity and reusability but achieve them differently. Greatest house metaphor. Functional programming. Immutable blueprints. The house blueprint is fixed. Any change requires creating a new blueprint, ensuring the original stays untouched. Rooms. Functions are self-contained, never modifying each other and always producing the same results. Declarative programming. Architect's vision. You define the desired outcome, 3-bedroom house with garden, and let the builder, compiler, or runtime figure out how to achieve it. Object-oriented programming. Customizable rooms. Each room has specific properties, color, furniture, and can be modified independently, but changes might unintentionally affect the entire house. Shared states. Summary of adding properties in FP. In functional programming, you cannot add properties like name or age directly to a list passed to a function because it would violate immutability. Instead, you return a new list with additional properties, leaving the original unchanged. Metaphor for adding properties. In an FE house, if you want a new room, you don't build onto the existing house. Instead, you design and construct a completely new house with the extra room included. This is a photo of a residential house with a small front area covered by a roof. If you're asking about plumbing or construction materials suitable for this house, here are some suggestions based on typical use cases. For plumbing, pipes and fittings, use PVC pipes for clean water supply, galvanized iron pipes or HDPE pipes for durability in outdoor plumbing, ensure proper pipe insulation for exposed areas to prevent leaks or degradation, etc., etc. Inheritance. Some CSS property values set via CSS rule for parent elements are inherited by their children or child elements. For example, if you specify a color and font family for an element, every element in it will also be styled with that color and font unless other color and font values have been explicitly applied to it directly. For example, though other CSS rules, some properties, on the other hand, such as those for defining border, are not inherited. Otherwise, setting a border for a single element would result in the same border being displayed for all child elements, which would be a bit too much for a good thing. Applying colors and text formatting. In this section, I'll show you how to use CSS to define the color of elements on a web page and how to format text. Defining the text color and background color. To define the color of a text or the foreground color in general, you can use the CSS property color. You can define the color value in several different ways. RGB values. In this case, you define the value as a composition of red, green, and blue components where each component is expressed by a number between 0 and 255. For example, the CSS value RGB 2552550 represents the color yellow. Hex values. In this case, you define the value as a 6-digit hexadecimal value with 2 digits each for the red value,
2 digits for the green value and 2 digits for the blue value. For example, the color yellow would be represented with the CSS value #FF00. In addition, a short notation is used for 216 web colors, for example, #FF0 for #FFF00 or #F90 for #FF9900. Color names. In this case, you specify the color name of the desired color. Over 140 predefined color names are available. For example, you would define the color yellow using the name yellow. In addition, exotic color names are available like hot pink, deep sky blue, or lavender blush. A detailed overview of the available color names can be found at www.w3.org. RGBA values. Since CSS3, you can also define color values using an RGB value with an additional value for specifying the opacity, called the alpha value. This value is between 0.0 and 1.0 and determines how transparent the color is. For example, you would define yellow of 50% using the CSS value RGBA 255, 255, 0, 0.5. HSL values. Also, since CSS3, you can define color values based on HUE, saturation, and lightness. HUE, is expressed as an angle between 0 degrees and 360 degrees, and saturation and lightness are percentages. For example, you would define the color yellow using the CSS value HSL 60, 100, 50. HSLA values. Similar to the definition of RGBA values, in the case of HSL, since CSS3, you can specify a font value for determining opacity. A yellow of 50% in this case would have the CSS value HSLA 60, 100, 50, 0.5. Some examples of defining colors using CSS are shown in listing 3.11. Defining text colors via color names, hexadecimal values, and RGB values. You can set the background color of an element using the CSS property background-color. For this property, you can use the same values as for the color property, like RGB values, hexa values, color names, etc. Listing 3.12, defining background colors via color names, hexadecimal values, and RGB values. Designing text. Using CSS, in addition to defining text colors, you can influence the basic appearance of text on a web page. For example, you can define fonts, adjust font sizes or styles, and adjust the spacing between words, word spacing, or individual letters, letter spacing. Figure 3.5 shows some text formatting options possible using CSS. We'll look at the CSS properties in detail in the following sections. The result of the Figure 3.5, the result of text formatted with CSS. Defining fonts. First, CSS can define the font for a text. The only requirement for displaying the font correctly when the corresponding web page is called up is that the font must be installed or available on the computer. The property for specifying the font is called font family, and this property expects the name of the detailed font as its value. Optionally, you can specify multiple fonts separated by commas. These fonts then serve as fallback fonts. If the font you specified first in the list is not installed on a computer, the browser then has the option of falling back on other fonts specified in the list. As shown in listing 3.13, for example, the Times New Roman font is first defined for the body element. If this font is not available on a computer, which is rare because this default font is available on all computers, but for demonstration purposes, let's assume this is the case. Then the browser can fall back to the more general Times font family and use a font from this family. If neither is available, the serif specification says that the browser may use any serif font. Note, if the name of a font contains spaces, the entire name must be enclosed in quotation marks. For good style, you should always specify the general name of a font as a fallback font last when using font family. Possible values in this context include following: serif, serif font, that is, a font with small hooks on the main strokes of the letters, commonly used in printed text. Sans serif, sans serif font, that is, a font without small hooks but with straight letter ends. As a rule, sans serif fonts are more suitable than serif fonts for displaying text on screens because they are easy to read regardless of the screen resolution due to the comparatively less detail. Monospace, non-proportional font, that is a font in which all characters have the same width. This type of font is particularly well suited for displaying source code on a web page. So for example, if you're writing a blog about web development and want to include code samples, you might use a non-proportional font. Cursive font or italic font, that is a font that looks as handwritten. I would recommend this type of fonts for a web page design only in exceptional cases. For example, to set visual accents, but not for the display of continuous text. Fantasy font, that is a font that contains decorative elements and like the cursive/italic font is more suitable for discrete use and not for displaying continuous text. Adjusting the font size. You can modify the size of a font using the font size property. Several options are available when specifying font size. Among other ways, you can specify font size via a pixel value, a percentage value, or the M unit of measurement, which is based on the width of the letter M. Pixel values specify the size of a font in screen pixels. A font with specification 14 px per pixel is exactly 14 pixels high. The specification of font size in percentages is based on the standard font size, which is preset in the browser or has been configured by a user through computer settings. By default, most browsers use a font size of 16 pixels. Thus, if you specify a font size for heading as 150%, for example, the font size of the heading will be 24 pixels. The specification of font size using the M unit is also based on the font size. For example, as shown in listing 3.14, the font size for headings is set to 1.5 times the font size used in each case. Listing 3.14, adjusting font size with CSS. Adjusting the font style. The font style of a text, that is, whether the text is to be displayed in italics or bold, can be specified via the font-style italics or font-weight bold properties. The font-style property takes one of the following values. The italic value provides italic text, and the oblique value provides oblique text. See the box for the differences between italic and oblique. The normal value provides normal text, i.e. neither italic nor oblique. With the font weight property, you can specify the weight of a font, that is whether the text should be displayed normally, normal value, or bold, bold value. In addition to these two values, lighter and bolder are also available, which makes the text one level thinner and bolder respectively than the text of its parent element. Furthermore, individual gradations can also be defined as numerical values in hundreds between 100 and 900. For example, the normal value corresponds to the numeric value 400, while the bold value corresponds to the numeric value 700. Listing 3.5, adjusting font style with CSS. Note, the difference between italic and oblique is subtle. In the former, the browser should display the text in a font style where the characters of the font have been specially optimized and designed for italic printing. If no special font style is available for a font, the oblique value forces the browser to tilt the corresponding font. However, the result is usually not as visually appealing as with the real italic font. Other font formatting options.
In addition to formatting font size, and font style, CSS offers many other ways to format fonts. You can use the text transforms property to switch between different notations. The uppercase value represents the entire text in uppercase and the lowercase value in lowercase. By using capitalize, you can specify that the first letter of each word in a text should be capitalized. The text decoration property allows you to decorate text by using lines, that is to strike through line through value or underline, to draw a line across the text, overline, and even to make the text blink. However, you should avoid the latter if possible, as blinking text on a web page can be annoying. You should also avoid underlining text because underlined text is usually interpreted by users as a link. Users might be confused if no link opens when they click on the text. To influence the line spacing of a text, you can use the line height property. The spacing between individual letters, letter spacing, can be controlled by using the letter spacing property, while the spacing between individual words, word spacing, can be managed via the word spacing property. You can manipulate the horizontal alignment of the text using text align property. Possible values are left alignment, right alignment, center alignment, and justified alignment. The vertical alignment, on the other hand, is determined by the vertical align property. Text can be aligned top, bottom, or middle. The text indent property can be used to indent the first line of text. The text shadow property can be used to add a shadow effect to text. Formatting links. Links are a special case of text and are specially marked by the browser by default, often underlined and in blue. You can use pseudo classes to customize the appearance and behavior of links via CSS. The pseudo class is used in the following selectors as shown in listing 3.16. Link allows the formatting of links that have not yet been visited. Visited allows the formatting of links that have already been visited. Hover allows the formatting of links when touched by a mouse cursor. Active allows the formatting of links the moment they are clicked on. Focus allows the formatting of links when they receive focus. Complete example, designing text. The full code for the web page shown in figure 3.5 earlier in the section is provided in listing 3.17. In this example, we've included several CSS properties for formatting text. Look at the CSS code and the HTML code at your leisure and try to understand which CSS rules apply to which HTML elements. Of course, the best way to explore this code interactively is to download the source code for the listing from the web page for this book and open it in a browser. The developer tools of modern browsers such as Chrome, DevTools are also useful in this regard. Use these tools to examine exactly which CSS rules are applied to which HTML elements. Listing 3.17 Formatting text with CSS. Practical tip. In practice, you may no longer have direct overview of which HTML element is affected by which CSS rule or why an element is assigned a certain property, whether explicitly or through inheritance. In this case, the browser developer tools, for example, Chrome DevTools, can help. Within the Elements section, various features are available. For example, the Styles tab lets you view the application CSS rules for a selected element as shown in figure 3.6. The Computed tab, on the other hand, provides information about which properties have been assigned to an element as shown in figure 3.7. This information is interesting, for example, if multiple CSS rules apply to an element. 3.3 List and tables. Components like lists and tables can be customized using CSS. In this section, we'll look at what CSS properties are available for these elements. Designing list. In the case of list, you can primarily customize the bullets of individual list entries. Use the list style type property to specify their appearance. Depending on whether the list is an unordered list or an ordered list, different values are possible for this property. Formatting unordered list. Unordered list or list where the individual list entries are not sorted. By default, each entry is preceded by a block dot as a bullet. For this type of list, you can choose between the following values for the list style type property. None, no bullet is used. The bullet is a block circle. Circle, the bullet is a white circle with the block borders. Square, the bullet character is a block square. Listing 3.18 and figure 3.8 shows a simple example of customizing bullets. Designing ordered list. Ordered lists are lists where the individual list entries are sorted in some way. For this type of list to manipulate the appearance of the bullets and thus the appearance of the sorting, you can use the following values for the list style property among others. Decimal, enumeration in decimal numbers, decimal leading dash 0, enumeration in decimal numbers preceded by 0 for 1, digital numbers 01, 02, 03, 09, 10, 11. Lower dash alpha, enumeration in lowercase letters of the alphabet, A, B, C. Upper dash alpha, enumeration in uppercase letters of the alphabet, A, B, C. Lower Roman, enumeration in Roman numerals represented by lowercase, I. Upper Roman, enumeration in Roman numerals represented by uppercase letters. In listing 3.19, for example, bullets are presented as Roman numerals. The result is shown in figure 3.9. Using images as bullets. In addition to configuring bullets via the list-style-type property for an ordered list, you also have the option of defining a graphic to be used as the bullet. You can pass the path or URL for the desired image to the corresponding list-style-image property as shown in listing 3.20. Then the image is used as a bullet for list entries as shown in figure 3.10. Setting the position of bullet points. You can use the list-style-position property to customize the position of the bullet points. The outside value ensures that the bullet points are to the left of the text block, which is also the default if the position is not controlled via CSS. The inside value, on the other hand, ensures that the bullet points are positioned indented within the text block. This value works for both an ordered and ordered list. Figure 3.11, displaying indented bullets with the inside value. Designing tables. Tables always look rather plain at first without CSS as shown in figure 3.12. The good news is that the appearance of tables can be easily customized using CSS. In this section, I want to show you briefly which CSS properties are used to make tables shown in figure 3.12 more descriptive and to get to the result shown in figure 3.13. Figure 3.13, tables formatted with CSS are more appealing. Note, most of the CSS properties presented in this section can be applied to other elements in addition to tables. You already know some CSS properties commonly used for table design. For example, for adjusting the font-family, the font style, and font-weight, the text alignment, text align, the text color, and the background color, background-color. Thus, I won't discuss these properties further. In listing 3.22, I've highlighted new properties accordingly. Also highlighted are the pseudo classes or their corresponding selectors that have not yet been mentioned. Let's go through these properties and pseudo classes in order of occurrence. The border property is used to design borders. In this case, to design the border of the entire table, this property allows you to specify the width of the border, thin but pixel specifications are also allowed.
the style, solid, and the color, hashtag 60. Shorthand properties. The border property is a special kind of CSS property called a shorthand property because this property combines several other CSS properties. Border-width for setting the width of the border-style for setting the style, and border-color for setting the color. These properties in turn are also shorthand properties. For example, border-width is a shorthand property for the border-top-width, width of the top border, border-right-width, width of the right border, border-bottom-width, width of the bottom border, and border-left-width, width of the left border properties. The shorthand property for designing border is always useful when you want the border to look the same for all pages. This approach will save you some typing. The corresponding written out variants are also included in the listing for demonstration purposes. Usually, each cell of a table has its own border. You can use the border-collapse property to collapse these borders, collapse value. That is, that the individual cells share a border. You can use the padding property to define how much space should be between the content of a cell and its border. This property allows you to make the table more airy and less squat than the default. With the pseudo class first-child, you can select the first child element of a given element type. For example, the TD first-child selector selects all TD child elements. In other words, all cells in the first column. The selector in our example will print the text in the first column in bold. The -child open and close parenthesis pseudo class, on the other hand, can select child elements that are located at a specific position within the parent element. The position is passed as a parameter. In our example, we are selecting the cells of the second column to display these cells in italics and selecting the cells of the third column to align the text of these cells to the right. In addition, colon-child odd and the colon-child even can be used to select child elements that are at an odd position, or at an even position. In our example, we colored odd table rows with a different background color from the even table rows. Thus, with relatively little effort, tables can be made a lot more appealing than their default look. Like this code. Understanding different layout systems. Using CSS, you can precisely position HTML elements on a web page and thus influence the layout of the web page. In the early days of the web, tables were often more or less misused for positioning elements, using them as layout tables. Although tables in HTML should only be used for displaying table data, gradually, other possibilities were created called layout systems, which I'll describe in this section in their order of appearance. Basic principles of positioning with CSS. Before taking a closer look at layout systems, let's cover some basic principles of positioning elements. Block-level elements and inline-level elements. Basically, HTML distinguishes between block-level elements and inline-level elements. Block-level elements are always displayed by the browser on a new line, whereas inline-level elements are displayed where they appear in the text flow, as shown in figure 3.14. In other words, block-level elements are arranged vertically, inline-level elements horizontally. However, with the CSS property display, you can customize the behavior of elements with regard to text flow. The block value ensures that the element is considered a block-level element. The inline value accordingly ensures that the element is considered an inline-level element. Figure 3.14, block-level elements versus inline-level elements. Types of positioning. Via CSS,
You have basically different ways to position elements, no matter if block level or inline level as shown in figure 3.15. This positioning can be modified via the position property, static positioning, static value. In this case, the elements are positioned as they appear in the HTML code in the normal flow. Relative positioning, relative value. In this case, elements are positioned relatively upwards, to the right, downwards, or to the left based on their position in the normal flow. Absolute positioning, absolute value. In this case, elements are taken out of the normal flow and positioned in relation to the parent element. Fixed positioning, fixed value. In this case, elements are positioned relative to the browser window, also called the viewport. Sticky positioning, sticky value. In this case, elements behave similarly to fixed positioning in terms of positioning but scroll only to a specified point and then remain fixed in the viewport. Inherited positioning, inherit value. In this case, the positioning behavior is inherited from the parent element. Figure 3.15, comparing positions in CSS. In addition, elements can be positioned using the layout system mentioned earlier. Float layout. You can use the float layout to influence the behavior of elements in relation to the text flow. The corresponding CSS property float can be used to set elements to the left or right border of the surrounding HTML block, as shown in figure 3.16. For a long time, the float layout was the weapon of choice for arranging elements. Now, however, you have two alternatives, the flexbox layout and the grid layout, which are more suitable and which I want to describe in the next two sections. Nevertheless, I'd first like to explain the float layout using the forms as an example. We'll then implement the same form with the other two layout systems, and in this way, you can directly evaluate the different layout. Example, float layout for forms. Forms look even worse than tables by default, as shown in figure 3.17. However, the individual form elements behave normally. They flow with the text flow from left to right and from top to bottom because form elements such as label, input, and button are all inline level elements. Figure 3.17, the readability of forms is not particularly good by default. Forms can be customized using the float layout as shown in listing 3.23. Using the float property, the label, input, and button elements are aligned to the left and right of the surrounding form element. The overflow property in the form element also ensures that this element is extended in height accordingly to include all flowing elements. If you were to omit this property, these elements would protrude above the form elements, which would then be too small. In addition, some other CSS properties can affect the overall appearance of a form, such as the background color, rounded corners for the border of the form, text alignment, and more, but do not otherwise contribute to the positioning of the elements. However, the width and max width properties are still important as these properties enable you to specify a preferred width as well as a maximum width for elements. In our example, we defined a maximum width for the form as well as defined the widths of the labels and text fields in each case. Listing 3.23, designing forms using the float layout. Thanks to these adjustments, the form already looks much better. Figure 3.18, a form design with CSS. Flexbox layout. The Flexbox layout introduced with CSS3 is much more flexible than the float layout or the standard layout of blocked level elements or inline level elements. The main concept behind the Flexbox layout is to allow an element to dynamically adjust the width and height of its child elements to best fill the available space. A flex container accordingly expands the width and height of the child elements, the flex items, to fill the available free space or shrink them to prevent overflow. Unlike the regular layouts of vertically arranged
block level elements and horizontally arranged inline level elements. The flexbox layout is direction independent. In other words, this layout can be used for both vertical arrangements and horizontal arrangements as shown in figure 3.19. You can use various CSS properties to influence the display of the individual flex items, including alignment, shown in figure 3.20, expansion, shown in figure 3.21. Table 3.2 provides an overview of the CSS properties relevant to the flexbox layout. Property display refers to flex container. Description defines an element as a flex container with value flex. Sequence and arrangement. Flex direction. Flex container specifies the direction in which flex items are arranged in a flex container. Flex wrap. Flex container controls whether the flex container is single line or multi-line. Flex flow. Flex container shorthand property for flex direction and flex wrap properties. Order. Flex item determines the order of individual flex items. A numeric value representing the position of the respective flex item can be specified as the value. Alignment. Justify content. Flex container defines how the available space should be distributed among flex items. Align items. Flex container sets the default orientation of all elements for the other axis of the flex container. Align self. Flex item like align items but refers to individual flex items. Align content. Multi-line flex container defines the arrangement of individual flex items in multi-line flex containers. Extension. Flex basis. Flex item controls via numeric value how large an element can become along the major axis before it grows or shrinks. Flex grow. Flex item determines via a numeric value how much an element can grow in relation to its sibling elements. Flex shrink. Flex item determines via a numeric value by how much an element shrinks in relation to its sibling elements. Flex item shorthand property for the previous three properties. Table 3.2 CSS properties related to the flex box layout. Now you have the essential basics in a nutshell. Let's see how a form can be implemented using the flex box layout next. Example, flex box layout for forms. First, a few adjustments to the HTML code are necessary. The individual labels and text fields are each placed in pairs in div elements. These elements are then assigned the display property and its value is set to flex, which results in each of the state elements being interpreted as its own flexbox container. Labels and text fields are then arranged within each container with the flex property defining their extent. Text fields, value 2, have twice the width of labels, value 1. The justify content property with value flex-end also ensures that the elements within each container are arranged at the end, in this case on the right. The result of all this code is shown in figure 3.23. Listing 3.24, designing forms using the flex box layout. Grid layout. The flex box layout enables the flexible arrangement of elements. For complex layouts, however, the newer grid layout is more suitable. In contrast to the one-dimensional flex box layout, this two-dimensional layout involves the positioning of elements, the grid items, in a two-dimensional grid inside the grid container, as shown in figure 3.24. Individual elements arranged using the grid layout can therefore be arranged in 2 dimensions rather than just one, as is the case with the flexbox layout, making it much easier to implement complex layouts. Figure 3.24, the grid layout principle. As with the flexbox layout, a whole set of CSS properties are relevant for the grid layout. Table 3.3 provides an overview of these properties. Property display refers to grid container. Description defines an element as a grid container with value grid, grid definition, grid template columns, grid container, defines the number and size of the columns of the grid, grid template rows, grid container, defines the number and size of the rows of the grid, grid auto columns, grid container, defines the number and size of automatically created columns of the grid, grid auto rows, grid container, defines the number and size of automatically created rows of the grid, grid auto flow, grid container, defines how automatically placed elements flow within the grid, grid templates areas, grid container, defines the structure and position of grid elements defined via grid area, grid template, grid container, shorthand property for grid template areas, grid template columns, and grid template rows, grid container, shorthand property for grid auto columns, grid auto flow, grid auto rows, and grid template. Placement of grid items. Grid row start. Grid item defines the vertical start of a grid area. Grid column start. Grid item defines the horizontal start of a grid area. Grid row end. Grid item defines the vertical end of a grid area. Grid column end. Grid item defines the horizontal end of a grid area. Grid row, grid item, shorthand property for grid row start and grid row end. Grid column, grid item, shorthand property for grid column start and grid column end. Grid area, grid item, shorthand property for grid row and grid column. Alignment, justify self, grid item, defines the alignment of a grid item within the grid container. Justify items, grid container, defines the alignment of all grid items within the grid container. Align self, grid item, defines for a grid item how a single grid item is positioned along the cross axis. Align items, grid container, defines for a grid containers how the individual grid items are positioned along the cross axis. Justify content, grid container, defines the direction of the main axis along which grid items are oriented. Align content, grid container, defines how individual grid items are positioned along the cross axis. The cross axis is defined as whichever axis is not the main axis. Blank space, row gap, grid container, defines the distances between the individual rows of a grid. Column gap, grid container, defines the distance between the individual columns of a grid. Gap, grid container, shorthand property for row gap and column gap. CSS properties relevant to the grid layout. Table 3.3. Example, grid layout for forms. Even though our form example does not use the two-dimensional characteristic of the grid layout to its fullest extent, I hope that my example shows you how easy using this layout system is. First, as shown in listing 3.25, note that the div elements necessary for the flexbox layout have been omitted. The form element is defined as grid container via the display property via grid-template-columns. The number and width of the columns of the grid are defined. The number results from the number of values separated by space, whereas the width is given as a fraction, fr for fraction. So the value 1fr, 2fr defines two columns with the second column twice as wide as the first. You can also use the grid-gap property to define the spacing between the columns. Then, using the grid column property for the labels, text fields, and buttons, you can define exactly from which column to which column the elements should be arranged. The labels from column 1 to column 2, 1/2 in the text fields, and the button from column 2 to column 3, 2/3. The result of all this code is shown in figure 3.25. Listing 3.25, designing form using the grid layout. Figure 3.25, a form designed using the grid layout. Summary and outlook. The basic principles of CSS are not particularly complex as we've shown in this chapter. although implementing a particular layout in real life can be quite time consuming in some circumstances, so you won't get practical experience with CSS overnight. The only thing that helps in this way is to try it out and look at many examples. I hope I provided some useful examples in this chapter and that you feel motivated to deal more extensively with this important language. Key points. Let's summarize a few key points you should take away from this chapter. CSS rules allow you to define how the content of certain HTML elements should be displayed. CSS rules basically consist of two parts. You can use the selector to define which HTML elements a CSS rule should be applied to. You can use the declaration to specify exactly how these HTML elements should be displayed. Individual declarations in turn consist of a property and a value. You can include CSS in an HTML document in several ways, namely the following. External style sheets. In this case, you save CSS instructions as a separate file and include this file in the HTML document. Internal style sheets. In this case, you define the CSS instructions in the header of the HTML document. Inline styles. In this case, you specify the CSS instructions directly in an HTML element. You can use CSS to design all the components of a web page. For text, for example, the font style, text color, and alignment can be adjusted. We also showed you how to make lists, tables, and forms look appealing with CSS. CSS provides several layout systems for arranging elements. In the float layout, elements flow in the text flow, and you can interrupt this flow and arrange elements in new lines this way. With the flexbox layout, you can arrange elements in rows or columns and, among other things, specify the space that the elements take up in the process. The flexbox layout is a one-dimensional layout. In the grid layout, elements can be arranged in grids of any complexity. This two-dimensional layout is the most flexible of the layout systems we've mentioned. Recommended reading. To study CSS in more detail, I recommend the following books. Kit J. Grant, CSS in Depth, 2018. Eric A. Meyer, CSS Pocket Reference, Visual Presentation for the Web, 2018. Eric Meyer and Estelle Weil, CSS, The Definitive Guide, Visual Presentation for the Web, 2017. Leah Veru, CSS Secrets, Better Solutions to Everyday Web Design Problems, 2014. Peter Gaston, The Book of CSS3, A Developer's Guide to the Future of Web Design, 2014. Attentive readers will notice that this exact list was featured in our code example for designing tables in section 3.3.2. Outlook. Of course, this chapter is only an introduction to the CSS language. The language has a lot more to offer, including the following. Other features. CSS provides numerous other properties that we have not discussed in this chapter. For example, for defining background image or determining the width and height of elements. Animations. CSS allow you to animate elements on a web page by defining transitions between different values of properties. For example, you can use this method to slowly fade in elements, make them larger or smaller, or change their background color. Responsive design. This term refers to the ability of a web page to adapt its content to different screen sizes for desktop, smartphones, etc. Crucial in this context is the role played by what are called media queries, which enable you to apply or disable CSS rules depending on certain factors such as screen size. Chapter 11 discusses this topic. CSS frameworks. Sometimes a lot of effort is required to define CSS rules to make standard elements on a web page, such as form, elements, tables, and lists look appealing. CSS frameworks like Bootstrap, https getbootstrap.com, Semantic UI, https semantic-ui.com, or Materialize, materializecss.com, offer previewed style sheets that style standard elements accordingly. All you need to do is include the appropriate CSS files for the framework and possibly prepare the HTML structure accordingly, and the web page presents itself in the corresponding design or layout. In Chapter 9, we'll also discuss what are called CSS preprocessors, which can save you a great deal of typing when working with CSS. Now that you've learned the basics of the two languages, HTML and CSS, I want to introduce you to this JavaScript language in the next chapter and show you how to make web pages more interactive. Making web pages interactive with JavaScript. In this chapter, I'll provide a condensed overview of the language core of JavaScript. You'll learn how to store individual values in variables and perform calculations, control the flow of a program using branches and repetitions, and structure the source code into reusable building blocks. First things first, of course, I cannot possibly teach you all the features of the JavaScript language in a single chapter. I would therefore like to use this chapter to introduce the essential basics of the language. To learn JavaScript more intensively, I prepared some additional recommended resources at the end of this chapter. Figure 4.1, JavaScript, one of the three important languages for the web, adds dynamic behavior and interactivity to a web page. Introduction. As with HTML and CSS, I don't want to dwell on historical details in the case of JavaScript either. If you're interested, you can find the relevant information on Wikipedia, wikipedia.org. For example, the only important thing to know is that the JavaScript standard called ECMA script is managed by ECMA International, formerly the European Computer Manufacturers Association. This standard is designated ECMA-262. Look at ecma-international.org and has been published annually since 2015. In the context of JavaScript, you may encounter other versions like ECMA Script 2015, ECMA Script 2016, and so on. 4.1.1 Including JavaScript. JavaScript code can be included in a web page in several ways, as you'll see in this section. Preparing the directory structure. To get started in working through the following examples, I recommend that you use the directory structure shown in Figure 4.2 for every example. The entry point for the browser, i.e. the HTML file, is at the top level. However, a good practice is to create different folders for CSS files and for JavaScript files, usually the directory names, styles for CSS files, see Chapter 3, and scripts for JavaScript files. Creating a JavaScript file. I recommend storing JavaScript code in a separate file or in several separate files. In this way, the code stays clear, and you also have the option of including the same JavaScript code in different HTML page. For this reason, I want to introduce you directly to this variant. The other variant, i.e. the inclusion of JavaScript code without separate JavaScript file, will be described next. First, you'll need a JavaScript file with HTML and CSS. It's just an ordinary text file. In the case with .js file extension. For this purpose, simply open the editor or development environment of your choice, create a new file, paste in the lines of source code, and then save the file as main.js. Our example code only displays a notification dialog box with the message hello world. Alert, quote, hello world, semicolon. Integrating a JavaScript file in an HTML file. Now, to use the JavaScript file you just created within a web page, you must integrate this file in the HTML code using the script HTML element. Use the src attribute to specify the URL or path to the JavaScript file you want to integrate. Then, create an HTML file named index.html and insert the content shown in listing 4.2. The issue with ESLint was resolved and the pre-commit hook passed. Your commit message fit update CI or CD configuration was successfully recorded with changes to 6 files. However, you're still seeing a deprecation warning about Husky. It's advising you to remove the following lines from your .husky/precommit and .husky/commit-message files. These lines will no longer work in Husky V10. You should remove them as suggested to avoid issues in the future. Let me know if you need help with that. It seems like you're still facing the issue with the no unused vars ESLint rule in your edit post button.jsx file. The error message indicates that React is imported but not being used in the file. You can fix this by either using React in your component. If you're using JSX, which you are, React needs to be imported, but if it's not being used directly, like React.component or React.createElement, you can just remove the import. Removing the React import if it's not necessary. If you're not using React directly in your component, like not using React.createElement or React.component, you can remove the line that imports React. So your import could just be import useState from React. This should resolve the unused import warning. After making these changes, try committing again. Let me know how it goes. It looks like you're using PowerShell, and the rm-rf command is a Unix style command that doesn't work directly in PowerShell. To delete the node_modules folder in PowerShell, use the following command instead. Remove -item-recurse-force node_modules. This should remove the node_modules folder. Once deleted, run npm install. This will reinstall your dependencies. The error you're encountering, uncaught reference error, React is not defined, is likely due to the fact that React is no longer automatically imported in JSX file in React 17 and later. This typically happens if you're using JSX but have not explicitly imported React. To resolve this error, simply add import React from React at the top of your post.list.jsx file, as well as any other JSX files you might be working with. For example, in post.list.jsx, ensure you have this import at the top. Import React from React, add this import to resolve the error. Import prop types from prop types, etc. and the code. This should fix the error where React is not defined. If you've made other changes, I suggest reviewing the rest of your JSX file for missing React imports as well. To add an edit function without breaking your existing delete functionality, you'll need to follow these steps. First, backend. Add the edit route in your routes/post.js. The patch route for editing a post is already in place. This already handles updating posts, so no changes are required here. Second, backend. Update the service layer. The update post function in services/post.js is already implemented correctly, like this code. This function uses find_one and update to update a post, title, author, contents, and tags. Third, front end. Add edit post button component. Now let's create an edit post button component that will handle the editing functionality on the front end. Edit post button.jsx, like this code. This component allows user to edit the title and contents of a post. When the user clicks the edit post button, an input field and a text area are shown, and they can modify the title and contents. Front end, update post component. Now update your post.jsx component to include the edit post button, like this code. Fifth, front end, update post list component. Ensure that the post list.jsx is passing the title and content correctly to the post component, like this code. 6. Front end, update API call for editing. Add a new update post function in your API/post.js to handle the API call for editing a post, like this code. Final thoughts. Now, the edit post button will allow users to edit their post without breaking your existing delete functionality. The delete post button will continue to work as before. Both operations, editing and deleting, are now part of the post interaction experience. It seems like Visual Studio Code is still showing an error for line 1, even though your code looks fine. The error could be due to a few possible reasons. VS Code doesn't recognize the @tanstack/react-query package. Ensure that package is installed in your project by running npm install @tanstack/react-query. After installing, restart VS Code to refresh its internal state. TypeScript or ESLint issues. If you're using TypeScript, there could be a type checking issue. Make sure your project is properly set up for TypeScript or adjust any ESLint rules that might be causing issues. Cache errors in VS Code. VS Code might be caching errors from previous runs. Try restarting VS Code and clearing any cache data by running the following in the terminal. Like this code. Check your jsconfig.json or tsconfig.json. If you're using a jsconfig.json or tsconfig.json to configure your project, make sure that your paths and settings are correct. You can try adding node_modules to the include array, like so, this code. Restarting the development server. Sometimes, the development server may not fully reload, causing errors to persist even after fixing the code. Try restarting it, like this code. npm run dev. After trying these suggestions, let me know if the issue persists. The error uncaught reference error useState is not defined suggests that you're trying to use the useState hook from React but haven't imported it properly in edit post button.jsx file. In React, hooks like useState, useEffect, etc. need to be explicitly imported at the top of your file. To fix this error, add the following import statement at the top of your edit post button.jsx, like this code. Make sure that this import is present in every file where you're using React hooks like useState. Once you add the import for useState, the error should be resolved, like this code. This should fix the error where React is not defined. If you've made other changes, I suggest reviewing the rest of your JSX file for missing React imports as well. To add an edit function without breaking your existing delete functionality, you'll need to follow these steps. First, backend. Add the edit route in your routes/post.js. The pouch route for editing a post is already in place. Second, backend. Update the service layer. The update post function in services/post.js is already implemented correctly. This function uses find_one and update to update a post title, author, contents, and tags. Third, front end. Add edit post button component. Now let's create an edit post button component that will handle the editing functionality on the front end, like this code. This component allows user to edit the title and contents of a post. When the user clicks the edit button, an input field and a text area are shown, and then they can modify the title and contents, etc. Now let's go back to full stack development JavaScript chapter 3. If you now open this HTML file in the browser, a small hint dialog box should open and display the message hello world. Figure 4.3, a simple hint dialog box generated via JavaScript. For the sake of completeness, I'll now show you how to define JavaScript directly within an HTML file, but this approach is usually not advisable because you're mixing HTML and JavaScript code in a single file. Knowing that it can be done doesn't hurt though. You can use the script element not only to include external JavaScript files but also to define JavaScript code directly. For this approach, simply write the appropriate code inside the script element. Listing 4.3 shows our earlier hello world example but without a separate JavaScript file. Thus, the src attribute isn't needed. Listing 4.3, defining JavaScript directly in an HTML file only makes sense in exceptional cases. The noScript element. By the way, you can use noScript element to define HTML code that will be rendered by the browser
only if JavaScript is not supported by the browser or has been disabled by the user. Search engine crawlers also evaluate no-script sections, thus especially for web pages that consist almost exclusively of JavaScript and load their content via Ajax. For example, using this element can be useful, like this code. Displaying dialog boxes. In the opening example, we showed you how to use the alert function to generate a simple output in a hint dialog box. Two other standard functions for displaying dialog boxes are possible. The confirm function calls a confirmation dialog box shown in figure 4.4, which unlike the hint dialog box has two buttons, one to confirm the corresponding message and one to cancel. The from function on the other hand opens an input dialog box where users can enter text as shown in figure 4.5. In practice, the standard dialog box for hints, confirmations, and inputs aren't used often because on one hand, their functionality is quite limited, and on the other hand, their appearance cannot really be customized. Using the developer console, especially for testing JavaScript functionality, of enormous help is generating certain outputs for testing purposes, for example, for checking the intermediate results of certain functions. However, outputting these outputs each time via a hint dialog box would very quickly lead to annoying unnecessary clicking. For this reason, all current browsers now provide developer consoles to which you can write messages from a JavaScript program. The console is part of developer tools and is hidden by default. To activate the console depending on the browser you're using, follow these steps. In Chrome, select View, Developer, JavaScript Console. In Firefox, open the console via Tools, Web Developer, Web Console. In Safari, you can open the console via Developer, Show Error Console. Note that in current versions of Safari, the developer menu item must first be enabled under Preferences, Advanced. In Opera, you must first select Developer, Developer Tools, and then select Console tab. In Microsoft Edge, you can open the Developer Tools by pressing F12 or selecting from the menu Other Tools, Development Tools. Figure 4.6 shows what the developer console looks like in Chrome. I'll show you how to write output text to this console using JavaScript next. To write to the console, browsers provide an object called console, which in turn has various methods to produce outputs. For example, you can create a simple console output using the log method. To test the use of the console, simply replace the source code in the main.js file from earlier with the code in listing 4.5 and reload the web page, like this code. Listing console.log hello developer world, listing 4.5, output the console via the console object. The hello developer world message should be displayed on the console. Figure 4.6, developer console displayed at the bottom of the browser window by default, Google Chrome. In addition to the log method, the console object provides several other methods listed in table 4.1. Depending on the browser, the output for the individual method is highlighted in color or by symbols, like this code. Listing 4.6 using the console object. Method, clear, description, clears all messages in the console. Debug, prints the message only if the debug log level is enabled, that is, only during debugging. Error, outputs an error message. In most browsers, an error icon is displayed in the console next to the output message. Info, outputs an info message to the console. Log, prints a normal message on the console. Warn, issues a warning to the console. Again, most browsers will display a corresponding icon next to the message. Table 4.1, most important methods of the console object for outputting messages at the console. Introduction to programming. Before we start with JavaScript language, I want to give you an overview of what programming means and the essential components of a programming language. First, I want to address the question of what programming means, or rather what purpose we pursue with it. Programming is primarily about letting a computer take over certain tasks. These tasks can be, for example, complex tasks that we humans may find difficult to work out ourselves, or calculations that help us do things more effectively in everyday life. The task of developers in programming is to provide instructions to the computer so that it can perform the task given to it. As a developer, you'll formulate individual work steps to solve a specific problem. The steps are then evaluated one by the computer. In summary, the steps involved in solving a problem in computer science are referred to as an algorithm. A program, sometimes also software or application, in turns contains a sequence of different algorithms. Deep down, computer work with binary code, machine code, or machine language that is zeros and ones. For a little background, at the hardware level, computers only understand 0 for power off and 1 for power on. Now, to make the computer do calculations and other things, you ultimately have to supply it with various combinations of zeros and ones. In this way, you can, for example, tell the computer what color pixel to display on the screen, which letter should be typed in the text editor, or which recipient an email is intended for. As humans would find it immensely complicated entering instructions to a computer in the form of zeros and ones. Instead, we can use programming languages which provide a level of abstraction for interacting with the computer. Instead of typing in zeros and ones, you can use keywords and control structures provided by that particular programming language to tell the computer what to do. Note, programming languages can be further classified into different categories depending on their degree of abstraction. JavaScript is called a higher level programming language because the language abstracts relatively far from the zeros and ones. In chapter 13, you'll see some other types of programming languages. Programming languages provide various constructs besides keywords to help with programming. Before I show you how you can use these constructs, let's look at the most important constructs in JavaScript, namely the following. Variables. Variables are containers that can take on different values during program execution. For example, you can use variables to cache results from calculations and reuse them elsewhere. Constants. Similar to variables, constants are also containers that can take on a value. However, this value, once assigned to the constant, cannot be changed again. The value of a constant is constant, i.e. unchangeable. Data types. The data type of a variable or constant, or the value associated with it, describes whether the value is a numeric value, a string, a boolean value, and so on. Operators. Operators enable you to perform calculations such as the addition of numbers. Control structures. You can control the program flow via control structures. These constructs include branches and various types of loops. You can use branches to decide which path you want to take in the program logic depending on a certain condition. You can use loops to define how often a certain part of the program should be executed repeatedly. Functions. These reusable code blocks can be called, i.e. reused in different places in the code. Objects. You can use objects to group data in a meaningful way. Classes. Classes can be used to create blueprints for objects. See also chapter 13. Arrays. In simple terms, arrays are containers in which you can manage multiple values, variables, or objects one after the other as a list. Variables, constants, data types, and operators. Now that you know the basic language constructs in JavaScript, let's learn how to use each construct specifically in JavaScript next. Defining variables. To cache data in a JavaScript program, you'll need variables. In JavaScript, you can create variables using the let keyword. You create variables in two steps. First, you must define the variable such as within a variable declaration. Then, you must assign a concrete value to the variable called value assignment or variable initialization. To simplify things, The two can also be combined in a single line, like this code. Note, you can also create variables using the var keyword. The difference between these two keywords isn't important for beginners. For this reason, I want to refer to my book on JavaScript at Mainwork Computing. Defining constants, you can change the value of a variable at any time, called overwriting the existing value with a new value. In some cases, however, you might not want this to happen. Constants are essentially variables that can only be initialized once and then can never be changed. You can define constants in JavaScript using the const keyword. Const maximum equal 5000, like this code. Note, a common convention for naming constants which are usually written entirely in capital letters. Using data types, JavaScript provides a total of 6 or strictly speaking 7 boxes different data types. First are the 3 primitive data types that are for representations of numbers, data type number, character strings, data type string, and boolean, truth values, data type boolean. Then, we have the special data type null and undefined, also a form of primitive data types, as well as a further data type for objects. Let's briefly consider each data type next. Numbers, more precisely, numeric data, is used to perform mathematical calculations, define value ranges, or simply to count. For example, you could calculate the total cost of all items in a shopping cart or count how often a user clicks on a certain area of a web page. As shown in listing 4.9, both integers and decimals can be created, even if no internal distinction is made between the two with regard to the data type.
Listing 4.9, defining different number variables. Strings designate a sequence, i.e. a chain of characters consisting of letters, digits, special characters, and or control characters. You use strings whenever you're dealing with any form of text. Listing 4.10 shows how to create strings using single quotes and double quotes. Note, a best practice in JavaScript is that for all variables whose value does not change, you should use the const keyword. Strictly speaking, then, these values are no longer variables but constants. Another possibility for generating strings we'll only mention in passing. You can now also create strings using the backstick symbol to define what are called template strings. Ultimately, within the strings, you can use variables as placeholders. Boolean truth values or booleans can take only one of two values, true and false. Booleans are typically used with variables that can have one of two states. Listing 4.11, defining Boolean variables. I won't go into detail about the special data types null and undefined at this point. Objects, on the other hand, will be discussed later in section 4.5.1. Note, as a matter of fact, JavaScript has another type, data type, symbols. However, for reasons of space, we won't explore this topic further. 4.2.4, using operators. At this point, you know how to define variables and constants and how to cache values of different data types in them. Now, you still need a way to work with these values as well, or to change and combine them to derive new values. To perform this task, you can use operators, several of which are available in JavaScript. Arithmetic operators. These operators enable you to work and calculate with numbers, which include the addition, plus operator, subtraction, dash operator, multiplication, asterisk operator, division, / operator, and modulo, percentage operator. Furthermore, the increment operator, plus, and the decrement operator, dash, adds or subtracts 1, 2, or from a number, while the exponential operator, asterisk, calculates powers. Assignment operator. We already showed you the assignment operator equal when we initialize variables and assign values to them in section 4.2.1. Concatenation operator. Working with strings. Then working with strings, you can use the concatenation operator plus to combine two strings into a single string. The technical term for this process is concatenation. Logical operators. These operators use Boolean truth values. The end operator checks whether two Boolean values are true, and the vertical operator or operator checks whether at least one of two Boolean values is true. Also, the exclamation operator, negation operator, reverses a Boolean truth value, that is, turns true into false or vice versa. Bitwise operators. These operators enable you to work with single bits of values. The following bitwise operators are available: AND, bitwise AND, vertical, bitwise OR, upward greater than, bitwise SOR, enye, bitwise negation, double less than symbol, left shift, double greater than symbol, sign propagating right shift, triple greater than, zero filling right shift. Comparison operators. These operators allow you to compare values with each other. The operators are less than, greater than, less than or equal to, greater than or equal to, double equal, equality, triple equal, strict equality, exclamation mark equal, inequality, and exclamation mark equal, strict inequality. Special operators. In addition, a number of other operators are available in JavaScript, but I can go into them here for lack of space. Note, a good overall overview of all the operators available in JavaScript can be found at https://developer.mozilla.org. Using control structures. You can use control structures to define which path a program should take. Let's say, on a registration form, you want to display a message when the user enters an invalid value. For example, a password that is too short. Perhaps you want to dynamically generate a table on a web page based on a list of data, and you want the code to work regardless of the length of the list. For these cases, programming language provide control structures to define whether a statement block should be executed and how often. You can achieve the former decision point using conditional statements or branching, and the latter decision point using loops or repetitions. 4.3.1 Using conditional statements and branching. You can define conditional statements using the if keyword to implement the use case of displaying a certain message depending on the validity of the password a user entered. You would use an if statement as shown in listing 4.12. The content of the if statement in curly brackets is executed only if the user is logged in. Variable contains the value true. Via the else keyword, you can also define a branch. In this case, the code branches. In other words, if the condition is met, the statement block inside the if statement is executed. Otherwise, the statement block inside the else statement is executed. Like this code. Note, the document object used in listing 4.12 represents the HTML document for the current web page. Using the getElementById method of this object, you can retrieve an HTML element by its ID. You can redefine the text content via the text content property of the HTML element returned by this method. So in listing 4.12, the content of the message variable is written as text content to the HTML element with the ID info. We'll describe dynamically modifying HTML using JavaScript in more detail in Chapter 7. You can use conditional statements to test against a condition and execute or not statements depending on the result, possibly by implementing branching using else. To test multiple conditions, you can extend this construct with any number of else-if statements, like this code. Listing 4.13, example of branching with multiple paths. In addition, multiple branches can be defined using the switch keyword, and which allow the program to take one of several paths based on the value of a variable. A simple example of this functionality is shown in listing 4.14. Depending on which value the test result variable contains, one of the paths defined via case will be taken. For example, if the variable has the value 0, the code views defined under case 0 : is executed. If the value is 1, the code defined under case 1 : is executed, and so on. The break keyword allows you to cancel the execution of the switch statement. Listing 4.14 using the switch application. Note, if you do not break within a block defined via case, all following case blocks will be executed from the case that is jumped to until either a break is reached or all blocks have been processed. Using loops to execute certain statements repeatedly, you can create loops in programming. Three types of loops exist in JavaScript. First, the counting loop can be used to repeat statements based on a counter variable. Second, the head controlled loop and the tail controlled loop repeat statements as long as certain condition is met. Counting loops are introduced in JavaScript using the for keyword. These constructs are referred to as for loops. In the brackets that follow, you'll define three areas. In the initialization, you write the code that should be executed exactly once before the entire loop is executed. Usually, this area is for initializing the counter variable. In the condition, you write the code that checks whether to continue executing the loop or to abort it before each loop iteration run. At this point, you usually check if the counter variable has reached a certain limit value. Finally, in the increment expression, you write the code to be executed when performing an iteration of the loop. Usually, you count up the counter variable at this point. Inside the curly brackets after this part, you'll need to write the statements that are to be executed repeatedly. A simple counting loop that outputs the numbers 1 to 10 to the console is shown in listing 4.15. Head control loops and tail control loops work similarly. Both loops repeat one or more statements as long as a given condition is met. The only difference is the moment when the check takes place. In a head control loop, also referred to as a while loop because of the keyword use, the first thing that's checked is whether the Boolean condition is met, and only then will the first loop iteration be started. Thus, in certain cases, no loop iteration is performed at all, like this code. In a tail-controlled loop, also called a do-while loop, the condition isn't checked until after each loop iteration. In other words, at least one loop iteration is executed in any case, even if the condition is not fulfilled already at the beginning. 4.4 Functions and Error Handling. You can use functions to group source code into reusable code blocks. Defining and calling functions. JavaScript offers several ways to define functions. First, in a function declaration, you can introduce a function with the function keyword, followed by the name of the function and a pair of parentheses. You can then write the logic to be executed or the statements in curly brackets in the function body, like this code. Alternatively, functions can be created using function expressions. In this case, you don't specify a function name, which makes this function what's called an anonymous function, and store the function in a variable instead. The function declared in listing 4.18 can be modified to use a function expression instead, as shown in listing 4.19, like this code. In addition, you can define functions using a short notation. Because of the syntax used, this type of functions are also referred to as arrow functions or fat arrow functions. Our earlier functions, again, now as an arrow function, is shown in listing 4.20, like this code. Note, some differences exist regarding the use of these function types, but I won't go into any further detail here. If you're interested, you can find detailed explanations in my JavaScript, the comprehensive guide book at rainworkcomputing.com. The print numbers from 1 to 10 function we just declared in whatever way can now be called at various places within a program by simply specifying the function name followed by parentheses.
print numbers from 1 to 10. Passing and analyzing function parameters. Of course, functions are only really powerful when you pass values to them. You can pass values to functions via function parameters. To define function parameters, simply write the names of the parameters in the parentheses after the function name. Within the function, you can then access the individual parameters via these names, just as you would with ordinary variables. Our earlier example from section 4.3.2 can be adapted in such a way that it not only outputs the numbers 1 to 10, but the numbers within a specific value range, i.e. the numbers from x to y, like this code. Defining return values. You can use function parameters to pass information to a function. Conversely, you can also return information from a function back to the calling code. The information returned by a function is called the return value. For a function to return a value, use the return keyword followed by the value to be returned. Listing 4.23 shows a simple addition function that calculates the total of two numbers, x and y, stores the result in the intermediate result variable and returns it, like this code. Responding to errors. When running programs, various types of errors can occur, such as the following. Syntax errors occur when you don't follow the syntactical rules of JavaScript. For example, if you forget the parentheses when defining a for statement, or if you write function, i.e. with a K, instead of function when declaring a function. Runtime errors, on the other hand, are errors that do not arise from faulty syntax, but, for example, when you try to access variables that don't exist. Logical errors or bugs refer to errors caused by incorrect logic in your program. You can detect syntax error by using an editor or development environment with syntax validation. You can prevent logical errors with automated tests. See also chapter 18. You can respond to runtime errors with what's called error handling, which I want to introduce in this section. To respond to runtime errors, you can define what are called try-code blocks, try-catch code blocks. Let's work through the basic keywords of a try-catch block next. Try can be used to execute a block of code that potentially produces errors. Catch enables you to catch or respond to the error and take appropriate countermeasures. In addition, you have access to the object that represents the corresponding error and usually provides detailed information about the error. A sample program containing code that can potentially throw errors is shown in listing 4.24. The check password function uses already known logic to check a given password regarding its length. If the password contains less than 10 or more than 50 characters, the password is considered invalid and cannot be used. Notice how you can trigger, throw, and respond to catch errors. You can throw an error using the throw keyword, in this case by specifying concrete error object to be thrown. We haven't discussed the new error expression yet. For now, just keep in mind that this constructor function creates a new error object based on the error class, passing the error message as a string as a parameter. So the function in our example throws two errors. One if the password contains less than 10 characters, and another if the password contains more than 50 characters. If you now call the check password function elsewhere, you should take appropriate measures to respond to these errors. You achieve this response by surrounding the block of code that might throw an error with a try-catch block. So you try to execute the corresponding code block, but you're prepared to catch the error and respond to it. You can accomplish the latter inside the catch block. In our example, only the error message is output to the console. In a real application, you could pass on an appropriate message to the user, for example, in the form of a message dialog box, like this code. Objects and arrays. In addition to the primitive data types, JavaScript provides objects and arrays. You can use objects to group together related functionality in a meaningful way. Arrays work like a kind of list, so they can contain multiple values. Using objects, you can create objects in several ways in JavaScript. At this point, I would like to introduce the simplest variant, the literal notation or object literal notation. In this approach, you define an object using curly brackets. Inside the curly brackets, you can then define the object's properties and define its methods, which are virtually functions that can be called on the object. You can access individual properties and methods using dot notation. Simply use the name of the object, then a dot, and then the name of the property. In our example shown in Listening 4.25, the item object is created with 4 properties: name, price, author, and ISBN, as well as print description method. Then, using dot notation, all properties are output and the method is called once. Note, by the way, in Listing 4.25, a template string is used within the print description method. Within such a template string, you can use $sign variable to define placeholders to directly integrate the value of the corresponding variable into the string. The this keyword is also used to access the current object. This.author accesses the author property of the current object, while this.title accesses the title property. Using arrays, array serves as a list of values and can be created in several ways in JavaScript. Just like object, at this point, I will again present only the simplest variant, the array literal notation. An array is defined by square brackets. You can write the individual elements inside the square brackets separated by comma. Additionally, you can also add values afterwards using the push method, like this code. In your package.json, it appears that @babel/preset-react is not listed as a dependency. However, you are using Vite with the @vite.js/plugin-react plugin, which is typically used for handling React projects, including JSX transformation without explicitly needing Babel presets like @babel/preset-react. Here's how the JSX transformation works in your case. Vite with @vite.js/plugin-react. The @vite.js/plugin-react plugin handles the JSX transformation for you. It integrates React with Vite, and you don't need to manually install or configure Babel presets for React because Vite internally uses Babel with the necessary presets to transform .jsx and .tsx files. This includes handling JSX and TypeScript if applicable. Since your project uses Vite, here's how it works behind the scenes. Vite uses ESBuild for fast bundling and transforming JavaScript/JSX code, which automatically supports JSX syntax. The @vite.js/plugin-react plugin enables features like fast refresh and JSX transformation by integrating React with Vite. If you still want Babel configuration, if you specifically need to install and configure Babel for more control, you can manually install the required Babel packages like @babel/preset-react. Here's how you can add and configure Babel. Install Babel presets. Run the following command to install Babel along with the @babel/preset-react. npm install --save-dev @babel/core @babel/preset-env, etc. Update Vite configuration. While this is optional, as Vite does most of this automatically, you can manually configure Babel in vite.config.js if you want to use Babel's full capabilities instead of ESBuild's default behavior. Example, like this code. Optionally, you can configure Babel options here if needed in this code. Conclusion, you don't need to install @babel/preset-react manually if you're using Vite with the @vite.js/plugin-react plugin, as Vite already handles JSX transformation for you through ESBuild. If you need additional configuration or more control over the JSX transformation, you can set up Babel, but for most React projects with Vite, it's not necessary. The alert function is a browser-provided feature that interacts with the JavaScript engine, user interface, and operating system. Here's a detailed explanation of how it works. its internal process, and its relationship with memory, file system, and hard drive. How alert works: JavaScript engine execution. When you call alert, the JavaScript engine, like V8 in Google Chrome, processes it. Alert is part of the window interface implemented by the browser and is exposed to JavaScript via the window.alert method. Browser's rendering engine. The browser rendering engine, like Blink for Chrome, creates and displays a modal dialog box. This dialog is not part of the web page DOM but is rendered as an overlay by the browser UI. Interaction with the operating system. The browser requests the operating system to display a system modal dialog box. This involves API calls specific to the OS, like Win32 APIs on Windows or Cocoa on macOS, to create the dialog box. Blocking behavior. The script execution is paused until the user interacts with the dialog, clicks OK. This is achieved by the JavaScript event loop, waiting for a signal that the dialog interaction is complete. Code for alert in Google Chrome. The code for alert is not directly available since it is built into Chrome source code. However, we can understand its implementation from Chromium, the open source project behind Chrome. JavaScript binding. Chromium uses the V8 engine for JavaScript execution. The alert function is implemented in the bindings between V8 and the browser. In C++, the alert function is defined as part of the window object. Example binding, like this code. This links the JavaScript call window.alert to the browser's internal UI code. Dialog box rendering. The Chromium rendering engine Blink creates the modal dialog. The UI is typically a native dialog provided by the OS but styled to look consistent across platforms. Source code reference. You can explore Chromium source for the alert implementation in the Blink repository on GitHub or Chromium source. Relation to memory usage. The browser allocates memory to the JavaScript engine for running your script. When alert is called, the message string is temporarily stored in memory. The dialog box data, such as its UI elements, is also stored in memory. Blocking mechanism. The JavaScript thread is paused while waiting for the user's interaction. The browser maintains the dialog box state in memory until the user dismisses it. Relation to file system and hard drive. No direct interaction. Alert does not directly access the file system or the hard drive. It operates entirely in memory and the browser's rendering UI layers. Indirect interaction. The browser might log events like JavaScript alert displayed to its internal debug logs, which could be stored on the file system. Example in Chrome's logs. If you run a performance analysis or debugging tool, information about the alert call may be written to a local trace or log file. Visualization of the workflow. User input: 2 clicks on a web page, 2 calls alert. JavaScript engine V8 2 executes alert and informs the browser to display a modal. Rendering engine Blink to request the OS to display a modal dialog box. Operating system renders the dialog using system APIs and wait for user input. User interaction closes the dialog, signaling the browser to resume the script. Why is alert simple and limited? Security. Since it's a modal dialog, it doesn't interact with the file system or network, minimizing security risk. Browser control. The browser ensures consistent behavior and prevents malicious use by sandboxing the alert function. Key takeaways. The alert function works through a coordinated effort between the browser's JavaScript engine, rendering engine, and operating system. It primarily uses memory to display the modal dialog with minimal to no interaction with the hard drive or file system. The alert hello world in your main.js file does not manipulate any HTML elements directly. Instead, it displays a modal dialog box with the text hello world. This is a browser provided feature and not part of the DOM API. Here's why. Nature of alert. The alert function is part of the JavaScript window object, not the document object model. It pauses the script execution and displays a simple modal dialog box with a specified message. No interaction with HTML elements. Since alert only shows a modal dialog, it does not change, access, or interact with the HTML elements. DOM nodes. The DOM API is used to work with elements of the document, such as document.query selector, to select an element or element.inner HTML to modify content. In your code example, like this code, this script tag links the main.js file, which executes the alert hello world function as soon as the script loads. The dialog box appears but no HTML elements in your body are modified. To manipulate an HTML element using DOM API, if you want to manipulate HTML elements, you would use DOM methods. In your main.js, for example, like this code, if your goal is to both show an alert and modify HTML, you could do this code. JavaScript is not something you install in the same way you might install software. It's a programming language that runs in specific environments. Here's how it works and what you need to get started in Visual Studio Code. Is JavaScript built into VS Code? No, JavaScript itself is not built into VS Code. VS Code is a code editor that supports JavaScript through its features like syntax highlighting, IntelliSense, and debugging. However, you need a JavaScript runtime like a browser or Node.js to execute JavaScript code. How to set up JavaScript in VS Code? To work with JavaScript in VS Code, follow the steps. First, install VS Code. Download and install Visual Studio Code from the official website. Second, install Node.js. Node.js is a popular JavaScript runtime that allows you to execute JavaScript code outside the browser. Download Node.js from node.js org and install it. Use the LTS version for stability. Why Node.js? Node.js comes with a built-in JavaScript engine, V8, the same as Google Chrome's engine. It also includes the Node command to run JavaScript files and the npm package manager for installing libraries. Third, test Node.js and npm installation. Open a terminal, command prompt, PowerShell or VS Code's integrated terminal and type node-version. This checks if Node.js is installed. Similarly, check npm node package manager. Fourth, write and run JavaScript code in VS Code. Create a new file, open VS Code, create a new file and save it with a .js extension, i.e. app.js. Write your code, example, console.log, hello, JavaScript in VS Code, run your code. Open the terminal in VS Code, ctrl /1 run the file using node.js, node app.js. You'll see the output in the terminal. What about running JavaScript in browsers? JavaScript is built into web browsers like Chrome, Firefox, and Edge. You can test JavaScript directly in the browser. Open the browser's developer tools, F12 or right-click, inspect, go to the console tab, type JavaScript code and hit enter. Like this code. To enhance your JavaScript experience with VS Code, consider installing these extensions: ESLint for linting and catching errors, Prettier for code formatting, JavaScript ES6 code snippets for helpful snippets, Debugger for Chrome for debugging JavaScript in the browser, Conclusion: JavaScript is not built into VS Code but can be executed with Node.js or a browser. To get started, install Node.js and use the Node command to run JavaScript files. VS Code provides excellent support for JavaScript with extensions to make coding smoother and efficient. In Windows 11, sandboxing is a technique used to isolate applications from the rest of the system to enhance security, limit the impact of potential vulnerabilities, and prevent malicious actions from affecting the overall system. Microsoft has several technologies that enable sandboxing, including Windows Sandbox and Windows Containers. Windows 11 itself doesn't have a single source code dedicated to sandboxing, but it leverages a combination of different technologies and mechanisms to achieve isolation. Here's an overview of how it works. First, Windows Sandbox. Windows Sandbox is a lightweight virtual machine that isolates applications from the rest of the system. It uses Hyper-V, Microsoft's hardware virtualization technology, and is available in Windows 11 Pro and Enterprise editions. Purpose: Windows Sandbox is designed for testing untrusted applications in an isolated environment. It ensures that any changes made by the application do not affect the whole system. Key technologies used: Hyper-V virtualization provides a virtualized environment to run applications in isolation. Windows Containers for isolation of application processes within a lightweight virtualized environment. App Container, a sandbox environment that isolates UWP, Universal Windows Platform, apps, restricting their access to the system and preventing malicious behavior. The Windows Sandbox feature is implemented at the system level by configuring Hyper-V virtual machines and managing their lifecycle. Here's a high-level view of how sandboxing in Windows Sandbox works. When a user starts a sandbox, a new lightweight virtual machine is created using Hyper-V. The application runs inside that isolated environment with no access to the host files, registry, or processes. Once the user is done, the sandbox is discarded and all changes made within the sandbox are wiped out. How to enable Windows Sandbox? You can enable Windows Sandbox through Windows Features dialog or via PowerShell, like this code. Second, application containerization. App Container. App Container is a security feature used in Windows 8 and above that isolates UWP, Universal Windows Platform apps, making them more secure by restricting access to system resources. This mechanism is used by many apps in the Windows Store to prevent them from interacting with sensitive system areas like the file system, registry, or network. How App Container works: it creates a security context for the apps that limits their access to only the resources they need. App inside the container cannot access files or settings outside their designated sandbox environment unless explicitly permitted. App Container uses access control lists, ACLs, and security tokens to enforce isolation, while App Container is not a full virtualization solution like Windows Sandbox. It is commonly used for lightweight application isolation. Third, Windows Containers, Docker, and Windows Server. Windows Containers are another form of sandboxing used for isolating applications. Windows Containers allow applications to run in isolated environments called containers, but unlike virtual machines, containers share the host operating system's kernel. Use case: Windows containers are often used in cloud-native applications and for deploying applications in isolated environments. Technologies involved: Windows Server containers. These share the host OS kernel. Hyper-V containers, a more secure form of containerization where each container gets its own kernel. Fourth, security features for sandboxing in Windows 11. Control Flow Guard, a security feature that prevents control flow attacks by validating indirect function calls at runtime. Memory Integrity, Core Isolation, a memory protection feature that prevents attackers from using exploits to modify system memory. Virtualization-based security, It uses Hyper-V virtualization to protect critical system processes from being compromised. Windows Defender Application Guard WDAG, a security feature that isolates untrusted websites and apps in a virtual machine. Source code for sandboxing techniques. The specific source code for sandboxing in Windows 11 is not directly available as it is part of the internal code base maintained by Microsoft. However, you can interact with and configure some sandboxing mechanisms through tools and APIs provided by Microsoft. How to use or implement sandboxing features in Windows 11. Windows Sandbox. The Windows Sandbox feature is already integrated into Windows 11. You don't need to write source code for the sandbox itself, but you can launch and manage sandbox sessions using PowerShell or Windows settings. PowerShell example, like this code. Developers can create sandbox applications using the UWP API, which automatically uses app container to isolate apps. These apps have limited access to resources and are tightly sandboxed by the operating system. Windows containers. For containers, you can use Docker to create and manage containers in Windows 11. Docker is commonly used to containerize applications with Windows Server containers or Hyper-V containers. You can install Docker Desktop on Windows 11 and use it for containerization. Docker run -it-rm and mcr.microsoft.com/windows. Summary. The sandboxing techniques in Windows 11, like Windows Sandbox, App Container, and Windows Containers, work by isolating applications and limiting their access to system resources. These features are implemented using various technologies such as Hyper-V for virtualization and access control list for resource isolation. While the exact source code for these features is proprietary and not available for public inspection, you can use the APIs, tools, and mechanisms provided by Microsoft to create and run sandbox applications. If you want to explore more deeply how these features work under the hood, you can refer to Microsoft official documentation on technologies like Windows Sandbox, App Container, and Hyper-V. How Windows reads and executes binary files like GDI32.dll. When a binary file like GDI32.dll is loaded into memory, Windows follows a systematic process to read and execute the code. Here is a breakdown of how the operating system handles this, specifically for libraries like GDI32.dll. First, loading the binary DLL file into memory, executable in linking format DLF/PE. Windows uses the portable executable PE format for both executables.exe and dynamic link libraries .dll. The PE format is a standard for binary files in Windows. The PE file consists of headers, sections, and code that represent the binary file and its associated data, like resources and symbols. Windows Loader. When a program requires a library like GDI32.dll, Windows first searches for the file in the directories listed in the system path or specified in the application. The Windows Loader part of the OS is responsible for loading the DLL into memory. This is how the OS reads the binary file. File parsing. The loader reads the PE headers and extracts the important information like memory, addresses, imports, exports, and entry points. Mapping to memory. The loader maps the contents of DLL into the process virtual address space. This includes the text code section, which contains machine instructions, data sections, which may include global variables, resources, and initialization data, relocation and binding. If the binary uses addresses that need to be adjusted, i.e. based on the base address, the loader performs relocation. Memory allocation. The loader allocates a portion of the process virtual memory space for the DLL's code and data. Once loaded, the binary code can be executed by the CPU. Second, how the OS executes the code. Function calls. When an application calls a function from GDI32.dll, i.e. create Windows, Windows uses the Windows API to invoke the function. The Windows API acts as an abstraction layer that allows an application to interact with system libraries like GDI32.dll without knowing the low-level details of how the function is implemented. For example, when an application calls create window, the OS locates this function in GDI32.dll, which was loaded earlier, and transfer control to the entry point of that function in the library. Third, dynamic linking and import table. Let's go now to how stack, heap, cache, TCP, UDP, and cookie works. To find cache in Google Developer Tools, follow these steps. Accessing cache in Google Developer Tools, open Developer Tools. Alternatively, right-click on any web page and select Inspect. Go to the Application tab. In the DevTools interface, look for the top menu and click on the Application tab. If you don't see it, click the menu on the right to expand hidden tabs. Navigate to Cache sections in the left-hand sidebar of the Application tab. You'll find options to view cache data, storage, cache to cache storage, shows cache assets stored via the Cache API, often used by progressive web apps. Storage to IndexedDB, sometimes cache-related data is stored here for web applications. Storage, local storage / session storage, though not through cache. Developers occasionally use this for storing temporary data. Network to disk cache, if available. Some browsers show local cache usage here. Inspect specific cache content. Click Cache Storage to view cache files. This typically includes JavaScript files, images, and other resources. Select a cache entry to see the content and metadata. Alternative, viewing cache through the Network tab. Go to the Network tab. In DevTools, click the Network tab. Reload the page, CTRL+R or CMD+R to populate the network request. Filter for cache content. In the Network tab, look for the size column. Requests served from the cache are often labeled as memory cache or disk cache under the size column. Analyze cache usage. Check the status column. Some entries may show 3 or 4 not modified, meaning the browser is using cache resources instead of fetching fresh ones. Use case for clearing cache. If you're testing a website or debugging, you may want to clear the cache. Go to the application, clear storage, then clear cache storage, and click Site Data. Alternatively, clear the cache for a single resource by selecting it in the cache storage and deleting it. By using these tools, you can easily inspect, debug, and manage cache resources. How cache works? Simplified. Cache is like a temporary storage area that holds frequently accessed data to save time and resources. Instead of fetching data from a slower resource like a hard drive or a remote server every time, the cache stores it locally for faster access. Metaphor 1. Cache is a house system. Cache, a bowl of fruit or snacks on your dining table for easy access. It's quick and convenient because it's right there and frequently used. If you run out, you restock from your pantry, main storage. Main memory or storage, the pantry or fridge where you store most of your food and supplies. It takes more effort to access compared to the dining table, but it holds more items. Stock, the counter top where you place items you're actively using while preparing a meal. It follows a last in, first out rule. The last ingredient you place is the first one you use. Heap, a big cabinet where you store pots, pans, and large cooking tools that are less frequently used. It's flexible and not as structured as the countertop stock TCP, like carefully following a recipe and double checking each step to ensure it's perfect. Reliable but slower because you confirm every step. UDP, like throwing ingredients into a pot without measuring. Faster but riskier, as the result may not be exactly what you wanted. Cookies, like a sticky note on the fridge that reminds you what ingredients you need or prefer for future meals. It remembers your preferences for when you come back later. Metaphor 2, cash as a MIUI 25 I125S motorcycle system. Cache, the tools or items stored in your motorcycle's small storage compartment. These are things you frequently use while riding, like gloves or a map, so they're quickly accessible. Main memory or storage, your garage or a shop where you store extra parts, fuel, or tools. You go there when you need more supplies, but it takes longer than using what's in your compartment stock. The seat where you temporarily place things like a delivery bag. It follows a LIFO principle. The last thing you put on the seat is the first thing you grab. Keep the cargo box on the back of your motorcycle where you store larger items. It's more flexible and can hold a variety of items, but accessing them takes more time. TCP, like confirming every delivery address with the customer before dropping off a package. Reliable but slower since you stop to confirm every detail. UDP, like throwing promotional flyers on the road as you drive by. It's faster because you don't stop to confirm if the flyers were received. Cookies, like notes or reminders stored in your phone or dashboard about frequently visited places or commonly delivery addresses. They save time by remembering details for future trips. Best metaphor, cache as a travel and delivery system. Integrating all concepts, cache, stock, heap, TCP, UDP, and cookies into a travel and delivery metaphor is the most relatable because it combines speed, efficiency, and structure. Cache, a shortcut or express lane that avoids traffic and gets you to frequent destinations quickly. For example, remembering common delivery routes saves time instead of recalculating every time. Main memory or storage, the city's main road network, which is slower but connects to every location. You can only use it when the shortcut cache isn't available. Stock, the items you carry in your delivery bag for immediate use. Following a LIFO principle, you stack the package on top of each other so that last package loaded is the first one delivered. Heap, the cargo area of a truck where items are stored more flexibly and are less organized. It holds large or irregularly shaped items but takes time to retrieve. TCP, a planned delivery route where you stop at every address, confirms delivery, and ensures the package is received. It's reliable but slower due to the extra checks. UDP, a fast delivery system where you throw packages at the door without confirming if they were received. It's quicker but riskier because some packages may not reach their destination. Cookies, a GPS system that remembers your favorite routes or frequently visited places for future reference. It makes travel faster and more efficient over time. Why the travel and delivery metaphor is the best? Intuitive, travel systems are relatable to most people, making it easier to understand abstract concepts like cache, stock, heap, TCP, UDP, and cookies. Integrative, it covers all components in a way that shows their relationships and trade-offs, speed versus reliability, real life application. It mirrors how efficiency and planning are balanced in both computers and transportation systems. This metaphor helps you think about the cache's speed and proximity, while stock, heap, TCP, and UDP represent structured and flexible workflows. Cookies add personalization, making the system smarter and more efficient over time.
Sure, here is a metaphorical explanation of dependency injection in Spring Boot using the concepts of House and MIUI 125S motorcycle system. First, what is dependency injection in Spring Boot?
Imagine you're building a house, Spring Boot application, and inside the house, there are different rooms that need certain tools and appliances to function properly. Like a kitchen needing a fridge or a living room needing a TV. Instead of each room going out and buying these tools themselves, the house builder, Spring Boot container, injects the necessary appliances, dependencies into each room when the house is constructed. This is dependency injection, the process of providing an object with its dependencies, tools, rather than allowing the object to create them itself. Second, how does the @AutoWord annotation work in Spring Boot? Now, think of AutoWord as a special automatic delivery service in the house. Every room in the house knows it needs a fridge or a TV, but they don't go out and get it themselves. When you mark a specific place in the room in your code, a field or a constructor with @AutoWord, the Spring Boot builder automatically sends the appliance dependency that is required. So when you use @AutoWord, Spring automatically injects the right object, like a fridge or TV, into your room, the class, without you needing to manually do it. It saves you time and keeps your house organized. Third, how do you inject resources in Spring Boot? If you want to inject a specific resource like a toolbox or electricity, you would typically define it in a Spring configuration, a setup or plan. Using annotations like @bin, Spring Boot knows how to create and inject resources into your house. Think of the resources as essential items, i.e. electricity or water. They are provided and set up by a central system, like the builder in charge of the house. These resources can be injected into any room or class that requires them. This process makes sure everything needed in the house is available, and each room gets its required resource automatically. Summary metaphor: house equals Spring Boot application, rooms equal classes, tools or appliances equal dependencies, i.e. services components. @AutoWord equal automatic delivery service that provides the dependencies. Resources, electricity, toolbox equal specific configurations or bins that can be injected. Dependency injection, DI, helps you keep the house, your application, well organized by ensuring rooms, classes get what they need, dependencies, without going out and finding themselves, making the construction process more efficient. Let me explain dependency injection methods using a house metaphor. Constructor injection, like moving walls during house construction. Dependencies are built into the house from the beginning. Most robust and recommended method ensures all critical components are in place before the house is functional. Immutable and clear dependencies. Example, permanent electrical wiring installed during initial construction. Setter injection, like swappable furniture. Dependencies can be added or changed after initial setup. More flexible but less secure, can modify dependencies runtime. Example, easily moving furniture between rooms or replacing appliances. Field injection, like randomly placed power outlets. Dependencies inserted directly into rooms. Least recommended approach, makes testing and understanding dependencies harder. Can create hidden dependencies. Example, adding random electrical outlets without a clear wiring plan. Metaphorically, for Mias, I assume you meant something specific. Constructor injection, precise, plan integration. Setter injection, adaptable, modifiable connection. Field injection, direct but potentially chaotic attachment. The metaphor highlights why constructor injection is generally preferred. It ensures a solid, clear, and controlled setup from the start. I'll expand on the dependency injection house metaphor with more nuanced architectural details. Constructor injection, architectural foundation design, structural integrity, like load-bearing walls that define the entire house blueprint. Immutability, concrete foundation poured during initial construction. Validation guarantees, ensures all critical systems, plumbing, electrical, are validated before occupancy. Dependency relationship, clear, transparent architectural plan where every system's connection is explicitly mapped. Security prevents runtime modifications that could compromise structural integrity. Testing analogy like a comprehensive building inspection before final sign-off. Setter injection, modular interior design, flexibility, movable interior walls and reconfigurable rooms. Runtime adaptability can swap out entire room functionalities. Potential risk, less predictable system behavior. Dynamic reconfiguration, like smart home systems that can be remotely adjusted. Partial initialization allows gradual system completion. Vulnerability, more points of potential system manipulation. Field injection, chaotic electrical wiring. Hidden connections, unpredictable wire routing behind walls. Implicit dependencies, unclear how systems interconnect. Testability challenges, difficult to mock or replace individual components. Maintenance nightmare, like a house with random, undocumented electrical circuits. Tight coupling, systems deeply intertwined without clear separation. Refactoring complexity, requires extensive rewiring to make changes. Code representation metaphor, like this, Java code. Advanced architectural considerations. Dependency direction follows dependency inversion principle. Complexity management reduces cognitive load of system interactions. Scalability enables easier system expansion and modification. This expanded metaphor illustrates how different injection strategies represent varying approach to system design, with constructor injection providing the most robust and transparent architectural model. I'll provide a comprehensive explanation of dependency injection and related concepts in Spring Boot. Dependency injection in Spring Boot. Dependency injection (DI) is a design pattern and core concept in Spring Boot that helps manage dependencies between different components of an application. It's a technique where the control of creating and managing object dependencies is transferred from the application code to the Spring framework. Instead of a class creating its own dependencies, these dependencies are injected into the class from the outside. Key benefits of dependency injection include reduced coupling between classes, easier unit testing, more modular and maintainable code, simplified configuration and management of application components. How @AutoWord annotation works. The @AutoWord annotation is used to automatically inject dependencies into Spring managed bins. When Spring sees this annotation, it automatically finds and injects the appropriate bin based on type. There are three primary ways @AutoWord can be used. Constructor injection, recommended, like this code. Setter injection, field injection. Resource injection in Spring Boot. Spring Boot provides multiple ways to inject resources. A. Constructor injection, preferred method. B. Using @component, @service, @repository annotations. This annotation tells Spring to automatically create and manage bins. Qualifier annotation. When multiple bins of the same type exist, @qualifier helps specify which bin to inject, like this code. Contextual injection with @resource, an alternative to @AutoWord, primarily used in Java EE concepts, like this code. Best practices: prefer constructor injection, keep dependencies minimal and focused, use interface-based programming, avoid circular dependencies, use @component, @service, @repository to define bins. Advanced injection techniques. @AutoWord required equal false for optional dependencies. Using @primary to define a primary implementation. Custom @qualifier annotations for more complex scenarios. By leveraging these dependency injection techniques, Spring Boot simplifies application configuration and promotes loose coupling between components, making your code more modular and easier to maintain. What is Spring Boot? Spring Boot is an open-source Java-based framework used to create standalone, production-grade Spring applications with minimal configuration. It simplifies the development process by providing defaults for code and annotation, configuration, embedded servers like Tomcat, and a range of plugins for building, testing, and deploying applications. It's part of larger Spring ecosystem. What is the Eclipse IDE? Eclipse IDE Integrated Development Environment is a free open source software development platform used primarily for Java applications. It provides a comprehensive environment for coding, debugging, testing, and deploying applications. Eclipse supports plugins for various programming languages and frameworks, making it highly extensible. What is Gradle? Gradle is an open source build automation tool that uses a Groovy or Kotlin-based DSL domain-specific language for defining build scripts. It is designed to support multi-language projects and is widely used for building, testing, and deploying Java applications, including Spring Boot projects. Gradle is known for its flexibility, performance, and dependency management capabilities. How do we create a Spring Boot project? You can create a Spring Boot project using the following methods: Spring Initializer, visit https start.spring.io, configure your project, i.e. maven/gradle, Java or Kotlin, Spring Boot version, dependencies like Spring Web, Spring Data GPA, etc. Click Generate to download the project as a file. Extract the zip file and import it into your IDE, i.e. Eclipse. Using Eclipse IDE, open Eclipse and go to File, New, Spring Starter Project. Fill in the project details and select dependencies. Click Finish to create the project. Using command line, use curl or http to generate a project. Curl https start.spring.io/starter.zip-o space myproject.zip -d type equal gradle-project-d dependencies equal web. Extract the zip file and import it into your IDE. How do we run a Spring Boot project? You can run a Spring Boot project in several ways. Using Eclipse IDE, right-click on the project, select Run as Spring Boot App. Using command line, navigate to the project directory. For Gradle, run /gradle w boot run. Using a jar file, build the project using maven mvn clean install or gradle build. Run the generated jar file like this code. How do we use logging with Spring Boot? Spring Boot uses SLF4J, simple logging facade for Java, with Logback as the default logging framework. To use logging, add logging statements. Use logger in your classes, like this code. Configure logging. Add logging configuration in application.properties. logging.level.com.myapp equal debug. Create a logback-spring.xml file in the src/main/resources directory for advanced configuration. How do we find error and log messages in Eclipse? To find error and log messages in Eclipse, console view, log messages are displayed in the console view when running the application. Look for errors, warnings, and info messages in the console output. Error log view, go to Window, Show View, Error, log to see errors and warnings, log by Eclipse itself. Search in log files. If logs are written to a file, i.e. app.log, open the file in the Eclipse or use an external text editor to search for errors. Debugging, set breakpoints in your code and use the debug perspective to inspect variables and trace errors. Filtering logs, use the search or filter functionality in the console view to find specific log messages or errors. By leveraging these tools and techniques, you can effectively manage and troubleshoot your Spring Boot applications in Eclipse. You needed to refresh the build.gradle file and run the application because Eclipse Gradle integration sometimes require manual steps to synchronize the project and ensure all dependencies and configurations are properly loaded. Here's why. First, refreshing build.gradle. Why? When you update the build.gradle file, i.e. adding dependencies, plugins, or modifying the configuration, Eclipse needs to reload the changes to incorporate them into the project's build path. What happens? Refreshing synchronizes Eclipse with the Gradle project and ensures all dependencies and settings from build.gradle are applied. How to avoid refreshing manually? Use the auto build or auto refresh option in your Eclipse Gradle plugin via BuildShip to synchronize automatically when changes occur. Make sure your IDE is properly configured to detect Gradle changes. REST Representational State Transfer Metaphors. House metaphor. Standard rooms and resources. Imagine a house with different rooms: kitchen, bathroom, bedroom. Each room has a specific purpose, just like how REST has specific resources like users, product, etc. that are accessed in a certain way. Standard interactions. Every room has its own door or switch. In REST, each resource has standardized way to interact with it, such as using HTTP methods like get, post, put, delete to manage resources. Unique address and URL. Just like each room or house has a unique number or address, each resource in REST has a unique URL that identifies it. For example, https myhouse.com/rooms might be the URL to get all rooms in the house. House rules and constraints. A house may have rules like no shoes inside or no loud noises. In REST, these are the rules, called constraints, that ensure proper communication and consistency between systems. Mikata block fan metaphor. Remote control and API interface. Think of the fan's remote control as the API interface. You use it to control the fan settings. Similarly, in a RESTful service, the API is the interface that lets you interact with the data. Standard buttons in HTTP. Methods. The buttons on the remote represent the various HTTP methods. Power on/off equal post/delete. Starting or stopping a service. Check speed equal getting data. Change speed equal put updating data. Set timer equal patch partially updating data. LED display and response status. The LED display shows you what's happening with the fan, just like how REST APIs send back responses that show the result of your request, success or error. MIUI 125S metaphor. Fuel injection system and REST architecture. The fuel injection system in a motorcycle is like the architecture of REST. The throttle is the request you make, the engine is the resource state, and the ECU, engine control unit, is the API controller that makes decisions based on what you ask for. Sensors and endpoints. The sensors in the motorcycle are like the endpoints in an API, which gather data and send it back to the ECU for processing. Creating RESTful services with Spring Boot. House metaphor. At-rest controller and control panel. The at-rest controller annotation is like the main control panel in a smart house, where you set the rules for how rooms and devices behave. At-request mapping and addressing. The at-request mapping annotation is like the house address system, where you define the path that leads to specific rooms like /house or resources like /rooms. Service classes and wiring system. The service classes are like the electrical wiring inside the house, ensuring that everything works as expected. They're responsible for the actual logic that gets executed when you interact with a room or device. Mikata block fan metaphor. Controller endpoints and remote buttons. The controller endpoints like at-post mapping /speed are like the buttons on the fan's remote control. Each button triggers an action, such as changing the speed or setting the timer. DTOs and fan settings. Configurations. DTOs, data transfer objects, are like the fan settings. They represent the current configuration, such as speed or timer values that you want to update or fetch. Service layer and internal mechanisms. The service layer is the internal mechanism that processes the request, like how the fan's internal motor responds to button presses to change its settings. MIUI 125S metaphor. API endpoints and diagnostic ports. Just like a motorcycle, diagnostic ports help you check the engine's health. API endpoints allow you to check the status of resources or perform actions on them. Request or response and sensor data. When you send a request to check the motorcycle's fuel injection stats, the request is like a diagnostic test, and the response is like the sensor data that tells you how the system is performing. Service layer and ECU. The service layer processes the incoming data, just like this ECU processes input from the sensors to make decisions about the engine state. CRUD operations: create, read, update, delete, house metaphor, get, read, checking room status. This is like going into room to see its current state, such as whether the lights are on or off. Post, create, adding a new room. This is like building a new room in the house. Put, update, renovating a room. This is like renovating or changing the setup of a room. Delete, removing a smart device. This is like removing a device from your house, such as a smart light bulb you no longer need. Mikata block fan metaphor. Get, read, checking current settings. This is like checking the fan's current settings, such as its speed or oscillation mode. Post, create, adding a new timer. This is like setting a new timer for the fan. Put, update, changing the fan mode. This is like updating the fan's mode, i.e. switching from low to high speed. Delete, removing all timers. This is like clearing out all the timers you've set on the fan. MIUI 125S metaphor. Get, read, checking FI stats. This is like checking the status of the motorcycle fuel injection system to see if there are any issues. Post, create, adding a maintenance record. This is like logging a new maintenance record for the motorcycle, such as an oil change. Put, update, updating ECU settings. This is like reprogramming the motorcycle ECU for better performance. Delete, clearing error codes. This is like clearing any stored error codes that show up in the motorcycle diagnostics. Database and ORM concepts. House metaphor, entity class, at entity, and house blueprint. The at entity annotation is like the blueprint of a house. It defines how the house is structured, such as how rooms are laid out and what each room contains. At one-to-many and room listings. The at one-to-many annotation is like saying one house has many rooms. Each house can have several rooms, just like how a database record can have related data, such as rooms in a house. Mikata block fan metaphor, repository. At repository and fan settings. Database. The at repository annotation is like a catalog for fan settings. It lets you look up specific settings, such as finding all fans with a certain mode or fetching a specific timer. MIUI 125S metaphor, one-to-many relationship. At one-to-many and maintenance records. This is like saying one motorcycle can have many maintenance records. Each motorcycle can have multiple maintenance logs, and this relationship is stored in the database. API documentation, Open API specification. At Open API definition and vehicle API info. The at Open API definition annotation is like the user manual for an API. It describes what the API does, how to use it, and what each endpoint does, just like how a car's manual explains its features and controls. REST, representational state transfer. Metaphors with more complex examples. House metaphor, room setup, CRUD operations, get, read. Imagine you want to check the current lighting in the kitchen. You open the door and look around. In REST, this is similar to fetching information about a resource, like fetching user details from a database. Post, create. If you want to add a new painting to the living room, you might call a service to install it. This mirrors how Post is used to create new resources, like creating a new user or adding an item to a cart. Put, update. Let's say you decide the kitchen needs a new fridge. You take out the old one and replace it with the new one. Similarly, put in rest replaces an existing resource with a new one, updating a user's profile. Delete. If you decide the kitchen table no longer serves a purpose, you remove it. This is analogous to the delete method in REST, which deletes a resource from the system. Patch, partial update. Instead of replacing the entire kitchen table, you decide just to change its color. Patch allows partial modifications to a resource like changing only one field in a user's profile, i.e. updating only the address, not the whole user record. Mikata block fan metaphor, more complex example, fan speed adjustment, multiple endpoints. Get, read, you check the fan's current speed and oscillation status. In REST, this is a get request to retrieve current values from the API, i.e. get /fan/status to see the fan settings. Post, create, imagine you're installing a brand new fan and setting its initial speed. You make a post request to create the fan settings, i.e. post/fan to set up the initial configuration. Put update, let's say you need to update the fan speed to high. You send a put request to change its speed to a new value, i.e. put/fan/speed to replace the current speed with a new one. Delete, you remove a fan from the room, effectively deleting the resource. A delete request might look like delete/fan/fan_id to remove a specific fan. Patch, partial update, you change the fan speed without affecting other settings. Patch allows for partial updates to a resource. For example, patch/fan/speed to adjust only the speed while leaving other settings untouched. MIUI 125S metaphor, complex example with API. Diagnostic data, request response lifecycle. Get, read, you want to check the motorcycle current fuel mixture or performance data. This is a get request where you pull diagnostic information about the system like get/motorcycle/diagnostics. Post, create, if you want to add a new service log or maintenance entry, you use post. For instance, post/motorcycle/service record creates a new entry for the last maintenance check. Put, update, if the ECU engine control unit needs reprogramming, you use a put request to replace the old configuration with a new one, i.e. put/motorcycle/ECU/settings to completely override the old settings with new ones. Delete, suppose you want to clear out diagnostic logs, you might issue a delete request like delete/motorcycle/diagnostics/log_id to remove a specific record. Patch, partial update, if only one sensor needs calibration and not the entire engine setup, you can use patch to update just the specific sensor data, like patch/motorcycle/sensor/sensor_id. Creating RESTful services with Spring Boot. House metaphor with advanced details. Controller class and managing different resources. The at-rest controller annotation acts like the house central control system. It listens for requests to different parts of the house, endpoints, and send bulk responses. Imagine that the house has multiple rooms, resources like users, products, orders. The at-request mapping annotation maps each door to a room, endpoint, for example, at getMapping/kitchen lets you access the kitchen, read the kitchen status, and postmapping/kitchen might create a new feature in the kitchen. Complex controller example like this code, at-rest controller, at-request mapping/house, public class, house controller, at getMapping/kitchen, etc. etc. In this example, the controller is handling requests for various actions like reading, get, creating, post, updating, put, and delete like kitchen items. It's like having a dedicated team that manages the kitchen's operation, checking its status, adding items, and handling removals. Mikata block fan metaphor with multiple controllers. Multiple fan controls. You may have different fans in your house with their own specific controls like speed, oscillation, power. Each fan could have its own controller with different endpoints for each type of action, like this code. Here, the controller is dedicated to fan operations and can handle specific tasks like adjusting the fan speed or removing a fan. Each endpoint, i.e. /fan/id/speed, works with a specific part of the fan system. MIUI 125S metaphor, advanced API, complex request response flow, like this code. In this example, the API interacts with motorcycle-specific data such as diagnostic information, service records, and ECU settings. Each endpoint is tailored for a specific part of motorcycle, allowing detailed control over its different systems. CRUD operations with more complex examples. House metaphor, CRUD, advanced scenarios, get, read. Imagine you want a full inventory of all kitchen appliances, not just one. A GET request could return a list of all items in the kitchen, like get/house/kitchen/inventory. Post, create. You want to add a new appliance to the kitchen. You submit an appliance object, a toaster, through a post request. It's similar to ordering a new appliance online and having it delivered. Put, update. You decide to replace the entire kitchen counter with a new one. Put is like replacing the whole resource, not just small part. In terms of API, put/house/kitchen would replace the whole kitchen setup with a new one. Delete. If you want to remove an item, say an old refrigerator, you issue a delete request. In this case, delete/house/kitchen/refrigerator/id would remove the refrigerator from the system. Patch, partial update. Here's a metaphor using a house, Mikata block electric fan, and MIUI 125S motorcycle to explain the concepts. What is REST? House. REST is like the main entrance to a house where you can enter through a specific door, endpoint, to access different rooms, resources. Mikata, block electric fan. REST is like setting up your fan speed, HTTP methods. You can adjust it to low, medium, or high control to control the airflow, data exchange, depending on your need. MIUI 125S motorcycle. REST is like having a smooth road system, URL structure, where each road leads to a different destination, resource, allowing you to efficiently get from one place to another. How can you create a RESTful web service with Spring Boot? House. Creating a RESTful web service is like building a house with multiple rooms, endpoints, where each room serves a different purpose, resource. Mikata, block electric fan. Setting up a RESTful web services is like installing a fan where each control button corresponds to a method that manipulates the air data, such as increasing speed, get, or turning it off, delete. MIUI 125S motorcycle. Creating the web service is like customizing the motorcycle's gear system, where each gear method lets you go at different speeds, access different resources. How can you fetch items using a RESTful web service? House. Fetching items is like opening the door to a specific room, resource, and taking what you need, get method. Mikata block electric fan. Fetching items is like setting the fan to a specific speed, get, to get the right airflow, data. MIUI 125S motorcycle. Fetching items is like taking a ride to a particular destination, endpoint, where you can pick up the package, data. How can you delete items using a RESTful web service? House. Deleting items is like removing furniture from a room, delete method, to free up space, data. Mikata block electric fan. Deleting items is like turning off the fan, delete method, to stop the airflow, data removal. MIUI 125S motorcycle. Deleting items is like discarding an old helmet, no longer needed on your motorcycle ride, removing data. How can you add items using a RESTful web service? House. Adding items is like furnishing a room, post method, bringing in new furniture, data, to make the space resource better. Mikata block electric fan. Adding items is like installing a new fan, post method, introducing a fresh source of airflow, data, into the environment. MIUI 125S motorcycle. Adding items is like equipping the motorcycle with extra gear, post method, enhancing its capacity, data insertion. How can you update items using a RESTful web service? House. Updating items is like redecorating a room, put or patch method, changing the furniture arrangement, data. Mikata block electric fan. Updating items is like adjusting the fan speed settings, put/patch method, changing the airflow based on your current needs. MIUI 125S motorcycle. Updating items is like upgrading the motorcycle's part, put/patch, enhancing performance, data modification. How can you use queries with a RESTful web service? House. Using queries is like asking a housekeeper for specific items in a room, filters, where you only get the requested furniture, data, instead of everything. Mikata block electric fan. Using queries is like setting the fan to direct the airflow towards a specific area, filtering, making sure it's just what you need. MIUI 125S motorcycle. Using queries is like selecting a specific route to a destination rather than going through every road, filtering data. What is the Open API specification? House. The Open API specification is like a blueprint of the house, showing the design, rooms, and how the house functions, service, routes, and responses. Mikata block electric fan. It's like a user manual to the fan, detailing how to use the fan settings, API documentation. MIUI 125S motorcycle. It's like the motorcycle's manual, outlining the mechanics, parts, and how to navigate it, API routes, and behavior. What is Swagger UI? House. Swagger UI is like taking a virtual tour of the house, showing you all the rooms, their layout, and how to interact with each space, API visualization. Mikata block electric fan. Swagger UI is like having digital interface that lets you control the fan settings with all available options displayed. MIUI 125S motorcycle. Swagger UI is like using a digital dashboard on the motorcycle, showing all the routes and options available, guiding you on how to proceed. What are ORM, GPA, and Hibernate? House. ORM, GPA, and Hibernate are like the internal plumbing system that connects the house to the city's water supply database, ensuring that water data flows to the right faucets entities. Mikata block electric fan. ORM, JPA, and Hibernate are like the wiring system that connects the fan's motor to the switch, ensuring the fan runs smoothly. MIUI 125S motorcycle. ORM, JPA, and Hibernate are like the motorcycle's engine and fuel system, enabling smooth operation and ensuring data flows like fuel to the engine. How can you create an entity class? House. Creating an entity class is like designing a room with specific furniture, attributes, defining how it fits into the house database. Mikata block electric fan. Creating an entity class is like choosing the design and features for a new fan, defining attributes like speed and oscillation. MIUI 125S motorcycle. Creating an entity class is like customizing the motorcycle body design, attributes to fit your riding style database. How can you create CRUD repository? House. A CRUD repository is like organizing a storage room in your house with clear sections to store data and labels for easy access. Mikata block electric fan. A CRUD repository is like a fan control panel where each button corresponds to a specific function: create, read, update, delete. MIUI 125S motorcycle. A CRUD repository is like the bike's toolkit, which allows you to modify or maintain the motorcycle parts, data, easily. What does a CRUD repository provide for your application? House. A CRUD repository is like a reliable housekeeper who manages the house inventory, data, ensuring everything is stored, retrieved, updated, or removed as needed. Mikata block electric fan. A CRUD repository is like an intuitive control system that makes it easy to adjust fan settings, perform CRUD operations on data. MIUI 125S motorcycle. A CRUD repository is like a reliable service mechanic who can maintain, repair, or replace parts of the motorcycle application. How can you create a one-to-many relationship between tables? House. A one-to-many relationship is like a master bedroom, one with several smaller rooms, many connected by doors, where the master room controls access to the smaller rooms. Mikata block electric fan. A one-to-many relationship is like having one fan with several modes, many, that can be adjusted independently. Motorcycle. A one-to-many relationship is like motorcycle with one main engine, one controlling various parts, many that work together. How can you add demo data to a database with Spring Boot? House. Adding demo data is like staging furniture in-house for an open house event, allowing potential buyers to visualize the space. Mikata block electric fan. Adding demo data is like setting up the fan at a store, showing different settings and features to potential customers. MIUI 125S motorcycle. Adding demo data is like preparing the motorcycle for a showroom, making sure it's ready for display with all the features visible. How can you access the H2 console? House. Accessing the H2 console is like going to the house utility room, where you can manage all the systems. Database. Mikata block electric fan. Accessing the H2 console is like having a manual control panel to adjust and monitor the fan's operations. MIUI 125S motorcycle. Accessing the H2 console is like checking the motorcycle dashboard to view the system's health and settings. How can you connect your Spring Boot application to MariaDB? House. Connecting to MariaDB is like hooking up your house to the city's water system, MariaDB, to ensure you get a steady flow of water data. Mikata block electric fan. Connecting to MariaDB is like plugging the fan into a power outlet database connection, allowing the fan to function application to work. MIUI 125S motorcycle. Connecting to MariaDB is like attaching the fuel tank to the motorcycle database connection, ensuring it has the energy to run smoothly. Understanding REST like operating common things. House. Think of REST like how you interact with your house. Just like you use doors to enter rooms, switches for lights, and follow house rules, REST uses standard ways to interact with web services. Mikata block fan. Like using a remote control, you press specific buttons for specific actions. Turning on or off like creating/deleting data. Checking the speed like getting information. Changing settings like updating information. Setting timers like modifying parts of settings. MIUI 125S like how your motorcycle responds to controls. When you twist the throttle, make a request, the engine responds, gives you back data, the ECU brain controls everything, different sensors give different information. Create a web service setting up systems. House, like installing a smart home system where you have a main control panel, controller, room addresses, web addresses, wiring, internal connections, pre-installed features, automatic setups. Fan, like setting up your fan where each button does something specific. Settings can be saved and changed internal system, make everything work. Motorcycle, like having diagnostic ports. Each port gives specific information. Data comes in standard formats. The ECU processes everything. Working with data, CRUD operations. House, checking room status, get. Removing devices, delete. Adding new rooms, post. Renovating rooms, put. Fan, checking settings, programming timers, updating modes, clearing saved settings. Motorcycle, checking engine stats, recording maintenance, updating settings, clearing error codes. Database organization. House, like having a blueprint that shows house ID number, list of all rooms, house address. Fan, like having memory that stores different mode settings, timer information, current configuration. Motorcycle, like keeping track of bike identification, maintenance history, service records. Setting up the database. House, like connecting to city utilities. Fan, like having temporary memory system. Motorcycling, like having a preset factory settings. Documentation, like having a complete manual that explains what the system can do, how to use each feature, what to expect when using different functions. All these components work together to create a complete system that can store information, database, process requests, controllers, perform actions, services, communicate with users, API, keep everything organized, ORM/JPA. Yes, you're already using the useState hook in your full code, but the difference is that you're directly using it within a script tag in an HTML file with Babel enabled to transfile JSX into JavaScript. This works fine for small demos, but when you move to a more modular setup with a React project, for instance, using tools like Webpack, Create React App, or Vite, you would typically separate the components and their logic. Here's how the key parts are connected in your code. In your HTML file with JSX and React, you're using React.useState to declare the state speed in the electric fan component. UseState manages the fan speed, and you use the setSpeed function to update the speed when the button is clicked. In the modular JavaScript version, the UseState hook is imported from React as a part of React's standard package. The electric fan component uses the UseState hook to create state, speed, and setSpeed is used to update it. The export default electric fan statement is used to export the electric fan component for use in other parts of the application. In short, the behavior is the same in both setups. The first version works in a single HTML with embedded React code using Babel to transpile JSX, while the second one uses the same UseState hook but is structured for a React application where components are often exported and imported separately. So to clarify, yes, you're using UseState correctly in both versions. The main difference is modularity. The second example breaks the component into separate files, which is typical for larger React projects, and uses export to allow the component to be imported into other parts of the application. If you're transitioning from the HTML version to a modular setup, the concept and use of this UseState hook remains the same. It's just that the components are now in separate files and you'd use import/export to manage them. Yes, equating HTML text to a state in React is valid and is actually the basis of how React works. In the code you provided, React is using the UseState hook to manage state and dynamically update the DOM HTML. Here's a breakdown. State declaration, const count, set count equal UseState 0. UseState 0 initializes the state count with the value 0. SetCount is a function that updates the value of count when you want to change it. Rendering state, p counter equal count, closing tag p. The count value, which is state, is rendered in the HTML, meaning that whenever count changes, React will update the DOM to reflect the change. Updating state, when you click the increment button, the setCount function is called, which updates count by adding 1 to it. React re-renders the component every time the state changes, ensuring the UI stays in sync with the state. Explaining in terms of the fan metaphor, now to connect this concept with your electric fan metaphor, where the speed is controlled based on whether a user is logged in or not, you can think of count as the fan speed and set count as the button that adjusts the speed. Here's how you can think about it. State in the fan metaphor. Count is like the current speed of the fan, just like the speed was in your fan example. The setCount function is like the action that controls the fan speed. In this case, it's like the increase speed button. Updating state. When you press the increase speed button, you're calling setCount, count plus 1 to increase the fan speed, similar to how setSpeed, prev, arrow to prev plus 1 work in your electric fan example. This causes the count to be updated, and React ensures that the fan speed in the form of HTML text gets updated in the DOM, rendering the updated state. Just like how speed in electric fan component is dynamically rendered, count in this counter component dynamically reflects the updated speed when you click the button. More complex nuance. The nuance of using UseState here is that React doesn't immediately update the state directly in the DOM. Instead, React schedules an update, and once the state changes, React re-renders the component. This makes React more efficient than traditional methods of DOM manipulation because it only re-renders parts of the UI that actually need to change. So in your fan example, when the speed changes, only the part of the UI showing the speed updates rather than re-rendering the entire page. Refactoring your example using the fan metaphor, here's how you can use the same concept in your fan example. Like this code. Final takeaway. In summary, using useState equates an HTML element like text or the content inside the p tag to a state variable, count or speed. This allows dynamic updates of the UI without having to manually manipulate the DOM. React handles the rendering based on state changes. This makes React an efficient way to build interactive UIs. I see. You want to visualize the fan being off when its login is false, meaning the UI should clearly show the fan is off, as if the fan is not working. The message should appear as the fan is off, and the button to increase speed should disappear. I'll clarify how to adjust the UI so that when the fan is off, when isLogin is false, the message appears, and when the fan is on, when isLogin is true, the button to increase speed shows up. Let's modify the example so that UI reflect this properly. Update the code with clear off like this code. What's changed? Conditional rendering inside electric fan component. When isLogin is true, meaning the user is logged in, we show the button to increase the fan speed and a message saying the fan is running. When isLogin is false, meaning the user is not logged in, we replace the button with the message the fan is off. Please log in to control the fan. UI behavior. When the UI is not logged in, the C message, the fan is off, and there is no button to change the fan speed. When the user is logged in, the button to increase the fan speed appears and the fan is considered running. What this would look like in the browser? Initially, isLogin equal false. The page will show please log in to control the fans. For each fan, it will show fan speed 2, fan speed 3, and fan speed 5. Below each fan speed, you'll see the fan is off. Please log in to control the fan with no button to increase the speed. After clicking login, the page will show here login, control the fans. For each fan, it will show the button increase speed under each fan speed. When clicked, the button will increase the fan speed and you'll see the updated speed and the message the fan is running. Switching between login or logout. When the user clicks logout, the fan becomes off again and the button will disappear, showing the message about login to control the fan. Final visualization. Fan off, not login, the fan is off. Please log in to control the fan. Fan on, log in, the fan is running with the button to increase the speed. Sure, I'll walk you through how to add the My component with the conditional rendering example into the existing HTML and React code, and I'll also incorporate the metaphor and understanding of the different concepts. Conceptual metaphor recap. Let's keep the metaphor of electric fans and motorcycle to make sense of how conditional rendering and useState work. Electric fans. Each electric fan has a speed setting. UseState is like the speed control of a fan. The speed can be changed and it's individualized for each fan, like having its own independent state. Motorcycles. Each motorcycle has a color, which is a prop that gets passed from the outside, meaning the motorcycle's color is fixed based on the information it received. Now, let's use the isLogin variable in My component as a metaphor for turning on or turning off the fan. When logged in, the fan is running, and when not logged in, the fan is off. Step-by-step integration. Here's how we can integrate your conditional rendering component inside the existing electric fan setup. Updated code, like this. What's happening here? Electric fan component. The electric fan component now also receives an isLogin prop, which determines whether the fan is active, allows increasing the speed, or off, shows the fan is off message. If isLogin is true, the button to increase the speed appears. If isLogin is false, the button is replaced with the message the fan is off. My component. The My component displays a message based on the login state. Is login. If the user is logged in, is login equal true. It displays your login, control the fans. Otherwise, it asks them to please log in to control the fans. App component. The app component controls whether the user is logged in or not through the isLogin state, React.use state false. It passes this isLogin value to both electric fan components and my component so they can react accordingly. Button to toggle login. There's a button at the bottom of the apps to toggle the login state. When clicked, it changes the login status, which affects both the fan speed controls and the message displayed. Understanding the nuance of each concept, use state. The electric fan metaphor holds for the state speed, where each fan has its own state, independent of others. The states start with initial speed and can be changed through the button interaction. The fan speed is independent for each electric fan, just like the state of each use state is separate props. The isLogin prop acts like a switch for the entire app. If you're logged in, you control the fan, and if not, the fans are turned off. The props are like external settings that the component receives, i.e., the color of the motorcycle or whether the fan is on or off. Conditional rendering. The My component uses conditional rendering based on the isLogin prop to change what is displayed, similar to showing the fan speed control or a message saying the fan is off. Conditional rendering is like deciding whether a fan is on or off based on the condition of the isLogin prop. What is the best metaphor for this? Electric fans. Each fan controls its own speed, like the independent states for each fan. But whether the fan is running, speed control allowed, depends on whether the user is logged in. Motorcycles, like motorcycles, props, are things external to the fan, like initial speed or login status, that come from outside the component and affect the behavior of the fan. So in essence, props are external settings like the initial speed of a fan. State is the internal status of the fan like the current speed which can be updated. isLogin as a prop is a global switch that controls the availability of the fan controls like turning the fan on or off. Yes, your understanding is quite close. Let's break down the code you shared to explain how conditional rendering works in React. Like this code. What does this mean? This is an example of conditional rendering in a React functional component. It means that based on the condition, in this case whether the user is logged in, the component will render different elements. isLogin is a prop passed to the component which indicates whether the user is logged in or not. If isLogin is truthy, i.e. true, a component will return the logout component. If isLogin is false, or something like null, undefined, 0, etc., the component will return the login component instead. So the logic works as follows. If the user is logged in, i.e. isLogin is true, the logout component is displayed. If the user is not logged in, i.e. isLogin is false, the login component is displayed. Does React automatically detect the else case? React doesn't automatically detect the else part in the sense that you don't need to explicitly write else or return after the if statement. The structure you've written is already sufficient. The if isLogin checks the condition. If the condition is true, it immediately returns logout. If the condition is false, it proceeds to the next line and returns login. So no, React doesn't automatically detect an else, but because of the flow of the code, the if and the following return, it behaves like an else after the if. How can you simplify this further? You can also write this using a ternary operator, which is a shorthand for if-else, like this code. This is the same logic but condensed into a single line. It does the following. If props that isLogin is true, it renders logout. If props isLogin is false, it renders login. Summary. React doesn't automatically detect else in a component. The logic flows needs to be explicitly written by using if or a ternary operator. In your example, React will render either logout or login based on the value of props that isLogin. Yes? This .handleClick is a JavaScript method defined inside the React class component. Let's break down your questions to explain how React works with JavaScript, JXX, which combines HTML and JavaScript, and how file structure is typically handled. TypeScript, the grand symphony of
type order in digital cosmos. Imagine the vast, untamed chaos of the digital multiverse, a realm where raw JavaScript roams wild, unshackled by rules, unpredictable in behavior. In this anarchic cosmos, TypeScript emerges as the grand symphony, a conductor that brings order to discord, transforming vague whispers into precise, harmonious compositions. TypeScript is not just a superset of JavaScript, it is the philosophy of precision, the alchemy of structure, the lighthouse guiding developers through the stormy seas of runtime errors. It is a guardian of logic, ensuring that every note in the digital symphony plays in perfect synchrony. What is TypeScript? Metaphor, the philosopher's stone of programming. TypeScript is like the philosopher's stone, turning JavaScript unpredictable, shifting sands into solid gold, refining it into a language of clarity and certainty. While JavaScript is like a poetic language, expressive but ambiguous, TypeScript is like mathematical logic, ensuring that each equation balances and each theorem holds. It is not just a language, it is a form of digital alchemy, imposing predictability onto uncertainty, structure onto chaos. How do we define variable types? Metaphor, the inscription of arcane sigils on reality. In JavaScript, variables are like shape-shifters, fluid and unrestrained. One moment they are numbers, the next they become strings, objects, or even undefined specters. TypeScript, however, binds variables with arcane sigils, inscribing their nature in immutable glyphs, like this code. Let name string equal Garrett. This name, one set, shall never become a number. By engraving these arcane runes of typing, we prevent mutations of essence, ensuring that a warrior does not suddenly transform into a bird-made battle. How do we define types in functions? Metaphor, the cosmic contract of divine architects. In a chaotic universe, a deity might call upon a summoning spell function but receive an entirely unexpected creature. A function might expect a warrior, but instead a merchant arrives, causing confusion. To prevent such cosmic mishaps, TypeScript enforces a divine contract between the function and its summoner, like this code. Here, the contract ensures that the function accepts only a number as its input. It guarantees a number as its output. Like a sacred law of the universe, this contract prevents anomalies, no summoning of undefined shadows or nonsensical creatures. How do we define types for React props and states? Metaphor, the genetic blueprint of living entities. React components are like life forms. They breathe, change, and react to their environments. But how do we ensure that they evolve correctly without mutating into abominations? TypeScript acts as the genetic blueprint, encoding their traits, props, and internal essence state in precise structures, like this code. Here, we have ensured that the label must always be a string, preventing it from mutating into a number or an undefined ghost. The onClick function must be defined, preventing a user from summoning a button that does nothing. Thus, TypeScript acts as the genetic engineer of UI components, ensuring stability, clarity, and predictability. How do we define types for events? Metaphor, the laws of motion in a celestial ballet. Events in JavaScript are like rugged meteors, unpredictable and volatile, colliding into code bases with unexpected force. TypeScript introduces Newtonian laws, regulating these celestial bodies and ensuring they follow predefined trajectories, like this code. Here, the event is no longer an unknown force, it is an identified celestial entity precisely categorized as a mouse event.
interacting only with an HTML button element. By defining event types, we avoid black holes of uncertainty, ensuring each interaction in the UI follows a governed law of motion. How do we create a React TypeScript app using Vite? Metaphor, the birth of a new civilization in a perfectly structured universe. Creating a React TypeScript app with Vite is like terraforming a new planet, laying down the laws of physics before life even begins. Like this code. npm create vite at latest my app dash dash template react dash ts is like initiating the Genesis protocol, spawning a world where TypeScript is already woven into the fabric of reality, ensuring structure from the very first breath. The development environment is optimized for performance, like an ecosystem thriving on sustainable energy. Code is modular, scalable, and predictable, preventing the rise of digital entropy. By using this command, we are not just starting a project, we are birthing an ordered civilization, one where components, functions, and data flows exist in perfect harmony, bound by the laws of TypeScript. Final metaphor, TypeScript as the architect of digital order. TypeScript is not merely a language enhancement, it is the grand architect of a type multiverse where variables are marked with immutable sigils, functions operate under divine contracts, props and state follow genetic blueprints, events obey celestial laws, projects are born into structured civilizations. To write TypeScript is to embrace the highest form of digital governance, to wield the tools of order in a chaotic reality, and to shape a future where errors bow before logic and clarity reign supreme. React as the living ecosystem of a digital universe. Imagine a vast, self-sustaining digital ecosystem, a cosmic symphony of interactive entities pulsating with logic, structure, and dynamic evolution. Each entity has its own existence, state of being, and communication pathways, yet all are governed by a universal set of principles. This is the universe of React, an ever-expanding digital reality where components, states, props, and hooks functions like elements of an intelligent biosphere. What is a React component? Metaphor, the living organism. A React component is like an autonomous organism within a vast digital ecosystem, a self-contained unit of existence, capable of perceiving its surroundings, receiving props, evolving, updating state, and interacting with other organisms, rendering UI changes. Just as cell in the body specialize neurons for thought, muscle cells for movement, components have rules, buttons, forms, modals, dashboards. Some live independently, while others function as a part of a greater structure, forming the organism of an application. What are states and props? Metaphor, the DNA and bloodstream of the digital organism. Props are like genetic instructions, DNA, inherited from a parent, immutable within the component itself. Defining core characteristics, state is like blood flow and electrical signals, coursing within the component, changing dynamically based on internal and external stimuli. A tree leaf component may inherit its shape and color, props from its parent tree, but its moisture level and flexibility state change based on environmental factors. How does data flow in a React app? Metaphor, the river system of a planetary biosphere. In React, data flows unidirectionally like a great river network starting from high altitude mountains, parent components cascading down through valleys, child components, and reaching the ocean, UI. Props are the river's pure source water flowing downward from the parent's glaciers. State changes are the rainfall and tributaries, altering the flow at different points. Lifting state up is like evaporation. Data rises back into the sky, parent component, condensing into new rain, updated state, and continuing the cycle. This structured flow prevents chaos, ensuring predictable and manageable updates across the app. What is the difference between stateless and stateful components? Metaphor: the difference between statues and living beings. A stateless component is like a stone statue, unchanging, immutable, and only reflecting what it was given. It receives props and presents them but has no personal experience. A stateful component is like a bird, aware of its internal hunger, navigating the skies, dynamically responding to stimuli. A stateless button is like an engraved sign, it simply displays text. A stateful button is like an intelligent bird. It remembers past interactions, changes colors when pressed, and responds to environmental triggers. What is JSX? Metaphor: the genetic code of digital organisms. JSX is the DNA sequence that combines HTML structure and JavaScript logic into a single hybrid entity, the ultimate genetic blueprint of UI components. Traditional UI building is like assembling a robot with separate components, one part for visuals, another for logic, and another for movement. JSX, however, fuses all three into a singular biological script where form and function coexist seamlessly, giving birth to self-rendering digital entities. How are React hooks named? Metaphor: the language of spellcasting in a magic realm. The React hooks are named like ancient spells, each invoking a different force of the universe. Use state: summon the inner spark, stores component memories. Use effect: channel the cosmic winds, reacts to environmental changes. Use context: unveil the collective knowledge, shares wisdom across realms. Use reducer: enforce the law of change, manages state transformations. Each hook follows the sacred incantation rule. It must begin with use, marking it as a tool that interacts with React's life force, state, and reactivity system. How does context work? Metaphor: the neural network of a collective consciousness. Imagine a hive mind where knowledge flows freely across beings. Each creature does not need to pass information manually. Instead, they are all plugged into the same neural network. This is React's Context API, a global telepathic link connecting distant components, eliminating the need for excessive prop drilling. Instead of passing down props through generations like oral storytelling traditions, components simply tap into the universal consciousness, accessing shared knowledge instantly and efficiently. Final metaphor: React as a self-sustaining digital organism. React is not just a framework, it is a breathing, evolving digital biosphere where components form the organisms, state and props function as a lifeblood and genetic memory. Hooks serve as adaptive evolutionary tools. Context acts as the hive mind connectivity. JSX writes the genetic code of existence. Data flows like rivers, shaping the ecosystem interactions. By mastering React, you become a digital architect, designing and breathing life into a self-sustaining, intelligent ecosystem of interconnected components. This is a great analogy for understanding how state management works in programming, particularly in the context of component-based architectures like React. Let's break it down. Lifting state up. In component-based programming, lifting state up means moving the state data of a component to a higher level parent component in the component tree. This is done when multiple components need to access or modify the same data. Instead of each component managing its own copy of the data, the shared data is moved to a common ancestor. Evaporation. The analogy to evaporation represents the process of the data rising from a lower level component to the parent component. It's not that the data disappears, but it's transferred or lifted to a higher level. Data rises back into the sky, parent component. This refers to the data now residing in the parent component. The parent component becomes the single source of truth for this particular piece of data. Condensing into new rain updated state. This is the crucial part. The parent component, having received the evaporated data, can now process it, modify it, or combine it with other data. This processed data then condenses. It becomes the new updated state. This new state is then passed down like rain falling to the child components that need it. Continuing the cycle, this highlights the ongoing dynamic nature of the state management. Child components can trigger events that cause the state to be lifted, evaporated again. The parent component updates it, condenses, and the updated state is distributed, rain, once more. This cycle repeats as the application interacts and data changes. In simpler terms, imagine a family. Several family members' components need to know the current weather data. Instead of each person checking the weather themselves, one person, parent component, checks the weather, lifts the state up, and tells everyone else updated state/rain. If the weather changes, that one person updates their information and tells everyone again, restarting the cycle. This lifting state up pattern promotes data consistency and make it easier to manage complex applications. It avoids situations where different components have conflicting versions of the same data. You're right to focus on this. It's a good way to understand how river works. Let's break down state changes or the rainfall and tributaries, altering the flow at different points. State changes. In this context, state changes refer to alterations in the river's flow. This could mean changes in the volume of water, the speed of the flow, or even the direction of the flow. Rainfall. Rainfall is a major factor that can cause state changes in a river. When it rains, some of that water will eventually find its way into the river. This increases the volume of water in the river, which can lead to a faster flow and even flooding. Tributaries. Tributaries are small streams of rivers that flow into a large river. When a tributary joins the main river, it adds more water to the river, again increasing the volume and potentially the speed of the flow. Altering the flow at different points. This means that the impact of rainfall and tributaries on the river's flow is not uniform. It varies depending on where along the river this input occurs. For example, heavy rainfall near the source of the river might have a more significant impact on the overall flow, the rain further downstream. Similarly, a large tributary joining the river near its mouth will have a different effect than a smaller tributary joining it upstream. In essence, this sentence highlights that a river's flow is dynamic and constantly changing. It's influenced by various factors like rainfall and the addition of water from tributaries, and these influences have different effects at different points along the river's course. Think of it like a road system. The main river is like a major highway. Rainfall is like extra cars entering the highway. Tributaries are like on-ramps where more cars join the highway. The flow of traffic, water on the highway, river, will change depending on how many cars, water, enter at different points. Sometimes it's a smooth flow, sometimes it's congested, flooding, and it all depends on where and how many cars, water join. Yes, you're already using the useState hook in your full code, but the difference is that you're directly using it within a script tag in an HTML file with Babel enabled to transfile JSX into JavaScript, etc. etc. jQuery and React Query are two different tools used in web development, but they serve very different purposes. Here's a breakdown of their differences. First, purpose and functionality. jQuery. jQuery is a JavaScript library designed to simplify HTML DOM manipulation, event handling, animation, and AJAX calls. It was widely used in the past to make JavaScript easier to use across different browsers and to reduce the amount of code needed for common tasks. It is not tied to any specific framework or architecture. React Query. React Query, now known as Tanstack Query, is a data fetching library specifically designed for managing server state, caching and synchronization in React applications. It simplifies data fetching, caching, and updating in React apps, making it easier to manage asynchronous data. It is tightly integrated with React and works best in React-based applications. 2. Use cases: jQuery, DOM manipulation, i.e. selecting elements, updating contents, adding or removing elements. It is tightly integrated with React and works best in React-based applications. Use cases: jQuery, DOM manipulation, i.e. selecting elements, updating content, adding or removing elements. Event handling, i.e. click, hover, submit. Ajax request for fetching data from a server. Animations and effects, i.e. fade in, slide up. React query, fetching, caching, and synchronizing server-side data in React apps. Managing loading and error state for API calls. Background data refetching and caching to improve performance. Pagination, infinite scrolling, and optimistic updates. Architecture: jQuery, imperative programming style. You directly manipulate the DOM and handle events using jQuery methods. Not component-based, it works with traditional HTML and JavaScript. React query, declarative programming style. You define what data you need, and React query handles the fetching, caching, and updating. Works seamlessly with React's component-based architecture and hooks, i.e. use query, use mutation. 4th, dependencies. jQuery, a standalone library that can be used in any JavaScript project regardless of the framework or library. Does not depend on React or any other framework. React query, specifically designed for React and relies on React's ecosystem, cannot be used outside of React applications. 5th, modern relevance. jQuery, while still used in some legacy projects, its popularity has declined with the rise of modern frameworks like React, Vue, and Angular, which provide more efficient ways to handle DOM manipulation and state management. Many of jQuery's features are now natively supported by modern browsers. React query, highly relevant in modern React applications for managing server state and data fetching, often used alongside state management libraries like Redux or Zustan for client-side state. 6. Example comparison: jQuery, Ajax request, like this code. Summary: jQuery is a general-purpose library for DOM manipulation and Ajax, while React query is a specialized library for managing server state and data fetching in React apps. jQuery is more suited for traditional non-framework-based web development, whereas React query is designed for modern React applications. If you're working with React, React query is a much better choice for handling data fetching and synchronization. jQuery is largely outdated for modern front-end development. TypeScript, the grand symphony of type order in the digital cosmos, etc., etc. Yes, this.handleClick is a JavaScript method defined inside the React class component. Let's break down your questions to explain how React works with JavaScript, JSX, which combines HTML and JavaScript, and how file structure is typically handled. First, is this.handleClick a JavaScript function? Yes, this.handleClick is a JavaScript function or method that is part of the class component. In React's class-based components, methods are typically defined inside the class and can be used throughout the component, like this code. This.handleClick is a JavaScript method that is invoked when the button is clicked, updating the component state. Second, how does React combine HTML, JavaScript, and JSX? React allows you to mix JavaScript and HTML-like syntax, JSX, within a single file. This is one of the powerful features of React. It makes it easier to build interactive components by combining the structure, HTML, and logic JavaScript in one place. JSX allows you to write HTML-like elements inside JavaScript code, but React interprets this JSX into regular JavaScript that browsers can understand. It may look like HTML, but it's actually just syntax that React uses to create JavaScript objects. Here's an example that combines all three, HTML, JavaScript, and React, like this code. The render method is where we write JSX that looks like HTML, but within this JSX, we can use JavaScript expressions inside curly braces. For example, this.state.count in JSX is a reference to the JavaScript state of the component. Third, file structure, combining or separating JavaScript and HTML. While JSX combines HTML and JavaScript into one file for component-based development, i.e. in a .jsx or .js file. When developing large applications, it's common to separate the logic and structure into multiple files to keep the code clean, modular, and maintainable. Option 1. Combine the JavaScript and HTML in the same file. This is typical for small applications or learning purposes. One file contains both the logic, JavaScript, and the structure, JSX/HTML, like this code. This is simple and works well for smaller projects or when you're first learning React. The JSX syntax inside render allows you to write HTML-like code but embed JavaScript expressions like this.state.count directly. Option 2. Separate files for JavaScript and HTML. For larger React applications, it's common to separate the JavaScript logic and the JSX structure across different files. React components can still be combined, but with modular components in separate files, it's easier to maintain and scale the project. Here's an example with the two files. Button.jsx, JSX/React component, like this code. In this example, button.jsx contains the logic and the button structure. App.jsx is a parent component that imports and uses the button component. When building a larger app, you might also have directories like /components for various components like buttons, headers, etc. /assets for images, CSS, etc. /services for APIs or utility functions. Fourth is onClick, a JavaScript or HTML property. The onClick event is part of React's event system. It is a JavaScript property that gets attached to HTML elements like a button when rendered. In regular HTML, you might see an onClick attribute, i.e. button onClick equals some function, click me button. In React, onClick is used in JSX as a JavaScript property that expects a JavaScript function or method as its value. Conclusion: React components allow you to mix JavaScript and JSX HTML-like syntax in the same file for ease of development, particularly when you're working with small applications. For large projects, you can separate JavaScript logic and JSX structure into different files for better organization and maintainability. This.handleClick is a JavaScript method that defined inside a class component and invoked when an event like onClick occurs. OnClick is a React property that expects a JavaScript function, and it's used in JSX to handle click events in React. This is why React uses curly braces to embed JavaScript expressions in JSX to allow you to pass JavaScript functions, variables, and state directly into the JSX structure. Let's break it down step by step. First, how do you reference JavaScript functions in handleClick and render? In the example you provided, handleClick and render are methods inside the React class component. They are functions within a class, like this code. How it works: handleClick is a regular JavaScript method within the class. It's called when the button is clicked and it updates the state using this.setState. Render is a special method in class components that returns JSX to be rendered. It's like saying, this is what I want to show on the screen. This.handleClick that bind this. This line binds the handleClick method to the current instance of the class, i.e. this refers to the instance of the button class. This is necessary because in JavaScript, methods lose their context when passed around. So bind this ensures that the method has the correct context when it's called. React's onClick event in JSX. We use curly braces to embed JavaScript expressions including functions when you write this code. The value of onClick is a JavaScript function. This.handleClick Reacts takes care of attaching this function to the button's click event. So when you click the button, it calls the handleClick method. Second, is this how we use React properly? To expect a JavaScript function? Yes, exactly. In React, we use JSX to define the structure, HTML-like syntax, and we embed JavaScript functions inside curly braces to handle events, update state, and more. React props like onClick expect JavaScript functions as values. For example, when you define an event handler in JSX like onClick equal this.handleClick, React treats that as passing a function to the onClick prop. So when a user clicks the button, React runs the function this.handleClick, which updates the component state. Third, what does super, props, and constructor props mean? In a class-based React component, the constructor, props, and super, props have specific roles. Constructor, props. The constructor is a special method in JavaScript classes. It's used to set up the initial state of the component and to bind methods to the component instance. Constructor, props, is automatically called when an instance of the class is created. It receives props, properties, or attributes passed to the component from its parent as an argument and initializes the state with that state. Super props is a call to the parent class constructor, which is React.component. You must call super props in the constructor of a subclass, which is what your component class is. This allows the component to inherit methods and behavior from React.component like setState. Without super props, you can't use this to refer to the current instance of the class because it hasn't been initialized yet. Like this code. Fourth, what is the greatest metaphor to explain this? Here's a metaphor to explain. Class component equal a car. Imagine the class is like a car. It has some basic functions like moving, methods, and part, state. Constructor equal car engine. The constructor is like the car engine that gets everything ready. When you start the engine, you set the car's properties like the fuel level, speed, etc. The constructor, props, takes care of the setting up the initial state, the car's starting condition. Super, props, equal car manufacturer, super props is like calling the car manufacturer and saying, hey, I need all the basic parts that are already built for this car. Because the car needs a basic framework from React.component to work. State equal fuel in the car. State is like the fuel. It's the internal data that drives the component. In the same way that a car can change speed, fuel level, or direction, React components can update their state to reflect changes. HandleClick equal car's accelerator. HandleClick is like the accelerator of the car. When you press the button, i.e. when you click, it performs an action. It changes the state like the car accelerating. Render equal car's dashboard. Render is the car dashboard. It shows the current state, speed, fuel level, and updates the user, or in this case the browser, with the current state of the component. So the component car needs the constructor engine to get started, the state fuel to work, and the render dashboard to display information to the user. Summary: in React, we use JavaScript functions inside JSX for event handling like onClick equal this.handleClick. Super props is required to call the parent class React.component. Constructor, which gives you class access to its inherited methods like this.setState. The constructor is used to initialize the state and bind methods in class components. The greatest metaphor is comparing a class component to a car. The constructor is the engine, super, props is the manufacturer, state is like fuel, handleClick is the accelerator, and render is the dashboard. How does React re-render only the change component? What React does behind the scenes? User clicks button, set speed, prev equal prev plus 1, runs. React compares the old state with the new state. React only updates the affected component, electric fan, instead of re-rendering everything. React preserves other component states. This is why multiple electric fan instances don't affect each other. A better metaphor, car dashboard and speedometer. Imagine driving a Yamaha Mio i125S motorcycle. The speedometer shows your current speed state. When you accelerate, the speed increases. Each motorcycle has its own speedometer, like each React component has its own state. If you have 3 motorcycles, each rider controls only their own speed in React. The dashboard updates only when speed changes, rendering affected components. Each motorcycle has independent control. Each use state is separate. Prev ensures correct speed tracking when accelerating multiple times. Complete code example like this code. Summary. Prev is not built into React, it's just a parameter name. Prev ensures correct updates when state changes multiple times. React renders only the change component instead of everything. Each component instance, like separate motorcycles, controls only its own state. Why do we use const for useState? We always define useState with const because React renders the component. If we use let or var, React might not track state updates properly. State does not change directly. We don't modify state manually. We use set state instead. Incorporating partial update in the metaphor. Metaphor, electric fan with adjustable speed and rotation. Imagine an electric fan with speed control, speed state, rotation control, is rotating state. Instead of resetting all settings when changing speed, we want to partially update only the relevant part. Updated code, partial update in new state, like this code. Explanation. We store both speed and rotation in a single state object. When updating, we use prev key colon new value to partially update state without resetting other values. Metaphor in real life. If you increase the fan speed, the rotating setting stays the same, partial update. If you toggle rotation, the speed remains unchanged. This is like adjusting only one feature of a device without resetting everything. Why wrap use state in a function? Like this code. Const speed, set speed equal react.useState 0. We use a function to enclose state inside the component because each component gets its own state. If multiple fans exist, each control its own speed. React can track re-renders. React re-renders only the affected component when set speed is called. Metaphor, personal motorcycle settings. Imagine 2 Mio i125S motorcycles. Each rider can adjust their own speed and headlight settings. They don't affect each other. This is why useState is inside the function, so each instance manages its own state independently. To use object destructuring in your hello component while keeping the code minimal, modify the hello function like this. Updated code using object destructuring, like this code. What's optimized? Object destructuring applied. Instead of function hello props, we use first name, last name directly, like this code. No need for extra variables, like this code. This directly renders up into root. Why is this most efficient approach? Fewer lines of code, more readable, reusable hello component, modern ES6 syntax. Difference between props and state using metaphors and visualization. Main difference: feature props, properties, state, internal data. Definition: external data passed from parent to child internal data that can change within the component. Who controls it? Parent component, component itself, mutable, read-only, unchangeable inside component, can be updated using setState. Example use case displaying a username, a title, or a message passed from parent handling button clicks, toggles, form inputs. Metaphor, MIUI 125S motorcycle versus electric fan. Imagine a MIUI 125S motorcycle and a manual electric fan. Props equal buying a motorcycle from the factory. The factory, parent components, gives you a blue MIUI 125S. You cannot change the original color yourself. Props are read only. If you want a red Mio, you need to ask the factory to give you a new one. Parent changes props in code like this. Motorcycle receives color equal blue from app. The child cannot change its own color. State equal changing the speed of manual electric fan. You own the electric fan and can manually adjust its speed anytime. You don't need the factory parent to update the speed. You control the state. Use state. Store speed. Pressing a button updates the fan speed using setState. In code like this. Clicking the button changes the speed inside the component. Unlike props, the component can modify its own state. How to visualize props and state in Chrome DevTools. Render in the browser. To see it render, copy-paste this into an HTML file and open it in Chrome. Like this code. Open the file in Google Chrome. Click the button and see state update while props remain unchanged. Second, inspect using Chrome DevTools. Right-click the page, click Inspect, go to the Elements tab. Expand div id equal root. Inside the React components, you will see props, motorcycle always stays blue. State, fan speed changes when you click the button. Final metaphor, summary concept metaphor example, props MIUI 125S motorcycle, factory color from manufacturer, parent gives child a color prop, child cannot change it, state manual electric fan, adjustable speed by user, component manages and updates its own state, speed, how to use state in HTML, CDN setup, to use the state concept, const, state, comma, set state equal react.useState initial value, you need event handling to update the state. Example, click button to change greeting like this code. Best metaphor to understand useState. Imagine useState as a manual electric fan, house, and MIUI 125S motorcycle. First, manual electric fan, Mikata, the fan doesn't move automatically. You have to turn the knob yourself. State equal current fan speed of, 1, 2, 3. Set state equal you manually turn the knob to change speed. React.useState 0, fan starts at speed 0 of clicking a button, set state 2, fan speed changes to 2. Relates to useState because you manually change state, not automatic like remote control. You can store and update fan speed like a variable. Second, house, static state versus React, dynamic state. A traditional house has a fixed paint color, no state change. A React powdered house allows you to change colors dynamically. State equal house color. Set state equal painting it a new color. Initial state, the house starts with blue paint. Use state, blue. Action, when you repaint it red, set state red, it updates immediately. Relates to useState because a normal house doesn't change. HTML is static. A React house allows updates, set state like repainting. Third, MIUI 125S motorcycle, key versus key start, like this code. Key start, like useState, initial value, you set an initial state. Kickstart, manual change, like calling set state, new value. State equal engine status, off, on. Set state equal turning the key to start it. Relates to useState because useState off, the motorcycle starts off. Set state on, when you turn the key, it starts. No automatic transmission. You have to shift gears manually, like updating state manually. Final takeaway: electric fan, adjusting state manually. House paint equal changing the color, state updates. MIUI 125S equals starting and stopping manually. React doesn't update automatically like remote control. You have to change state manually using a set state. Good question. You still need this line like this code. Why can't you just define app and hello without render? If you only define this like this code, nothing will show up in the browser. React does not automatically inject your components into the DOM. What does React DOM.create do? React needs a specific place in the HTML to render components like this code. Const root equal React DOM.create root document get element by id root.render up. Document.get element by id root finds div id equal root in your HTML. React DOM.create root creates a root React element. Root.render up tells React to put up inside hashtag root and manage updates. What if you don't use React and just use vanilla JS? If you wanted minimal code without React, you would just do like this code. Body h1 hello Johnson body. But React is not just for displaying text. It manages state, re-renders components, and updates the DOM efficiently. Can you make it even shorter? Yes, if you want minimum code but still React, use this like this code. This eliminates functions and renders directly, but it's not reusable like components. Final answer: yes, you need React DOM.create root.render up because React does not directly modify the DOM. It works with the virtual DOM and needs explicit rendering. Would you like to explore how React updates only parts of the DOM instead of the whole page? No. In JavaScript, function declarations are hoisted, meaning they can be called before they are defined. However, in React and JSX, there's a logical reason why the parent component is written below the child component. Why is hello defined first? When writing React components in JSX, React needs to know what a component is before it is used. If app is declared before hello, JavaScript doesn't know what hello is when parsing hello, first name equal John, last name equal Johnson, leading to errors. What happens if you put app first? If you write like this code, JavaScript will not throw an error because function declarations are hoisted. However, this is not a good practice because readability, it's harder to understand what hello does by defining it. Consistency. In modern React, we often use arrow functions and const/let for components. Unlike function declarations, arrow functions are not hoisted. How modern React works? In modern React, with arrow functions and hooks, if you try this, like this code, error. JavaScript does not hoist const function expressions, so app tries to use hello before it exists. Best practice, define the child first. For clarity, maintainability, and future-proofing your code, define child component first. Define the parent component after the children. Correct order, best practice, like this code. This approach ensures no confusion, works with function expressions, modern React, easy to read and maintain. Yes, below is the full .gsx code you need to save in Visual Studio Code and run in Google Chrome. This example uses React with CDN links, so you don't need to set up a full React project. Just save this as index.html and open it in Chrome, like this code. How to run it in Chrome: open Visual Studio Code, copy and paste the code into a new file, save the file as index.html, open index.html in Google Chrome, double click the file or right click, Open with Chrome. Your browser should display Hello Johnson. Developing at age 25. The age of 25 isn't a hard cutoff. Brain development is more of a gradual process that varies between individuals. When scientists say the prefrontal cortex develops until around 25, they mean some people's prefrontal cortex may fully mature at 24, others might continue developing until 26 to 28. There's no universal switch that flips at exactly 25. The key point is that your mid-20s, whether that's 25, 26, 27, or 28, represents the general period when the prefrontal cortex typically reaches full maturity. This doesn't mean learning suddenly becomes harder after this age. Your brain stops developing or changing. You've missed some crucial window if you're older. Think of it more like a gradient than a cliff edge. Your brain maintains significant plasticity throughout your life. You can continue learning and developing new skills well into your 30s, 40s, 50s, and beyond. The mid-20s just mark the end of the initial development period. The practical takeaway is that whether you're 24, 26, or 28, you're still in a very good period for learning complex, technical material like CompTIA A+. Would you like me to explain more about how to take advantage of your brain's plasticity while learning technical concepts? Here's how to maximize your brain plasticity while learning technical concepts like CompTIA A+. Active recall learning. Instead of just reading, actively test yourself. For example, after reading about network protocols, close the book and try to explain DHCP or TCP/IP as if teaching someone. This builds stronger neural pathways than passive reading. Spaced repetition. Don't cram all 1,000 pages at once. Break your study into smaller chunks and review materials at increasing intervals. For instance, review new concepts after 1 day, then after 3 days, then after a week. This strengthens long-term memory formation. Practical application. Your brain forms stronger connections when theory meets practice. If you read about RAM installation, actually open a computer and handle the components. This engages multiple sensory pathways in your brain, enhancing learning. Teaching others, explaining concepts to others, even if just verbally to yourself, forces your brain to recognize information into clearer patterns. Try explaining complex topics like motherboard, components, or troubleshooting steps. Physical factors that enhance brain plasticity. Get adequate sleep, 7 to 9 hours. This is when your brain consolidates technical learning. Exercise regularly, increase blood flow to brain and promotes neuron growth. Maintain good nutrition. Your brain needs fuel for forming new connection. Take breaks. Your brain needs time to process complex technical information.
This component receives an initial speed prop, which determines the initial speed of the fan motorcycle. It uses the U-state hook to manage the current speed of the fan. The initial speed prop is passed to U-state as the initial value. The increase speed button allows the user to increment the speed by 1 each time it's clicked. The update uses the prev state to ensure correct speed updates even if multiple button clicks occur rapidly. App component. The app component renders 3 instances of the electric fan component, each with a different initial speed. This demonstrates how each fan can start with its own independent speed but can be controlled separately. React and React DOM. React is used for rendering the components, while React DOM is responsible for attaching them to the DOM, in this case the div. Key points. Props used to pass the initial speed to each individual fan component. State managed independently for each fan speed, allowing users to interact with each fan speed independently. Using prev ensures the state speed is correctly updated based on its previous value, even when the updates are triggered quickly in sequence. What will you see? 3 fans are displayed on the page, each with an initial speed set by the initial speed drop.
Clicking the increase speed button will increment the speed of the fan independently of the others. To provide a clearer metaphor with props and state, let's build on your Mio motorcycle example, which can be expanded to represent the electric fan and app components. Metaphor: the motorcycle's props plus state. The motorcycle metaphor with state and props. Props: motorcycle manufacturer's specifications. Imagine you're buying a Yamaha Mio i125S motorcycle. The manufacturer provides you with specifications, props like the model name and engine type. Once you buy the motorcycle, you cannot change these factory settings from the outside. Props are read only. In REACT, props are passed into components and are used to configure or display information. They can be changed inside the component directly. State: the rider's speed control. The speedometer state tracks how fast you're going. This is controlled by the rider, the component. When the rider presses the throttle, they change the speed of their motorcycle. This reflects in the state of the motorcycle. The state is controlled internally within the motorcycle or component. The rider can adjust it, but the factory settings, props, can be modified from inside. Each motorcycle is independent, multiple components with their own state. Imagine you have 3 motorcycles and each rider can independently control their own speed. Each one has a unique speed, state, even if they are all the same model. Similarly, in REACT, you can have multiple instances of the same component, electric fan, with independent states. They all get the same props, but their states are separate and do not affect each other. Example with your code in your example. Here's how the metaphor applies. Electric fan is like a motorcycle. Each fan, motorcycle, has a speed state. Props, fixed attributes. Imagine you pass a certain attributes to your motorcycle, like its model or color. Just like props are passed into components. State, dynamic changes. The rider, the component itself, can adjust the speed, just like how the fan speed changes with the button. Press, setting state. Why use Prev for speed updates? To control the throttle on a motorcycle, i.e. increasing speed. The rider needs to know the current speed if they press the throttle multiple times. Each press should add to the current speed. In REACT, using Prev ensures you're always working with the current speed state, even if multiple state changes are batched together by REACT. Without Prev, you might end up with incorrect values, similar to not knowing the exact speed of the bike after multiple accelerations. Full metaphor explanation. Props. Imagine factory set motorcycle features like color, model, and engine type. This cannot be modified by the rider. Props are static and passed down to the component, motorcycle. State. The rider controls the speed just like the components. Just like the component's internal state is controlled by user interactions or internal logic. State is dynamic and can be modified by the component, rider. Multiple motorcycles. If you have multiple motorcycles, each rider has control over their own speed, state, independent of the others. This is like having multiple instances of the same component, each with its own independent state, code update, reusable components. To make your electric fan metaphor more reusable, we can add props to the electric fan to pass its initial speed. So each fan can be unique at first. Here's how we would adjust the metaphor in code, like this code. Now, the initial speed is set via props when creating each electric fan. Each fan has its own independent speed state that can be updated by its own button. Summary of the metaphor. Props equal motorcycle's fixed features. Color, model, state equal motorcycle speed controlled by the rider. Multiple motorcycles can exist, each with its own independent speed. Is Prev included in React library? No. Prev is not a special keyword in React. It's just a parameter name used in the function inside state. How does prev work in useState? When you update state based on a previous value, you use a function inside setState, like this code. Prev represents the previous state value. Prev plus 1 increases the speed based on the last known state. Why use prev? React's rendering process. React batches state updates to improve performance. This means if you update state multiple times, React may not update it immediately. What happens without prev? If you try to update state using speed plus 1 multiple times, React may use an outdated value, like this code. You expect speed to increase by 3, but React may only increase it by 1 because speed doesn't update immediately. Using prev fixes this, like this code. Now, prev always follows the latest value, so React ensures it updates correctly. How does this work in Chrome DevTools? You can check the React component updates in Chrome Developer Tools. Open Chrome DevTools, right-click on your page, inspect, go to the console tab, check states updates. You can log state changes inside your component like this code. Now, every time you click increase speed, you'll see logs in the Chrome console like this. This proves that prev always has the most recent value. How does React renders only the change component? What React does behind the scenes? Users clicks button, set speed, prev to prev plus 1 runs. React compares the old state 0 with the new state. React only updates the affected component, electric fan, instead of rendering everything. React preserves other components, states. This is why multiple electric fan instances don't affect each other. A better metaphor, car dashboard and speedometer. Imagine driving a Yamaha Mio i125S motorcycle. The speedometer shows your current speed state. When you accelerate, the speed increases. Each motorcycle has its own speedometer, like each React component has its own state. If you have 3 motorcycles, each rider controls only their own speed in React. The dashboard updates only when speed changes, rendering of the affected components. Each motorcycle has independent control. Each use state is separate. Prev ensures correct speed tracking when accelerating multiple times. Complete code example like this code. Summary, prev is not built into React, it's just parameter name. Prev ensures correct updates when state changes multiple times. React renders only the change component instead of everything. Each component instance, like separate motorcycles, controls only its own state. Why do we use const for useState? We always define useState with const because React renders the component. If you use let or var, React might not track state updates properly. State does not change directly. We don't modify state manually. We use setState instead. Incorporating partial update in the metaphor. Electric fan with adjustable speed and rotation. Imagine an electric fan with speed control, speed state, rotation control, is rotating state. Instead of resetting all settings when changing speed, we want to partially update only the relevant part. Updated code, partial update in useState, like this code. We store both speed and rotation in a single state object. When updating, we use prev, key, new value to partially update state without resetting other values. Metaphor in real life, if you increase the fan speed, the rotation setting stays the same, partial update. If you toggle rotation, the speed remains unchanged. This is like adjusting only one feature of a device without resetting everything. Why wrap use state in a function, like this code? We use a function to enclose state inside the component because each component gets its own state. If multiple fans exist, each one controls its own speed. React can track re-renders. React re-renders only the affected component when set speed is called. Metaphor, personal motorcycle settings. Imagine 2 Mio i125S motorcycles. Each rider can adjust their own speed and headlight settings. They don't affect each other. The relationship between reading complex books and increasing intelligence is complex itself. It's not as simple as saying reading these books will make you smarter in direct, quantifiable way. Intelligence is multifaceted, and these books primarily impact certain aspects of it. Here's a breakdown. What these books can do: enhance cognitive skills. They can improve critical thinking, analytical reasoning, problem solving, and information processing. By grappling with complex ideas, you're essentially exercising your brain. Expand knowledge. They expose you to new concepts, theories, and perspectives, broadening your understanding of the world. This increased knowledge base can be a component of intelligence. Improve vocabulary and language skills. Many of these books use sophisticated language which can enrich your vocabulary and improve your ability to express yourself. Strong language skills are often associated with intelligence. Develop intellectual curiosity. Engaging with challenging ideas can spark a thirst for knowledge and a desire to learn more, which is a key driver of intellectual growth. Promote metacognition. Thinking about thinking is a crucial aspect of intelligence. These books often encourage you to reflect on your own thought processes and biases. What these books might not directly do: raise your IQ score. While cognitive skills are related to IQ, reading these books is unlikely to significantly increase your score on a standardized intelligence test. IQ is influenced by many factors, including genetics and early childhood development. Make you an expert in any specific field. While they can broaden your knowledge, they won't make you a physicist just because you read a book about physics. Expertise requires focused study and practice. Guarantees success in life. Intelligence as measured by cognitive abilities is only one factor in success. Other factors like emotional intelligence, social skills, and perseverance are also crucial. So, will they make you the most intelligent? It depends on how you define intelligence. They will make you more intellectually capable in certain ways. They'll improve your cognitive skills, expand your knowledge base, and encourage intellectual curiosity. These are valuable assets that can contribute to success in many areas of life. However, they won't magically transform you into a genius overnight. The most important thing is how you engage with these books. Simply reading them passively won't do much. You need to actively engage with the material, think critically about the ideas presented, and relate them to your own experiences. The more you put into it, the more you'll get out of it. It's wonderful you're seeking out complex classics by women. These books offer rich intellectual and emotional experiences that can be deeply rewarding for your mental, emotional, and even physical well-being. Here are some suggestions with notes on their potential benefits. Cognitively and emotionally demanding classics by women. To the Lighthouse by Virginia Woolf. This novel is a masterpiece of modernist literature, exploring themes of time, memory, and the inner lives of its characters. Woolf's stream of consciousness style requires active engagement from the reader, stimulating cognitive functions. The emotional depth and nuanced relationships in the book can foster emotional intelligence and empathy. Potential benefits: improve cognitive flexibility, enhance emotional understanding, and a deeper appreciation for the complexities of human relationships. Jane Eyre by Charlotte Bronte, a classic of Victorian literature. This novel follows Jane's journey from a difficult childhood to finding love and independence. The complex plot, vivid characters, and exploration of social issues makes it a cognitively stimulating read. Jane's emotional resilience and moral strength can inspire readers and promote emotional well-being. Potential benefits: increased cognitive engagement, emotional resilience, and a stronger sense of self. Their Eyes Were Watching God by Zora Neale Hurston. This powerful novel tells the story of Janie Crawford, a black woman in the early 20th century as she navigates love, loss, and self-discovery. Her stunned uses of dialect and vivid imagery creates a rich cognitive experience. The themes of female empowerment and racial identity can be emotionally challenging but ultimately liberating. If you want a sprawling, immersive experience with a wide range of characters and themes, Middlemarch is an excellent choice. If you're more interested in psychological depth and stream of consciousness, To the Lighthouse might be a better fit. If you enjoy classic coming of age stories with strong female characters, Jane Eyre is a great option. If you're looking for a powerful exploration of race, identity, and female empowerment, Their Eyes Were Watching God is a must read. If you're interested in exploring themes of female sexuality and independence, The Awakening is a good choice. If you enjoy literary experimentation and complex narratives, Wide Sargasso Sea could be a good fit. Ultimately, the best book is the one that resonates most with you. I encourage you to read reviews and see which book sparks your interest the most. You might even consider reading a few of them. One of the most cognitively and emotionally demanding classic novels written by a woman that has been widely recognized for its psychological depth and impact on personal growth is Middlemarch by George Eliot. Here's why it's considered beneficial. First, cognitive benefits. Complex narrative structure. Middlemarch features a multi-layered story with interweaving plots and a large cast of characters, requiring readers to maintain focus and track various storylines. Philosophical and ethical themes. It explores profound questions about morality, ambition, and societal change, stimulating critical thinking and intellectual engagement. Rich language and style. The intricate prose challenges readers, enhancing vocabulary and comprehension skills. Emotional benefits. Empathy development. Eliot's deep psychological insights into her characters foster understanding and compassion for others. Relatable struggles. Themes such as unfulfilled ambition, marriage, and personal growth resonate emotionally, providing comfort and validation for readers navigating similar experiences. Potential physical health benefits, stress reduction. Immersing in a rich narrative like Middlemarch has been shown to lower stress levels and improve relaxation. Increase emotional resilience. Engaging with complex, emotionally charged stories can help readers process their own emotions more effectively. Other works written by women that might have similar benefits include Pride and Prejudice by Jane Austen for emotional insight and social critique, The Bell Jar by Sylvia Plath for a raw psychological exploration of mental health, To the Lighthouse by Virginia Woolf for its stream of consciousness, style, and emotional depth. Each of these books is proven to enhance emotional intelligence, empathy, and mental resilience, making them a worthwhile read for overall well-being. Deploying and hosting web applications. In preceding chapters, we learned how to develop web applications, so now is the time to take our finished web application to the internet. In this chapter, we'll explore the options available for installing a ready-made web applications on a server so that users can access this web application via the internet. Introduction. For a web application to be accessible to users over the internet, several steps are required. The complexity of these steps depends, among other things, on the complexity of the web application. Building, deploying, and hosting. The basic process for creating a finished product from the source code of a web application and making it accessible to users via the internet essentially consists of the following three steps, which I will discuss in more detail throughout the chapter. Building the web application for production use. Deploy, installing the built web application on the hosting server. Host, deploying the deployed web application on the hosting server. Build. In the first step, the build process, or build for short, you create a build web application based on the source code. This process includes, for example, compiling source code into machine code for compiled programming language, compressing or minifying source code for interpreted programming language such as JavaScript, and generally generating other build artifacts such as program packages. The build process can be executed on a development computer or on special build servers. The latter is particularly advisable when working in a team for elaborate build processes. Often, the build process is also triggered automatically by what are called continuous integration (CI) servers. For example, when changes are made to the source code that are uploaded centrally via a version control system. Deploy, the step to transfer the built-up web application from the development machine or build server to the server that deploys the web application over the internet, is referred to as deployment. Basically, various deployment options are available, which I'll discuss separately. Host, the server that provides a web application to users, is called a hosting server, or host for short. Hosting is not a real step but rather a state. A hosting server hosts the web application. You can rent a hosting server or some web space, i.e. the storage space you need for your web application, via a hosting provider. In addition to the web space, you also need a domain like cleancoderocker.com so that users can enter it in the browser, and possibly on secure socket layer SSL certificate so that you can also deliver the web application via HTTPS. What was that again about domains? Remember in chapter 1, I showed you what happens in the background when a user enters a URL in the browser's address bar. For the browser to know from which server to load the corresponding web page, it requests the IP address of the server with the URL from a domain name system server. Remember, DNS servers contain a mapping from domain names to IP addresses. For a domain that you rent, you can create what's called a DNS entry with a corresponding provider, i.e. concrete mapping from a domain to the IP address of the server on which the web application is installed. Since domains can be rented independently of web space, a distinction is also made between domain hosting and web space hosting. For this reason, nothing stops you from renting a domain from a completely different provider than the web space. Basically, different variants of web space hosting exist, which I will present separately in section 19.1.3. 19.1.2 Types of deployment. To deploy a completely built web application to a server, we have several options. In this section, I'll introduce you to the most important options: File Transfer Protocol (FTP), Secure Copy Protocol (SCP), Container Management. File Transfer Protocol. The classic variant uses the FTP or its secure variant, Secure File Transfer Protocol (SFTP). This protocol allows you to transfer files from one computer to another. As per requisites, an FTP client must be installed on the source computer and an FTP server must be installed on the target computer. Using the FTP client, you can connect to the FTP server already installed on the hosting computers of most hosting providers, and place the files on the server into the appropriate destination directory to which the web server installed on the hosting computer has access, as shown in figure 19.3. Note: known FTP clients include the following: FileZilla, https filezilla-project.org, CyberDoc, https cyberdoc.io, Forklift, https binarynights.com. Secure Copy Protocol. The Secure Shell-based SCP allows you to copy files securely from one computer to another, as shown in figure 19.4. For this purpose, you need an SCP client on the source computer and an SCP server on the target computer, both of which are installed by default in most Linux distributions and thus on most hosting machines, or can be installed relatively easily at a later stage. Note: SCP is particularly constructed for use on the command line and is thus specially suitable for automation by shell scripts or other programs you write yourself. Container management. Another option that has gained significant popularity and importance in recent years is deployment using containers, where Docker software plays a particularly important role. We'll go into more detail about Docker in section 19.2.1, but I want to outline its basic functionality, roughly as shown in figure 19.5. In terms of deployment, you can use Docker to package your web application into what are called Docker images, usually directly together with the corresponding web server to run the web application. You'll then upload these images to central registry from which the hosting machine, assuming an appropriate runtime environment for Docker, can download the image and launch the application. Docker is especially useful when you want to put a web application into a consistent format that can be installed on different machines or servers without much effort. In addition, Docker provides rather different scaling capabilities from a web application hosted without Docker. Types of hosting. Regardless of how you deploy a web application, you can distinguish between different types of hosting. The following are the most important types of hosting: shared hosting, virtual private server, VPS hosting, dedicated hosting, cloud hosting. Shared hosting. In shared hosting, your web application shares the appropriate hosting server with other web applications as shown in figure 19.6. Compared to the other types of hosting, this type is particularly inexpensive and especially suitable for smaller web applications that don't require a lot of memory and don't expect too high a number of simultaneous users. Virtual private server hosting. With this option, your web application is run inside the VPS as shown in figure 19.7. This virtual layer above the operating system divides the server into different areas. So, in turn, each VPS has its own operating system with guaranteed resources, memory, storage, CPU cores, etc. that you don't need to share with other users. VPS hosting is suitable whenever you want to host a web application that should be able to handle a high number of concurrent users. Moreover, with VPS hosting, you can usually flexibly increase resources if you find that the current resources are no longer sufficient over time. Dedicated hosting. Dedicated hosting goes one step further than VPS hosting. In this case, your web application has an entire server for itself, as shown in figure 19.8. You get full administration access to this server, which gives you a relatively large amount of freedom. Conversely, however, you usually need to take care of aspects like installing security updates yourself. Dedicating hosting is a good choice if you have particularly high requirements for the performance of a web application and want to be flexible regarding the software you want to install on the hosting server. Cloud hosting. One type of hosting that has become increasingly popular in recent years is cloud hosting. In this case, your web application sometimes run on multiple servers or on a cloud infrastructure formed by a network of servers, as shown in figure 19.9. Cloud hosting is particularly suitable if you want to scale a web application dynamically, for example, depending on the current number of users. Requirements for servers. Regardless of what type of hosting you use, the hosting server must, of course, meet the system requirements specified by the particular web application. Static web applications. If you have a static web application consisting only of hypertext markup language, cascading style sheets, and client-side JavaScript code, all you need is a web server like Nginx or the APIC HTTP server installed on your server, as shown in figure 19.10. Usually, you place a configuration file on the web server to define in which directory the files are located, and the files are made available via the web server through the corresponding directory path. Dynamic web applications. If the web application is dynamic and consists of a part that must execute server-side logic, among other things, which programming language implements the server-side logic is important, as shown in figure 19.11. Do you use JavaScript to implement the logic? Then the server must have an appropriate runtime environment such as Node.js. Have you implemented the server-side logic with Java? Then a Java runtime environment must be installed on the server. Note, before you decide on a hosting variant and hosting provider, make sure you check whether the system requirements for the corresponding web application are met. Web applications with a database. If you've implemented a dynamic web application, most likely you also need a database to manage the dynamic data. Consequently, this database must also be installed on the hosting server as shown in figure 19.12. Full stack server. Basically, the requirements for the server on which a web application runs are derived from the components used in its underlying stack as shown in figure 19.13. Servers must therefore provide the entire software infrastructure to run the respective application. In other words, you'll need a full stack server. Docker can considerably reduce the amount of work required to install or deploy this software infrastructure, as you'll see next. Container management. In this section, I'd like to go a little deeper into Docker and show you how easily you can package web applications using Docker. Docker, a container virtualization software, allows you to deploy individual software components such as databases, web servers, message brokers, or even complete web applications in the form of what are called Docker images, which are launched as Docker containers. Benefits of Docker. The benefits of Docker are huge for developers. Instead of having to install all software components separately on your system, you can simply launch the corresponding component via Docker. For one thing, this approach keeps the development machine clean, and second, you can also exchange Docker images with other developers very easily. In this way, you can ensure that all developers on your team use the same version and configuration of a software component. Moreover, in contrast to a manual installation of required software components, databases, messaging systems, backend services, front-end services, monitoring tools, logging tools, and so on, you can save an enormous amount of time that would normally be spent on installation and maintenance. But it gets better. Deploying your own software, for example, a web application as Docker images, makes sense. This approach allows you to install your applications easily on other computers. All that's required is that Docker runtime environment be installed on the target computer. Whether the computer is another developer's machine, a computer's computer, or hosting server is irrelevant. Once brought in the form of a Docker image, your web application can be installed anywhere. Deployment with Docker. The basic process of deploying with Docker is shown in figure 19.14. Using a Docker file, you create a Docker image that contains your web application. Based on this Docker image, you can then launch a Docker container within which the web application will run. Optionally, you can push the Docker image to a Docker registry, which is particularly relevant with respect to the deployment on hosting machine. From the Docker registry, in turn, the Docker image can be downloaded, pulled, and installed. Real-life example, packaging a web application using Docker. Now, let's package the web service from chapter 17, which manages data using SQLite database into a Docker image. For this purpose, you'll need to extend the package.json configuration file with the node.js package manager script shown in listing 19.1. While not mandatory, this step does allow you to conveniently start the web service right away using npm start command. Note, to test whether everything starts correctly, call the npm start command in the application directory and then open the URL http localhost 8001/api/contacts in your browser. As a response, you should see any empty array in the browser. Installing Docker. I have omitted a description of the installation process at this point. Instead, I would like to refer you to the official documentation at https://docs.docker.com/get-docker, where you can find details about installing Docker on various operating systems. Creating the configuration for the Docker image. To create a Docker image, you need a configuration file, which by default is named Docker file. In this file, you can define the individual steps to perform in order to create the Docker image. The file thus acts as a blueprint for a special Docker image. Basically, various commands are available in a Docker file that you can use to define the individual steps. For example, to copy files, install software packages, or execute certain command line commands. Listing 19.2 shows the contents of the Docker file for creating a Docker image for the name web service. An explanation of the various steps follow after the listing. In addition, you can find a complete overview of all available commands in the official documentation. First, define the base Docker image. From node :14, create the application directory workdir/usr/src/up. Copy the configuration files package.json and package.lock.json. Install the dependencies, run npm install. Alternatively, in the production system, run npm install -- production. Copy the source code files, copy ... Release port at which the Express server is running, expose 8001. Start the defined npm script, cmd npm, start. Alternatively, start in debug mode, cmd npm, start, debug. The following commands are used in our example. The from command allows you to define which Docker image is the basis for the image to be created. For Node.js, a good idea is to use one of the official Docker images of Node.js. At https://github.com, https://hub.docker.com, and https://store.docker.com, Docker store, respectively. You can find Docker images for all major Node.js versions and can also draw upon older versions if necessary. For example, to test the backward compatibility of an application, we'll use the Node image for the current long-term support LTS version of Node.js, version 14, which is tagged accordingly under the Docker Hub. The workdir command enables you to define the working directory within which the application will be launched when later a Docker container is created based on the image. The copy command allows you to copy files and directories from the development machine for host machine in the context of Docker into a Docker image. The copy package.json/command makes sure that both the package.json and package-lock.json files are copied into the Docker image. Run allows you to define commands that are executed on the command line when the Docker image is created in a Docker image. In our example, run is how we call the dependencies installation process via npm install. The copy ... command then copies the actual source code of the application to the working directory of the Docker image. You can use the expose command to define the ports that the started Docker container should make available to the outside world. Since our web server runs on port 8001, we release exactly this port via the expose 8001 command. Using cmd, you can then specify a command that is executed when a Docker container based on the image is started. Using cmd npm, start, we make sure that the npm start command is executed and thus the web service is started. Metaphor: the dome as a living city. Imagine the dome as a vast, living city where every web page is a thriving metropolis with different types of buildings, roads, and services. JavaScript, acting as the city's architect and maintenance crew, uses the DOM API to construct, modify, and manage the city dynamically. The key components of the DOM city: document node equal the city government. The document is the central authority governing everything. It holds the blueprint, DOM tree, of how the city is structured. Element nodes equal buildings and infrastructure. Every HTML element is like a building in the city. Div, p, h1, img, or image are different types of structures. They shape the physical layout of the city. Text nodes equal billboards, street signs, and advertisements. The text inside buildings and signs conveys information. Example, a P tag with "Welcome to Dome City" is a billboard. Attribute nodes equal addresses and building permits. Each building has identification details, ID, class, styles. Example, ID equal main-street, class equal apartment, style equal color, red. Modifying the city with the DOM API. Adding new buildings, elements. Use create element, div, to construct a new building. Use append child to place the building into the city. Example, a new shop, div class equal shop, closing div, is built. Renovating existing structures, modifying elements. Inner HTML equal complete interior redesign, dangerous if uncontrolled. Text content equal changing signs, inside safer. Demolishing buildings, removing elements. Remove child, tears, down an old building. Example, closing a shop by removing its div, repainting or renaming, modifying attributes. Set attributes, class, skyscraper, changes a building's purpose. Example, changing a shop into an office tower. Navigating the city roads, parent nodes equal main roads and highways. Parent node finds the main road leading to a district. Example, a neighborhood UL contain houses, LI. Child nodes equal buildings in a district. Child nodes list all buildings inside the district. Example, UL contains LI houses. Sibling nodes equal neighboring buildings. Next sibling, previous sibling, check what's beside. Example, a coffee shop next to a bakery, bringing external data into the city, fetching data. The fetch API is like a delivery service, bringing new resources into the city. It fetches new articles, images, and user-generated content from the servers. Example, a news board, div ID equal news, is updated with the latest headlines. Exploring more of the world, other web APIs. Beyond city building, JavaScript can tap into a vast network of APIs. Geolocation API, find the location on a map. Canvas API, paint a digital artwork. WebSocket API, enable real-time communication. Final mnemonic cities to remember how the DOM works. C. Create new elements. Create elements. I. Insert them into the DOM. Append child. Insert before. T. Traverse between nodes. Parent node. Child nodes. Next sibling. I. Identify and modify. Get element by ID. Set attribute. E. Erase elements. Remove child. S. Synchronize data. Fetch API. This metaphor connects every major DOM concept to a real-world city, making it easier to visualize. Let me know if you want an even deeper breakdown. Think of the DOM, document object model, as grand family tree, where every web page is a dynasty with interconnected relationships. Metaphor, the royal family tree of the web page. Document node, the monarch, the supreme ruler overseeing the entire page. Every element descends from it. Example, document in JavaScript. Element nodes, the nobles. The key figures in the kingdom, kings, queens, dukes, represent HTML elements, div, p, h1. They shape the structure of the web page. Text nodes, the decrees. The royal message and decrees contain the actual text inside elements. Example, hello world, inside p, hello world. Attribute nodes, the titles. Honorary distinctions like Sir or Duke of York provide extra information to elements. Example, ID equal main, comma, class equal hero. In div, ID equal main. Mnemonic, delta, the ever-changing river of nodes. Use delta to recall the most important nodes. D. Document node, the grand ruler. E. Element nodes, the structure nobles. L. Literal text nodes, the decrees. T. Title and attribute nodes, the royal titles. A. Access and modify methods, append child, replace child. Just like a river data constantly changes, the DOM tree dynamically updates as you manipulate the web page with JavaScript. In your package.json, it appears that @babel/preset-react is not listed as a dependency. However, you are using Vite with the @vite.js/plugin-react plugin, which is typically used for handling React projects, including JSX transformation without explicitly needing Babel presets like @babel/preset-react. Load the DLL or sys file into a disassembler or debugger. Use Visual Studio Disassembly View for functions. View for functions is stepped through in a debugging session. View API documentation. For GDI32.dll, refer to Microsoft Docs. For nvl.ddmm.km.sys, look for GPU driver development documentation from NVIDIA. Fourth, why is the source code restricted? Proprietary nature. Both GDI32.dll and NVL.ddmm.km.sys contain intellectual property that Microsoft and NVIDIA guard against reverse engineering. Security. Openly available driver or OS library source code could be exploited by malicious actors. Fifth, learning more. If you're genuinely curious about how this system works, study the Windows internal book. Explore open source graphics libraries like Mesa 3D or driver frameworks like Linux DRM/KMS for GPUs. Use tools like sysinternals, Soot to monitor and learn about the interactions between system components. The operating system implements multiple layers of security and restrictions to prevent unauthorized programs from abusing features such as GUI rendering and dialog box creation. This involves both hardware-enforced mechanisms like CPU privilege levels and software checks like API validation and access control. Here's a detailed breakdown. First, how is the OS secured against unauthorized access? The OS enforces security through the following core components: user privilege separation, using functions. SAS provides several features that make using CSS much easier. For a long time, these functions were globally accessible. However, since the introduction of the SAS module system, SAS developers have advised loading the functions via the corresponding modules, as it isn't guaranteed that all these functions will remain global in the future. The functions provided by SAS can basically be divided into the following categories: caller functions, SAS: caller module. These functions simplify the use of caller values. For example, you can mix colors, determine the saturation, brightness, and transparency of a color or the individual component of a color: red, green, and blue, and much more. String functions, SAS: string module. These functions make it easier for you to deploy strings. For example, you can determine the length of strings, form substrings, or convert the characters of a string to uppercase or lowercase. Mathematical functions, SAS: math module. These functions enable you to perform various mathematical operations such as finding the maximum or minimum of several numbers, generating random numbers, rounding numerical values, and much more. List functions, SAS: list module. These functions facilitate the work with list. For example, values can be read from list, values can be added to list, or the number of list entries can be determined. Map functions, SAS: map module. The functions in this module help you to use maps. Among other things, the values for keys can be defined. Values can be deleted or read, and multiple maps can be merged. Selector functions, SAS: selector module. These type of functions allow you to process CSS selectors. To use the functions from the corresponding modules, you first need to import the respective module using the @use keyword followed by the name of the module. For example, @use sas::color. Then, to use a function from a module imported in this way, simply specify the name of the corresponding module without the sas: prefix, followed by a period and the name of the function. For example, color.mix parenthesis #00ff00 comma #ff00ff semicolon closing parenthesis. Listing 9.16 shows some example like this code. When you compile this SAS code, the functions are called internally by the SAS compiler and the respective return values will be inserted into the generated CSS code, like this code. Implementing custom functions. In addition to built-in functions, SAS also allows you to define functions yourself, which you can then call within the SAS code. These custom functions are similar to what you already know from programming languages such as JavaScript. A function definition can be introduced with the @function keyword followed by the name of the function, the parameter list in parentheses, and the function body in curly brackets. As shown in listing 9.18, for example, the sum function is defined, which expects a list of dynamic length, recognizable by the 3 dots following the $sign numbers parameter name, and the total of the numbers contained in this list. A nice example of using the @each loop you already know from section 9.2.6. In this case, the sum, open and close parenthesis function can be called within CSS rules with different parameter combinations, like this code. By the way, and here's a little food for thought, actually an exercise, the SAS code shown earlier in listing 9.18 can be further optimized or written in an even more compact way. Can you spot where code can be saved? Correct. The selectors of the 3 CSS rules already look quite similar, so why not put the whole thing in another loop? Note, before you look at the solution directly, you can of course take a little break and try to solve this use case yourself first. Just take a look at the previous sections for this purpose. Here's a little tip. You need variables, a loop to iterate over list, and preferably a nested list. Alright, we haven't described nested list yet, so I'll give you that part. Another little tip, the more complex the SAS code you implement, the more often it makes sense to get some more information about the program flow every now and then. For example, which value a variable currently has, which loop iteration you're in, etc. The debug function can help you in this regard. Pass it a message which will be printed on the command line during the compilation step. This output does not affect the final result, i.e. the CSS file that is generated, but can be really helpful for debugging, like this code. So now I have given away almost too much. Feel free to try it yourself before continuing with the sample solution. The solution for the use case described earlier is shown in listing 9.22. First, we'll store the parameters we need to pass to each of the sum function in a list of lists. So the first entry in this list contains the list of parameters needed to generate the first CSS rule. The second entry contains the second parameter list, and the third entry contains the third parameter list. Then, we'll use the @each loop to iterate over the outer list. Within the loop body, we'll then call the sum function in each case and pass the respective parameter list, i.e. the respective inner list, whereby the 3 dots ensures that the entire list is not passed as a single parameter, but rather the values contained in the list as individual parameters in each case. We'll store the return value of the sum function in the $sum variable and can use it as usual in several places in the following code. Specifically, we'll use the variable for the class name within the selector, and second for the concrete value of the with property, like this code. Nesting rules. With all these features of Sass, as a web developer, you should ask yourself regularly why these features are not already part of standard CSS. One feature that I think particularly adds to clarity and is really missing in standard CSS is the ability to nest CSS rules. An example is shown in listing 9.24, where different CSS rules are defined for the UL list, UL LI single list items, and UL LI nested list items selectors, conveniently nesting these CSS rules. In this way, you can save some typing when defining the CSS selectors. Instead of explicitly specifying these selectors individually for each CSS rule, the selectors result from the nesting, like this code. The CSS code Sass generated for listing 9.24 is shown in listing 9.25. Based on the nesting, the selectors were automatically determined and the corresponding CSS rules were generated for the different selectors, like this code. Using inheritance and mixins, variables and functions already provide an easy way to reuse code within CSS or Sass. You can further use concepts such as inheritance and mixins. However, inheritance lets you define that individual CSS rules inherit from other CSS rules. For this purpose, you must use the @extend keyword as shown in listing 9.26, followed by the selector of the CSS rule from which the CSS rule should inherit. In the example shown in listing 9.26, the CSS rules for the .button-special and .button-submit selectors inherit the entire CSS declarations of the CSS rule with the .button-base selector, like this code. When you compile the Sass code shown in listing 9.26, a CSS rule will be defined for three selectors: .button-base, .button-submit, and .button-special due to inheritance. Mixins are another way of reusing code and work similarly to inheritance in Sass. However, they differ in terms of the generated CSS code. Basically, you can define a mixin by using the @mixin keyword followed by the relevant CSS rule. You can then use the @include keyword to include the mixin, specifying the mixin name used, like this code. However, unlike inheritance via @extend, when mixins are used, the corresponding selectors are not combined into a single CSS rule. Instead, the mixin code included via @include will be directly inserted into the corresponding CSS rule, like this code. Summary: in this chapter, you saw how CSS preprocessor can be used and the additional features they offer compared to standard CSS. Key points: you should take away from this chapter the following information. CSS preprocessor language like Sass, Less, and Stylus are languages that are converted to CSS by CSS preprocessors. These preprocessor languages provide various features that CSS itself does not offer or has not offered until recently, such as variables, functions, operators, and nesting of CSS rules. These features make the CSS code clearer and also facilitate the CSS development process. You learned about the following features in this chapter using Sass. Variables. Using variables, you can centrally define values once that you want to use in different places within the CSS code and reference the variables instead of the value within CSS rules in each case. Operators. Using various operators such as comparison operators, mathematical operators, and conditional operators, you can calculate CSS values dynamically. Branching. Using branches, you can generate different CSS code depending on certain conditions. Loops. For repetitive tasks, you can use loops in CSS preprocessor languages like Sass. These features allow you to generate similar CSS rules or CSS declarations relatively easily. Functions. You can use functions to structure code for generating CSS into reusable code blocks. Nesting. CSS preprocessor languages like Sass allow CSS rules to be nested. Inheritance. Through various constructs, it is relatively easy in CSS preprocessor languages for CSS rules to inherit from other CSS rules. Recommended reading: Implementing Single Page Applications. In this chapter, Sebastian Springer explains how you can use React to build a single page application using the basics of hypertext markup language HTML, cascading style sheets, and JavaScript. As a full stack developer, sooner or later, you'll come across one of the major front-end frameworks in JavaScript. In this chapter, you'll learn how to use React to create a single page application and manage the information for your application, like this code. Introduction. With a combination of HTML, CSS, and JavaScript, you can create web apps that rival native desktop or mobile apps. One of the most important features in this context is the fact that such applications are implemented with individual HTML pages, through which a user navigates via hyperlinks, but instead are implemented as a single page, called a single page application. Single page application. A single page application is an application that runs in the browser and consists of HTML, CSS, and JavaScript. Basically, as the name suggests, a single page application consists of only one HTML page. This page is controlled using the underlying web technologies, and only certain views are presented to the user. The data is stored in the browser's memory. As soon as the page is manually reloaded by a user, the memory is reset and must be rebuilt by the application, which results in a decisive speed disadvantage. Thus, the goal of every developer is to prevent these full page loads. React supports you in implementing single-page applications by providing a number of tools. Anything React does not do can be included via external libraries. You can implement single-page applications in pure HTML, CSS, and JavaScript. However, one disadvantage of this approach is that you must solve a whole series of standard problems and thus virtually reinvent the wheel again. At this point, relying on an established solution that takes care of this task for you is the best approach. As usual in the JavaScript world, no one standard solution is the correct one. Numerous frameworks and libraries are available for your use. In recent years, however, three major solutions have emerged and have established themselves as the standards: Angular, Vue, and React. What all three have in common is that they are open source projects managed on GitHub. They also all follow a component-oriented approach, but more on that later. The similarities end at this point. Each solution has its own raison d'etre and can rely on strong and active communities. All three of them have specific strengths and characteristics. Let's briefly consider these differences. Next, Angular, structure and order. In my opinion, these two terms best describe Angular compared to other frameworks. Angular was developed by Google as a front-end framework and provides a standard solution for most problems. This framework is based on the TypeScript programming language and makes some specifications regarding the design and structure of applications. The guidelines of the frameworks give clear recommendation for the structure of the directory and file hierarchy. These recommendations also specify a framework for implementing the components of an application, including how the individual parts of the application interact with each other and where they should be placed in the file system.
Yes, .ev extensions configuration files for AWS Elastic Beanstalk typically use the YAML format, but the file extension is usually .config rather than .yaml. For example, you would use certbot-ssl.config instead of certbot-ssl.config.yaml, like this code. The error message you're seeing indicates that the archive file c/work/chapter01/car-database.zip already exists, and the compress archive command doesn't automatically overwrite existing file unless explicitly told to do so. To resolve this, you have two options. First, override the existing archive. Use the -force parameter to override the existing .zip file. Second, update the existing archive. If you want to add or update files inside an existing archive, use the -update parameter, like this code. Choose the one that best fits your use case. If you simply want to replace the existing archive, the -force option is the way to go. Re-uploading a .zip file, such as for your application to your AWS Elastic Beanstalk environment will not automatically trigger a reboot of your EC2 instance or the IAM role itself. However, depending on what you're deploying, there are a few things that might happen. First, Elastic Beanstalk deployment process. When you upload a new application version via .zip file, Elastic Beanstalk will automatically deploy the new version to your environment. This can trigger the following actions. EC2 instances may be restarted or replaced if Elastic Beanstalk needs to update the application or infrastructure. Services and configurations, such as those defined in .eb extensions, may be updated according to the deployment. Rebooting EC2 instances. Elastic Beanstalk itself manages the EC2 instances behind the scenes. When you upload and deploy a new version of the app, the EC2 instances may undergo a rolling restart to ensure the environment is updated properly, but it doesn't reboot unless necessary for the deployment process, i.e., if there are changes to the environment that require restart. IAM role. The IAM role associated with the EC2 instance in the Elastic Beanstalk environment typically doesn't change when you upload a new .zip file. The IAM role is a part of the environment configuration and would only be updated manually. A re-upload of your .zip file doesn't affect the IAM role unless you explicitly modify it through the AWS Management Console or CLI. Key points: EC2 instances may be restarted or replaced as part of the application deployment process. IAM role: no automatic change occurs to the IAM role unless you explicitly modify it. Elastic Beanstalk process typically manages updates to ensure application versions are deployed successfully, which could lead to instance restarts if needed. If you want to ensure smooth deployment with no downtime, Elastic Beanstalk generally handles it with rolling updates, so only some instances are updated at a time. However, if you need a manual restart for specific reasons, you can always trigger one manually through the AWS console or CLI. The error you're encountering during the deployment seems to be related to the certbot command that is being executed as part of your .eb extensions configuration file. certbot-ssl.config, specifically the error message command 04-run-certbot failed points to an issue with the certbot command in the 04-run-certbot section of your configuration file. Here are a few things you can check and adjust to resolve this. First, check file paths and syntax. The error log mentions that your .zip archive appears to be using backslashes as path separators, which is not correct for Linux systems. They use forward slashes / instead. Make sure the paths in your .zip file follow the correct Linux path format. If you're developing on Windows, consider using tools like 7-zip to create the archive to ensure it uses the correct path separator. Second, verify certbot command. The certbot command you're using might fail due to missing dependencies or permission issues. Try running the certbot command manually on an EC2 instance to ensure it works as expected. Here's how you might manually test: sudo certbot apic-d your domain, etc. If this command works manually, then the issue might be related to how the .eb extensions command is executing during the deployment. Logs for more details. The error message suggests looking into /var/log/cfn-init.log for more details. This file might contain more information about why certbot is failing to run. You can SSH into the EC2 instance and check the logs, like this. This may provide more specific information about the failure. Ensure certbot is installed. Make sure that certbot is installed correctly in your EC2 instance. You can install it using the following commands: sudo yum install -y certbot. Additionally, verify that APIC is installed and the mod _SSL module is enabled, since certbot will interact with APIC to set up SSL certificates. Revisit the .eb extensions file. Double check the syntax in your .eb extensions /certbot-ssl.config file. Sometimes small issues such as missing indentation or incorrect YAML formatting can cause the deployment to fail. Make sure the file follows the YAML syntax properly. Here's a refined version of your .eb extension config. Check for missing dependencies. If you continue to encounter errors, make sure that all dependencies such as APIC and certbot are installed and up to date. For APIC, you can check the status, sudo systemctl status httpd. If APIC isn't running, the certbot command might fail. Permission issues ensures the user running the certbot command, typically root, has the necessary permissions. If not, try adjusting the permissions on relevant files and directories. By checking these potential issues and improving the .eb extensions configuration, you should be able to resolve the certbot deployment problem. If the issue persists, the logs from /var/log/cfn-init.log or /var/log/eb-engine.log will be crucial in narrowing down the exact cost. It seems like you're running the compress archive command and using the -force parameter to overwrite an existing .zip file. This should successfully overwrite the previous archive without any issues, and it looks like the command has completed without errors. However, based on the error you mentioned earlier about the path separators in the .zip file, it appears that Windows-style backslashes are being used instead of Unix-style forward slashes. To fix this, you can try adjusting the file paths in your .zip file before uploading it to Elastic Beanstalk. Here's how you can do that. Unzip the .zip file on your machine, extract the contents of car database.zip file, etc. When you redeploy a new version of your application to an Elastic Beanstalk environment, the environment itself doesn't always require a full reboot of the EC2 instances. However, Elastic Beanstalk will trigger a deployment process which typically involves first stopping the old application version. This could involve stopping the web server or any processes running the previous version of your application. Second, deploying the new application version. The new version is extracted and placed on the EC2 instances. Third, starting the new version. The EC2 instance will load the new application, including any necessary changes from your .eb extensions or other configuration changes. Fourth, health check. Elastic Beanstalk will run health checks to ensure that the new version is running properly. If there are issues with the deployment, the health status may transition to warning or no data. In your log, environment update is starting. This indicates that the environment is beginning the update process to deploy the new version of your application. Environment health has transitioned from warning to no data. This can happen if instances aren't reporting data properly, possibly due to the deployment process being in progress or an issue with the configuration. In most cases, the EC2 instances will not fully restart, but there could be a temporary stop or start process for the services involved. If you're using .eb extensions to modify your EC2 instances or install software like certbot, there may be specific restart steps built into those configurations. To answer your question directly, yes, the deployment process could involve a temporary service restart or instance restart depending on the changes you made in the application or configuration. If the health check fails during this period, you might see a temporary no data state. If the instance health doesn't recover and the environment stays in a bad state, you might need to check the logs like /var/log/eb-engine.log or /var/log/cfn-init.log for more specific errors that could be causing the issue. From the logs you've shared, the issue seems to stem from a failure during the pre-build extension phase, specifically with the command 04-run-certbot. The error indicates that the certbot command, likely a part of your .eb extension's configurations, failed to execute properly. The failure leads to an aborted deployment and result in environment reverting to the previous configuration. Here's a breakdown of what's going wrong. First, error during the certbot run. The key part of the error message is error occurred during build. Command 04-run-certbot failed. This indicates that the certbot or renewal command failed when the deployment tried to execute it. This can happen if there is a misconfiguration or missing dependencies on the EC2 instance for running certbot. .eb extensions failure. The .eb extensions configuration files may be set to run certbot as part of the environment setup. If this is the case, it's important to review the configuration to ensure certbot is properly installed and the required environment settings, i.e. domain permissions, are set correctly. Suggested steps to troubleshoot. First, check eb.engine.log. You might find more details about the certbot failure in the eb-engine.log or cfn-init.log on the EC2 instance. Review those logs to see the specific error returned by certbot. Verify installation. Confirm that certbot is properly installed and available on the EC2 instance. You can do this by accessing the EC2 instance directly and running the following command: certbot-version. If it's not installed, ensure your .eb extensions file installs certbot correctly. Review your .eb extensions config. Double check your .eb extensions configuration, especially around the 04-run-certbot script to ensure everything is configured as expected, especially if you're attempting to set up SSL certificates. Test the certbot command manually. Try running the certbot command manually on the instance to see if it produces any more detailed errors. You can SSH into the EC2 instance and try something like sudo certbot renew. Redeploy the environment. Once you have addressed the issue with certbot, i.e. by fixing installation issues or permissions, try redeploying the application to see if the error persists. Additional considerations: if the issue is related to file paths as mentioned in the unzip error with backslashes, ensure that the zip file structure uses / for paths, especially if you're developing on Windows machine. If certbot requires specific permissions, i.e. access to certain directories, make sure those permissions are correctly configured in your .eb extensions. The .eb extensions configurations provided looks mostly correct, but there are a few points worth checking and refining to ensure that certbot runs smoothly on your Elastic Beanstalk environment. Here's a breakdown of your configuration and potential improvements. Potential issues and recommendations. Certbot installation. Elastic Beanstalk environments are often pre-configured with certain base packages. While you are installing certbot using YAM, make sure that the correct repositories are available to install it. Some Amazon Linux versions may not have certbot in the default YAM repos. You may want to ensure you're adding the EPEL repository to install certbot properly. Try modifying your .eb extensions to include this step explicitly, like so. Second, permissions and directories. Ensure the //bar/triple-w/html/.well-known/acme-challenge directory is writable by the APIC web server. This seems to be handled by your chown and chmod commands, but it might be worth verifying that APIC has the correct permissions to create files there. You could also check the permissions of etc/let's encrypt to ensure that certificates can be created and read by APIC. Elastic Beanstalk environment variables. The aws/elasticbeanstalk-url environment variable is being used, but ensure that it's properly set up in the Elastic Beanstalk environment configuration.
If it's not automatically injected, you might need to define it in the environment variable section of the Elastic Beanstalk configuration, i.e. in the Elastic Beanstalk console under Configuration, Software Environment Properties.
It may not be necessary or practical to actively involve all stakeholders in design as participants, but generating a list of stakeholders helps to decide who to involve and to what degree. Potential users and those affected by the product's introduction are primary candidates for close involvement. Identifying this may seem like a straightforward activity, but it can be more complicated than you think. For example, Xia Zhao et al. 2016 found a more diverse set of users for smartphones than most manufacturers recognize. Based on analysis of 1 month's smartphone app usage, they discovered 382 distinct type of users, including screen checkers and young parents. Some products such as system to schedule worksheets have defined user communities. For example, a specific role, shop assistant within a particular industrial sector, retail. In this case, although there is a range of users with different roles who relate to the product in different ways, the list is constrained. Apart from direct users, shop assistant and scheduler, indirect users include those who manage direct users, those who receive outputs from the system, and those who test the system. Those affected by the product include the customers of the shop who want the right level of service and family members of the staff. Having identified and consulted the list of stakeholders, engaging the right groups may still prove to be difficult. Katie Seaborn et al. 2020 discussed a number of challenges in engaging the user community in a large urban food waste recycling project, despite partnering with a range of stakeholders. Having tried a number of tactics to involve residents, including word of mouth, residents association meetings, cold calling, and sticking up posters, the researchers chose the unusual approach of observing the contents of the existing bins to build up a picture of food waste habits. The importance of involving users. Chapter 1. What is interaction design? Stress the importance of understanding people and their activities when designing interactive products. This involves considering users or potential users in the design process, not just to understand them and their activities, but also to test and evaluate candidate designs in their context. Both aspects are necessary because it is the best way to ensure that the end product is usable and provides a good experience so that it will be used. In commercial projects, a role called the product owner is common. The product owner's job is to filter user and customer input to the development cycle and to prioritize requirements or features. This person is usually someone with business and technical knowledge and is often called upon to assess designs. Although they have close engagement with the product and customer needs, they are only able to represent a limited view of the product's use and cannot predict how customers will respond to a given design at any useful level of detail.
The best way to ensure that the product is usable is to involve potential users across all stages of development. Two other aspects are equally important if the product is to be usable and used: expectation management and ownership. Expectation management is the process of making sure that the expectations of the new product are realistic. Its purpose is to ensure that there are no surprises when the product is released. If people feel the product has been misrepresented, then this will cause resistance and even rejection. Although avoiding disappointment in design may be particularly difficult to achieve with a large and complex system. Nevo and Wade, 2007. Involving potential users and those impacted by the new product at different stages during development helps with expectation management because they can see the product's capability from an early stage. They will also understand better how it will support their activities, how it will affect their jobs and lives, and why the features are designed that way. Adequ- Adequate and timely training is another technique for managing expectations. Having the chance to see pre-release video or work with a hands-on prototype or early version will create a better understanding of what to expect when the final product is available. A feeling of ownership is another reason for involving potential users. Those who are involved and feel that they have contributed to a product's development are more likely to feel a sense of ownership toward it and support its use. When developing tools to support Wikipedia contributors, Angelica and Kai found that early involvement of members of the Wikipedia community led to a higher acceptance of their innovations. How to involve potential users in what roles and for how long needs planning, as discussed in the next dilemma box. Dilemma: too much of a good thing. Involving potential users in development is a good thing, but what evidence is there that it is productive? How much should users be involved and in what roles? Is it appropriate for users to lead a technical development project, or is it more beneficial for them to focus on evaluating prototypes? Uli performed a detailed review of the literature in this area and concluded that overall, the evidence indicates that user involvement has a positive effect on user satisfaction and system use. However, they also found that even though the data clearly indicates that these positive effects, some links have a large variation, suggesting that there is still no clear way to measure the effects consistently. In addition, they found that most studies with negative correlation involving users and system success were published more than 10 years previously. The kind of product being developed, the kind of user involvement possible, the activities in which they are involved, and the application domain all have an impact on the effectiveness of user input. Peter investigated the effect of user involvement in transport design projects. They found that involving users at later stages of development mainly resulted in suggestions for service improvement, whereas users involved at early stages of innovation suggested more creative ideas. Recent moves towards an agile way of working has emphasized the need for feedback from customers and users, but this also has its challenges. Kurt suggests that in tailoring their methods, teams consider the distinction between frequent participation in activities and effective engagement. Fisher reviewed the literature on involving older people during technology design and asked whether it matters in design practice, and if so, in what ways. They identified three main consequences of involving older people: learning about older people's lives, adjusting designs based on older people's input, and increased sense of participation and feelings of ownership. But their findings also highlight that empirical papers they surveyed were unclear on the impact that involving users had on acceptance and adoption.
Involving people as participants at different stages of the process is without a doubt beneficial, but the key is knowing who, when, where, and how. Degrees of user involvement. Different degrees of user involvement are possible, ranging from fully engaged throughout all iterations of the development process to targeted participation in specific activities, and from small groups of individual users in face-to-face context to hundreds of thousands of people online. Occasionally, individuals may be co-opted onto the design team so that they are major contributors to the development. On the downside, full-time involvement may mean that they become out of touch with their own community and context of use, while part-time involvement may result in a high workload for them. On the upside, having someone co-opted to the design team, full or part-time, means that their input is available continually. More commonly, individuals may take part in specific activities to inform the development or to evaluate designs once they are available. Where user involvement is limited, there are techniques to keep users' concerns uppermost in designers and developer minds, such as true personas. User participation may take the form of small groups or individual tasks taking part in face-to-face information gathering design or evaluation sessions, but increasingly online sessions are used, leading to many thousands of potential users being able to contribute to product development. There is still a place for face-to-face user involvement and in situ studies, but there is now a wider range of possibilities than in the past. One example of this is online feedback exchange system, which are increasingly used to test design concepts with millions of target users before going to market. In fact, design is becoming increasingly participative through crowdsourcing design ideas and examples. For instance, where crowdsourcing is used, a range of different people are encouraged to contribute. This wide participation helps to bring different perspectives to the process, which enhances the design itself, produces more satisfaction with the final product, and engenders a sense of ownership. Another example of involving users at scale is citizen engagement, the goal of which is to engage a population with the aim of promoting empowerment through technology. The underlying aim is to involve members of a community in changing their lives, where technology is viewed as an integral part of the process. For example, Rajan described crowd research. Their goal was to increase global upward mobility within the scientific community by making research experiences accessible worldwide. They report that more than 1,500 people from 62 countries have been participated over 2 years and have produced top-tier computer science articles. This project illustrates how community engagement can increase inclusivity and widen opportunities, offering meaningful ways for the general public to engage in community design projects can be challenging. Brandon suggests a framework to provide a structured process of engagement, support inclusive and sustained participation, and promote effective management of large-scale participation. Further examples of community engagement and the use of crowdsourcing in design and evaluation are described in Chapter 14. Participatory design, also sometimes referred to as co-creative design, co-operative design, or co-design, is an overarching design philosophy that places those for whom systems, technologies, and services are being designed as central actors in creation activities. The idea is that instead of being passive receivers of new technological or industrial artifacts, end users and other stakeholders are active participants in the design process. Chapter 12, Design, Prototyping, and Construction, provides more information about these approaches. The individual circumstances of the project affect what is realistic and appropriate. If the user groups are identifiable, for example, the product is for a particular company, then it is easier to involve them continually. If, however, the product is intended for the open market, it is unlikely that potential users will be available to join the design team. It is also likely that customer experience design issues the experienced users have
when interacting with the brand, not just a product, will become relevant. Box 2.2 outlines an alternative way to obtain user input from an existing product, and Box 2.5 discusses A/B testing, which draws on user feedback to choose between alternative designs.
A strong metaphor is controlled components are like marionette puppets, while uncontrolled components are like free roaming wind up toys. Explanation: controlled components, marionette puppets. Every movement, state change is controlled by the puppeteer, react state. The puppeteer always knows the puppet's exact position. Changes in input fields are reflected in the state and vice versa. Uncontrolled components, wind up toys. Once you wind them up, set an initial value, they move independently. You have to observe them, use ref, or get value and submit to see where they went. React doesn't have direct control over their state. Demonstrating this in Krita. First, sketch two scenes. Left, a marionette puppet with strings controlled by a puppeteer labeled React state. Right, a wind-up toy moving freely on a table labeled uncontrolled. Add arrows and labels. Arrows showing direct control from the puppeteer to the puppet, controlled components. A dashed or indirect observation arrow pointing to the wind-up toy, uncontrolled components. Use color coding: blue for controlled, reacts control, red for uncontrolled, independent movement. Component hierarchies in React are like an orchestra where the conductor, parent component, leads different musicians, child components, each playing their specific instrument. Explanation: parent component, conductor, manages the overall performance, state, server communication, gives instructions, props to musicians, child components, ensure harmony by coordinating all elements, child components, musicians, focus on playing their part, rendering specific UI elements, receive instructions, props from the conductor, can signal back callbacks if something needs adjusting, i.e. deleting a record. Data flow, music notes and signals, notes, props, flow from the conductor to musicians. If a musician, child component, plays a wrong note, modifies state, they signal the conductor callback functions. How to demonstrate in Krita? Sketch two scenes. Left, a single person playing all the instruments, messy, inefficient, like one giant React component. Right, a well-organized orchestra with a conductor leading violinist, drummers, and a pianist, modular component structure. Add labels. The conductor equal parent component, i.e. list component. Musicians equal child components, list item, buttons, etc. Music sheets equal props being passed down. Hand gestures or signals equal callbacks for state changes. Color coding: blue for parent component, conductor, green for child components, musicians. Arrow showing data flow direction, props and callbacks. The library system metaphor: context equal library system. The library is a centralized place where books, data are stored. Any branch component can access books without having to request them from another branch. Provider: main library headquarters. The headquarters distributes books, data to all branches components. It ensures that every branch gets the latest book additions, updated state. Use context hook equal library card. Any branch component with a library card use context can borrow books, access state. They don't need to ask another branch for books. No prop drilling. Updating state equal adding or removing books. When a new book is added, new contact and state, it's immediately available to all branches. If a book is removed,
Deleting a contact, it disappears from all branches instantly. Illustration in Krita. First, two panels left without context. Each library branch must request books from other branches. Messy, inefficient, prop drilling. Right, with context, all branches have direct access to the headquarters collection. Clean, efficient, centralized. Labels, library system equal context. Headquarters equal provider. Branches equal components. Library card equal use context. Arrows show inefficient communication in the left panel. Props being passed manually. Shows smooth direct access in the right panel. Use context retrieving data instantly. To make form creation and component hierarchy deletion stick in memory, the family tree metaphor. Imagine a family tree where the parent component equal grandparents. They own the family house, state, and manage it. They pass down stories, data to their children, child components. The child components form equal parents. They receive traditions, props from grandparents. They teach those traditions to their children, grandchildren, or nested components. The submit button equal family storytelling. Every time someone tells a story, submits the form, it gets added to the family history state. Deleting a component, a branch of the family tree disappearing. If a family member component moves away, is deleted, the family still remembers their stories, state persists. But if no one tells the stories anymore, state is not managed properly. History is lost. How to illustrate this in Krita or visually? Two side-by-side family trees. Left, before React context, the grandparents, list component, must directly tell every child and grandchild the family stories, prop drilling. This becomes messy and difficult as the family grows. Right, with React context, a family diary context is placed at the center. Any family member component can open the diary, use context, and read or write stories. No need to call grandma for every detail. Arrows and labels. Label props as family traditions being passed down. Label context as a shared diary accessible to all. Show what happens when a component is deleted. A branch of the tree disappears, but the diary keeps the records. This deeply relatable analogy makes it memorable for people of all ages, from a young learner to someone 100 years old. Grandparents metaphor for routing in React. Routing in React using React Router can be understood through the family house metaphor. How routing works in a family home. Imagine a big family house where each room represents a different component page. The living room equal contact list / list. The study room equal form / form. The front door equal default route / redirects to / list. The hallways and doors represent navigation, routing. A hallway browser router connects all rooms. Doors, links and navigate, let you go from one room to another. How grandparents React Router guide the family. When you visit the house for the first time, / grandma, the router says go to the living room first / list. That's where everyone gathers. If you want to add a new family record, you walk to the study room / form. After writing in the family diary, submitting the form, grandma reminds you, go back to the living room / list. Everyone should see the new record. This is like navigate / list. Why this makes routing memorable? First, everyone relates to a home layout. We all know how moving between rooms works. Second, grandparents guiding the family is a timeless concept. Third, no unnecessary steps like in React Router. You go directly to the room you need. Fourth, the house remains standing even if family members change, like how the app state remains even when routes switch. Now, if someone asks, how does React works? You can say it's like walking through a family house where every room is a different page.
and Grandpa Router tells you where to go. The family home metaphor, component, hierarchy, and routing. Imagine a big multi-generational family house where Grandma, the highest level component, manages everything. Grandma, up component, the wise family matriarch who oversees the whole house. Parent, list component, takers of organizing the family's contacts. Child, form component, allows family members to add new records. Context API, family tradition, stores shared family knowledge so nobody forgets important details. How routing and state work in the house. Grandma's house has rooms for different activities. Living room / list where family members gather to see the contact list. Study room / form where new family records are added. Front door / grandma always redirects visitors to the living room first. Using the context API, family traditions, instead of each room keeping its own separate list of family members, Grandma maintains one shared family tree global state in a big book context API. Any room can read, form, or update this family tree, ensuring all records are consistent. Forms equal family diary. Controlled components. When someone writes a new entry, fill outs a form, they don't write directly in Grandma's book. Instead, they first write in a draft, local state in the form component. Once it's finalized, submitted, Grandma adds it to the official family book, updates context / state in the list component. Navigation between rooms equal moving around the house. Links, doors. A door from the living room leads to the study room / form. Use navigate, Grandma's reminders. After writing an entry, Grandma reminds you to return to the living room / list. A family house is easy to visualize, just like an app with multiple views. Grandparents maintaining a family book, context API is relatable. Moving between rooms, routing makes sense. You go where needed without resetting everything. Filling out a form before recording history is like a real-life documentation. Final thought. In React, Grandma, the app component, organizes the whole house component hierarchy, ensures everyone follows traditions, context API, and makes sure records are properly written before being stored, forms and controlled components. The error in this item.jsx on line 5 likely occurs due to one of the following issues, possible causes and fixes. First, undefined contact prof. If contact is undefined or null, trying to access properties contact.id, contact.firstname, etc. will cause an error. Solution, check the ESLint. The difference between Express and React Router. First, Express, type, backend framework, server-side, purpose. Express is used to build web servers and handle HTTP requests from clients like a React app. It provides the routes that your application responds to, such as handling GET, POST, delete requests for database operations. Usage, when your React app sends a request, i.e. fetch, HTTP localhost 8001/API/contacts. The request is processed by the Express server to fetch or send data back. Express is the server-side part of a web app. Example, if you want to fetch list of contacts from a database, Express will provide an endpoint, i.e. API/contacts for the React app to call. React Router, type, front-end library, client-side, purpose. React Router is used for client-side navigation. It enables your React app to switch between views or pages without reloading the whole page, making the app feel like a single-page application. Usage,
React Router helps you navigate between different components of your app, like navigating from a list view to a form view without refreshing the page. It handles the routes in the browser front end. Example, you might have /list route for showing contacts and /form for submitting new contacts. React Router handles switching between those views in the browser. In short, Express is about handling requests on the server, backend. React Router is about navigating between pages in the browser front end. To remember these concepts for decades, you can associate them with memorable metaphors and emotional connection. First, Express as a postman. Imagine Express as a postman who delivers messages between your app and the outside world, i.e., database. The postman, Express, picks up requests, processes them, and brings back data or sends information to other places. Second, React Router as a map. Think of React Routers like a map guiding you through a city, your app. It lets you move between different neighborhoods, components, without needing to leave or reload the city app. React Router is the tool you use to get from one place to another in the front-end world. Analogies with real-life memory triggers. Express equal postman delivering packages. The image of postman delivering package that's fetched or sent could stick with you every time you think of Express. Imagine the postman handling data. React Router equals city map. Think of your app as a city with lots of routes like streets, and React Router is the map that guides you around without having to reload or start over. Deep emotional connection. Focus on how important it is that Express delivers data safely and efficiently, and how React Router lets you seamlessly move between parts of your app, keeping the user experience smooth. Memory tip for a lifetime. Create a fun story or a memory palace. Picture Express as a reliable postman you can always trust, and React Router as the smooth navigation of your dream city. Teach someone. Teaching is one of the best way to make something stick in your memory for decades. Daily use and repetition are key. Anytime you build an app, remind yourself about Express being the server-side helper and React Router being the front-end guide. This fun, vivid imagery should help keep the concepts clear for many years to come. No, despite the passing months, he could not forget how someone he still loved had gone like dew from a twilight beauty, and those proud, fastidious ladies who always withheld themselves from him were so demanding that he yearned particularly for the one who had touched his heart by yielding to him utterly. How he longed, incorrigible as ever, to find someone dear and sweet, with no great name to uphold, and with whom he need never feel required to be on his best behavior. He missed no news of any likely prospect, and one may assume that if he detected any further sign of promise, he sent her at least an encouraging line. Who by now can doubt that very few rebuffed him or received him with indifference? Those who remained willfully cool simply failed, in the prim and proper heartlessness of their ways, to know their place. Nor did they often persist long in their pride, for they would then collapse ignominiously into marriage with one nobody or another. He dropped many for that reason. Now and again he recalled that woman of the cicada shell with irritation. She of the reed, too, must have been surprised sometimes by a note from him, whenever a favorable breeze blew her away. He would gladly have seen her again at her ease in the lamplight. On the whole, he was not one to forget any woman he had once known. The daughter of Nurse Simon, his favorite after Nurse Dani, was now serving at court, where she was known as Taifu, the commissioner's Myobu. Her father, the commissioner of war, was of imperial descent. Genji himself sometimes called on her for one errand or another, since she was a young person much given to gallantry. When not at the place she lived at her father's, now that her mother had gone down to the provinces as the wife of the governor Chikozen. Taifu once happened to tell Genji how the last and best loved daughter born to His Highness of Hitachi was living in sad circumstances now that her father was gone. What a shame, Genji, intrigued, asked to hear more. I know little about her character or looks. She is so shy and reticent that when I visit her of an evening, I speak to her through curtains and so on. Her one real friend seems to be her kin. That is one of the friends. Though I can think of another that would ill become her, please let me hear her. His Highness her father played so well that I cannot imagine she is no better than anyone else. I wonder whether her music would really interest you, she answered, although she spoke in a manner designed to pique his interest. You are trying to tempt me, aren't you? I shall go there secretly one of these nights when the moon is veiled. You must come with me. Taipu had not wanted to get in his sleep, but she still went there one spring evening when all was quiet at the palace. Her father had taken up residence elsewhere and visited the place only now and again, but Taifu, who had never felt comfortable at her stepmother's, had become a familiar presence there. Genji arrived, as he had said he would, at the prettiest hour for the moon of the 16th night. What a pity, Taifu explained. This is not at all the kind of night to bring out an instrument stone. Do go to her though, and get her to play a little. I would hate to live again without hearing her at all. Taifu installed him in her own comfortably casual room and set off, guilty and nervous, for the main house. The lattice shutters were still up, and Her Highness was gazing out at a deliciously fragrant plum tree. Taifu judged the moment to be propitious. I could not resist the promise of so beautiful a night, my lady, when I realized how lovely your kin would sound. I so regret that in the rush of all my comings and goings, I am never able to hear you play. I gather that some people really do appreciate the kin, Her Highness answered. But how could my playing possibly interest anyone who frequents His Majesty's seat? She sent for her instrument, and Taifu trembled to think how she might sound to Genji. She played very softly. It was quite nice. Not that she was any sort of master, but her instrument was so superb in tone that Genji was not displeased by what he had heard. That so great a lord should have brought up his daughter so tenderly to manners strict and now long abandoned, in a house so sad and neglected, and all for nothing. Ah, what regrets she must have. Why in the old tales this is just the kind of place that provides the setting for all sorts of moving scenes. Such musings encouraged him to want to approach her, but fear that she might think forward made him hesitate after all. Taifu, whose wits were always about her, had no wish to give him his fill of the princess' music. The sky seems to be clouding over, my lady, she said. A guest of mine said he would be coming and he might suspect me of having no use for him. Soon, though, when I have the time, do let me put the shutters down, and off Taipu went without encouraging her further. She stopped almost before she began, Genji complained. I had no time even to decide whether or not she was worth listening to. What a bore. Her Highness' music has been well received. Let me stand nearer to listen, if you don't mind, he went on, and Taipu saw he was intrigued. I think I would rather not, though, she replied. The dismal life she has to lead is so depressing for her, and her whole existence is really so sad. I do not see how I could take it upon myself. He agreed that she was probably right. One could get on perfectly easily with some lesser woman right from the start. But her very rank aroused his sympathy, and so he urged Taifu to convey something of my feelings to her nevertheless. He then prepared quietly to leave, having no doubt a rendezvous elsewhere. My lord, I often think how amusing it is that His Majesty worries so much about your being too serious. He will never see you in this disguise. Genji turned back toward her, smiling. "You had better not bring up my feelings as though they were none of yours," he said. "If mine is what you call wanton behavior, then I know a young woman who would be hard-pressed to defend herself," he often teased. He often teased Taifu for being rather loose in her ways, and she was too abashed to say more. He stole off toward the main house, hoping for a sound from the lady within. When he reached a sheltered spot where only the tattered fragments of screening fence remained, he discovered that another man had been standing there all the time. Who could he be? No doubt some gallant with his eye on the lady, he thought, melting into the shadows. But no, it was the secretary captain. Earlier that evening, they had both left the palace together, and when after they parted, Genji made for neither his excellencies nor Nijo. The captain so longed to know where he was going that he followed him despite having a rendezvous of his own. Genji had failed to recognize him on the nag he was riding, casually dressed in hunting cloak. The captain was intrigued to see Genji enter an establishment quite new to him. He stood there listening to the music and then lay in wait on the assumption that Genji would soon be leaving. Genji, who still did not know who he was and who had no wish to be recognized, was sleeping quietly away when the captain came straight up to him. "My lord, I was so put out when you just left me that I decided to keep you company. We were together when we turned our steps away from Palace Mountains, but I see, this 16th night, the moon hides where he will set." Genji was at once amused and annoyed when he grasped who the speaker was. "What had he to do me?" he complained bitterly. "One certainly may gaze upon a regence that illumines all, but who would wish to hunt out Mount Ilusa where it sets? What would you do if someone else were to follow you this way? When you are gadding about like this, you would be much faster with an attendant. You should not leave me behind. There could be an embarrassing incident when you are out at night in disguise." Genji hated to be found out this way, and he gave himself full credit for the secretary captain's failure so far to locate his little pink. Now in high good humor, the two did not set off again to his promised assignation. Instead, they rode together in one carriage to his excellencies under a moon pleasingly veiled by clouds, blowing away in concert on their flutes. They stole in silently, since they had sent no men ahead to clear their path, and they changed to dress clothes in a deserted gallery. Then they launched into playing their flutes, looking the picture of innocence as though they had just arrived. His Excellency, who could never pass up a concert, brought out his own coma flute and played it beautifully, for he was an expert musician. Then he called for instruments that he had various gentlewomen fill that music play behind the blinds. Nakatsuka was very good on the biwa, but she, who had spurned the secretary captain, had not refused Genji's kind attentions on his sporadic visits, and she had then inevitably seen her involvement with him become common knowledge, which had in turn earned her the displeasure of Genji's mother-in-law. Now, she was reclining against a pillar, obviously unhappy and ill at ease. She was miserable at the thought of going away, where she would never see him again. The young gentleman remembered the music they had heard on the King and dwelled with pleasure on how different that sad house had been, and the captain dreamed of the lady sweet and fair whom he would begin courting there, after all her long years alone, and with whom he would then fall so recklessly in love that all the world would be talking about it, and he himself would teeter on the brink of folly. He recalled with mingled annoyance and apprehension the self-assured way Genji went roving about. Would he let a slip chance like this? Both were soon apparently writing to Her Highness. Neither got an answer, which baffled and irritated them. It was really too awful of her. Any lady living in a place like that should sometimes give poignant voice to her feelings by conveying the sorrows she knew so well in terms of the fleeting moods of plants, trees, or the sky. The captain fretted even more than Genji that it was dull of her, and rude as well, to remain so shut up in herself, however ponderously serious she might be. "Have you had any reply from her?" he plaintively inquired of Genji, from whom he could keep nothing. "I sent her a line to see what would happen and got back only a strange silence." Sure enough, Genji thought he has been courting her, and he replied with a smile, "Perhaps I have no answer from her, because I for one am not really that keen." The captain was very annoyed to be put off. Faced with such indifference, Genji had lost interest in an adventure that mattered little enough to him anyway, but he supposed that if the captain was now showering her highness with notes, she would yield to the one who sent her the most. The thought of how pleased with herself she would be after casting aside her first suitor was more than he could bear, and he therefore called Taifu into solemn conclave. It is extremely irritating of her to turn me away like this, without even hearing me out," he said. "She must suspect me of wanting only to amuse myself, whereas in reality I am not frivolous at all. Things cannot help going wrong when the other person assumes the worst, and it always ends up being one's own fault. I should have thought someone well disposed, someone living in peace without parents or brothers and sisters to brother her, would be far more attractive." "Oh no, my lord, I doubt she would suit you. I cannot imagine her being the sweet shelter from the rain that you have in mind. Few people are so desperately shy and withdrawn." She told him what she knew of the lady. Apparently she is neither witty nor clever. After all, though, it is the childlike, innocent ones who are the most apt to catch one's fancy. He had not forgotten. Spring and summer passed while he suffered from his recurrent fever and remained absorbed in his secret grief. That autumn, as quiet, persistent recollection led him to remember with longing even the sound of the falling blocks and that other noise that had so offended his ears. He wrote often to the resident of the Hitachi prince, and when he still got no response, he walks indignant with the lady for her boorish inexperience, vowed to reject defeat, and began pressing Taifu vigorously. "What is going on?" he fumed. "I have never seen anything like it." She sympathized. "Not once have I suggested to her that you do not deserve her. As I see it, her crippling shyness is the reason why she cannot bring herself to answer you." "Exactly. That is just what I mean by inexperience. A girl may well be shy as long as she still knows little of life or is too young to do as she pleases. But I should think that this lady would give all things due consideration. I myself, for some reason, am feeling listless and low, and I would be quite unsatisfied to get an answer from her in the same vein. I am not out for hanky-panky. All I want to do is sit for a while on her creaky veranda. I just cannot understand her, and that is why I want you to arrange it for me, if necessary without her leave. I will not lose my head or do anything foolish."
Advanced Next.js concepts and optimizations. Now that we have learned about the essential features of Next.js and React Server components, let's dive a bit deeper into the Next.js framework. In this chapter, we are going to learn how caching works in Next.js and how it can be used to optimize our applications. We're also going to learn how to implement API routes in Next.js. Advanced Next.js concepts and optimizations. Now that we've learned about the essential features of Next.js and React Server components, let's dive a bit deeper into the Next.js framework. In this chapter, we are going to learn how caching works in Next.js and how it can be used to optimize our applications. We're also going to learn how to implement API routes in Next.js. Then, we are going to learn how to optimize a Next.js app for search engines and social media by adding metadata. Finally, we're going to learn how to optimally load images and font in Next.js. In this chapter, we're going to cover the following main topics: defining API routes in Next.js, caching in Next.js, search engine optimization with Next.js, optimize image and font loading in Next.js. Technical requirements. Before we start, please install the requirements from Chapter 1. Defining API routes in Next.js. In the previous chapter, we used RSCs to access our database via a data layer. No API routes were needed for that. However, sometimes it still makes sense to expose an external API. As an example, we might want to allow third-party apps to query blog posts. Thankfully, Next.js also has a feature to define API routes called route handlers. Route handlers are defined inside the src/app/directory but in a route.js file instead of a page.js file. A path can only be either a route or a page, so only one of these files should be placed inside a folder. Instead of exporting a page component, we need to export functions that handle various types of requests there. For example, to handle a GET request, we must define and export the following function. Export async function GET. Next.js supports the following HTTP methods for route handlers: GET, POST, PUT, PATCH, DELETE, HEAD, and options. For unsupported methods, Next.js will return 405 method, not allowed response. Next.js supports the native request: https developer.mozilla.org/n-us/doc/web/api/request, and response developers.mozilla.org/n/us/doc/web/api/response web APIs, but extends them into Next request and Next response APIs, which make handling cookies and headers easier. We use the cookies function from Next.js to easily create, get, and delete a cookie for the JWT in the previous chapter. The headers functions makes it easy to get headers from a request. These functions can be used in the same way in RSCs and route handlers. Creating an API route for listing blog posts. Let's start by defining an API route for listing blog posts. First, copy the existing ch17 folder to a new ch18 folder as follows. Second, open the ch18 folder in VS Code. Third, to make the API routes easier to distinguish from pages on our app, create a new src/app/api/folder. Fourth, inside the src/app/api/folder, create a new src/app/api/v1 folder to make sure our API is versioned for potential changes to the API later. Next, create a src/app/api/v1/post folder for the API/v1/post route. 6. Create a new src/app/api/post/route.js file where we import the init database function and the list all post function from the data layer. 7. Then, define and export get function. This is going to handle HTTP GET request to the API/v1/post route. 8. Inside it, we must initialize the database and get a list of all posts. 9. Use the response web API to generate a JSON response. 10. Make sure Docker and the MongoDB container are running properly. 11. Start the Next.js app as follows. 12. Now go to http localhost 3000/api/v1 post to see the post being returned as JSON, as shown in the following figure. Now, third-party apps can also get posts via our API. Let's continue by learning more about caching in Next.js. Caching in Next.js.
So far, we have always been using Next.js in dev mode. In dev mode, most of the caching that Next.js does is turned off to make it easier for us to develop our apps with hot reloading and always up-to-date data. However, once we switch to production mode, static rendering and caching are turned on by default. Static rendering means that if a page only contains static components such as an About Us or imprint page, which only contains static content, it will be statically rendered and served as HTML or as static text/JSON for routes. Additionally, Next.js will try to cache data and server-side rendered components as much as possible to keep your app persistent or performant. Next.js has four main types of cache: data cache, a server-side cache for storing data across user requests and deployments. This is persisted but can be revalidated. Request memorization, a server-side cache for return values of functions if they are called multiple times in a single request. Full route cache, a server-side cache of Next.js routes. This cache is persistent but can be revalidated. Router cache, a client-side cache of routes to reduce server requests on navigation for a single user session on time-based. The first two types of cache, data cache and request memorization, mainly apply to using the fetch function on the server side to, for example, pull data from a third-party API. However, recently, it's also possible to use these two types of caches for any function by wrapping them with the unstable/cache function. Despite its name, this function can already safely be used in production. It is only called unstable because the API might change and require code changes when new Next.js versions are released. See https next.js for more information. Note, alternatively, the React cache function could be used to memorize return values of functions, but the Next.js unstable_cache function is more flexible, allowing us to dynamically revalidate the cache via a path or tag. We're going to learn more about cache revalidation later in this section. The full route cache is an additional cache that makes sure that when data doesn't change, we don't even need to re-render pages on the server side so that Next.js can directly return pre-rendered static HTML and RSC payload. However, invalidating the data cache will also invalidate the corresponding full route cache and trigger a re-render. The router cache is client-side cache and is mainly used when the user navigates between pages, allowing us to instantly show pages that they have already visited without having to fetch them from the server again. Additionally, if Next.js detects that a page or route only contains static content, it will pre-render and store it as static content. Static content cannot be revalidated anymore, so we need to be careful and ensure that all dynamic content on our app is considered dynamic by Next.js and not accidentally deleted as static content. Note, in this book, we call this process static rendering. However, on other resources, it may also be called automatic static optimization or static site generation. Next.js will opt out of static rendering and consider a page or route dynamic in the following instances: when using a dynamic function such as cookies, headers, or search params; when setting export cons dynamic equal force-dynamic or export cons revalidate; when a route handles a non-get request. For more in-depth, look at this website, Exploring Static Rendering in API Routes. In this chapter, we implemented a route handler for getting blog posts. Now, let's explore how this route behaves in dev and production mode. First, edit src/apps/api/v1/post/route.js and add a current time value with date now to the response as follows. Second, refresh the page on http localhost 3000/api/v1/post a couple of times. You will see that current time is always the latest timestamp. Third, quit the Next.js development server by using CTRL plus C. Fourth, build the Next.js app for production and start it as follows. Fifth, refresh the page on http localhost 3000/api/v1/post a couple of times. Now, current time doesn't change at all. Even if we restart the Next.js server, current time still doesn't change. The response of the get/api/v1 post route is statically rendered during build time. Static rendering works similarly for routes and pages, so pages will also be statically rendered by default. This means that RSCs do not require a server per se. They can also run during build time. We only need a Node.js server if we want to have dynamic pages/routes. This means we could, for example, create a blog or website in Next.js and export a static bundle, allowing us to host it on a single web server. Note, exporting a Next.js app as a static bundle can be achieved by specifying the output :export option in the next.config.js file. Interestingly, if you create a blog post, our homepage does not get updated. However, that is only the case because root layout uses cookies to check if the user is logged in, making all pages on our blog app dynamic and thus not statically rendered. These can also be seen by looking at the output of npm run build. As can be seen from figure, the api/v1/post route is pre-rendered as static content, while all other routes are server-rendered on demand using Node.js. Note, if we want to statically render some pages in our blog, we would have to make sure the user bar isn't visible on those pages. For example, we could create a route group like this website for all pages that have a user bar with a separate layout that contains the user bar. Then, we can remove the user bar from the root layout. That way, we could create, for example, an about pages that is statically rendered while keeping the rest of the blog dynamic. As we have seen, in Next.js pages and routes are statically rendered by default if possible. However, in the case of our API route, this is not what we want. We want to be able to dynamically fetch posts from the API. Static rendering and caching in Next.js can be confusing when we're starting out developing apps with it, but it becomes a powerful tool for keeping our apps optimized. Now let's learn how to properly handle the cache to make our pages and routes dynamic when they need to be, while keeping them cached whenever possible. Making the route dynamic. To make the route dynamic, we need to set the export const dynamic equal force-dynamic flag on it. Follow these steps. First, edit src/app/api/v1/post/route.js and add the following code. Second, quit the currently running Next.js server. Third, build the Next.js app for production and start it as follows. Fourth, refresh the page on http localhost 3000/api/v1/post a couple of times. Now, the API route behaves the same way as it did on the development server. Unfortunately, we now have completely disabled the cache, so we also don't get any of the benefits of using a cache. Next, we will learn how to turn on the cache for specific functions. Caching functions in the data layer. To cache functions from our data layer, we can use the unstable_cache function from Next.js. The unstable_cache fetch data key parts option function accepts 3 arguments. Fetch data. The first argument is the function to be called. The function can also have arguments. Key parts. The second argument is an array of unique keys that identify the function in the cache. Arguments that are passed to the function in the first argument will automatically be added to this array as well. Options. The third argument is an object containing options for the cache, where we can specify tags to revalidate the cache later, and a revalidate timeout to automatically revalidate the cache after a certain number of seconds. Now, let's enable this cache for all functions where it makes sense. Follow these steps to get started. Edit src/data/post.js and import the unstable underscore cache function, aliasing it as cache. Second, wrap the list all post function with cache as follows. As the cache key, we define an array containing the file name post and the file function name list all post to uniquely identify the function in our data layer. Additionally, we added a post tag which we are going to use later to revalidate the cache when new posts are created. Next, wrap the getPost by ID function. Fourth, you may notice that there is now an error when getting post because object ID from MongoDB is getting serialized into a string by the cache. Edit src/components/post.jux and adjust prop type as follows. Fifth, edit src/data/users.js and import unstable underscore cache there. Sixth, wrap the getUserInfo by ID function. 7. Quit the currently running Next.js server. 8. Rebuild and start the app in production. You will notice that after creating a new post, it does not update the homepage or the API route anymore. That's because our posts are now cached. 9. This cache even works in dev mode. Quit the Next.js server and start it again as follows. Then, create a new post. You will see that neither the home page nor the API route has the newly created post in the list. Now that caching has been configured, let's learn how to deal with revalidating the cache, causing data in the cache to be updated. Revalidating the cache via server actions. The best way of dealing with stale data is to revalidate the cache when new data comes in. For example, via server actions. To do this, we have two options. Revalidating all route segments at a specific path by using revalidate path function, revalidating with a specific tag, and thus potentially revalidating multiple paths by using the revalidated tag function. Revalidation means that the next time data is requested from the cache function, the function will be called and new data will return and cache instead of returning previously cached data. Both functions revalidate the data cache and thus revalidate the full router cache and the client-side router cache as well. Follow these steps to call the revalidate tag function after creating new post. First, edit src/app/create/page.js and import the revalidate tag function. Second, inside create post action, call the revalidate tag function on the post tag after creating the new post. Third, now create a new post and go to homepage. You will see that newly created post appears in the list. The API route will also show the newly created post now. Revalidating the cache when data is changed via server actions is the most direct way of updating the cache. However, sometimes we will be fetching data from the third-party APIs where revalidating is not possible. We'll explore this case now. Revalidating the cache via a webhook. If the data comes from a third-party source, we can revalidate the cache via a webhook. Webhooks are APIs that can be used as callbacks. For example, when data changes, the third-party source calls our API endpoint to let us know that we need to refetch the data. Integrating a third-party API. Before we can start implementing a webhook, let's integrate a third-party API into our app. For this example, we're going to use the real-time API, but feel free to use any API of your choice. Let's start implementing a page that fetches from a third-party API. First, create a new src/app/time/folder. Inside it, create a new src/app/time/page.js file. Second, edit src/app/time/page.js and define an asynchronous page component. Third, inside the component, fetch the current time from the real-time API and parse the response as JSON. Fourth, render the current timestamp.
Tip, if you go to https localhost time page in your browser, you will see that it shows the current time. However, when refreshing the time never updates. That is because requests with fetch are cached by default, similar to what happened after we added unstable underscore cache to our data layer function.
Ito, sir. Ito po yung mga withdrawal of enrollments.
Hindi, kunyari, kasi hindi ko naman ako mag-enroll eh. Parang lalagay ko lang yung pera dun sa account.
Ayun, sir. 100% refundable naman yun, sir.
Pagka ganun.
Opo.
So, kapag nakalagay sa account, refundable, marirefund naman.
Opo.
Tapos basta hindi pa nakakreate yung mga subjects. O sige, yun lang. Thank you so much. Yung pipicturean ko na lang. Hindi nyo ba ako pwedeng tulungan dito? Kasi malabo yung phone ko eh. Papicturean ako tapos pa-upload.
Wala din kami dito, sir. Yung sa camera po eh.
Yung sa phone mo. Kasi si Joanne, tinulungan ako eh. Ang galing talaga nun. Sayang nang umalis eh. Sige. Sige, parang habang hinihintay ako, mababayad lang ako sa sarili nila. Ha? Sige, thank you. Hindi, sige, iwan mo na lang muna dyan para ma-picturean mo. Dito tayo 7-Eleven. Hindi, magbabayad na tayo. Tapos babalik pa tayo kasi kukunin ko yung TOR ko. Inaamin nila, kinikredit nila eh. Tara, dito, Che.
Di ba dapat clear?
Functional programming. While object-oriented programming focuses on objects, functional programming focuses on functions. Let's consider the main principles of functional programming next. Principle 1. Functions are first-class objects. Functions are treated here as first-class objects, also called first-class citizens, which means that functions can be combined with each other in a wide variety of ways. Thus, just like normal objects and primitive values, functions can be assigned variables. They can be used as arguments of other functions or as their return value. In non-functional programming languages, on the other hand, where functions are not treated as objects, none of this is possible or can only be reproduced with elaborate design patterns. Principle 2. Functions use immutable data structures. In functional programming, the data structures on which the functions work should be unchangeable or should not be changed by the functions. Consider an example. Suppose we have a function that takes a list of numerical values and sorts them in descending order. In functional programming, when the function is called, the list passed to the function as an argument should not be changed. Instead, the function should create a new list, sort the numerical values into this new list, and then return it. In purely functional programming languages such as Haskell, even the language itself prevents lists or other data structures once created from being subsequently modified. By the way, JavaScript is not a purely functional programming language, which is why lists or arrays can be changed at any time. However, changing data structure like lists and arrays would not be good style in terms of functional programming. Principle 3. Functions have no side effects. This principle follows directly from the previous principle. Functional programming functions should not have any side effects at all and should behave like mathematical functions. In other words, functions in functional programming should always return the same result for the same input without any side effects. In purely functional languages, side effects are again excluded by the language itself. JavaScript, as a programming language that is not purely functional, does allow functions to return different results for the same input. But in this case, too, in terms of the functional programming paradigm, this inconsistency would again not be good style. Principle 4. Functional programs are declarative. As mentioned earlier, imperative programming is a programming paradigm in which you give the computer precise individual instructions on how to solve a problem. Imperative programs use loop statements, while loops, for loops, etc., and conditional statements, if else, and sequences of statements. Functional programs, on the other hand, are declarative and avoid the use of these statements. Instead, you use functions like for each, map, and reduce to formulate what the program is supposed to do. What are programming languages? In addition to the basic differences between the individual languages, programming beginners may wonder what a programming language is at all, what the differences exist, and which one should be learned. In this section, I'll provide a short overview of different programming languages that play a role in web development. Forgive me if I do not list all relevant programming languages to stay within the scope of this chapter. Rankings of programming languages. Various indexes evaluate the popularity of the most common programming languages, regularly publishing programming language rankings. The TIOBE index, for example, shows an overview of currently popular programming languages based on the TIOBE index. As of February 2023, the TIOBE index considers the number of hits in search engines to calculate the popularity of a programming language. In other words, the more often a language is found, the higher its rankings. As should be clear, neither the quality nor the real popularity and spread of a programming language can be concluded from this information. In this respect, we advise you to consider this index only as an indicator and by no means as a criterion for selecting a programming language. Rank 1, Python. 2, C. 3, C++. 4, Java. 5, C. 6, Visual Basic. 7, JavaScript. 8, SQL. 9, Assembly Language. 10, PHP. Which programming language should you learn? Basically, don't let yourself get influenced by an index when choosing a programming language, regardless of whether you're learning a language or selecting it for a specified project. Rather, the choice of the appropriate programming language is an individual one that has a lot to do with personal taste. Also, each programming language has its advantages and disadvantages and can be well suited for some things but not well suited for others. Let me therefore briefly discuss a few programming languages in this section. JavaScript. You already learned about JavaScript in Chapter 4. JavaScript is a language that supports both the object-oriented programming paradigm and the functional programming paradigm. In terms of object orientation, JavaScript is classless, even if newcomers may be confused at first glance by the class word class and the ability to create classes. Note that the classes in JavaScript, importantly in quotes, are not real classes, only a syntactic refinement that help developers switching to JavaScript from class-based programming languages to get started. While the JavaScript language has been used only on the front end since its appearance in 1995 and in the early days of web development, it has also gained acceptance on the server side in recent years. The language owes this change from a pure front-end language to a front-end and back-end language primarily in the Node.js runtime environment, which allows JavaScript code to be executed outside the browser and thus on the server side. To execute JavaScript code, you don't need a compiler. JavaScript does not need to be compiled but instead is interpreted and executed by a JavaScript interpreter at runtime. Full-stack developers will inevitably have to deal with the JavaScript language at some point since it makes sense to use this programming language not only for the front end but also for the implementation of the back end. For this reason, in the next chapter, I will go into detail about how JavaScript can be executed on the server side using Node.js.
TypeScript. TypeScript is an open source programming language developed by Microsoft that is based on JavaScript and extends it with various features such as static typing. JavaScript only has weak typing. Via static typing, TypeScript allows you to specify a type for variables, object properties, function parameters, and so on, which in turn reduces errors the source code due to incorrectly used types. TypeScript code cannot be executed directly by browsers but must first be compiled into JavaScript code. Type errors can then already be detected during compilation. PHP, unlike the other programming languages presented so far, which also play a role in other development fields, PHP for web development, embedded HTML code. PHP is parsed on the server side by a corresponding interpreter, the PHP interpreter, and is suitable for example to dynamically generate HTML as shown in listing. PHP was one of the most popular languages of the web for a long time, although this popularity may have waned in recent years due to alternative web languages. You can still find a lot of websites developed in PHP. PHP therefore continues to play an important role in web development, if only because content management systems, CMS like WordPress and Joomla, are programming PHP. In addition, PHP is part of the well-known LAMP stack, the Linux operating system, the Epic web server, the MySQL database, and PHP. We'll discuss the PHP language in a little more detail in chapter 15. Python. Python is an interpreted programming language, which means that the code does not have to be compiled into machine code before execution. Instead, the Python interpreter executes the code directly. The syntax of the Python is a matter of taste. Java and JavaScript developers might have a hard time at first because Python doesn't use curly brackets and instead uses indentations to define corresponding code blocks as shown in listing. However, once you get used to the syntax, Python code can be quite clear. Basically, Python can be used to program anything from command line applications to desktop applications to web applications. Regarding the latter, the server-side Django web framework is worth mentioning, among others, for simplifying the implementation of web services with Python. Moreover, Python is considered the language par excellence when it comes to the development of artificial intelligence applications or applications using machine learning. Frameworks in this context include TensorFlow and Scikit-learn. Ruby. The Ruby programming language was designed in the mid-1990s by Yukihiro Matsumoto with the goal that programming with Ruby should above all fun and that the source code should above all understandable for developers. The language supports several programming paradigms including procedural, object-oriented, and functional programming. With regard to web development, Ruby became known in particular through the web framework called Ruby on Rails. However, like PHP, Ruby and Ruby on Rails have lost their popularity in recent years. A large community still exists around the language and framework, but due to competition from front-end frameworks like React, Angular, and Vue, much of the functionality of web applications is covered in the front end. With the enormous success of Node.js, interest in Ruby and Ruby on Rails has declined significantly. Java is an object-oriented, class-based programming language. The syntax of Java is similar to C and C++, but this language has fewer low-level functions than the other two languages. Java's code is translated by the Java compiler into machine code that can be executed within the Java virtual machine. This approach has an advantage. Java applications don't need to be compiled separately for each operating system. The only requirement for the machine code to run on any operating system is that the JVM be installed. Java can be used for all types of applications: command line applications, graphical desktop applications, web applications, and mobile applications for smartphones running Android. With regard to the development of web applications, Java Enterprise Edition, JEE, the Spring Framework, and the Play Framework can take a lot of work off your hands and deserve mention. These frameworks should be part of the toolbox of every Java developer who wants to develop professional web applications with Java. Go is a programming language that originated as a hobby project by some Google employees and has gained significant popularity in recent years. Code written in Go must be compiled into machine code by a compiler before it can be executed. Interestingly, Go can be compiled not only into machine code but also into JavaScript code using the Gopher.js compiler. This compiler allows you to write code in Go, which then runs after compilation into JavaScript within a web application on the client side. However, Go is primarily used for the implementation of backends, web frameworks like Gin or Revel, or frameworks that help implementation microservices like GoKit or GoMicro can be quite useful. C and C++. No list of programming languages is complete without mentioning the classics C and C++. After all, the C language is already a good 50 years old and thus one of the most widespread programming languages. Then, in 1985, the object-oriented language C++ was launched, extending C with classes and objects. Code written in both C and C++ must be compiled by an appropriate compiler before it can be executed. C or C++ are particularly suitable if you develop close to the operating system. For example, the Linux kernel is mostly written in C. Or if you develop programs that must perform extremely well or must squeeze resources out of hardware, for example, computer games. However, both languages are poorly suited for entry-level programming and or web development due to their complexity. C. The C language is based on the C and C++. C hashtag. The C hashtag language is based on the C and C++ language and was published by Microsoft in 2002. C hashtag is a lot catchier than the two heavyweight predecessors. The language is often compared with the beginner-friendly Java, especially in combination with the .NET framework. C hashtag is also an option for implementing backends. Similar to Java, C hashtag code is compiled into intermediate code before execution, which can then be run within the runtime environment included in the .NET framework common language runtime. Like Java, C hashtag is suitable for beginners in programming. But seriously, now, which programming languages should you learn? After our deliberately brief overview of the programming languages that play an important role in the context of web applications, I would like to conclude by giving my personal opinion on the question, which programming language should you learn? My advice for anyone completely new to web development is, you've probably guessed it, to take an in-depth look at the JavaScript language. Sure, some smarties still consider JavaScript as a script kiddie language and not a programming language to be taken seriously. Do not listen to them. JavaScript has changed tremendously in recent years from a completely client-side programming language to a full-fledged programming language that can implement complex applications. If you know JavaScript, a helpful pursuit might be to take a closer look at TypeScript. TypeScript builds on JavaScript, so getting started with this language shouldn't be particularly difficult. More and more JavaScript frameworks are focusing development on TypeScript, or at least making their APIs available in TypeScript as well as JavaScript. The third language is then a matter of taste and depends above all on the area in which you work or want to work. If you want to implement larger web applications with complex backends, the choice probably falls on Java or C. If you plan to take a closer look at CMS like WordPress and possibly even plan to write a plugin for WordPress, you can get around PHP. If your goal is to write a particularly high-performance application, C or C++ would probably be a suitable choice. And if you want to deal with AI and machine learning, get grips with Python language. Personally, the first programming language I learned after HTML, CSS, and basic JavaScript was Java. The reasons were that first, the language was incredibly hip at the time, at the beginning of the millennium. Second, it was taught in university. And third, I had to master it at a professional level due to my parallel work at Fraunhofer Institute. It wasn't until the release of Node.js in 2009 that I started to work more intensively with JavaScript again and got to know it as a programming language that should be taken seriously. TypeScript came next, and I'll probably take a look at the Go language soon as well. I've had some experience with the other languages I've mentioned, but I haven't really gotten stuck with any of them. But as I said, much of this choice is also a matter of taste. Summary and outlook. In this chapter, we learn about different types of programming languages and we explore the most important programming language for web development. Key points. The following key points were presented in this chapter. Programming language can be classified into several categories. Programming language can be subdivided according to the degree of abstraction. Higher programming language, abstract far from the machine code, that is the code that's understood by the computer. Assembly languages abstract less but are usually not easy for developers to understand as higher level programming languages. Division into compiled and interpreted languages. In compiled programming languages, a compiler translates the source code into machine code at compile time. In interpreted programming languages, an interpreter interprets the source code at runtime and executes it. Programming language can be subdivided by a programming paradigm. With imperative programming language as a developer, you define exactly how a program works. In declarative programming language, you define what a program is supposed to do. Subgroups of the imperative programming paradigm include, among others, structured programming, procedural programming, modular programming, and objective programming. Subgroups of the declarative programming paradigm are, among others, logical programming and functional programming. Some languages support multiple programming paradigms. For example, in JavaScript, you can program in an object-oriented way and in a functional way. Object-oriented programming focuses on objects. Object-oriented language can also be divided into class-based and classless or prototype-based language, depending on whether the object orientation is based on classes or objects or prototypes. Functional programming focuses on functions. Functions are treated like objects and can be assigned to variables like objects, used as a parameters for other functions as their return value. Developers face a large variety of language when choosing the right programming language. In this chapter, I've gone into some languages that are relevant to web development. The question is, to which language is the right one for you is something you'll have to decide for yourself. And the answer to that question often depends on the personal taste and the project you're working with.
Using JavaScript on the server side, as a full-stack developer, you should have a good command of at least one programming language that can also be used on the server side. Only with such a programming language can you implement the server-side logic that is called by the client through incoming HTTP requests. In Chapter 4, you learned about the JavaScript programming language. For full-stack developers, this language is relevant not only because you need it for front-end development anyway, but also because you use it to implement server-side logic via the Node.js runtime environment. JavaScript on Node.js. Using JavaScript to implement the server-side logic or backend has several advantages over the other programming languages I introduced in Chapter 13 in terms of becoming a full-stack developer. These advantages include the following: universal language. Since you need to learn the JavaScript language anyway as a full-stack developer, you can kill two birds in one stone. JavaScript can be used both in the browser to implement client-side logic and make web pages more dynamic, and also used on the server side to implement server-side logic such as web services, file system access, or database access. In the best case, You can even structure JavaScript in such a way that you can use the same code on both the client side and the server side. Libraries such as Lodash can be used universally. Go to lodash.com. In this context, we call this universal JavaScript or isomorphic JavaScript. Easy installation. Node.js can be installed easily for all common operating systems. See the box. This aspect and universality have a decisive didactic advantage. At no time are the examples in this book so abstract that they can only be followed in theory. Rather, it is important to me that you can also try out and understand the examples for the server side easily yourself. Basis for further code. The other examples in this book, for example, when we talk about web services, are all based on JavaScript or Node.js. Installing Node.js. Several options exist for installing Node.js. To keep you reading at this point, I have prepared several installation guides in Appendix C. To follow the practical examples in this chapter, now would be a good time to install Node.js first. I'll be waiting here. Node.js architecture. Node.js is a runtime environment for JavaScript. Just like a browser, Node.js includes a JavaScript engine that can interpret and execute JavaScript code. In addition, Node.js also contains a lot more, such as various modules that provide a wide variety of functionalities. Thus, among other things, you can use these modules, which are part of the Node.js application programming interface, to access the file system, implement a web server, and much more. Each module provides JavaScript APIs, whereby the respective implementation often communicate internally with C++ libraries. Within a Node.js application, you can then use this JavaScript API as shown in figure. Node.js has become so well known and popular primarily because it uses certain concepts that ensure that applications running on Node.js are relatively fast and scalable by comparison. I want to briefly discuss this concept next. Comparison with other web servers. Even though Node.js itself is not a web server, the corresponding module for implementing web servers is probably one of the most used modules in Node.js. To better understand and classify the concepts behind Node.js mentioned earlier, let's use this web server functionality for a comparison with other web servers. Let's first consider how traditional web servers such as Nginx or APIC HTTP server work, as shown in figure. With these servers, in simple terms, every time a user makes an HTTP request to the server, a new thread is created on the server side, and the HTTP request is processed within this thread. For this reason, these types of servers are also referred to as multi-threaded servers. If an operation with blocking input and output, also blocking input or output or blocking I/O, is executed within the scope of a request, for instance by an operation that blocks the further processing of the program, such as a search query to a database, loading a file from the file system or similar, then the respective thread waits until the result of the corresponding operation is available. Only when the result is available will thread continue to execute the program. One disadvantage is that as long as the thread is waiting, it utilizes memory, which in turn leads to a higher memory utilization of the server when many requests are made to the server, resulting in blocking operations. The more complex the input and output operations are, or the longer they take, the more the memory utilization of the server is affected, because as long as threads are blocked, a new additional thread must be created for each new request. Non-blocking input and output. This blocking problem is exactly what Node.js avoids in an elegant manner, as shown in figure. Instead of creating one thread for each incoming request from the client, Node.js uses only a single main thread that receives all requests and manages them in a request queue. Thus, Node.js, or a web server created with it, is also referred to as a single-threaded server. However, this sounds strange at first. How can a single thread still be performant? The key factor is what's called the event loop. This internal loop continuously checks requests from the request queue and processes events from input and output operations. If a new request arrives at the server, the event loop first checks whether request requires a blocking input or output operation. If not, that is, if it's not a non-blocking input or output operation, also non-blocking input or output or non-blocking I/O, the request will be processed as quickly as possible and the response will be sent to the user. On the other hand, if a blocking input or output operation must be performed as part of the request, one of several internal Node.js workers is used to perform this operation. In this context, as a developer, you can pass a function that will be called as soon as the input or output operation has been performed. Since you never not know how long exactly the respective operation takes, and therefore you also do not know when exactly this function is called, these kinds of functions are also referred to as callback functions. An important aspect about this flow is that while blocking input and output operations are being processed, the main thread does not stop. The event loop continues to run uninterrupted, checking new incoming requests and processing or distributing them accordingly. This structure prevents more and more threads from being created and occupying computing power and ensures that the web server always remains responsive. Our first program, now that you've learned the basic concepts behind Node.js and before we dive a little deeper into the world of Node.js, I'd like to show you a simple code example to give you an idea of how easy it is to develop in Node.js. You can see this Hello World example for Node.js in listing 14.1. Notice we can implement a simple web server using the HTTP module, which runs under localhost on port 8000 and responds to every HTTP request with the message Hello World. Note, in section 14.3, we'll return to this example and expand on the code. Let's consider what's happening in listing 14.1 in detail. First, the HTTP module is included via the require function and assigned to the HTTP variable or constant. The require function is generally used to include internal modules and external packages in Node.js so you can conveniently distribute JavaScript code across multiple files. Then, we define two constants, host and port, which contain the host name and the port under which the server will be started later. Generally, a good practice to write the names of such constants completely in capital letters, and furthermore, if they are placed after the important modules or packages as in our example, to separate them from this by a blank line. Then follows the main part of the program. First, we define a function that contains the logic to receive incoming HTTP requests and generate the corresponding HTTP responses. The function expects two parameters. Request represents the HTTP request and response the HTTP response. With the function, the HTTP header content dash type is first set to the meme type text / plain via the write head method on the response object, and then the content of the response body is defined via the write method. The entire function is stored in the request handler variable to be subsequently passed as a parameter to the http.createServer method. This method is part of the HTTP module and creates a web server that henceforth redirects incoming requests to the passed function. We store the return value again in a variable server and call the listen method on it, passing port, host, and callback function that will be called exactly when the server has been successfully started. If you now save this program as a JavaScript file, for example as main.js, and then call it from the command line using the node main.js command, Node.js installation required, the web server will start and you can send requests to it by calling the URL http localhost 8000 in any browser. The program will run until you cancel it, for example by pressing ctrl+c. Package management. For Node.js, a huge selection of different packages are available, maybe the largest ever, that is libraries or frameworks that provide a specific functionality.
For example, some packages facilitate the implementation of web services, enable communications with web APIs or databases, integrate services such as Twitter, Facebook, and LinkedIn, and enable many more use cases. At the official registry for these packages, npmjs.com, you'll find more than 1 million packages. The Node.js Package Manager. For package management, Node.js provides the Node.js Package Manager by default, which is also installed directly with Node.js. This package manager enables you to install, update, delete, and initialize your own packages. For now, though, start with learning how to initialize packages and install new packages. Alternative package managers. Besides NPM, which included in the default installation of Node.js, other package managers are available for Node.js. The best known are Yarn, developed by Facebook, and pnpm.js.org. Initializing packages. In our earlier Hello World example, you have already seen how easy it is to execute code using Node.js. In this example, we use only a single code file. However, as soon as a program consists of multiple files, we should combine the code in the form of a package. In this way, you can more easily manage dependencies in the code on other libraries and packages, as well as organize automated scripts for starting, testing, etc. in a central place. For initializing packages, npm provides a command line wizard that can be started via the npm init command, and which then creates a pre-configured configuration file for the package according to your specifications as shown in listing. To test the command, first create a directory for the package you want to create. As a rule, the same name is used for the package, but you should pay attention to the naming rules for packages. See docs.npmjs.com. Then, within the respective command line terminal, go to the newly created directory and call the mentioned command. Calling npm init creates a file named package.json in our example. This file contains all relevant meta information for the package, such as the package name, version number, keywords, developer details, and license information. Also, the entry point to the package, by default, a file named index.js, is linked in the package.json file. An overview of the most important information that can be configured in the file is shown in table. Property name, the name of the package. Description, the name of the package. Version, the version number of the package. The name and version number of a package serves as a unique ID for the package. Version numbers should follow what's called semantic versioning, where a complete version number consists of 3 version parts separated by a dot. Description, a description of the package. Main, the main file or entry file into the package. For example, the file that should be executed automatically when a package is started. Keywords, an array of keywords to classify the package based on the subject. For example, these keywords are searched when you perform a search query via npm search. Homepage, the URL of the project homepage. License, the license of the package. Author, the main author of the package. Only one person can be specified here. Additional authors can be specified via the contributors property. Contributors, person involved in the development of the package besides the main author of the package. Repository, repository in which the source code of the package is managed. Dependencies, in this area, dependencies of the package on the other packages can be defined. Dependencies are defined by name and version of the corresponding package. Dev dependencies, in this area, the dependencies can be defined that are only required during development, but not when the required package is used in a production system. As a rule, packages for automatic execution of tests, the checking of code quality, or packages related to the build process can be found in this property. Installing packages locally. As mentioned earlier, the official registry of NPM offers a huge selection of packages. To install a new package as a dependency for your own package,
Use the npm install package command, or in short form npmi package, where the package placeholder stands for the package you want to install. For example, to install the express.js package, call either npm install express or npm iExpress. You don't need to do this now because we'll return to express.js later in section 14.3.3 anyway. Then npm creates a new directory named node_modules in the current directory if no such directory already exists. Install the package into this directory and enters dependency into the package.json file. Not only does npm ensures that the specified package itself is installed, but also that all dependencies of the package will be installed as well. This process is done recursively for each package to be installed until all dependencies of the resulting dependency tree have been resolved and installed as well. Other ways to install packages. By default, npm installs the respective package in the last current version. If, on the other hand, you want to install a specific version of package, you can simply specify the version after the name of the package. For example, npm install express at 4.16.3. By the way, instead of using the name of the package, you can also pass URLs directly, for example, to a GitHub repository. For an overview of the various package installation options, see docs.npmjs.com/csi/install. To install dependencies that are only needed during the development of a package, such as test frameworks or tools that you need as part of the build process called dev dependencies or development dependencies but not in production, a best practice is to install them using the npm install --save-dev or npm install-d command. These packages are then listed in the package.json file in a separate area under dev dependencies and are not installed in the production operation of that package. Installing package globally. In the previous section, you learned how to install packages locally for a project or for your own package. This installation variant is what you'll use most times. In some cases, however, you might want to install a package globally so that it becomes available globally on a computer. This approach is especially useful if you're dealing with standalone tools that you subsequently want to call via the command line, such as command line tools for Angular. To install a package globally, the -g or --global flag must be passed as an argument to the install command. Depending on the configuration, the global packages are located in a directory to which you only have write access with admin privileges, and thus the command must be executed under the appropriate identifier. For example, in Unix-based environments, sudo npm install -g package. Using the integrated modules, as mentioned earlier, Node.js provides a large range of modules of a wide variety of use cases. A selection of modules included in the standard installation can be found in the following table. Detailed descriptions are available in the official documentation at node.js.org/api/index.html. Module assert description provides a set of functions for checking invariants and testing conditions. Buffer provides functions for processing binary data. Child_process provides the ability to create child processes, for example, for IO-intensive work. Cluster simplifies the creation and management of child processes. Crypto provides cryptographic functions, including for encryption and decryption, as well as for signing data and verifying signatures. DNS enables domain name system lookups and make it possible to determine IP addresses based on host names, among other things. Events enables using events. FS allows access to the file system, for example, to read or write files. HTTP allows you to create a web server. HTTPS allows you to create a web server for HTTPS. HTTP2 provides an implementation of HTTP in version 2. allows the implementation of TCP or inter-process communication, IPC servers and clients, provides information about the operating system, OS, path, facilitates working with file paths, perf_hooks, provides functions for measuring performance, query string, provides utilities for parsing and formatting URL query strings, read line, facilitates the line-by-line reading of data, stream, facilitates the use of data streams, string_decoder, enables the decoding of buffer objects in strings, timers, allows functions to be executed at a specified time, TLS, provides an implementation of transport layer security and secure socket layer, TTY provides classes used in connection with the implementation of terminal applications or command line applications, URL provides utilities for using URLs, util provides various utility functions, V8 provides access to information from the V8 engine, which is the JavaScript engine used internally by Node.js to execute JavaScript code, allows JavaScript code to be compiled and executed in its own V8 context, worker_threads enables the parallel execution of JavaScript code using what are called worker threads, for example, for CPU-intensive work. zlib provides functions for compressing and decompressing data. In this section, I want to introduce you to some functions of the FS module as examples, which we'll also need later in the chapter. The FS module allows you to access a computer's file system computer. FS stands for file system. See node.js org/api/fs.html. For example, you can read files, write files, create directories, rename files and directories, change permissions on both, and much more. Synchronous versus asynchronous. Basically, the FS module provides methods in each case in asynchronous variant, in an asynchronous callback variant, and in an asynchronous promise-based variant. In a synchronous method, the JavaScript interpreter waits until the result of the file operation is ready and then return it as a return value to the calling code. With an asynchronous method, the file operation is executed in the background and the JavaScript interpreter continues executing the remaining code. When the result of the asynchronous method is ready, the result is passed to the calling code by calling the initially passed callback function or promise. Reading files. For the synchronous reading of files, the FS module provides readFileSync function. As a parameter, you must pass the path to the file as shown in listing. As a return value, you get a buffer which, for example, for output to the console, you must first convert into a string by means of calling toString function. Reading files synchronously is only useful if you read small files, such as configuration files, although you should not exaggerate the number of files. For larger files, on the other hand, you should also, for the reasons mentioned earlier in section 14.1.1, choose the synchronous variant, namely the readFile function, as shown in listing 14.6. In addition to the path to the file, you pass a callback function as the second parameter, which is called when the file has been read or an error has occurred. Writing files. Similar to reading files, both the synchronous function and an asynchronous function are available for writing files, although I will only present the asynchronous function in this section. The use of write file is shown in listing 14.7. In this case, as parameters, you pass the path to the file to be written, the content to be written, and a callback function that will be called when the file has been written or an error has occurred. Deleting files. For deleting files, the unlink and unlink sync functions are available. However, the names of the functions do not necessarily indicate at first glance that these functions are about deleting files. As background, the name stems from the idea that with the two functions, not only files can be deleted, but also symbolic links can be removed. Note, even more precisely, the name of the methods mentioned comes from Unix file systems where each directory entry is a link. Regular files are called hard links, while references to files are symbolic links, also symlinks. The usage of the asynchronous and link variant is shown in listing 14.8. The function expects the path to the corresponding file as a parameter, and as a second parameter, the callback function that is called after successful deletion of the file or in case of error. Implementing a web server. With the knowledge from the previous section, let's return to our initial web server example. Our goal should now be more than simply returning hello world, but to read a hypertext markup language file from the file system and return that data instead. Preparations. For our HTML code, we want to use one of the sample forms from chapter 3. In addition, as in real life, 4 to enable the reusability of style sheets, we'll store the cascading style sheet code in a separate file. Overall, this preparation results in an HTML file and a CSS file. We'll also place all this code in a new directory, for example, web server. The HTML file index.html will go into the static/html subdirectory, and the CSS file will go into the static/css subdirectory. We can also create a still empty file called start.js to which we can immediately add a code for the web server. Now, we can initialize the entire thing as a package by calling npm init, resulting in the file and directory structure shown in listing 14.5. Providing static files. The goal now is to implement the following behavior. When a user enters the URL http localhost 8000 or localhost 8000/static/html/index.html in the browser, the web server should read the HTML file and send the HTML code the file contains back to the browser. The browser will then try to load the CSS file included in the HTML code. So, for this HTTP request, going to the URL localhost 8000/static/css/styles.css, the web server must load the CSS file from the file system accordingly and send it back to the browser in the HTTP response. So much for the theory. Let's see what it works in real life as shown in listing 14.11. First, we need 3 of the standard modules. The HTTP module as usual for providing the web server functionality, the FS module for reading the files, and on top of that, the path module to help assemble the file paths. Compared to listing 14.1, only the content of the request handler function changes. Within this function, we first need to find out which path is requested by the corresponding HTTP request. We can determine this path using the URL property of the request object, which contains exactly the relative path. To determine how the request should be handled, use an if-else branch on this property. If the property is the value static/html/index.html, that is, the user has entered the URL 8000/static/html/index.html in the address bar in a browser, or the value slash, that is, the user has entered the URL 8000 in the browser line in the browser, will load the HTML file using the read file function. Otherwise, if the path has the value static/css/styles.css, will load the CSS file accordingly. In all other cases, we'll send an error message with status code 404 not found back to the browser or client. An important point is that to read the files, we are using asynchronous function from the FS module. This approach is quite important so that web server can still accept further HTTP requests while reading a file. If we were to use the synchronous variant for reading files, the web server couldn't process requests again until the reading of the first file has been completed. The path module or the join function used from it in listing 14.11 can help you assemble the file paths so that you don't need to worry about operating system specific directory separator symbols, / or / and the code is executable on all operating systems. The globally available _dir name variable contains the current directory in which the JavaScript file containing the code is located. If you now start the code and call the URL localhost 8000 in the browser, the result should look as shown in figure 14.7. The code shown in listing 14.11 can certainly be improved, for example by extracting a similar logic into its own functions. Especially the code sections for loading HTML file and for loading the CSS file are quite similar and could make a good exercise. Routing engine. Recall in chapter 12, among other things, our discussion of the term routing engine. This functionality shown in listing 14.11 is virtually a small routing engine. Based on HTTP requests, it selects the appropriate request handler, also the controller in model view controller to execute. What is manageable in this example, however, can quickly confusing in more complex web applications. This complexity is an important aspect of web frameworks can do for a developer. Using the Express.js web framework, one of the most popular web frameworks for Node.js is Express.js or Express for short. In addition to routing, Express provides various features that greatly simplify the processing of HTTP requests and the generation of HTTP responses, among other things. In this section, I want to show how the example from the section can be implemented using Express. In chapter 15, I'll also use Express to explain the concept of web services. To use Express, you must first install it as a local dependency for the project via the npm install express command. Express can be included in the code using the require function as shown in listing 14.12. Then, using the Express call, you can create an object that represents the web application, that is the application object. To make static files like HTML files and CSS files available through the server, we can implement routing as described in section 14.3.2, but doing so does not make sense above a certain number of files because implementing all these routes would be too costly. For the provision of static files, Express therefore provides a separate special middleware, a kind of plugin, which can be configured by calling the use method on the application object. As the first parameter, the Express.static middleware function is passed the directory whose contents are to be made available as static resource. Optionally, a configuration object is passed as the second parameter, which you can use to configure, for example, which file types should not be considered. In listing 14.12, we can use a middleware function to provide the contents of the static directory accordingly. The files are then available at the following URLs. In addition, to handle the route, we can use the get method available on the application object. This method enables you to define a corresponding request handler in the form of a function, second parameter, for a route, first parameter, that is called by a get request. So the code in listing 14.12 ensures that when HTTP localhost 8000 is called, the specified function is called. Within the function, you can then respond to the corresponding HTTP request and generate an HTTP response. To read files or to send files to the client, Express provides a helper function called sendFile. You can simply pass it the path to the file, and Express will take care of reading the file contents and preparing and sending the corresponding HTTP request in the background. We can build the path using the join function from the path module. Processing form data. Not only can the Express web framework help you to serve static files requested by GET, but it can also handle requests for other HTTP methods. In this section, I'll show you how to process the form data on the server side once a form has been submitted on the client side, as shown in figure 14.9. First, we need to adjust the HTML code a little, as shown in listing 14.13. On the form element, we'll use the method attribute to define the HTTP method and action attribute to define the URL to be called when the form is submitted. In our example, the relative value results in the absolute URL localhost 8000/process-form. We can also add the name attribute to each input element. This step defines the names of the properties under which the correspondingly entered or selected values of the form fields are sent to the server. We can extend the code for the web server in two places. First, let's configure a second piece of middleware via express.url encoded. which internally ensures that Express parses the request body accordingly for form request. Second, we can define another route and the corresponding request handler by calling the post method. This method is called whenever a post request to the relative URL /process-form is received. Thanks to the middleware, you can conveniently access the transferred properties or data of the form fields within the request handler. In a real-life application, you would process the data in some way, for example, store it in a database and send an HTML document back to the client. For our example, we make do with a simple text message that confirms the successful submission on the form data and is sent back to the client via response.status 200.send. These comparatively simple examples illustrate how web frameworks like Express can make your life much easier when implementing web servers. In next chapter, we'll again use Express as a web framework when to implement some web services. Summary: in this chapter, we learned how to run JavaScript-based applications on the server side using Node.js runtime. We showed you how easy implementing your own web servers can be using Node.js and the Express web frameworks. Key points. The main points to remember from this chapter are as follows. Node.js is a runtime environment for JavaScript, thanks to which JavaScript can be executed outside browsers. For example, on the server side, Node.js provides various modules in addition to the runtime environment, which help you, for example, access the file system, implement web servers, and much more. The Node.js package manager can also be used to install many other external packages. NPM also helps with the initialization of your own packages. The meta information of a package, i.e., its name, version number, and dependencies, are managed in a configuration file named package.json. Node.js provides many methods in both asynchronous variant and asynchronous variant. As a rule, we recommend using the asynchronous variant. The Express Web Frameworks is one of the most popular web frameworks and facilitates the implementation of web servers. Recommended reading. We'll return to Node.js elsewhere in this book. To learn more about Node.js in parallel or in addition to this book, I would like to refer you to one book that was also been published by Rainwork Computing. Node.js, the comprehensive guide by Sebastian Springer, provides what I consider to be an excellent introduction to the subject that is suitable for beginners and advanced users alike. In the next chapter, guest author Florians Simet provides an introduction to the PHP programming language, still one of the most important languages in the field of web development.
Ay, gago. Yung sa laptop. Pero tumatanggap kayo ng Gcash?
Opo.
Ayun, sakto. Ito pala yung ano ko, SSD.
Sa inyo po. Ay, Joshua, patulungan mo baka muna. Sabay mo pala yung charger kanina, naiwan ko ata, hindi mo ako. Ay, shit. Ano yung bayad mo? Bayad mo ba? Ay, bayad mo. Ito na yung auto na patulong. Ano kaya na yung video na po? Possible sa board. Wala tayo sa ito pala eh, juice eh. May ginagawa ka rin? Kuhain ko lang ito.
Basta magkano yun?
Either board juice 2.5 to 3.5 kasi.
Yung parts is hindi na siya kasama. Pero may percent pa pala additional.
Sa mga parts, 500 to 1.5 yung price niya. Ayun,
Makalo ng 5K pataas.
pero sana hindi siya masyadong malala yung sira niya.
Ano ba nangyari dito last niya ginamit ko dito sir?
Kasi nga SSD parang
Ito, sir, ano nakalimutan kong magtanggal na ito? Marunong ba?
Hindi po. Nakaslip lang siya tapos naka-charge.
may ayos naman na to, sir.
Oo, meron.
So ano sir, anong ginawa niyo dito nung bago siya namatay ba?
Naka-charge.
Ayun
Full
ba?
charge na. Tapos, nung in-off na, then hindi siya nagawa. Gamitin ulit, hindi na nagawa.
Pero inaasahan natin full charge siya. Yung sana kayo ng ayun sir, nakikita natin.
Tapos, ito sir, kahit yung mabilisan lang, tingin mo, maayos mo pa to. Kasi, ang nangyari dito,
Ano naman?
maayos naman yung, ano, yung,
Paano pag may
Siguro,
itong battery. Ito, yung sinukat ko dito, yung voltage niya, tsaka ito dito, yung naka-charge, may 20 volts.
May 20
so,
volts pa.
ibig sabihin may,
May
ganun ba yun? May
kuryenteng
kuryente
ano,
papunta
nasa
dito.
pa.
So, ito, ang problema talaga niya, motherboard. No? Kasi,
Motherboard talaga.
ang nabasa kasi ito,
Okay, water damage.
tapos inano ko siya, pinatuyo, tapos gumana naman
Gumana
after.
naman po.
Kaya lang mga ilang buwan lang na mabigla na ulit siya namatay.
Ano matay. Pero nung nabasa po, tinanggal niyo siya sa body, then parang kahit binilad niyo man lang sa araw, yung board lang.
gawa na siya.
Hindi, talagang ano lang. Matagal na, siguro mga 4 na araw ko siyang inano sa bigas.
Sa
Kasi
bigas
gumana
po,
siya
okay.
eh. Kahit na ano yan, kape.
Ano tabunan na lang.
Oo, natabunan.
Sa thesis. Pwede
Ano po yan? Pwede rin po kasi ano eh. Kaso nga lang, bali, ida-diagnose pa po natin kung ano yung totally sira niya po.
Yung sa
May update na pick na po kami.
Kasi
Maganda
ang,
naman
sila,
po yan,
ang,
sir.
ang ano kasi, parang ang sabi parang 9K daw.
Kung ano sir,
Yung
kung
nung
willing po
yung
kayo na
motherboard.
paiwan yun
Ay, yung bagong board.
Gagawa na lang siya ng
Hindi naman. Magkano? Kasi,
Kasi kung board level lang po, ang gagastusin niya, siguro mga range ng 2.5 po. Depende pa po kung may mga parts na gagamitin. Mga ganun lang po.
so mga ganun, ang maaasahan ko yun.
Opo,
Hindi naman naabot ng 9K.
hindi naman po, depende kung prosi. Pero wala naman po kayo dyan tinanggal na nakakabit yung battery, di ba sir?
Wala, dito sa mga component. Wala,
Hindi po
wala.
kayo nagtanggal nito or
Wala,
nung
wala.
SSD nang nakakabit yung battery.
Hindi.
Hindi, ayun. Possible na, ano naman po natin yan sa diagnose kung ano po yung magiging, kung ano po talaga yung sira.
Prone siya sa mga init.
Pero, kasi ang budget ko lang talaga, kasi di ba magkano lang yun, 10, nasa ano lang. Ang budget ko lang sa pagpapagawa na ito is 5K lang.
Mga 5K po.
Oo.
Ano naman po eh, bago naman po gawin yan, parang may quotation po siya. Siya po yung CSR, siya po yung magsasabi kung magkano yung totally babayaran niya, yung mga ganun
Kasi
po.
meron daw, parang check-up fee na 500.
Ay, opo, pero babawas naman po yun once na nag-go-repair po kayo.
Na?
Nag-go-repair, alimbawa, nag-go-repair po kayo, alimbawa, board level lang, 2.5.
Hindi kasi
Then, ibabawas na po yun dun.
Hindi, kasi 5K lang yung budget ko. Pag
Pero nag-try naman
over
sa
ng
service
5K.
center naman.
5 dike, Pero ano pa naman yan, the-diagnose pa naman, sir. Depende naman kung ano pa.
Hindi ba pwedeng i-free na lang yung diagnose kung sakaling, kunyari 9K yung or nasa more than 5K.
Hindi, sir, ano nga po yun, ibabawas po yun dun sa mismo ano nyo. Halimbawa, di ba, nagbayad sa 500. So, 2.5 yung board level. So, ang mangyari, nagbayad na kayo ng 500 sa diagnose fee, then 2K na lang babayaran nyo.
Oh, pero
Bawas
for
na po
example
siya.
kasi, kunyari, naging 9K.
Naging 9K po, ano?
So, hindi ko na siya papagawa.
Okay.
Bibili na lang ako ng bago.
Ng bago po.
Oo. So, ayun yung ko.
Ayun yung concern nyo po.
Oo.
Kasi hindi ko alam sa kanya, sir. Tanong nyo na lang po.
Then, kung may diagnose na galing technical, sabihin niya magpalit tayo ng
Pero feeling ko naman, di naman nakabot po ng 9K.
update
Or
mo na lang
na-
kayo.
Kahit
Depende naman, basta wag lang
Hindi kasi
PCH or Pro siya.
hindi ko rin alam. Pag ganun ba, kunyari nakasaksak yung battery, tapos tinanggal. Parang feeling ko nagawa ako yun.
Kahit alam na
Or
namin
parang
yung sira,
biglang kumalas
yung
lang.
sira niya, tapos maging
Malay pa.
bakit
Ano, kung
Parang
possible
kumalas
yun, masisira yung motherboard nun, di ba? Pag ganun.
Oh, pero kasi kung nakatanggal naman to, kung halimbawa ito, kasi ito yung parang trigger niya rin eh.
Eh,
Ito,
pero ang
yung kumbaga kahit siguro kahit magtanggal ka dyan, kahit
lagi ko
nakasaksak.
tinatanggal to eh.
Oo.
Tapos minsan
Yes po.
yun din yung mali ko eh.
So ayun po,
Siguro
consider
okay
kung mas
naman.
Pero
mabilis
meron
siya
naman siyang
ma-diagnose.
power eh.
Oo, may power siya.
Possible ba na sira pa rin yung mother
Yung
kung may
mother.
power eh? Dito
Possible,
power.
malay mo sir, ang sira niya lang is yung
Dito.
mga capacitor
Yung nga eh.
or yung mga sa ano, di ba? Mano yun eh, malalaman yan, diagnose ng mga technician sa taas.
Sige. Oo, tama.
Paano
Sige,
mo sir? Kasi
padiagnose ako.
sa commutation naman tayo.
Oo.
Old model naman siguro to, no?
Sabi mo,
Ano
ako
bang
yung
specs
bumili
na
ng
ito?
ano, i7 to eh.
i7 ano yun sir?
Aspire, Acer Aspire
Acer
A15 576.
Okay. Kasi sir, pagtapos ni Sir Ryan, siya yung ano dyan eh.
Hindi naman kayo nagpa-plus sa salon niya, sir?
Sige, pa-diagnose din ako.
Diagnose na lang sir. Kaso ang diagnose niya siguro mga ano sir, 1 to 2 days po.
Oo.
Oo, kasi may mga nakapila po.
Okay, sige sir. Kahit si ma'am na lang. Para siya na lang tawagan.
Si ma'am naman kausap mo dito eh, no? Sir, ayun. Ano yung muna lang yun sir.
Siya ba yung may-ari ba?
Yan, siya yung ano lang.
Pwede yung picturean, sir. Eh, pagkita yun, sir. Siguro may akala
T480
kayo
yan,
sa bahay.
no?
3480 po. Ano? S. 3480.
Check natin.
Madalas kasi dito yung mga pang gaming, ano nila, DIY. Yung katulad nung nag-fault ng LCD, di natanggal battery. Ano?
Ganun yung mga
Mga
ano.
ganun
Ang mga
yung
gaming
nangyari.
ba usually inaayos?
Ay, nice po. Pinapalitan
Pero
ng
more on ano kayo?
Madalas kasi mga pang gaming dito, possible na laging sira nila is yung PCH yan, yung mga DIY po nila. Yun yung Pro C. Depende po sa mahal kung ano ba, yung Pro C nila is sobrang taas, like i9 13 yan yun. Katulad ng kanina.
7 to unit, sir. Ang taas ng specs. Okay.
Nakaka-base lang naman sa presyo din ng ano eh.
Hindi ko pa nga masyado nagagamit eh. Kasi puro thesis.
Charging.
Yung nagtithesis yung gumagamit eh.
Meron, pero may mga ganyan na nagtumatanggap ng ano eh, no?
Ng alin ba?
yung mga lumang model. HDD.
Ay, mga HDD.
Na T480.
T480, parang wala siyang slot ng HDD, pang M.2 lang po siya eh.
Hindi, I mean yung
Ay, yung,
dati.
ay, yung dati, oo,
Yan,
yung mga
wala
dati,
na
oo.
to. Pero mas maganda
Pero
yan.
pwede naman yung magaganto kayo pag kayong gusto nyo maganda.
Oo.
Yan.
Oo, ano.
Pang backup nyo na lang po pag
Storage. Ilan GB yun?
test ko lang sir.
May Facebook page naman kayo na wala.
Yes.
Kaibigan ko lang ng friend ko eh.
Pangalan ko ng friend ko, sir.
Mark.
Pinili po, baka kilala namin.
Ika lang sir, walang ano eh.
Francisco.
Parang meron po yung customer na kami po.
Sarayin yung wire mo dito. Nasa iyo pala eh. Wire, yung dito. So ito sabi ni mom. Ayun. Wala daw ba ano?
Hindi mga adapter natin. Charger. Wala kasi tayo. Check naman dyan sa loob.
Check mo dyan sa may ano, sa may box dyan.
Kailangan kong tawagan si Badin. Mali ako.
Sira.
DDR5 Ang dami niya. Oo, tapos sila talaga yung SSD niya. Hindi kaya ibakot yung Marlon kasi mas magkakaproblema pala yung adminin natin yung oras nila sa Coursera. Papartition.
Ay,
Yung
okay.
Coursera
So,
niya,
pwede pa add din pala nila itong RAM.
yung Coursera niya.
Ay, hindi yung RAM.
Ayun.
Yung RAM, pa lagay ako.
Sige. Test lang ko muna. Hello. Bali, ito sir, i7 na siya.
Ah,
Ay, 7-8 siya.
saan? Ah,
Okay. Tapos yung RAM niya naka 8 GB na rin.
this, zero.
Naka 5.1. Well,
5.1.
yun, sa iyan
Na
sir.
nabasa. Ito sana mabasa. Karoon ng corrosion.
May mga corrosion ba sir?
Yun mo.
Ito yun.
Pero try lang natin.
Tapos sir, may isa pa tayo.
Tapos,
DDR, tama, DDR4 na. Sak yan. Pambura lang yan. Kahit kung may civilian.
pambura.
Pambura lang yan. Mamaya ako ang pambura sa taas. Ay, full charge siya pala siya yan, sir. So, yung capacity niya nung binili siya is, 55,000. Tapos ngayon, yung pag na full charge siya is 55,000 pa rin kasi nga brand new yung battery niya. So, kaya yan. Ano yan? Ha? Ay, yung sa unit niya yung siya. Mamaya, yung bibili niya muna. Bale, ayan sir, awag hindi niya sa mga keyboard niya. Camera. Ayan, working din yung camera. Tapos yung speaker niya. Ayan, pares working din. Okay, sir. Add natin yan. Wala mong pambura sir, para sure bull na mababasa niya talaga.
Meron ako na nadala mo na ako.
Meron ka dyan? Ayun pa rin. Asa na siya? Ayun o, yung mga itim-itim niya. Mawala lang yung camera. Mawala lang. Siguro lang. Parang sa mga desktop lang yan eh. Yung biglang hindi na nag-display. Sa mga RAM lang naman nila yan.
Hindi na, wala naman siyang history na basa sir. Wala.
Kasi yung kanina lang. Amin lang natin kung
Possible po na try na yung gano'n na mag-patch.
karamihan din dito mga pang-game. Ultrasonic, yung binababad sa
Try na siya. Mas ano na, yung hindi na maganda yung ano yung transmission.
Ito di ba nabasahan mo yun sa may kasi?
Oo. Pero ano siya, gumana siya.
Hindi mo na tayo sa
Ano nga ba? Tapos,
Tapos biglang hindi na namatay na lang.
ang feeling ko tingin ko yung ano, yung cold blood ko. Kasi ito tinatanggal ko siya. Ngayon ko lang nalaman yung sinabi mo. Ito, nakalakit siya ng
Okay lang talaga makatanggal mo na yun. Para mas better.
Kasi yun yung una ko in-inquire dito. Akala ko talaga.
Hindi kasi pwede mo yun yan.
Ganun lang talaga sir, hindi natin hawak kasi yung ano, yung mga electronics component ng mga laptop. Hindi natin alam kung kailan sila masisira, mga ganun. Dahil pa-prepare na lang dito.
Medyo yung una kong in-inquire dito ng kung meron ba yung motherboard.
Motherboard mo na.
8K kasi talaga yung
Yung grade na no.
So parang ano lang ang brand new yung bago.
Nang bago rin yun.
Pero,
Hindi niya kami good kaso ano. Wala kaming 7 dyan eh.
7? Ano lang? Basta less than 5K, basta mag-aapos pa lang to.
Si Bali, check pa kasi sa taas sir eh.
Sige,
Ngayon.
basta patrol.
Pero pagka meron naman, pag na-troubleshoot, tapos pag meron, opera naman namin kayo.
Oo, 5K ah. Pasabi na lang ako kasi bumili na ako.
Oo, naman. O, tapos na lang. Hindi yung kami yung SSD mo, hindi mo mamatay.
Hindi namamatay?
Nalakay na natin.
Bukas na
Ang matagal lang
Gamit
talaga.
mo, bigyan ko kayo ng
Ano?
gamit tayo.
Yung-
Gamit.
At sa taas ganyan mo. May 100 lang. Nag-test na lang. Tagal lang tinagal.
Baka makita ko mamaya, magbubukas na dito.
May ilaw naman yan pag nag-buksan ka.
Sige, ganun na lang. Ako sir, magpipigos na yung lahat. Yung ano magbibigay ko na lang. Para kahit pa paano may turutuwa.
Mga kasi yan sa built-in yung ano niya. Yung 8GB niya kaya may isa pa sa slot.
Oo talaga. Hindi na kaya, pang-shipping pa lang. Pang-shipping na lang namin yung
Madaling i-repair.
Hindi na siya ganun kahirap yan, di ba?
Bukas-bukas lang.
Kailangan ang bilis na. Saka yung ano yung store niya, hindi na hindi na yung store niya. Dami rin namin sa amin, mga reseller.
Ganun? Marami kayong ganyan?
Hindi. Mga HP, gano'n.
Mga P-series yung ano kasi, provenda, no?
Pero ko lang, hindi puro Lenovo, no? Puro Lenovo eh. Kasi may mga GPU.
Closure. Tignan ko dyan. Balikan kita dyan.
Kasi may camera naman dito.
Sige, sige.
Pagka kunyari mali, paano po masasabi na pag
Ano sir, tester kasi yun sir, isa 19 volts na, 12 volts. Tapos yung 20 volts na.
Tinis ko lahat eh. Dito ako nagsuggest yung tamang bagay sa mga ganyan.
Ayun, yung mga headtech po natin yung makakalam yun sir.
Okay na.
Sila yung mga ano dyan, magaling sa
Nakalain ko po yung nagtanong sa akin. Huwag na lang kayo mag-design. Di na ako sa closure dyan. Uy sir, congrats! Sama ba ako? Dahil mo talaga siya. Company mo? May company nyo pala. Tama yan.
JT na nga rin ako dun mo. Ano? Ang nga kasi ba, hindi ko nga rin
Graduate ka na, dito ka pa. Wala yung parang nagpapag-failure ka.
Kasi bakit mo na mo ata sir? Sara mo, hindi compatible. Try natin yung isa mo.
Oo, iwan mo talaga yung sir kasi matagal yung bayan.
Dapat sir, dito ko na lang nag-OJT eh. Oo, pwede dito eh. Tingnan mo naman, nag-art na kami OJT eh. Ay, yun lang, computer engineering. Akala yun, repair eh. Ang ano, repair yan. Pero hindi ko computer engineering. Yung sa mga hardware lang kami.
Parang hindi po sa hardware. Kaso hindi po sa
Ay, sa mga ano.
Civil engineering, tapos pag-OJT.
Ng electronics. Layo eh, no?
Sige sir, akin na sir.
O sir, matagal yan eh. Kasi mas matagal, mas makikita yan eh. Burag-burag ko. Ano kasi natigas din yun eh, isa inch eh. Hindi pa ano, lumog na eh. Hindi ba sa gilsit yun?
Bukas sila dito sa
Ay, hindi nga
Sa gilid yan eh.
Basta tinamaan.
Ay, tinamaan.
Nakaangat na yun.
Hindi, cover sa kasi. Kasi yung mo lang yung pinaka-fighter ko.
Eh, pwede yan. Ano ba yun? Kapag minsan kasi tinatry ko lang ulit.
Sige, try natin.
Pero ba pa
Pag may corrosion pa.
Grabe. Matamaan talaga siya. Crack talaga.
Ano mo nung wala sa
Sakto niya sa
braso?
last day pa naman tatrabaho. Kaya mapagawa niya yun.
Kaya, kasi sa soli niya eh, no? Ay, ang init ng room mo sir, oh.
Ano yung ibig sabihin?
Naiinit.
Dito yun.
Hindi yung laptop. Pinapagawa ko yun. Sakto makakapili ko lang.
Note ba may tinobo ka na?
Kaso kami hindi nag-update yung GPU.
Eh,
Dadaling ko nga dito.
oo, nagagawa na kami.
Hindi ba gumagana yung GPU kasi hindi siya nag-update.
Kahit na-try mo sa ano, internet,
Ayaw po.
ayaw pa rin.
Lagi daw ko siyang ano, hindi compatible.
Hindi ko
Kahit
pa
compatible. Kaya,
Ano sir, wait lang. Kunin ko lang yung motor. Ayaw na ayaw.
Ayaw.
Ano yan pag ganyan incompatible? O
Hindi,
sira
hindi.
na?
Oh, pwedeng
Base-
sira rin sir
pwedeng
kasi
sira.
umiinit siya eh. Hindi normal yung sara na yung
Kasi
umiinit.
namin, ano yan sir?
Ah, ganun?
Oo, yun, umiinit oh.
Oo nga eh.
Tama.
Paano yung
Hindi
pagka
normal yun.
ganito? Sira
Break
na.
on, sira na yun sir eh. Pag ganyan.
Sabi ko dyan sir, pwede masira.
Oh, makasira ng unit yan eh.
Oo.
Ano yun eh. Makasunog pa.
Huwag na to, tapon na to.
Sabi ko ganyan, tinatapos ko na siya. Saan yung ginagawa mo?
Ba,
Anong ano?
anong cause doon? Corrosion kapag
Hindi
gano'n?
possible nga yun. Minsan nabasa na rin, corrosion na rin siya.
Kapag nabasa, gano'n? Kapag nabasa ba yung RAM, ano na?
Hindi, pwede naman siya kung may ano ka, may
Matutuyo.
magpapatuyo mo na maayos bago mo gamitin sa laptop.
Ganda yan, lahat yung
Pero pag may basa-basa pa tapos ginamit, masira yung RAM.
Masira yun sir, kahit nga yung board masisira yun.
Oh,
Oo,
baka
kasi
yung
basa
dahilan
yan
kaya
eh.
nasira yung ano.
Basa-basa,
Ito.
dapat tuyo na tuyo sir.
Mga
Maganda
ito
nga
kasi-
eh, sa ano eh, sa oven. Kaso may tamang timpla kasi sa oven pag magpapatuyo ka.
Oo.
May technique din.
Pero baka ito yung dahilan, no?
Kaya
Kaya
ano,
nasira.
oo.
Yun, posible din yun.
Possible yun.
List na nga natin yun. Para, kasi papatroubleshoot ko din to eh. List na sila. Kasi
Alam ko pag try sim 90
RAM.
Buti nga, ayun o, gumana. Possible natin yung mo.
yun ang sensitive.
Tingnan natin dyan.
Oo, sira nga yung RAM.
Siraan mo sa...
Kaya,
Pag naging ano to, naging 12. Kasi 8 yung built-in niya, tapos 4 yung dinagdag natin.
yun. Nabasa pero pinatuyo.
Ay siya, naging 12 gig. Nabasa niya.
Okay na yan. Thank you.
Hello? Ay, manantakam sa'yo.
Paano pag ganun, sira na yung board nun? Hindi na ma-repair yung board. Kapag ito, piling ko yun yung
Paano lang?
ay yung
Marirepair
dahilan.
pa po yun, sir.
Ma-repair
Oo.
pa. Hindi naman naabot ng more than 5K yun.
Depende sir eh. Depende sa ano.
Sino ba si Ate Beng kausap?
Oo, yan si Ma'am.
Ay, ma'am.
Ma'am.
Dito kasi dinala ko rin yung yung Acer. So, ang posible kasing issue na ito is yung RAM na basa, tapos naka-connect, nasira din yung board. So,
Nabasa ko si Ma'am.
oo, kasi di ko na kayang gumastos ng ganun ulit ng 9K. So, 5K pa baba lang yung
Kaya
sana.
sa
Paano kaya yun? Kasi di ba meron pang bayad din kapag chinek yung sa troubleshooting na 500. Pag for example, yung papalitan na yung buong board na 9,000, pwede bang hindi ko na lang bayaran yung check-up? Kasi parang 9,000, hindi na ako nagastos ng ganun kalaki.
Kasi ang ano sa... Pang ano kasi yun sir eh, parang tawag dito. Yun kasi yung kinukulit namin
Kasi,
pa. Siyempre kasi gamit kami ng sa kanya equipment, yung mga ganun, tools. Dahil ito din namin siya binabayad. Ang kaya naman yan siguro, ang lowest lang namin dyan, 300 sa check-up.
Lowest. Oh, sige. Oh, sige, pag ganun na lang. Kasi feeling ko ganun lang, yun lang yung... Di ko alam, di ko talaga inaasahan na ano to kasi alam ko ganun nga yung presyo na 8K to 9K nga.
Makabatyak po kayo si boss.
So, di ba, kesa naman parang yun nga, 8K. Pero okay naman yung goods naman.
Battery ito, 70.
Kung 300, okay lang. Sige, ganun na lang ate dito. Ano
Sige sir, ano para test? Parang po ulit siya ngayon. Yung gabi palaro.
check up. Tapos kapag ka-board, hindi naman ito.
Ganun na lang.
ang board lang natin, 2.5 diba?
2.5 lang ba yung board mo?
2.5 depende
Yung
sa
repair,
price.
pero hindi kasama
Yung
yung
yung sinasabi ko kanina, sir.
Si ano, 3
Yan ang gusto kong marinig.
You know,
Sige sir.
bukas na rin yung
Ano,
ship.
yan na lang yung ano.
Uy, sapas, chinelas. Ano sir?
Marami pa kayong T480.
Tara, tara. Tayo, parang nainunibak na. Parang nainunibak na. Sama mo.
Ay, hindi nila wala.
Hindi hinanap ka lagi. Huwag kang mag-ship doon para priority.
Ayun na nga pala.
Huwag kang kailangan ko para mauna dito. Ano ba kung mo, sir, yung rose mo?
Ate, send ko sa iyo yung yung mga possible issue para madalian na rin yung
Pero kasi
technician.
kung ganyan ang magiging cost mo, sir, tingin ko malaki rin gagastusin mo talaga. Kasi tulad niyan, yung RAM mo, sira din. Bibili ka pa ng panibagong RAM.
Hindi, I mean, yung RAM, meron naman kasi ako extra RAM eh. So,
Totoo lang, marami kaming gantong unit.
Di ba?
oh?
Kasi
Hindi
sirain
na-
talaga siya. Hindi yun nagagawa.
Ano yun?
Yung
Acer,
Acer?
Aspire,
Ang dami ko yan sa taas eh.
Ayun yung binenta natin kay ano, di ba?
Yung gamit ko rin, same sila.
Sirain talaga to.
Hindi maganda yung ano mo.
Minsan ko nga nasisira yung keyboard yun eh.
Madalas dito. Pero nasa iyo pa rin kung gusto mong budget.
Pero,
Kaya lang.
pero may nare-repair kayo na ganito.
Oo, may nare-repair.
Marami sir.
Marami rin.
Kaya lang, yung parang,
Kaya lang, kung hindi rin lang din siya tatagal kasi,
yun nga eh.
magiging sayang lang din yung bayad mo.
Pero sir,
Kasi
bumibili ba kayo ng ganito ate?
hindi namin ano yan. Nabili kami niyan, sir. Kaya lang, by parts lang yung inaano namin. Kung bibilin namin
Sayang
yan,
kasi,
considered
oh,
as defective, 500 lang. Kasi ang magpapakinabangan namin dyan totoo lang, yung LCD kung good.
700 to lahat, no?
Kasi kung ito, yan, kunyari, kailangan namin ito.
Yung yung LCD ba nito, saan pwede gamitin? Na laptop?
Sabi ito sa
6,000 pesos.
yung,
Okay na sir.
oo, 6,500.
Ibalot ko lang yung ano
Tama ba, sir?
Hindi sila umalma sa sorpresa.
Kahit wag mo na akong bigyan ng bag, marami
Ah,
akong
okay na. Ay, sorry.
Ito ba, ganito ba ibibigay ng bag?
Mm.
Ganito?
May bag.
Ay, hindi, iba pa. Ano yung tsura? Sige, ate ko ko na din.
Pusahan mo na, sir.
Oo nga eh. Para remembrance din.
Hindi, ikaw nag-email.
Ay, company niya pala yan sir.
Company niya yun.
Sana all big time.
Hindi ako din nag-apply.
Ah, sa ibang to. OJT lang ako.
nga.
Tagal kasi nung OJT, no, sir? Ilang hours? Ilang hours sa inyo, sir?
240 lang.
Go repair
Ayun,
tayo
sir,
Sana all.
yung bawas natin.
Sa amin, 500
Go repair
dito.
po tayo sa
Pag gano'n. Anong laptop niyo
Okay naman
gagamitin?
siguro bukas,
LCD.
mapamunta ulit.
Ito. Pwede sa Acer din.
Hindi
So, meron
Ay,
din,
wala
sir, din
pa.
na
Wala
15
pa.
inches.
Yun lang.
yung mga
Sige sir, ano, update
basta
ko na
pag
lang
15
kayo.
inches.
Basta pag pumunta po.
Magagamit po yun.
Ayun na lang.
Kuhanin ko na po.
Okay, sige sir.
Okay po. Bibigay ko na po. Thank you po.
Sige po.
Sige, sir,
So,
ingat.
Bukas na lang yan.
Ay, hindi ko po alam kung mabibigay ka agad.
Buyon.
Grabe naman.
Ate, parang,
Joke lang.
Sige. Inaano ko rin, parang napalapit na rin kasi.
Oh, sentimental
tagal,
value, no?
no, tagal kasi sa...
Pero kung itatry mo yung benta rin online, baka kaya nila mas mataas. Try mo na lang, sabihin mo na lang, offer na lang
Hindi,
sila.
hindi ko bibenta, ayusin, tatry ko ayusin. Pero hindi ko...
Kung may unit ka na ganyan, pwede, mas makakapit ka kasi mahal din yung LCD nito, sir.
Oo.
Sa...
Possible lang, kasi yung kahit yung busag lang yung LCD sa minsan meron nakasali ka ba sa ano, laptop repair na ano, tapos yung buy and sell ng, minsan kasi may mga nagbibenta doon, busag LCD, keyboard not working lang, pero buo yung unit.
Hindi, okay naman yung LCD na ito.
Eh, LCD lang talaga yung pinaka-best niya.
Board lang talaga yung ano.
Huwag ka na mag-Acer text next time. Hindi namin masyadong
Ay, mga
nare-recommend dyan.
tama nga lang.
Pag nagab yata. Ay, ako sabay na kaya yung bag natin.
Bago yung lugar. May 40. Si ate, na ano na, natawagan ko na. About isang LCD.
Bayaran ko na ito. Dito.
Ay, bayaran na daw si sir.
Ano, may bukas ng gusto ko ba?
Pili kasi. Kasi isa lang kulay namin.
Ay, ito na lang. Sige, okay.
Gray lang.
Ako nag-charge, hindi ako nagbukas ng
Uy na yan, sir.
bukas sa lugar.
Remembrance.
Souvenir.
Yes.
Warranty mo?
Oo,
Three months.
Wow.
ay, may tubig na yung kanina doon. Yung sino nagbukas nun?
Ipatay niyo yung tubig doon, lalaki yung bill.
Yung sino yung nagbukas nung kanina, ma'am? Nagsayang lang ako kanina, may tubig na doon.
Anong number?
Napatay mo na, Greg.
Number.
Sabi ka siya.
Dito sir sa ano?
Sabi ko sa inyo, di ba, pagka...
Tumatanggap ba kayo ng credit card?
Sir, hindi po. I-ano mo na.
0956.
Ito sir.
Ito na lang. Tama. Hindi. Ayan na. Asan?
Ayan, okay na na-receive. Si bank sir.
Hmm.
Ay, okay na si sir, receive na lang.
Wait lang. Ay, dito.
Buti nga sir, natanungan mo kami yung unit na yan. O naghahanap ka rin talaga.
Hindi, kasi sa nagre-research ako talaga ng yung repairable. Meron kasi meron na ngayon yung framework na talaga nakadesign siya na laptop para repairable. Kaso hindi pa available dito sa Pinas. Ang pangalawa na na-research ko is yung T-Series tsaka P na Lenovo. Tapos, sinearch ko kung saan pwede. Ang una daw, sa YouTube yun sabing ganun, magtanong daw sa mga repair shop. Actually, ito, pinapagawa ko to dito sa AB Blank, kung ano kayo doon na laptop. Magaling din yan sa customer service, parang kayo din. Pero sila, specialize sila sa Mac, Apple, gano'n, yung mga So, ayun yung inisip ko na baka kayo, mas magaling kayo, mas alam nyo to, yung ganito, na mas kayo sa board. Kaya, inano ko kayo, kasi nakita ko rin yung Facebook niya ang ganda rin ng review kasi mahirap kasi dito, di ba, parang yung tiwala, gano'n, na parang kung magpapa-repair ka, gano'n. Yun, so, parang, kaya ako na isip. Pero tinanungan ko rin, nagtanong din ako sa mga iba, doon sa ibig lang. Wala silang laptop. Bumibili sila ng laptop doon. I mean, dati yung pinakauna kong laptop doon ko sa kanila nagbenta Pero di sila nagbebenta ng laptop. Oo. Ngayon. Pero alam ko nagbebenta sila dati.
Kung meron, sabi ko meron, may isa pa rin.
Kasi yun nga, inaayusin ko dapat kasi inaano ko, tinetester ko to na merong kuryente. Sabi ko pwede, ibig sabihin, rin kasi ako, ako yung nag-aayos ng phone ko, kumbaga technical din ako. So, meron pang, inisip ko baka pwede pa, ganyan. Sabi ko hindi naman, meron sigurong magaling dito sa Pinas na kayang gumawa nito. Kaya may iba lang, di ko lang siguro alam, ganun. Kaya ako kayo nakakita kanina.
Tutusin, kaya
Kaya
yan.
naman, kaya na mahal talaga. Hindi na worth it. Kaya sabi ko, gusto ko kasi maayos kasi nasanay na ako dito sa laptop. Tsaka parang sayang din kasi may mga yung mga extra ko na SSD hindi nagagamit. And dito ko kasi yun ginagamit dati.
Model name mo?
T480S. Ang trusted talaga din namin.
Oo, T480. Ayun na yung yung pinaka, na-research ko, pinaka budget tsaka repair, madaling i-repair. Tapos yung more likely na 7 years to 10 years or 20, may mga parts pa din kasi maraming
Supply ceiling.
kaya
Yung Acer kasi yung dami namin tanggap yung pagka talaga sila yung tas lagi yung bibigay. kadalasan hindi talaga nagagawa. Bored talaga.
Mm,
Kung magawa man, parang
mahal na. Parang bumili ka na ng bagong
saka
laptop.
hindi rin siya tumatagal ng taon.
Ah.
Bago nyo rin yan binili. Matagal na
Ah,
rin sa'yo.
yung, 2018.
Kautan na rin.
Mga ganun, konta na din. Actually, second hand ko lang rin na nabili. Hindi ako bumibili ng ng brand. Kahit na motor, sa lahat, cellphone.
Ganun din kasi sir.
Oo. Oh, hindi. Inaaral ko rin. Kasi rin ako sa engineering din. Like, may maalam din ako, kumbaga kahit kakaunti, na kung paano i-check yung mga second hand.
Magkano yun, no? Magkano?
10 Wala SSD.
Pangalan, sir?
Kasi medyo mahaba yung kahit yung
Kaya pala, sir.
hirap spell.
Palayaw nickname na lang, sir.
Red, R-E-T. Tapos, yun, encomiendo na lang. Or kahit yung first name Garrett.
Bali 3 months warranty, sir.
Sige, salamat.
Sa bahay, ilan na tawag mo?
Ah,
Ilan na tawag mo? Oh, sige. Paano yung isa?
Sir, thank you ha.
ay, sige sir. Okay.
Ate, thank you. Sana na lang ulit pagka...
Chat kami sir, pag may problema din sa
Oh,
Sir, kahirap na mga bakuli ka pa.
Ay, putik na yan.
Ano nangyayari doon sa isa?
ano siya, 3 volts na lang siya. Bias siguro yun.
Babae ko.
Ayan.
8:30 pa naman.
Update ako kayo, no?
Ayun.
Wala pa yung charger. Greg, tulungan mo ako. Diyos mo. Ibayos lang daw yung HP namatay.
At anong name mo, sir?
Jamie.
Ano na?
Jamie. Ano yata nagpura.
Pagdaya mo. Ba't hindi ka bumili mo yung dalaga?
Bakit? Sabi ni Greg. Marami ka daw rin. Greg! Thank you, Tara.
Salamat.
Check na lang.
dito?
Wala din ang
Bila.
Pagkasa ko wala pa silang gas.
Ha?
Wala pa silang gas. Papagasara ako.
Pila ka sila. Jamie, 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 ano pa? Jamie.
Pahinga po na ako. Iwas traffic.
Ha?
Traffic eh.
Oo. Traffic ba ngayon?
Traffic.
Pag paano ako eh, pa Novaliches.
Yun.
Traffic mas lalo.
Sapol-sapol yun.
Ha?
Sakto yan, traffic.
Putik na yun eh.
Ano sabi ni Insan? Alam niya yun. Siya may sponsor yan. Alam ko eh. Oo. Alam niya yun. Ayaw lang niya sabihin kasi baka malaman ni Helen. Yari siya eh. Si Jovan. Sabihin mo, ano kasi, ako yung magkakit ng ano, sa bahay. Ako na magkakit sa ano, sa bahay. Kaya pag di mga babae, wala ka sa pagkain. Kaya sabi ko, tapusin lang yung ano, Moyang kuman.
Same origin policies, content security policies, and cross-origin resource sharing. In section 20.1.8, you learn that injecting malicious JavaScript code into a web page is one of the major vulnerabilities for web applications.
To lessen this vulnerability, I want to discuss three terms important in this context: Same Origin Policy, SOP, Content Security Policy, CSP, Cross Origin Resource Sharing, CORS. Same Origin Policy. An SOP basically states that code from one origin must not access content from another origin. Thus, JavaScript executed in the browser can only access resources of the same domain via HTTP, but the dynamic loading of resources from another domain, the execution of cross-origin requests, is prevented. More specifically, the requested resource must be accessible via the same protocol, host, and port as the JavaScript code. For example, to read a JSON file from a web page such as https www.example.com via JavaScript and load it using the Fetch Application Programming Interface API, for example, the JSON file must also be located at https www.example.com as shown. SOP only affects the dynamic loading of resources from JavaScript code. Resources that you embed directly via HTML, on the other hand, can be loaded from other domains, including the following: JavaScript files that are included via the script element, CSS files that are included via the link element, image, audio, and video files, among others, include via the image, IMG, open and close tags audio, open and close tag video, open and close tag object, and open and close tag applet elements. HTML files that are included via the open and close tag frame and open and close tag iframe elements. Cross-origin resource sharing. An SOP therefore prevents JavaScript from accessing resources on other domains. In some cases, however, accessing resources from other domains may make sense. For example, if you implement a web service and deploy it under https api.example.com subdomain and want to access the web service from a web application at https www.example.com, you cannot do so because of the SOP. Thus, CORS enables you to relax the security rules defined by the SOP as shown. The settings for CORS must be made on the server that provides the requested resource and not on the server that hosts the JavaScript code that requests the resource. Thus, with reference to our example, you would need to set up on the web service at https api.example.com that the web application at https www.example.com is allowed to access the web service. For this purpose, you'll configure the access-control-allow-origin header, listing the domains that are allowed to bypass the SOP restrictions, separated by spaces. Access-control-allow-origin quotation https www.example.com. Note, be sure you avoid specifying the wildcard operator as a value for the access-control-allow-origin header, which would allow any website to request resources from that domain. Instead, you should explicitly define the permitted domain as a whitelist. Configuring CORS for Express. CORS is relatively easy to configure on a web server. For configuring CORS for an Express application, the most suitable middleware is CORS, https github.com/expressjs/CORS, which you can install for a project as usual with the following npm command. npm install CORS. You can then include the package via require as shown in listing 20.4 and configure it as a middleware. Then, you'll pass a configuration object to the CORS call, which you can use to define the whitelist of domains for which CORS is to apply, among other things. Like this code. Content Security Policy. The SOP governs that JavaScript code running in one domain must not load resources from other domains. However, this rule does not prevent all malicious JavaScript code such as code injected into a website via XSS, section 20.1.8 from being executed. This scenario is where the CSP comes into play.
This additional layer of security can, among other things, let you determine exactly which JavaScript code is allowed to run and which is not. Note, while CORS allows you to relax the security rules defined by the SOP, a CSP allows you to further restrict these rules. For example, you can specify that a web page generally prohibits the execution of inline JavaScript, that is, JavaScript code defined directly within a script element rather than in an external file. However, not only the execution of JavaScript code, but also the loading of other file types such as images, CSS, etc. can be controlled via CSP. More on this topic shortly. You can define the rules that should apply to a web page by sending the content-security-policy header to the client with an HTTP response on the server side. As a value for this header, you pass the rules in form of a policy, content-security-policy, definition of the policy. Structure of the content-security-policy header. A single policy consists of the name and various parameters. The following policies can be defined with respect to resource loading in alphabetical order. Child-src defines for which domains, frames, and web workers can be created. Contact-src defines to which domains a connection via WebSocket or XML HTTP request XHR is allowed. Default-src serves as a fallback rule. Font-src defines from which domains external fonts may be loaded via CSS at font-face rule. Frame-src defines from which domains web pages may be included as a frame or via the iframe element. img-src defines from which domains images may be loaded, both from img tags and for images included via CSS. Manifest-src defines from which domains manifest files may be loaded. Media-src defines from which domains video files and audio files, video and audio elements may be loaded. Object-src defines from which domains Flash and other plugins, object, embed, and applet may be loaded. Prefetch-src defines from which domains files may be prefetched. Script-src defines from which domains external scripts may be loaded and whether inline scripts, those defined within a script tag rather than external JavaScript files are allowed. Style-src defines from which domains CSS files may be loaded. Worker-src defines to which domain web workers and service workers may be loaded. Table 20.1 shows some examples of possible values of a policy. Asterisk, example, font-src, asterisk, description, wildcard that allows the loading of all resources. Exceptions include URLs that use one of the following protocols: data, blob, file system, schemes. Value, none. Example, script-src, quote, none, prevents the loading of resources regardless of the source. Quote, self, script-src, quote, self, allows the loading of resources that use the same protocol, host, and port. Blob, colon, media-src, colon, self, blob, colon, allows the loading of resources via the blob protocol. Data, colon, img-src, quote, self, quote, data, allows the loading of resources via the data protocol. Example.com, media-src, example.com, allows the loading of resources from a specific domain. Asterisk.example.com, media-src, *example.com allows the loading of resources from all subdomains below the specified domain. https://example.com img-src https://example.com allows the loading of resources over HTTPS only. https://media-src https: allows the loading of resources using HTTPS only regardless of domain. So that is the parameters for policies. For example, you can define a header so that images can be loaded from all domains, but audio and video files should only be loaded from the audioexample.com and videoexample.com domains, and JavaScript files only from codeexample.com. All other files should only come from the originating domain, like this code. Several options exist for defining the content security-policy header. First, you can configure the header directly in the HTML code using the open and close tag meta tag. Second, you can carry out the configuration directly on the web server. Configuring CSP in HTML. To configure a CSP directly in an HTML document, simply use the meta tag as shown in listing 20.7. The HTTP-equiv property is used to specify the name of the corresponding header, i.e. content-security-policy, and the content property is used to specify the value of the header, i.e. the configuration of the individual policies. To be on the safe side and also support older browsers, you should repeat the same for the x-content-security-policy and x-webkit-csp headers, like this code. Configuring CSP for Express. To configure CSP for an Express application, I recommend Helmet https://helmet.js.github.io, which is middleware for configuring several other security-related aspects in addition to CSP. To install Helmet for an Express application, use the following command: npm install helmet. Now, you can use the package as shown in listing 20.8. The call of helmet.content-security-policy initializes the middleware, while the surrounding call of app.use registers the middleware with Express application as usual. You can pass the policies for directives to the helmet.content-security-policy call. Make this call. If you now start the program and thus the server, Express or the Helmet middleware only allows the loading of the resources defined via the policy. Authentication. As mentioned earlier, a distinction is made in web applications between authentication, checking whether a user is who he or she claims to be, and authorization, checking whether a user is allowed to perform a certain action. Various strategies exist for authentication, the most important of which I will present in this section, namely the following: basic authentication, session-based authentication, token-based authentication. Basic authentication, as the name suggests, basic authentication is the simplest type of authentication. The process consists of 4 steps as shown in figure 20.10. In the first step, the client sends an HTTP request to the web server, whereupon the server checks whether the requested resource is publicly accessible or requires authentication. If authentication is required, the web server sends a corresponding HTTP response to the client, which contains status code 401, an authorized, and www-authenticate header. On the client side, this approach ensures that the credentials, i.e. the access data consisting of username and password, are requested. If the client is a browser, a corresponding browser dialog box is displayed to the user. Then, the client sends the request to the web server again, passing the credentials as the authorization header. In the fourth and final step, the web server checks the credential and after successful authentications, sends the requested resource, or after failed authentication, a corresponding error to the client. After successful authentication, the authorization header, including the credentials, is sent to the server with any additional requests as long as the client is logged on the server.
of course, so the credentials are not persisted anywhere on the server side. In the case of HTTPS, all headers and thus also the credentials are also transmitted in encrypted form. Session-based authentication, in contrast to basic authentication, where credentials are sent to the server with each request after successful authentication, session-based authentication is based on sessions. The session-based authentication process is shown in Figure 20.11. Once the user has logged on to the web server using a username and passwords, the server creates a session to the user. This session is uniquely identified by an ID called the session ID, which in turn is sent back to the user by the web server and stored as a cookie in the user's browser. As long as the user remains logged onto the web server, the cookie is sent along with each subsequent request. The web server can then compare the session ID stored in the cookie with the session information stored on the server side to verify the identity of the user. Note, in session-based authentication, credentials are not sent with each request after successful authentication, but rather a session ID that the server can use to identify the user for the validity of the session. Token-based authentication. Session-based authentication is already more secure than basic authentication, but still has several disadvantages. First, for applications that are used simultaneously by a large number of users, you must ensure that the server has sufficient memory to store the session IDs and associated sessions. Second, session-based authentication is not suitable for authentication against web services due to the underlying cookies. For this reason, in such scenarios, example, when you expect many users or when authenticating against web services, you should use an alternative authentication strategy, token-based authentication. The procedure for token-based authorization is shown in Figure 20.12. Once the user has logged on to the web server using a username and password, the web server creates a token, which can also contain the entire session information, and sends this token to the client. The client in turn stores the token, for example, in the local memory, and sends it along with each request to the web server as an authentication header. The web server can then use the token to verify the identity of the client without having to memorize sessions internally. Note, the difference between session-based authentication and token-based authentication is that the user status is not stored on the server side in a session, but on the client side in the token. Since the sessions on the server side are omitted, the server does not have to use any storage space for this purpose. In other words, token-based authentication scales better than session-based authentication. Note, various standards exist for the implementation of tokens. For example, Simple Web Tokens, SWT, Security Assertion Markup Language Tokens, SAML tokens, and JSON Web Tokens, JWT. Today, JWT is common because it is more secure than SWT and also more compact than the XML-based SAML. Summary and outlook. In this chapter, we learn about common web application vulnerabilities and key terms relevant in the context of web application security. We covered a lot of different topics, but now you're well equipped to make your web application secure from the start. Key points. The most important points from this chapter include the following. Part 1. Vulnerabilities. The Open Web Application Security Project, OWASP, is an organization of security experts that deals with the security of web applications and web services. The following vulnerabilities are commonly encountered: injection, broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, XSS, insecure deserialization, using components with known vulnerabilities, insufficient logging and monitoring. Part 2. Cryptography, SSL, TLS, and HTTPS, asymmetric cryptography. Data is encrypted and decrypted with the same key. In
Asymmetric cryptography, on the other hand, data is encrypted with one key and decrypted with another. Asymmetric cryptography is used, for example, in secure socket layer (SSL), transport layer security (TLS), and hypertext transfer protocol secure (HTTPS). SOP, CORS, and CSP. The same origin policy specifies that code from one source domain must not access content from another source domain. Using cross-origin sharing CORS, you can relax an SOP by allowing access to resources of one domain for certain other domains. You can use content security policy to further restrict an SOP and, for example, determine which JavaScript code may be executed on a web page and which may not. Part 4. Authentication. Authentication refers to the process of verifying that a user is who they say they are. Authorization refers to checking whether a user is allowed to perform a certain action. Various authentication mechanisms are available, such as the following. Basic authentication, where after successful authentication, the credentials are sent to the server with every request. Session-based authentication, in which a session ID is generated by the server after successful authentication. From then on, the client sends this ID with every request, and the server can uniquely assign it to a session. Token-based authentication, in which a token is generated by the server after successful authentication, which is subsequently sent by the client to the server with each request and which contains the user's complete session information. Recommended reading. Web application security is a complex topic that can take years to learn. New security gaps are discovered all the time, while old ones are fixed. So an ordinary developer, usually not an expert in this field, can find staying up to date difficult. Nevertheless, I would like to recommend 2 books on this subject. Malcolm McDonald, Web Security for Developers, 2020. Andrew Hoffman, Web Application Security, 2020. Outlook. In the next chapter, you'll learn about several aspects you should pay attention in terms of web application performance and the various ways you can optimize the performance of web applications.
Optimizing the performance of web applications. Regarding the performance of web applications, you should consider several aspects and know the various options for optimizing performance. In the first part of this chapter, I'll describe the meaning of web application performance and what metrics and tools exist to measure performance. In the second part, I will provide an overview of various techniques that can be used to improve performance. Introduction. First, we want to address what should be optimized in the first place and why the performance of web applications or web pages is important. Note, for the rest of the chapter, I'll use the term web page as a proxy for both web pages and web applications. Whether a web page is then a web application, example, a single page application is of secondary importance when it comes to performance. What should be optimized and why? With regard to the optimization of web applications or web pages, one factor is particularly crucial, the load time, also page speed. That is the time between calling a web page and displaying the web page in the browser. Optimizing performance has the following primary advantages. It improves the user experiences. The load time of web page has a direct impact on the user experience, UX, that is how pleasant users find the website. Basically, the shorter the load time of a website, the better the UX. Conversely, the longer the load time, the more unpleasant it is for users, which means the greater the likelihood that users will leave your website from impatience. As a rule of thumb, you should keep in mind that a web page should load within 2 seconds, better yet in less than 1 second. It improves the conversion rate. Conversion rate refers to the percentage of users of a website who successfully perform a desired action, such as successfully ordering an item from an online store, or in other words, the percentage of converted users. As mentioned earlier, web pages with longer load times result in impatience on the part of the user, which in the worst case, in this online store example, leads to an item being ordered from another, faster online store. It improves the SEO ranking. The load time of a web page affects its search engine optimization ranking. SEO refers to the optimization of web pages in terms of their ranking within the displayed results of search engines. Web pages with good SEO rankings are therefore listed higher in the result list by search engines than web pages with poor SEO rankings. Search engines like Google consider the speed of web pages and rank pages with shorter load times higher than those with longer load times. It improves crawling. For search engines like Google to deliver search results as quickly as they do today, they must pre-process web pages in a first step. In this context, the process of crawling is important. Crawling refers to the automated tracking of links and working through web pages. Since the corresponding tools, the crawlers, each work with certain time quotas that they spend on crawling, the following applies. The faster the web pages of a website are loaded, the faster and more of these web pages the crawler can process and provide for the search engines. How can performance be measured? To measure the performance of a web page, various metrics have proven useful. These special key figures can be used to determine how well a web page is performing and if it doesn't perform well, where performance issues could be found. The load time of web pages. As mentioned earlier, an important aspect regarding performance is the load time. Reason enough to take a closer look at this topic. Essentially, load time consists of the following steps as shown in figure. Queuing. Before you call a web page or after you have entered a uniform resource locator in the browser's address bar and confirmed it, the browser places the request in an internal queue. DNS lookup. When the browser processes the request from the queue, the browser first sends a request to a DNS server to get the IP address of the web server based on the hostname. This process is also referred to as domain name system lookup. Not until the browser has received this information will it make the actual request to the web server. Connecting to the web server. Once the web server to which the client is making requests has been determined, the connection to the web server is established. This connection includes, for example, the TCP handshake or also the initiation of a secure socket layer connection if the communication takes place via HTTPS. Sending the HTTP request. When the connection to the web server has been established, a concrete HTTP request is sent to the web server. Preparing and sending the HTTP response. Once the web server has received the HTTP request from the client, it prepares the corresponding response. For this purpose, depending on the request, the web server itself might need to make requests to a database, for example, or to read the file from the file system. Downloading or processing the HTTP response. When the web server has sent the HTTP response to the client must load and prepare the response. Parsing the DOM. If the response is formulated in hypertext markup language code, the client must parse this code and convert it into document object model described in chapter 7. Rendering the web page. With the information from the DOM, the browser starts rendering, that is, drawing the web page. Other HTTP requests for resources. If other resources are included in the DOM or the underlying HTML, such as cascading style sheets or JavaScript code or image files, the browser initiates further HTTP requests to the web server to load those resources, etc. Metrics regarding the load time. In terms of load time, the following important metrics can be identified. Time to first byte. This metric refers to the period of time between the calling of a web page and the time when the first byte is loaded from the web server, as shown in figure 21.3. This metric is primarily an indicator of the performance communication with the web server or the performance of the web server itself. For example, if performance problems exist on the web server, the value of the TTFB metric will be correspondingly high. First paint. This metric refers to the point in time when the browser has completed the first drawing process. At this point, the DOM, the actual content of the web page, is not considered. But, for example, information about the background color of a web page as shown in figure 21.4, this metric can be used to determine for how long the browser is busy reading the HTTP response from the server and busy with starting rendering. For first contentful paint, this metric refers to the point in time when the browser, now taking into account the DOM, displays the first visible text or image, as shown in figure 21.5. This metric can be used to determine at what point the user receives the first content-relevant information. First meaningful paint. This metric refers to the time when the browser displays the first meaningful elements as shown in figure 21.6. This time marks the point at which the user feels that the web page has fully loaded, even if it actually hasn't yet. Time to interactive. This metric refers to the time when the page has been completely rendered and is ready for user interaction as shown in figure 21.7. In other words, now the web page has actually been fully loaded. Figure 21.8 shows the individual metrics in a chronological context. Core Web Vitals. In addition to metrics related to the load time of a web page, other metrics have been launched by Google called Core Web Vitals. In addition to the load time, these metrics also address aspects such as the interactivity and visual stability of web pages. That is their behavior after they have been initially loaded. Specifically, these metrics include the following. Largest contentful paint, LCP. This metric refers to the time that elapses between the point at which the URL was called and when the largest text or image was rendered. First input delay. This metric refers to the time that elapses between the point at which the user initiates the first interaction with the web page and when the browser responds to that interaction. It thus provides information about the interactivity of a website. Cumulative layout shifts. This metric refers to the total of all unexpected shifts of the layout and provides information about the visual stability of a web page. Which tools are available for measuring performance? Several helpful tools are available for measuring load times or determining the metrics listed earlier that you can use for free. Many tools not only determine metrics but also provide you with suggestions on how to further optimize the performance of the tested website. In this section, we'll explore a small representative selection of tools. Page Speed Insights. Page Speed Insights is an online tool provided by Google that analyzes web pages with regard to core web vitals and generates a corresponding report. Results are obtained for both the mobile variant and the desktop variant of the web page under analysis. Figure 21.9 and Figure 21.10, for example, shows the result of reviewing the desktop version of the website. https://www.sub-press.com. Note, at this point, big praise to the team responsible for the SubPress website. The values determined for the homepage are pretty good. Chrome DevTools. Chrome DevTools also enable you to determine different metrics. For this purpose, you want to select the Performance tab, and in the corresponding view, you can generate a report as shown in Figure 21.11. Among other things, this report contains a timeline so you can see exactly when which step was executed or which metric was determined. In addition to the Performance tab, the Network tab and its Timings tab sub-tab also provide useful information regarding load behavior as shown in Figure 21.12. Lighthouse. Lighthouse is an open source tool available as a Chrome plugin that can be accessed either via the Chrome toolbar or the Lighthouse tab in Chrome DevTools as shown in Figure 21.14. What's particularly useful about Lighthouse is that, in addition to determining performance metrics, aspects such as accessibility and SEO metrics can also be analyzed. Now that you understand the available metrics and tools, I'd like to show you next the options for optimizing the performance of a web pages. For reasons of space, I cannot go into the details of all the optimization techniques, but have selected a few important techniques as an examples. Options for optimization. Based on an earlier discussion regarding the load time of web pages, you can take various measures to optimize web page performance. Optimizing connection times. Depending on the geographical location of the web server, like the location of the physical server on which the code of the web page is located, a request to the web server may be fast or slow. The reason for this discrepancy is the physical nature of the internet. Data must somehow travel the distance between the web server and your computer. Depending on the individual case, the distance can have a negative impact on the load time of a web page. For example, if you host a website in Germany and a customer from the US accesses it. To counteract this geographical issue, you can use content delivery networks, which are geographically distributed server networks, with each server in this network called edge servers. Edge servers are for temporarily storing the content of a web page as shown in figure 21.16. User requests are then sent to the CDN first, rather than to the actual web server, which is also referred to as the origin server in this context. The CDN then takes care of forwarding the request to the edge server in the network, which is geographically located close to the client computer. Thus, a CDN acts as a cache for websites as shown in figure 21.17. Note, to use a CDN, you must first register with the provider that offers the corresponding infrastructure. Well-known providers are Cloudflare and Amazon CloudFront. Using a server-side cache. As mentioned earlier, to process an HTTP request, a web server may in turn need to make requests to other services, such as making queries to a database, or to web services, as shown in figure 21.18. The complexity of such a query affects the overall load time. Figure 21.18, general procedure when making a request to a web server. To prevent data queries or similar from always being executed anew, temporarily storing frequently requested data in a cache makes sense. Since the cache on the server side is used in this scenario, we call this cache a server-side cache. If a client then makes an HTTP request to a web server, the server first checks whether the requested data is in the cache and returns directly to the client. If the data is not in the cache, the web server performs the appropriate database query and then delivers it to the client, as shown in figure 21.19. Additionally, it stores the data in the cache for later faster access. Thus, with the server-side cache, the response time from the web server and thus the overall load time can be optimized, which in turn can be observed by an improvement in the TTFI metric. Example of technologies that offer server-side caching include Redis or Memcache. Validity of cache entries. The period of time data should be valid in the cache before it gets deleted or replaced by newer data can usually be configured by specifying a time to live (TTL). Introduction to data structures, algorithms, and pseudocode. When it comes to software engineering, there are many ways to solve one problem. Teams get together to break down complex problems into multiple subtasks, and some of these subtasks are things that software engineers do quite often. In Chapter 3, Roles in Software Engineering, we cover that software engineers often write code that will create, read, update, and delete data in their software programs. What happens when it's a large set of data that the user needs to filter, sort, or search through for something? When we look at a large amount of data on a web page or any other software, we often don't think about how much resource it takes to complete these types of tasks. As an example, let's consider a software program that retrieves a list of first and last names. A software engineer will write code that reads these names from a database and then loads them onto the screen in a readable format. If the list is quite long, the software engineer may need to handle how many names you see per page or view, also called paging, where you may see a list of numbers at the bottom of a list to see where you are in the list. They may also consider infinite scrolling, which you see on social media apps, where new text and content are often displayed as the user scrolls through an app or web page. As the list gets larger, you'll need to search for any specific names you're looking for, and you may want to have the ability to reorganize the list or search the list. Again, this is a common problem that software engineers face and have different options on how to approach. A software engineer will most likely pick the most efficient solution, which is the one that allows you to quickly search through and sort the names. Each of these options a software engineer has is called an algorithm, a set of tasks that solves a particular problem. However, many problems often have details and caveats that make the problem complex. In other words, the problem is solvable based on a certain set of conditions, which is why a software engineer picks the best one for the problem that they're trying to solve. Data structures refer to the specific way that data is organized and which allows the data to be easily accessed and searchable. In general, a computer program is made up of algorithms and data structures. Topics relating to algorithms and data structures are quite vast, so much so that there are entire courses and textbooks dedicated to the subject. While this may sound overwhelming, just remember that any code you write can be considered an algorithm. Furthermore, it's impossible to remember every popular algorithm and data structure out there, and software engineers will often refer to the internet or textbook to refresh their memory. If you tried out the exercise in the previous chapter, you have successfully written an algorithm. This chapter will walk through popular algorithms and data structures and show you how to conceptualize algorithms with pseudocode, which enables you to write algorithms in English or whichever written language you write comfortable with before you write it in code. Next, you'll dive deeper into popular data structures and algorithms, starting with learning about the array data structure and then exploring various sorting and searching algorithms. This chapter will cover the following topics: planning with pseudocode, the importance of data structures and algorithms, introduction to the array data structure, introduction to the selection sort algorithm, introduction to the linear search algorithm, introduction to the binary search algorithm. By the end of this chapter, you will be able to write pseudocode and write algorithms with it. Planning with pseudocode. Have you ever tried to plan out your day before starting to do things you plan to do? Think about whether you have ever done this for a large trip or whether you do so every day when you start work at your job. Planning helps you prepare for what's to come and, in many cases, can make things such as your trip or workday successful. Programmers sometimes need to do this for complex problems they're trying to solve. Pseudocode enables you to plan out the task you're attempting to accomplish by writing out the computational steps in English or any other prepared language. With no programming languages, you can freely plan and document how you plan for your program to run step by step. Unlike programming syntax, there is no right way to write pseudocode, and there are many guides on how to write it well, but a general rule of thumb is not to introduce actual code in your pseudocode. Save it for the actual program you're trying to write. You can write pseudocode with a pen and paper, in a document, on your phone, or even in the comments of the program you're creating. Pseudocode can be broken down into two concepts: tasks and constructs. Tasks are the things that you'd like your program to do, such as increasing the numerical value of a variable or retrieving information from a database. On the other hand, constructs are representations of common programming operations such as if, else, or loops. A combination of the two generates a sequence of progression of your task and construct that describe the logic of the program you'd like to create. Because pseudocode doesn't require syntax as a programming language does, we can dive right into writing it. Let's try it out in exercise with the FizzBuzz problem from the previous chapter. Exercise FizzBuzz in pseudocode. One of key things in pseudocode is to understand the problem you're trying to solve. So let's first revisit the prompt in FizzBuzz from the previous chapter. Write a console application that prints the numbers 1 to 10. For multiples of 3, print the word fizz instead of the number, and for multiples of 5, print the word buzz instead of the number. In the first sentence, we can ignore the console application part as it doesn't apply to pseudocode, but here is where our task is introduced, printing. In this program, we'll be printing numbers 1 through 10, which you have learned in the previous chapter that you can do with a loop, a construct. The next sentence contains another construct where the numbers will be checked for multiples of 3 or 5, which means that the program will need to evaluate a condition where an if-else statement would be a reasonable fit in Kansas construct. Now that we've identified the task and constructs in this problem, we're ready to write it out in the following example. First, set the counting number to 1. Second, keep increasing the counting number until the counting number is 10. Third, when the counting number is multiple of 3, print fizz. Fourth, when the counting number is a multiple of 5, print buzz. Fifth, when the counting number is neither a multiple of 3 nor 5, print the number. Sixth, increment the counting number by 1. Seventh, end the program after counting number prints 10. While this is an acceptable example, we can improve on this by introducing common constructs as keywords in the pseudocode, where these keywords resemble the syntax you would write in the actual program. Combining keywords with formatting such as indentation, spacing, and cases will closely resemble the syntax of programming language without writing code. The following example introduces keywords and formatting. First, set the counting number to 1. Second, well, the counting number is 10 or less. Third, if the counting number is a multiple of 3. First, print fizz. Fourth, if the counting number is a multiple of 5, first print buzz. Fifth, else, print a number. Sixth, increment the counting number by 1. Seventh, end the program after counting number prints 10. Notice that while an if-else keywords have been added and capitalized to stand out, also the step under while have been indented to notate that this task should be repeated until the loop is complete. Either version of this pseudocode can be considered complete, but keywords and formatting enhance it with more structure without introducing programming syntax. Recall earlier in the chapter that writing a program such as FizzBuzz is considered an algorithm, so writing pseudocode allows you to plan out algorithm before you start writing it and can be helpful tool to break down complex problems you face when creating software. The following sections will focus on data structures and algorithms, why they are important, and some popular ones out of many that exist. The importance of data structures and algorithms. You'll find that an important part of programming is practice and experience, where you continually improve your skills, try new things, and apply what you have learned from past mistakes and wins. As an example, in Chapter 5, writing your first C program, you have probably learned that you need a semicolon at the end of every C statement. Otherwise, your code won't run. As you practice, you may find that you discovered new ways to do something, a new solution to an old problem. When it comes to solving problems with software, algorithms create solutions. Algorithms solve problems where problems can vary in complexity, from adding two numbers to finding text in a picture. You have probably used software that has solved these problems, and you may not have noticed how fast it was and how accurate it was in doing so. There are things that software engineers face daily, and not only is it important to find a solution, but it's also important to do so efficiently so that it takes up the least amount of resources, time, and space. The thing about tasks on computers is that any operation will cost resources, whether it be time and or space in computer memory, and software engineers will use algorithms to find the best balance. Fortunately, many software engineers have faced similar problems and have built algorithms that others may use to quickly solve and move on to the next problem. The same goes for data structures, where efficiency means using the least number of resources to do something with data, whether that be reading, searching for, or inserting data.
Algorithm saves time for the programmers and computers alike, so that they don't need to worry about how long it takes for autocomplete to appear in a search engine such as Google when user starts typing, for example. The rest of the chapter will focus on data structures and algorithms. There are many different ones that have been discovered and used in software that you probably use today. The following sections will focus some popular ones, starting with the data structure you learn how to implement in C. In chapter 6, data types in C, the array. Introduction to the array data structure. Arrays are a popular data structure represented in various software languages, including machine code. You learned how to write them in C in the previous chapter. Arrays are a set of spaces in computer memory that have been saved for data, where each space has fixed size for data. When you create an array in a computer program, the computer saves or allocates space for the data, a collection of spaces that live next to each other and can be found in a single location in computer memory, and give each space a memory address, which is a unique location in computer memory, similar to a typical address. So when you create an array with 5 items in it, the computer allocates 5 spaces for your data and gives each of them a memory and address and index. This defines an array as continuous data structure where the data is one location and each item is in subsequent order. The opposite of this is a linked data structure where there may be space allocated for data in different locations, where these locations are identified in pointers. As you learned in previous chapter, data that takes up space inside of an array is labeled and can be identified by its index. Starting with the number 0, the following is visual representation of an array where the data will be pictures stored in computer memory. There are some advantages of arrays that provide programmers with an easy way to store and find data. As you learned earlier in this chapter, space is a valuable resource in computation. A computer program must not waste space, which can affect any other operations happening on the computer and may slow it down and affect user productivity. Arrays are a fixed size that is allocated for the data, so no space is wasted. When it comes to time, arrays provides a way to directly access data when the index is known, so there's no need to spend time searching through the entire array to find something if you already know where it is. One disadvantage is that arrays cannot be modified while a program is running, so you can add additional data to the array while you're looping through it. Although there is a type of an array called a dynamic array that does allow these types of operations. You can read, search for, insert, and delete data within an array. Let's walk through some examples of what this looks like, starting with an example of the read operation. Here is an example of a picture in the array being read. Computers can easily read data in an array thanks to the index, where the computer can increase an index by 1 to find the next item. When you want to find a specific item in the array by index, the computer has already made note of the memory address of the first item, where the index is 0. So if you want to retrieve data where the index is 2, the computer can easily jump for the item by adding 2 to the memory address, returning picture 3. In other words, it takes the computer one step to find a value by its index. Steps refer to the work the computer has to do to carry out a particular task, which will most likely be instructions from a block of code. More steps mean more time to complete a task, where time is a resource that we try to preserve when possible. Now, let's try the opposite of reading, which is searching an array. The difference between searching for data in an array and reading the data in it is that reading uses the index to find the value, while searching uses the value to find the location or index. To find a value, the computer will need to search through an array to find the value there. As mentioned before, the computer stores the memory address and index of the first item, so it knows where the value is but not what it is, so it must go through the array to find the value. To find the location of picture 3, the computer will visit each item in the array until it's found, starting with index 0 in the following example. The computer does not find picture 3 at the location visited, So it moves on the adjacent location as seen in the following examples. Again, picture 3 does not exist at this location, so the computer moves on to the next one. Finally, picture 3 is located at index 2. The computer took 2 steps to find it, but it would take much less if we were searching for picture 1. This means that depending on where the value is, it may take less or more time to retrieve the value. Let's move on to how insertion works in an array by looking at the following example. Because arrays are of a fixed length, insertion operations require the computer to allocate additional space for a new value. A space is added at the end of the array, then the value is inserted into the array. The value can be inserted into any part of the array, but to do so, the existing items may need to shift to a different space or index. The previous example showed how to allocate space for a new value to be inserted. Let's explore scenarios for inserting a new value. When new space is allocated, a new memory address and index are added to the end of the array where a new value could be inserted. Here's an example of adding a value to the end of the array. What if we wanted to insert picture 4 into another part of the array, such as into index 1? To do this, we must first return the first example with the empty allocated space and shift the existing values to the right to make space for it. Here's the first step of moving the last item, picture 3, to the right. There's now an empty space, but that's not the index where we'd like to insert the new value. So let's move the item on the left to the right in the following example. The empty space is now at index 1 and we can insert the new value there. Here's an example of the completed insertion. This took 4 steps to complete. New space was allocated for the value, then picture 3 and then picture 2 were shifted to the right, and finally, picture 4 was inserted into the empty space. In the insertion scenario, the smallest number of steps in this operation would have been 2 if we had inserted picture 4 into the last space. Let's move on to the final operation, deletion. In the following example, picture 2 has been deleted from the array. There's now an empty space in the array, which will make search operations less efficient because visiting each item will reveal an empty value. We can make any search operation a little faster by filling it with the neighboring values by shifting everything to the left, as in the following example. This operation took 2 steps, deleting picture 2 and shifting picture 3 to the left. Now, searching through the array will take less time because the empty space is at the end, and if the value we're looking for exists in the array, we'll find the intended value before the computer visits the empty space. Now that you have learned about the array data structure, we'll explore algorithms for organizing and searching data, starting with the selection sort algorithm. Introduction to the selection sort algorithm. In the previous section, we saw that the steps to complete an array operations can vary based on the position of the data. We sometimes arrange and organize data in such a way that it is more readable and faster to find what we're looking for, and computers can benefit from this too. A data structure that contains sorted data such as numerical sequence stored in an array takes fewer steps to complete an operation such as reading or insertion. Sorting algorithm also take several steps to complete the sorting process. We will explore the selection algorithm, which is a common sorting algorithm that finds the smallest element in data structure and moves it to the front. Let's dive in by exploring an example of an array that contains 4 integers. We can easily organize the sequence in our heads, but writing an algorithm to do this will involve writing code that takes a few steps, which we can write in pseudocode. First, store the value as the smallest. Second, compare the value to other items in the array by visiting each one. Third, find the smallest of the values. Fourth, if the smallest value is found, swap the location of the smallest value with the first item. Fifth, store the new value as the smallest one. Sixth, visit the next value at index 2. Seventh, repeat step 2 to 6 until all values in the array have been visited and compared. In this example, the value at index 0 is 9 and will be compared against the other values where 2 will be the smallest, The positions of 2 and 9 will be swapped, placing 2 at the beginning of the array at index 0 and 9 at index 3. The algorithms will now move on to index 1 where the value is 48. It is compared against the remaining values where 9 is the smallest and swap position so that 9 moves to index 1 and 48 moves to index 3. Well, we can see that array is now obviously sorted. The algorithm is not aware that the sorting is completed and visits index 2 and value 37 and compares it to the remaining value 48. At this point, the algorithm ends because the algorithm has reached the last item in the array and has no more comparisons to make. The selection sort algorithm is a common way to sort values. There are various other sorting algorithms such as bubble sort and quick sort with various level of complexity and efficiency. Having learned the importance of organizing data, we'll move on to searching algorithms, starting with linear search. Introduction to the linear search algorithm. The linear search algorithm is a basic search within data structure that begins by visiting the data at the beginning and visits each value until it's found or reaches the end of the array, where the value does not exist. In the introduction to the array data structure section, we did a linear search to find a picture in the example array. We'll experiment with it more by using the same array of integers used in the selection sort algorithm. First, let's write the algorithm in pseudocode. First, store the value being searched for. Second, starts at index 0. Third, while the value is not found and is not at the end of the array. First, if the value is equal to the value being searched for. First, return the index. Second, else. First, increase the index by 1 and move on to the next value. C, if at the end of the array. First, print value not found. In the following example, we will be searching for integer 48, so the algorithm will visit the value at index 0. The value at index 0 is 9 and is not required value, so the algorithm increases the index by 1 and visits the next value. 48 is at index 1, so the algorithm ends the search. While this is a straightforward algorithm, it can get quite lengthy depending on how items are organized. Let's try this algorithm again with the sorted version of the array and search for 48. We'll fast forward to the final step in this example where 48 is found. To get the value being searched for, the algorithm needed to visit all other values to find it, taking more steps. This could be costly in time and resources, so depending on the situation, a software engineer may pick this search algorithm to another to reduce the step and time. The next section explores another search algorithm, binary search. Introduction to the binary search algorithm. The binary search algorithm differs from the linear search algorithm in that the data structure, like an array, needs to be sorted to apply the algorithm. Binary search works by finding the middle value of the array and comparing it to the value that is being searched for. These narrow down the list of values so that every item in the array won't need to be visited because they are higher or lower than the middle value. First, let's set up the algorithm in pseudocode. First, store the value being searched for. Second, while the value is not found, first take the array length and divide it by 2. Second, set the value as the midpoint index. Third, if the index value is less than the search value, first stop visiting values that are less than the midpoint index. D, if the index value is higher than the search value, first stop visiting values that are larger than the midpoint index. E, if the index value is equal to the search value, first the value has been found, return the index. F, if no more indexes to visit exist, first print value not found. Now, we will revisit the previous example of the sorted array in figure 8.18 and add an additional number so that it has an even number of elements. The following example searches for 9 and highlights the middle index and value of the array. But because 9 is less than 37, we can ignore the values to the right, including the one at the middle index. The algorithm has now narrowed down the possible locations of the value. Next, the algorithm selects the next median value, which would be 1, and finds that the value at the index is the one that algorithm is looking for. Like the other algorithms, the amount of data and the value being searched can change how long or how many steps it takes to find a value in a binary search. This concludes our exploration into data structures and algorithms. Summary: data structures and algorithms save software engineers time with efficient ways to complete tasks and solve problems. You can get started with writing algorithm in plain English with pseudocode, or you can write what you like your program to do as tasks and incorporate them into common programming tasks as constructs. You have already learned about the array data structures and how to write it in C, and in this chapter you learn more about it as a data structure and about using read, search, insert, and delete operations on them. Finally, we learn about some popular sorting and searching algorithms where binary search required an array that had already been sorted. Software engineers rely on and will select different algorithms and data structure operations based on the problem they're trying to solve and how efficiently they use computer resources. In the next chapter, we'll return to programming C to create this algorithm. Questions: what is the difference between task and constructs in pseudocode? Second, why would software engineers seek to reduce the number of steps it takes to perform an operation on an array data structures? Third, in an array, what is the location of the first value where the selection sort algorithm begins? Fourth, what are the two outcomes of using the linear search algorithms? Fifth, what are some differences between binary search and linear search? Further reading: The Algorithm Design Manual, 2nd edition, 2010, by Sienna Springer. A Common Sense Guide to Data Structures and Algorithm, 2nd edition. Level Up Your Core Programming Skills, 2017, by J. Wengrow, Pragmatic Bookshop.
Data types in C. In the previous chapter, we learned how to get started with building software and configuring our development environment for .NET and C. Now, we will learn a little more about the C language. Software is often used to share and use information, which we usually define as data. Data can be represented in a variety of sizes and formats, and the end users of any software will want to see it represented in a way that helps them be productive by providing information or assisting them in completing a task. As creators and maintainers of software engineers need to be able to work with data efficiently and securely so that users can quickly access and work with their data and only see the relevant data. In Chapter 2, the Software Engineering Life Cycle, and Chapter 3, Roles in Software Engineering, we learn that software engineers have common interactions with data, where they will often be creating new data or creating, reading, updating, or deleting existing data, known as CRUD operations. Because of this, we can consider data to be part of software that needs to be maintained. But how can that all be done with a programming language? In this chapter, we will explore the foundations of storing and representing data in C, starting with variables. Next, you will learn about different basic types of data or data types. String, number, also known as integer, and boolean are common data types used in C and other languages. So, if you decide to explore other languages after this book, you will have enough knowledge about variables and common data types to be able to get started building in those languages. Finally, we'll end this chapter with a special data type called the array, which stores multiple data values. This chapter will cover the following topics: introduction to variables, introduction to the string data types, introduction to numerical data types, introduction to the Boolean data type, introduction to the array data type. By the end of this chapter, you'll learn about the purpose of variables, how to create and work with various data types, and how to store more than one data value with arrays in C. To complete the exercise in this chapter, you'll need a computer such as laptop or desktop computer that has Visual Studio Code and .NET installed. Refer to the previous chapter for information on how to install them. You can find the code files for this chapter on GitHub. Introduction to variables. Variables are a vital part of programming because that's the way data is stored. Imagine you're trying to keep track of how much cash you have in your pocket and you plan to do some grocery shopping. You decide you'd like to grab a cup of tea after shopping, so you'll need to budget your money wisely to make sure you have enough to enjoy some tea. You can most likely do some quick calculations in your head to get a rough estimate of how much you can spend on groceries that day. To double check your math, you decide to use the calculator app on your phone and you realize you should have enough to buy the book that you wanted. Let's try this out on a calculator app with a starting total of $75 as an example. You estimated that the cost of groceries will be $40 and that the tea will be $5, which has been calculated in the Windows calculator app as shown here. Computers and the software that runs on them are great at tasks like this because they can do them quickly and accurately. Basic math such as subtraction, which would be needed to calculate your remaining balance, is a common programming task that happens to be similar to what you would do on pen and paper. Creating a calculator app like this one would require taking the user inputs and using the subtraction operator to make a calculation. We're not quite ready to make a calculator yet, but we can make a small sample console application that subtracts the grocery fee from the cash you have at hand. Let's create a new .NET console app named MyBudget. .NET new console-o MyBudget. Open the app in Visual Studio and replace the default Hello World text with a calculation for groceries and tea so that the line looks like this. Console.WriteLine. Open and close parenthesis 75 minus 40 minus 5. If you open and run the application with .NET Run, you will see 30 printed in the terminal. We managed to calculate the grocery expenses and now have an estimate of the remaining funds. We can see that it's consistent with the estimate we saw in the calculator. While this is an accurate calculation, these costs are only an estimate, while the final cost of the groceries and tea might be more or less than expected. Remember that you decided to buy a book after tea and estimated that you should have enough left for it. How much money will you have after getting your book? How can we account for this in our application? Variables, as the name implies, are data that can change in value over time in a software application. Creating variables makes it much easier to manage values that will change. Let's have a look at that. Creating a variable. All these numbers could be considered variables in the application, but let's focus on keeping track of the cash you have by converting it into a variable by updating the application code by replacing what we have written so far with the following new lines of code. We have now created or declared a balance variable. In C, a variable declaration consists of the data type of the variable, which is int, a type used for numbers, and the name of the variable, which is balance. Running the code as it should produce the same result from last time, but now we can store the value of balance to keep track of how much is left for the book by updating the variable with the initial value. This process of assigning the initial value of a defined variable is defined as initialization, where balance has now been initialized to 75. The following figure notates the declaration and initialization of the balance variable by adding the assignment operator and assigning a value. Now that balance has been initialized, you can use it in calculation and the application will print the same value when run. The benefit of variables is reuse, where the value of the variable can be referenced by a known name without us having to track of the value that's stored, which is now the responsibility of the programming language and the computer. We'll work more with this example later in this chapter, but this is a start to understanding the need for variables. Now that you know how to create variable and assign a value to it, we will explore the different data types for variables, starting with strings. Introduction to the string data type.
A string is a sequence of characters made up of letters, numbers, symbols, and spaces. You can think of strings as text. We already worked with strings in the previous chapter when you changed the hello world message. Strings are enclosed in double quotations and can also be saved as variables. Let's update our existing balance application so that it prints some text to the console. The second line of code has introduced a new variable called balance message, where the type is defined as a string and the value is enclosed in double quotation marks. It is then printed to the console. Here's a graphical notation. Now that you know how to create a string, let's explore common operations we can perform with the data type, starting with concatenation. String concatenation. A common operation in strings is concatenation. Concatenation, which combines two or more strings to form a new string. One way to concatenate string is to use the plus operator between the strings you'd like to combine. Here's an example you can try. When you run these lines of code, you'll notice that console will print hello world instead of separating the two words. Because strings can be any combination of characters in various languages, sometimes the string can be something that's not meant to be read or printed on a screen, such as a computer ID. However, C cannot understand the context of the string and will not make assumptions about how it will be used and will leave the task of separating the words up to you. You can add empty spaces, known as white space, to the string to add spacing between characters or at the beginning of or end of the string, or even create a string that only contains white space. Let's try this out in our earlier example. The hello variable now has a space at the end of it, which will add separation between the two words when the application is run. Here's another example of adding space. Because concatenation can combine two or more strings, you could also concatenate three strategies together with an empty string in the middle to separate two words. You can also concatenate string to other values, such as numbers. Let's try this out in the My Budget console application. The balance message string variable has a space at the end to separate the text from the balance value with currency at the end and is then concatenated with the balance value. It will print the current balance is 75. Operators and type safety. Now that you know how to make strings, you can try to experiment with My Budget to concatenate balance message on line 4 as shown here. If you try to run this, you will see an error like the following in the console. Note the error. Error CS0019 operator cannot be applied to operands of type string and int. This error means that the operator cannot be used, the minus operator cannot be used with the int and string data types. Operators are symbols that are used to modify values in a computer program, and many programs can only be used with a particular type. We have worked with three operators so far: the subtract operator for subtracting numbers, subtracting numeric values, the equal symbol for assigning a value to a variable, and the plus symbol for concatenating strings. As the subtraction operator is only for numeric data types, we can use it with a string. This is a key feature of the C language called type safety, where operations on types are validated to ensure that they are being used on the correct types. This is a way to prevent errors and incorrect values. This defines C as strongly typed language, or a language that enforces type safety. Some languages do not enforce type safety in the same way that C does, but this does not mean that other languages are unsafe to use. It's simply a choice of language design. C and TypeScript are both strongly typed languages, but they are not the same type of language. While they share some similarities, there are key differences in their usage, type systems, and the context they are used in. Let's break it down. First, type system.